Hi everyone, good morning. Hello, good morning. Are we live? Live? Hi everyone, can you see me, hear me? Hello? Good morning. Good morning everyone, good morning. Happy morning, happy morning, happy morning. Hi. So first of all, tell me, can you see me, hear me? Yes, can you see me, hear me? Can you see me, hear me? Okay. So welcome to the class, guys. Sorry for starting it late. Some glitch was there, and obviously in the morning, no one was picking up my phone. That's why. Good morning. So are you ready for the session? Are you ready for the session? So it is the session where we are going to complete the most important, right? What are we going to discuss today? We are going to complete the most important topics of biology. So yes, it is the complete syllabus biology marathon, right students? It is the complete syllabus biology marathon, and today what is our target? We need to score 300 plus. So what are we going to cover? We are going to cover the most important topics of biology. So if you remember, I posted a videos few days back where I told you that these are the 60 most important topics that we should not avoid. Okay, and if you will check all the sessions, the predictor sessions, the NEET replica sessions, right, the NT authorized MCQs, so you will see that questions are revolving around these concepts only. Okay, so that is what we are going to cover today. Okay, that is what we are going to cover today. So if you guys are excited, do let me know in the chat section. Yes students, do let me know in the chat section. You know, it is a very difficult task for me as well to get up early in the morning and to take the classes, right? Because you know, from so long we are just working in such a way that we are sleeping late night, and then it's difficult to get up early in the morning. But anyhow I'm managing. So guys, how's energy? Yes people, ma'am, we want from basics. Bache, whatever the important topics are, we are going to discuss them from basics only. Okay, we are going to discuss them from basics only. So guys, quickly hit the like button. Okay, quickly hit the like button. And one more thing, you have to, right now I will not say that open your NCERT, do this, do that. No, right now understand that particular concept, and as per your understanding you guys can make the short notes. Okay, if you already have the notes of that topic, it's fine, you just revise it. Otherwise, make it right. Acha, sleep is reflecting from my face. Arey yaar. Yeah, it is possible. I can consider that. It is the possibility. But theek hai na, still it's fine. Right? Still it's fine. Still it's fine. At least I am here. Right? Before sleeping yesterday, even I was thinking, yeah, Ambika, will you be able to get up early in the morning? Will you be able to take the class? But theek hai, that's an achievement. Chalo, now come back. So as I said, we will be starting with the most important topic. So let me tell you students, what's the plan today? Today, yes, what is the plan today? We are going to start from the human physiology, right? So we will be starting with the class 11th syllabus first, right? And we are going to start with the chemical control and coordination. So in a reverse order, we will complete our syllabus. Okay, in a reverse order, we will complete our syllabus. Okay, done bache? Done. Okay, so guys, if Sanjay Wazeem sir is waiting for my power cut, na, that will be a problem for you people. Okay, that's quite rare. Power cut here is I don't know. I don't know. Let's hope for the best. So can we start the session? Can we start the session? So we are going to start with the very first topic, and that is the mechanism of hormone action. Mechanism of hormone action is one of the most important topics, and it is the simplest topic. Okay, bache. So first of all, let me tell you what kind of question can come from mechanism of hormone action, right? So it is not important that you understand mechanism of hormone action. You should know what kind of questions can come from the mechanism of hormone action. So when you talk about the hormone action, first thing that you need to know is, right, you can even write down, you can even revise it in that way. The first thing that you need to know is, students, right, that what type of hormones, right, the hormones having cell surface receptors, the hormones having intracellular receptor. This is the first kind of question. Second kind of question is, which hormones are going to produce second messenger, which hormones are not going to produce second messenger, right, bache? Third question is, they can give you some hormones and they can ask you their nature. Okay, so which one is steroidal, which one is protein hormone, which one is this, which one is that. That is, right, that are the kind of questions that can come in the paper, right? And if you people are asking me the session duration, okay, let me tell you, students, it is not fixed. I have to complete certain topics, I have to complete the entire syllabus. It is going to decide the session duration. Okay, and voice, again I'm repeating, voice is fine from my end. If you are using laptop, please use the mobile phone, voice will be clear. If you are using mobile phone and you are thinking my voice is low, please use the laptop or the computer. Okay. Okay, so yes, you guys can score 300 plus if you will follow this session, but for that, let me start the session. Okay, so mechanism of hormone action. So we know that when you talk about the endocrine glands, okay, students, when you talk about the endocrine glands, you know that they are going to produce the hormones, of course, right? What are they going to do? They are going to produce the hormones, of course, and that hormones will be released in blood, isn't it? Isn't it? So very first thing here is, students, that when you talk about the hormones, they are non-nutrient chemicals. They are not the nutrients that you can take. Okay, they are the non-nutrient chemicals and they are produced in trace amounts. Trace amount means in very less amount, they will not be stored. So here we have an exception. I will cover all the exceptions also. The hormones of thyroid gland. Right, the hormones of thyroid gland, that is your T3, T4 hormone specifically. Okay, that is your T3, T4 hormone, triiodothyronin, tetraiodothyronin, which is also known as thyroxine. These are the hormones that can get stored. Otherwise, bache, all the hormones, they will form in very less quantity. They are the non-nutrient chemicals, right, bache, they will be released. Now, how this hormone will get to know? That from the blood, right, that from the blood I have to act on a particular target organ, obviously. So let's say this is a cell, right? It is a cell. Its cell is made up of plasma membrane, right? It is made up of plasma membrane. Phospholipid bilayer is there. So now, bache, not every hormone can control this cell membrane. Why? Let's say this is some hormones are peptide hormones, protein hormones. What that protein hormones will do? Do you think they can directly cross the cell membrane? They cannot. Why? Why? Because this layer is made up of phospholipids. Okay, this layer is made up of phospholipids. So if any substance, if any new hormone, if it wants to cross the cell membrane, it should have the same nature. It should have that permeability. Right, it should have that same nature, it should have that permeability. So what is going to happen here? When it is a protein hormone, it cannot cross the cell membrane directly. So guys, here we will have some receptors, right? What are we going to have? We are going to have some receptors, and you know that when receptors are present on the plasma membrane, so these are the cell surface receptors, or you can call it as plasma membrane receptors. So receptors are nothing, they are also the protein. They are also the protein, but they are what? They are specific, right? What are they? They are specific. So let's say there is a hormone, it is having its specific receptor here, it will bind here. It will bind here. So the hormone which cannot cross the plasma membrane, like your protein hormone, so obviously it will get fixed here, it will join here. So we also use the first messenger word for hormone. Right, we also use the first messenger word for hormone. That's what you need to keep in your mind. Right, we also use first messenger word for hormone. So when this hormone and receptor complex will form, right, when both of them will join, it's just like that. Let's say you are going to a very high security office, you are not allowed there, but you have some very important information. So what will you do? You will go to that office, whosoever is the concerned person, let's say there is a security guard, the head of the security, whosoever he or she is, what will you do? You will tell them the things, right? And they are, okay, they will further pass the message. They will further pass the message. Let's say you are saying you are having a news related to the paper cancellation, or let's say your paper is getting postponed, whatever it is, obviously they are going to give that message to their higher authorities. It's like that. It's like that. A cascade will start because you are not allowed inside. So when this first messenger will bind to its specific receptor, so inside the cell there will be the formation of second messenger. In response to this binding, the second messenger will form within the cell. So one question is clear from this side, that which hormones are going to produce the second messenger? The hormones which are having cell surface receptor, right? The hormones which are having cell surface receptors, they are the one that are going to produce the second messenger. So the second type of MCQ that can come from this part is type of second messenger. So when you talk about the type of second messenger, it will be CAMP, it will be IP3, right? Cyclin adenosine monophosphate, it is cyclic guanosine monophosphate, it is inositol triphosphate, it is diacyl glycerol, right bache, and calcium ions, right? They are the examples of second messenger. So this is the one and another MCQ, right? They are the examples of second messenger. So obviously a cascade of information will start, right? So now come to this part. Look at this diagram. Hormone is coming. Again I'm saying, for hormone also you can use the word first messenger. What's that? It is the first messenger. It is the cell membrane. To the receptor this hormone will bind, and in response to that within the cell the second messenger will generate. So see, response 1, second messenger will generate, biochemical response will be there, then physiological response will be there. Okay, so this is what you need to know. Okay, now when it is a hormone which can control the plasma membrane, so the very first question should be there, that ma'am, what kind of hormones can control the plasma membrane? Obviously that are having the same nature. Just say here you are talking about the estrogen, which is a sex hormone, and sex hormones are steroidal in nature. They are basically the steroids. What are they? They are steroidals in nature, right? They are basically the steroids. So they will cross the cell membrane, right? So they will cross the cell membrane, and their receptors are present within the cell. So you can call it as intranuclear or even intracellular receptors. So what these receptors are going to do, because they can enter directly within the nucleus, they will form hormone receptor complex here within the nucleus, and obviously physiological response will be there, and they are going to do some, right, chart, they are going to do something here with the DNA, with the genome. This is the thing that you need to understand. Okay guys, this is the thing that you need to understand. So this part clear, so this is the kind of question. So mechanism of hormone action clear or not? Hormone receptor concept clear or not? Second messenger clear or not? So from this one topic you can see how many questions can come. Because students, the duration of class, it depends upon the time that I will be needing to complete the topic. So I request you one thing, even I got early in the morning, right? If you people will keep asking such questions which are irrelevant, that will be of no use. You please focus on the topic here. We are here to complete the most important topic. We have to revise the entire syllabus. It's more like the complete revision, right? So you can just imagine that there is a humanly book which is standing in front of you, and that is helping you people to revise the syllabus completely. Okay, and again I'm telling you, there is no issue in the voice. Guys, is voice fine or not? If it is fine, you please send me the thumbs up. It's fine, right? It's fine. Okay. So now look at this part. Right, on the basis of the chemical nature, hormones can be divided into groups. So peptide, polypeptide and protein hormones, which are made up of proteins, of course. So when the hormones, they are made up of proteins, their receptors are present on cell surface. That's what you have to remember, like your insulin, glucagon, pituitary hormones, hypothalamic hormones, etc. Steroidal hormones, right? Obviously steroids are what? Derived lipids. Okay, your cortisol, hormone of adrenal cortex. Sex hormones, which are also known as androgens, their receptors are present within the nucleus. Iodothyronins, which need obviously iodine, thyroid hormone. So here specifically you are talking about T3, T4. Amino acid derivatives are epinephrine or norepinephrine, epinephrine or norepinephrine, and also known as adrenaline and noradrenaline. And because these hormones are made up of amino acid, you also call them as catecholamines. You also call it as catecholamines. Is that clear? Is that clear? So this part is important. The hormones which interact with membrane bound receptors, they do not enter the target cell, so they will generate the second messenger. So yes, this question can come in your paper. Okay, so hormone with intracellular receptors, the steroid hormones and iodothyronins. So at least you need to mark these examples. Okay, so steroid hormones and iodothyronins, they have intracellular receptors. Okay, they have intracellular receptors. So that is what you need to keep in your mind. So this is our first topic. Okay, this is our first topic. Let's move to the next topic. Let's move to the next topic, and it is from neural control and coordination. And here you guys can see the neuron. Here you people can see the neuron. So can you tell me something about this neuron? Bache, amino, right? Can you tell me something about the neuron? Amino acid derived hormones are epinephrine, norepinephrine, also known as adrenaline, noradrenaline, and they are what? They are also known as catecholamines. What's the word for it? The word is catecholamines. Everyone, what is the word for it? The word is catecholamines. Clear? Clear, clear, clear? What is the word here? The word here is catecholamines. Understood? Understood? Very good, very good. So it is a neuron. So you know that when it comes to the neuron, also known as nerve cell, it is the structural and functional unit of neural system. It is a structural and functional unit of neural system. And when you talk about this neuron and nerve cell, it is the longest cell of human body, right? We know it very well. It is the longest cell of human body. And what kind of neuron it is? It is a multipolar neuron, students. What kind of neuron it is? It is a multipolar neuron, right? It is a multipolar neuron. Now, what is the meaning of being multipolar? First of all, you need to focus on one structure, that is your cell body. Let's say this is your cell body. What is it? Let's say this is your cell body. From the cell body, some processes will arise. Okay? From the cell body, some processes will arise. Just say you will be having this long cylindrical axon. Okay? You will be having this long cylindrical axon, and plus there will be many branched processes. Okay? So from cell body, two processes are going to arise, right? The one is dendrites. For one, the word is dendrites, and for one, the word is axon. For one, the word is dendrites, and for the one, the word is axon. So when you talk about these dendrites, what are they? These are obviously the branched processes, right? These are obviously the branched processes, yes or no? What are they? They are obviously the branched processes, right? Right. These are that branched processes, and here there will be the cylindrical axon. There will be the cylindrical axon, and here also it will be having the axon endings, or we also call it as nerve endings. Now, which question is important from this part? First of all, this is the cell body. It will be having the cytoplasm. You can call that cytoplasm as neuroplasm. Okay, you can call this cytoplasm as neuroplasm. And can you see this structure here? This kind of structure here. So, bache, it is also known as axon hillock. It is also known as axon hillock. Yes or no? It is also known as axon hillock. Clear, bache? Clear. It is the most sensitive region. It is having so many ionic pumps. So now when you look at the cell body and when you look at these dendrites, what are they? These are the dendrites here. What are they? These are the dendrites here, right? So in the cell body, even in the dendrites, what you need to note down that there will be the Nissls granules, there will be the neurofibrils. So first of all, this thing is very important. Nissls granule, where is it present? It is present in axon, it is present in cell body and dendrites. Okay, it is present in cell body, and this cell body is also known as cyton. It is also known as soma. It is also known as perikaryon. Right, it is known as cell body, is known as cyton, it is known as soma, it is known as perikaryon. So even in the cell body, even in the dendrites, I think my speed is fine, right? I think my speed is fine. Okay, I am not speaking too fast, I am not speaking too slow. Hey, no, it's fine. Yes or no? Arey yaar, get up, people, get up. So Nissls granules, they are in cell body and dendrites, and what are they? These are the masses, right? These are the masses or aggregates of what? These are the masses or aggregates of ribosomes plus rough endoplasmic reticulum. It is also an important PYQ. Okay, they are the masses of ribosome plus rough endoplasmic reticulum, students, right bache? Ribosomes plus rough endoplasmic reticulum. So it is helping in the protein formation, obviously. Now when you talk about this axon, in the axon, this Nissls granules, they are absent. Okay, they are absent. Okay, even the mitochondria and Golgi body is absent here. Here you will see all the cell organelles, right? You will see Golgi body here. You are going to see the mitochondria here, right? You will see neurofibrils here, but here it is absent. This is something very important. Okay, this is something very important. And moreover, centrioles, you know na, centrioles, they are also absent in your neuron, right? Centriole is also absent in your neuron. That is why it is not able to divide very frequently, you know na. It will be there in the, right, it will be there in what? It will be there in what kind of, it will be in G0 phase. It is not very frequently dividing cell, rather it will not divide. Okay, so that is what you need to remember. This is very important. Now the next thing is, bache, you know that sometimes these axons, they are covered, right? They are covered with the myelin sheath. Okay, they are covered with a sheath. It is an insulating layer, so it is the myelin sheath. Okay, so if myelin sheath is present, that type of neuron will be myelinated. That type of neuron will be myelinated, or we can also call it as medullary axon or the neuron. Okay, bache? So if you will see here, in between these two myelin sheath, like it is like this. Wait, I'll show you. Just let's say, okay, so let's say this is the axon here. Okay, you are wrapping the myelin sheath like this. I know color differentiation is not there. You are wrapping the myelin sheath like this. Okay, like this at this point. Now again, myelin sheath is wrapped at this particular point. Okay, just let's say you can talk about my thumb here. So myelin sheath is covered like this, okay. This, imagine this is the axon, and next myelin sheath is covered here. So can you see that, right? This is the kind of wrapping. This is my axon. Here I have the myelin sheath. Here I have the myelin sheath. It is covered like this. So in between there is a gap. And what do we call it? Yes, bache? What do we call it? We call it as node of Renwier. What do we call it? Node of Renwier. Right, with Renwier. And you know that which cells are going to form the myelin sheath? These are the Schwann cells. Right. So Schwann cells, they will form the myelin sheath, bache. They will form the myelin sheath, and especially where? In the PNS, in the peripheral nervous system. And even if a neuron is non-myelinated, kindly highlight this point, everyone. Even if a neuron is non-myelinated, even if an axon doesn't have the myelin sheath, still, bache, it will be having the covering of the Schwann cells. Okay, and these Schwann cells will form the myelin in the PNS. You have another cells that are known as oligodendrocytes. They also form the myelin sheath, but in the central nervous system. Right? Now, you know that these neurons are arranged in our body. So, dendrites will carry the impulse towards the cell body, right? Dendrites will carry the impulse towards the cell body, and axon will carry it away from the cell body. Axon will carry it away from the cell body. So, you guys can see here, these are the terminal arborization, these are the endings of neuron, and here you will see synaptic vesicles or the neurotransmitters. So that's what you need to remember, bache. That's what you need to remember. And please guys, all the questions related to neurons are so these are all the questions related to neurons. Okay? Now the very important topic, and most of the time I have seen that students, they make the mistake here in this topic, that is ionic theory of nerve impulse conduction, right? Ionic theory of nerve impulse conduction. So do you want me to explain this topic? Yes, bache, do you want me to explain this topic? So ionic theory of nerve impulse conduction. What is it? Ionic theory of nerve impulse conduction, that is our topic. What is it? Ionic theory of nerve impulse conduction. Yes? Do you need this topic? Hanji, do you need this? Ma'am, after the class, am I able to score 300 plus if you will revise with the class, if you will solve the MCQs with the class? Definitely you will. Definitely you will. I am not going to lie. Right, but if you will keep asking, ma'am, session duration, ma'am, when are you going to end the session, ma'am, do this, do that, then obviously yaar, not possible. So please focus here, okay? Focus here. Chalo. So ionic theory of nerve impulse conduction, I will slow down now because I know you make mistakes here, and obviously no one is going to ask you the direct mechanism in the paper, but at least you should understand the points from where the question can come, okay? The points from where the question can come. Okay? Ionic theory. First of all, this is what you need to remember, that this theory of nerve impulse conduction will be there in the non-myelinated axon. When your axon is non-myelinated, okay, so here this ion conduction will be there like this. Okay? Nerve impulse conduction will be like this. But when it is myelinated, yes, when it is myelinated, so myelin will not allow the ions to go here and there. It is just like an insulating layer, right, bache? So from this node of Renvier, right, from this node of Renvier, the impulse will jump to the next one. The impulse will jump to the next one. So this is known as saltatory conduction. What's the word for it? Right, the word for it is saltatory conduction. What is the word for it? The word for it is saltatory conduction. Okay, bache? So now let's talk about it. So this is so first of all, impulse will pass throughout the length of the axon, and it works on all or none principle, right? It works on all or none principle. Now what is the meaning of all or none principle? Like, first of all, you need a minimum threshold stimulus. Like the stimulus should be more than that threshold value, just a minimum value. Like in the NEET examination, minimum you need to score 300 marks. Okay? If you are not scoring 300 marks, you are not going to clear that exam. You know that the main criteria is that you should be in the merit list, but at least the minimum marks that you need to qualify is, let's say it is 300. Okay, so you have to score above 300 only. So same way mein, there will be a threshold stimulus. What will be there? There will be a threshold stimulus, right? That minimum stimulus value. So whatever stimulus is coming to generate the nerve impulse, it should be more than that threshold stimulus. This is the first point that you need to keep in your mind. Okay, this is the first point that you need to keep in your mind. Clear, bache? Clear, bache? This is the first point that you need to keep in your mind. So once this neuron, right, once it will receive that threshold stimulus, so throughout the length of the axon, that nerve impulse will be transmitted, right? So when this nerve impulse will be transmitted throughout the length of the axon, so once it is done, then after the refractory period, it means the axon will take time. The axon will take time to recover from that stimulus, and then the next stimulus will be received. Okay, it's not like that one stimulus is at this point and they are receiving another stimulus. No, it's not like that. It's not like that. So firstly, it will pick one stimulus, it will pass it. So that is why I'm saying it works on the all or none principle. Okay? All or none principle. This is the one thing. So non-myelinated clear, myelinated clear. Okay? I'm telling you the basic things. Now when you talk about this neuron, okay, this membrane is special. You know that. This membrane is special. It is having that special permeability for the ions. It is having the pumps. You know that it is the one through which ions can come and go. Obviously it is not like that all the ions can come and go, but you know that. I'm explaining the topic in a very simple language. Okay, I'm explaining the topic in a very simple language, in the layman language, so that you can understand it in a better way. So up to this part all clear? Up to this part all clear? So I want one student to volunteer. If someone will ask about the voice, right, please keep sending this message again and again that voice is fine, right? Please check your system. Okay, so this point clear? This point clear? This point clear? Yes? Guys, if voice is not fine, may I end the session? Because this is the best I can do right now. If voice is not fine, can I end the session? Can I end the session if it's not fine? I cannot increase the volume because this is the best I can do right now. I am telling you there is some issue with the system, right? Even I have seen other videos also. The audio is fine in the mobile phone, but when I started using it in laptop, the audio issue is there. So guys, please focus, okay? So this part clear now? This part clear? Now, this neuron membrane, obviously it is having the ion channels, it is having the special permeability, you know it very well. So in a very simple way, let me explain you this, right? See, there are three words that you need to understand. Firstly, when you are talking about the neuron, which is not conducting any nerve impulse, here inside negative ion will be more, outside positive ion will be more. So this condition is, here you will say it is polarized. What is it? It is polarized. What is it? It is polarized. When internal side, right, within the neuron, you will have more negative charge, outside positive charge. So if this is the condition, you will say that neuron is in resting stage. You will say the neuron is in resting stage. What is the meaning of being in resting stage? That it is not conducting any nerve impulse. Okay, what is the meaning of resting stage? That it is not conducting any nerve impulse. Is that clear? What is the meaning of resting stage, students? That it is not conducting any nerve impulse. It is polarized here. Okay, so here that ionic difference is minus 70 MV, and this is known as the resting potential. It is known as the resting potential. Clear, bache? So here the ionic difference across these membranes, sorry, the potential difference here in this condition, the potential difference here is minus 70 MV. That's what you need to keep in your mind. Okay, bache, that is what you need to keep in your mind. So this is the resting stage, right? Minus 70 MV, this is the resting potential. So at this point of time, your neuron is not conducting any nerve impulse. Okay, so when will be the action potential? Of course, when within the neuron it is plus, outside it is minus. So this is the state, you will call it as depolarized, right? Neuron membrane is depolarized. So when it is depolarized means it has started conducting the nerve impulse. So this is about the action potential. This is about the action potential. These are also the direct topics, direct MCQs, right, bache? So it is depolarized, outside negative, inside positive, outside negative, inside positive. Action potential, it is depolarized state, it is. So this is the MCQ. Okay, this is the MCQ here, and here this is the MCQ, right, bache? Right, polarized, depolarized, polarized, depolarized. So when it is depolarized, the action potential, the potential difference across the membrane will be somewhere plus 20 MV, right? Plus 20 MV, it is somewhere in the range plus 10 to plus 40, right? So this part clear, this part clear. Now the next question, if you want to understand this topic, you need to focus on the next question, and what that next question is saying, that how this condition is maintained. If I am saying that neuron is not conducting any nerve impulse, if I am saying that neuron is not conducting any nerve impulse, right. If I am saying that neuron is not conducting any nerve impulse, it is in resting state, then of course, it should be maintained like this now. How is it possible? How is it possible? Let me tell you. Imagine this is a cell, this is a neuron. Imagine this is a neuron. We are going to talk about some of the ion channels here, right? We'll be discussing leaky channels, students. What are we going to discuss? We will be discussing leaky channels. We are going to talk about the voltage gated ion channels, right? There will be leaky channels, voltage gated ion channels, and you will also talk about the sodium potassium ATPase pump. You will also talk about the sodium potassium ATPase pump, right? Sodium potassium ATPase pump. So now tell me, what do you know about this topic? Hanji, quickly tell me, what do you know about this topic? Anyone in the class? What do you know about this topic? Tell me about these ions, right? Tell me about these ions. Yes guys, tell me about it. Quick, quick, quick. I know you know the answer, right? You are nice people. Hanji, tell me. I am talking about these ionic channels, right? So I am saying that this is what you have. You have a neuron here. Imagine it is a neuron, right? It is that membrane. Okay, obviously it is having the special property. It can conduct, it can excite, you know it very well. So I am talking about certain channels, leaky channels, voltage gated ion channels, sodium potassium ATPase pump. Right now my speed is less because I want you people to understand this topic, then we will speed up as well. Okay, we will speed up as well. So dekho bache, when it is the leaky channel, right, leaky channel, you will be having sodium leaky channel, right? Sodium leaky channel, please understand this thing. You will be having potassium leaky channel, sodium leaky channel and potassium leaky channels, both will be there. Now what is the meaning of leaky channels? Here, as per along the concentration gradient, right, along the concentration gradient ionic movement will be there. What is the meaning of along the concentration gradient? Down the concentration gradient. What is the meaning of along the concentration gradient? Of course, down the concentration gradient, ionic movement will be there. This is the question that you need to keep in your mind. Again, I am repeating, along the concentration gradient, also known as down the concentration gradient, means the ions will flow as per their concentration gradient. You have sodium leaky channel, you have potassium leaky channel, right? When it comes to the voltage gated ionic channels, so sodium voltage gated ionic channel and potassium voltage gated ionic channel will be there. Now, when it is the ionic channel and sodium and potassium, right, voltage gated ion channel, so obviously change in the voltage will open it. Change in the voltage will open it. Then sodium potassium ATPase pump. When you are using the word pump, keep it in your mind. The things will move against the concentration gradient, and here we will have two tricks. One is Nokia, another is Kin 2. One is Nokia, another is Kin 2. This is our trick. Take a Nokia and Kin 2. This is what we need to understand. Now the word is leaky channel. As I said, along the concentration gradient, passively, without using energy, the things will move. Now when you look at this neuron, inside within the neuron, potassium is more, right? Potassium is more in comparison to sodium. Again, I am repeating this thing. In comparison to sodium, potassium is more. Okay? That doesn't mean that sodium is absent within the neuron. No, it is present, but in comparison to potassium, sodium is more in the neuron. Sodium is more within the neuron. First point clear? If it is a yes, I want to see some fire emojis in the chat section. Quick. If it is a yes, I want to see some fire emojis in the chat section. Quick guys. Tell me if it is a yes. Yes, yes, yes. Up to this point all clear? Up to this point all clear? Tell me. Up to this point all clear? All clear? Sure? Sure? 1 point clear? So, potassium is more in comparison to sodium. So, now when you talk about the extracellular matrix, so potassium is comparatively less and your sodium is more. Sodium is more. Okay? Okay? In the extracellular matrix, there are many ions, right? Basically, in the surrounding itself, there are many ions, many negatively charged, positively charged. So, in general, you will see that concentration is same. In general, you will see the concentration is same. right? It is managed. Different ions are there inside and outside, but it is managed, right बच्चे, right? जैसे outside more sodium less potassium, within more potassium less sodium, but still it is managed. But now we have to create the resting potential. The inside should be negative, outside should be positive. That now I will tell you how is it maintained. Even in the surrounding you will see chloride ions are there, but they are playing no role in this nerve impulse conduction, right? Outside the neuron you will see chloride ion is there, but it is playing no role in nerve impulse conduction. Now within the neuron there are some negatively charged, within the neuron there are some negatively charged proteins as well, right? There are negatively charged proteins as well. Obviously these proteins cannot cross the cell membrane, they will be within the neuron only, and they are making it negative. Now let's talk about the leaky channels, okay? Let's talk about the leaky channels, okay? So I told you it is as per the okay? So what am I saying? Let's talk about the leaky channels first. Students, I am making it very easy for you. Please listen to me very carefully. So let's say it is the potassium leaky channel. So I told you potassium is more within the neuron and sodium is comparatively less. Okay? Sodium is comparatively less. Outside potassium is less and sodium is more. So if I talk about the leaky channels, let's say these are the potassium leaky channels. Leaky channels means as per the gradient the ions will move. So what should be the movement of potassium? Inside to outside or outside to inside? What should be the movement of potassium? Inside to outside or outside to inside? Inside to outside or outside to inside? I'm talking about the leaky channels, and as per the leaky channels, what should be the movement of potassium? Potassium will move from inside to outside or outside to inside. When it is moving passively along the concentration gradient, definitely inside to outside, inside to outside. So more and more potassium, because outside less potassium is there, inside more potassium is there. So more and more potassium as per the concentration gradient it will go out. Now if let's say these are the sodium leaky channels. Okay, these are the sodium leaky channels. So if it is a sodium leaky channels, obviously sodium will move from outside to inside, right? Sodium will move from outside to inside. है ना? So this is passive movement. What kind of movement it is? Passive, along the concentration gradient. Along the concentration gradient. This is what I am discussing right now. Along the concentration gradient, that is how the movement will be. So if you will observe here, right, there are more potassium leaky channels in comparison to the sodium leaky channels. So can I say that whatever positive charge is coming inside, but in comparison to that, more positive charge is sent outside. Means basically you are throwing more positive charge outside, comparatively less positive ions are entering within. Can we say that? Yes, we can say so. Right, bache? Yes, we can say so. This point clear? Yes, we can say so. Right? Now there is the another channel, that is your sodium potassium ATPase pump. There is another pump, sodium potassium ATPase pump. So I told you that there will be two tricks, Nokia and Kintu. Nokia and Kintu. What is this Nokia? N stands for Na positive, that is your sodium. N stands for Na positive, that is your sodium. O stands for out. O stands for out. K stands for, K positive is your potassium. I means in. A means ATP. A means against. Okay, that is the trick here. That is the trick here. So what is the trick that we have? We have the trick Nokia. Nokia. So what that Nokia is saying, N mane sodium ion, O mane out, K mane potassium ion, I mane in, A mane ATP against. Basically when it is the pump, let's say here you have sodium potassium ATPase pump. So this pump against the concentration gradient will move sodium and potassium. This pump is going to move the sodium and potassium against the concentration gradient. Now ma'am, what is the meaning of that? Right? So now our another trick is Kintu. Right? Another trick is Kintu. Kintu means potassium will come inside, and how many potassium will come inside? 2 potassium. So against the concentration gradient, when things will move, you know that ATP will be used. Okay? So outside you already have less positive, right? Less potassium rather, but still 2K positive will move within the neuron, and 3Na positive will move out. Okay? This is the meaning of that pump. Are you able to understand now? Are you able to understand now what is happening here? 2 potassium ions will come within the neuron, 3 sodium ions will go out, right? So it is against the concentration gradient. Why am I saying it is against the concentration gradient? Because already within the neuron less sodium is there and we are throwing out 3 sodium ions, right? Outside less potassium is there, still we are outside less potassium is there, still from outside we are sending the potassium in, right? So these two, these leaky channels and these pump, sodium potassium ATP is pump, right? They will maintain this thing that inside is negative, outside is positive. You can compare it na. Dekho, already we have more sodium outside, still we are sending more sodium right outside, plus leaky channels are comparatively less. Okay? So more and more positive charge will be on the outer side of the neuron axon membrane, right bache? Plus within the neuron you have negatively charged, plus within the neuron you have negatively charged organic proteins, right? And they are negatively charged. These proteins cannot cross the plasma membrane, so obviously they will be within the neuron, so they are adding more to that negative charge. So these are the things which are maintaining the resting potential, and this can also be asked as a question. Understood? This can also be asked as a question, right bache? Right bache? This can also be asked as a question. So outside negative, sorry, outside positive, inside negative. Okay, so it is the state of polarization, resting potential. So how do I remember it? That when you don't do anything productive, right? When you are doing nothing, when you are taking a rest, sometimes it happens now, we feel negativity inside. We feel negativity inside. So that's how I remember that, yeah, I'm in a resting state, I'm not doing anything, I'm feeling negative inside. So negative positive means resting potential. That is how you can remember it. Okay bache, that is how you can remember it. Clear bache? Clear bache? So what's that? It is the polarization. What is it? It is the polarization. Now come to the diagram, right? Now let's say there is a stimulus. I told you it should be above threshold value. So stimulus mane, there is a point, right? When there will be when cell, this neuron will receive the stimulus, what is going to happen? There will be the influx of sodium, right? Influx of sodium. Again, it is an important question. Again, it is an important question. When the neuron will receive the what? When it will receive the stimulus, influx of sodium ion will be there. More and more sodium will start moving in. Actually, bache, when it is in the state, resting state na, there is one very important thing, right? The neuron membrane, right? Neuron membrane is more permeable. Neuron membrane is more permeable to potassium. Membrane is more permeable to potassium than sodium when neuron is in resting state. When neuron is in resting state. When bache? When neuron is in resting state. Are you getting it? This is something very, very, very important. When a neuron is not conducting any nerve impulse. When a neuron is not conducting any nerve impulse, the membrane is more permeable to the potassium ion in comparison to the sodium ion. Okay, this is a rule. Okay, this is a rule. Clear bache? Now, when it will receive the nerve impulse, what's going to happen? Suddenly the membrane polarity will change, right? When it receives, yes bache, when it receives nerve impulse, yeah, when it is receives stimulus, the membrane polarity will change, right? What is going to happen? Membrane polarity will change, right? Why? Now it will be more permeable to sodium than potassium, right? So what is going to happen? So when it receives the action stimulus, what is going to happen? Its permeability changes, right? Its permeability changes. Permeability should be the word, right? Membrane permeability will change, right? Membrane's permeability will change. It will be more permeable to sodium than potassium, right bache? Right bache, then potassium. So sodium ion will move within. Sodium ion will move within, right? It will come, there will be the influx of sodium. Now when there is the influx of sodium, more and more sodium has started moving in. So according to you, what kind of changes can be there? What kind of changes can be there? There is the influx of sodium. So now, because there is the influx of sodium, don't you think that that resting potential will change? Right? When neuron was resting, this was the resting potential. Now there is the, when it receives the stimulus, there is the influx of sodium, resting potential will change. It will start moving towards the positive side. Right? That potential difference across the membrane will change. And now when there is a change in the potential difference, so it will also open voltage gated ion channel. Right? It will also open voltage gated ion channel, and here it will be voltage gated sodium channel. More and more sodium has started coming within the neuron membrane, right? But within the neuron, so what is going to happen? The membrane permeability will change, right? The potential difference across the membrane will change, and when it will change, obviously it is going to open up the voltage gated sodium channels. So once they are open, more and more sodium will come within, and inside will become positive and outside will become negative. Inside will become positive, outside will become negative, and this is the depolarization. This is the depolarization, right? What is it? It is the depolarization. Clear bache? Clear bache? Depolarization. So that is how the membrane polarity will reverse. Now you know that current moves from positive to negative. So at this point of time, it has received the stimulus, it has passed it to, this stimulus should pass throughout the length of the axon. Now from plus to minus, the movement will be there. Just say it was like this now. It was like this now. Let's say this is the site A. Now current will move from plus to minus, from plus to minus. It means, let me show you this thing. It means now at point B, this is the thing that is going to happen now. Okay, bache? So at the point A, when it receives the nerve impulse, this is the point B. We have to conduct it. We have to conduct it. So current will move from plus to minus. So obviously this is how the movement will be. So now the nerve impulse will pass to the point B. Okay? So here, right, inside will be positive, outside will be negative. So that is how throughout the length of the axon, the nerve impulse will be conducted. Now if you are thinking that why, ma'am, why there is the reversal of polarity here, right? If you are thinking that why there is the reversal of polarity here, so let me explain this to you. Okay, let me explain this to you, because bache, this membrane is for a very less time, it is having this thing that it is more permeable for the sodium. Its polarity will immediately reverse, right? Its polarity reverse immediately. Okay, its polarity reverse immediately. Okay, just say for a moment, just say let's say you are, right, let's say you are in a relationship. Okay, you decided to cheat. Okay, you decided to cheat, that I am going to cheat, right? You started liking someone else and you are like, oh my god, I like that person, I will cheat. But immediately you are like, no, I cannot do to that person who's trusting me. It's like that. It is like that, right? That for a very short span of time, you were thinking, nahi yaar, I will cheat. But now then you realize, no, I'm a good man, I'm not allowed to, I should not. It's like that, right? Sorry, it's a bad example, but that is good. Just say for when it will receive the stimulus, neuron will be like, yaar, chalo, let's change the polarity. Now I will be more permeable for the sodium in comparison to the potassium. But it will again realize, no, I cannot ditch my potassium. Let's come back to the same situation. Let's come back to the same situation, right? So immediately it will be like, chalo, theek hai yaar. No, I cannot take it for a longer period. Let's be more permeable for the potassium only. So this is the reversal of polarity. So this is the thing, this is basically the repolarization. So immediately, right, within seconds itself, the neuron will realize its mistake and the neuron will be like, I will repolarize, right? I will repolarize. Are you getting my point? Right? Are you getting my point? Clear, bache? Clear, clear, clear. So it is like that. It is like that, right? So again, when the current will basically the nerve impulse will pass. So again, when it is the repolarization, how that repolarization will occur? The membrane's permeability for sodium for potassium will be more again, right? So at this point of time, voltage gated potassium channels will open. So this is how the nerve impulse will be conducted throughout the length of the axon, bache. Now just for your quick revision, I will make a table here, right? I will make a table here which will tell you about the ionic channels. Clear, bache? Which will tell you about the ionic channels, and it will tell you when which channel is open. ठीक है, depolarization, polarization, repolarization, hyperpolarization. You can make this table. So here you can write down the process. Here you can write down it is polarization, it is polarization, it is depolarization, it is repolarization, it is hyperpolarization. ठीक है, first of all write it down. ठीक है, then sodium potassium pump, then right, it is the sodium potassium pump, and here you can write down passive diffusion. Passive diffusion माने sodium is moving passively, potassium is moving passively. Here you will have voltage gated potassium channels, let's say voltage gated potassium channel, and here sodium channel. ठीक है, here let's say voltage gated sodium channel. Clear बच्चे? Clear, clear, clear. So when there is the polarization, for polarization, you know that sodium potassium ATPA pump will play the role. Yes. Passive diffusion will be there. Yes. Voltage gated sodium and potassium channel, they will be closed, right? They will be closed. Now when it is the depolarization, at the time of depolarization, because membrane polarity has changed, now your pump will not be active, right? At the time of depolarization, even if it is for a short span, the pump will not be active. Pump will not be active. Passive diffusion will be there as such. It will be there as such, means leaky channels will work like that. And when it is the depolarization, your voltage gated sodium channel will open, but the potassium channel will remain closed. But the potassium channel will remain closed. ठीक है बच्चे? ठीक है बच्चे? So now when there is the repolarization, again sodium potassium ATPA pump will be active. Passive diffusion is going on always like this. At this point of time, voltage gated sodium channels will be active, but potassium channel will be active, but the sodium channel will be closed only. ठीक है बच्चे? Will be closed only. And same is for the hyperpolarization. Same is for the hyperpolarization. So when it is the hyperpolarization, more and more positive charge will go outside. Clear bachche? Clear, 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 clear. So that is what you need to remember. So obviously you know that when it is the polarization, outside positive, inside negative. So somewhere minus 70 MV, somewhere plus 20 MV. Again, and if I have to consider a range, so again, right, if I have to consider a range, just say, let's say if it is repolarization or if it is hyperpolarization. So hyperpolarization may somewhere it is 85 or 90 MV, and here it is somewhere minus 70 MV. So here you can consider कि resting membrane का potential will be somewhere in range minus 62, minus 70 or 75 like this, right? Right. So this is what the potential difference is. So that is what you need to understand. Okay. So any doubt here? Any doubt here? This is all about the ionic theory. So ionic theory was a topic that is going to take time, but all the points are discussed here. Okay, all the points related to this topic are discussed here. Clear bachche? Clear, clear, clear. So do read it from NCERT, and I already told you about the impulse as well. So now let's focus on this diagram, that what exactly is the synapse. So you know that it is a pre means before. Presynaptic neuron, there will be a presynaptic neuron. Just let's say you have one neuron, second, third, fourth, right? The first neuron will be the presynaptic neuron, and the next neuron will be the postsynaptic, after synapse, postsynaptic neuron. So in between these neurons there is a gap, you will call it as synaptic cleft. you will call it as synaptic cleft. So what exactly is a synapse? Synapse include presynaptic membrane, postsynaptic membrane, and in between there is a synaptic cleft. In between there is a synaptic cleft, there is a gap. So this is the neuron ending. Okay, when nerve impulse will reach here, these neurotransmitters, they are going to fuse with this presynaptic membrane. Why? Because when nerve impulse will reach here, when nerve impulse will reach here, right and right, when nerve impulse will reach here, what is going to happen? There will be the change in the voltage. So calcium gated channels they will open. Calcium gated channels they will open. More and more calcium will come within the neuron. So when more and more calcium will be there within the neuron, these synaptic vesicle, they will fuse with the membrane here, and neurotransmitter will be released in the synaptic cleft. Neurotransmitter will be released in the synaptic cleft, and that neurotransmitter, right, just let's say if it is an, so neurotransmitter mein there are many types, right, just let's say if it is acetylcholine, if it is acetylcholine, what is it? If it is acetylcholine, right, so it is what kind of neurotransmitter? Excitatory. Jaise bachche, there are some neurotransmitter which stimulate our system, there are some which depresses it, which suppresses it, right bachche, jaise ki your glycine, jaise ki your GABA. This is important to know. Okay, this is something very important. The type of neurotransmitter, right, the type of neurotransmitter is also very important. So some are excitatory, that will excite, that will stimulate our nervous system. Some are inhibitory, that will suppress it. So if I talk about the inhibitory, neurotransmitters, you have the example of glycine, you have GABA. What is GABA? It is gamma aminobutyric acid. It is gamma aminobutyric acid, right bache? Even the dopamine is going to, it is also the inhibitory neurotransmitter. So yes, examples are important. Even the serotonin, which is the happy hormone, right bache, it is also the example of inhibitory neurotransmitter. So excitatory mein you have acetylcholine, along with acetylcholine you have noradrenaline and adrenaline. They are also the example of excitatory neurotransmitters. ठीक है, adrenaline, even the, right बच्चे, noradrenaline, norepinephrine is the example. So what's going to happen here? The synaptic vesicles will fuse, the neurotransmitter will be released in the synaptic cleft, and due to which what's going to happen बच्चे, even in the next neuron, right, the ionic changes will be there, right, this will bind to these receptors. So once it will, this neurotransmitter will bind to the receptor, ionic movement will be there, and nerve impulse will be conducted. Clear bache? Nerve impulse will be conducted. Are you getting my point? Nerve impulse will be conducted within the neuron. That is what you need to keep in your mind. Okay, so these neurotransmitters which are released here, they will immediately, right, they will again break. Just let's say if acetylcholine is there, so here you will see acetylcholine esterase enzyme will be present. It will immediately break this, right, it will immediately break it, and you will have acetyl plus choline, right, that will be resequestered by this neuron, and again acetyl plus choline will be used to make acetylcholine, right. So that's how the nerve impulse will be passed. Okay, now come to the topic of the joints, right, again it's important. I believe that you will get one question from this point, from this part, that is joints. So are you ready? Yes bache, are you ready? Let's revise the joints bache. One question can come from this part as well. So there are three types of joints, right bache? So there are three types of joints, and they are very important for the movement. Just you know that this is my 4 limbs, right? These are my 4 limbs. Humerus, revise it with me. Humerus, radio ulna, that is radius ulna, carpal, metacarpal, phalanges. Let's repeat, right? You never know, might be question can come, right? Let's talk about the skeletal system a bit. Okay, right? So if you want to revise it in detail, you can check my detailed marathon sessions. So you know that human skeleton, in the case of adult, how many bones are there? 206. How many bones are there? 206. But that baby will have 300 bones, right? ठीक है जी? How many bones will be there? 300 bones will be there. So now you have two type of skeleton. You have axial skeleton, you have appendicular skeleton. When it is the axial skeleton, total 80 bones are there. When it is the appendicular skeleton, total 126 bones are there. So now when it is the axial skeleton, it will include this axis of the body. Imagine a doll. Just let's say you have a doll. From that doll you are removing its arms and the legs. Remaining portion is your axial skeleton. So axial skeleton mein what will you have? You will have cranium, facial bones. Okay, yesterday we were practicing the questions now, so it was there. So guys, I am repeating this again. Okay, देखो, tomorrow hopefully we will be traveling. Okay, we will be traveling because all the complete panel of Unacademy NEET English will be together when it comes to the paper solving. So still I have scheduled one session for tomorrow morning at 9 AM. That is NTA authorized complete biology with 100 most important MCQs. So let's say today we are going to revise certain concepts. So tomorrow morning we are having the session where we will practice the questions from that concepts. So that will help you to revise this lecture, right? That is going to help you to revise this lecture. So this lecture is for 1 hour only, right? Or maximum 1 hour 15 minutes, not more than that. So tomorrow morning I will be taking it. So guys, quickly hit the like button. Just hit the like button. Okay. Okay, make sure that you attend the lecture tomorrow. It is at tomorrow 9 AM in the morning. Tomorrow 9 AM in the morning. So that will be the last revision of biology from my side. And after that, you just revise your diagrams, write the chemistry formula, physics formula, that's it. No need to start any new topic. So today, what are we going to do? Today we are going to revise our topic. Today we are going to revise our syllabus. You know it very well. Right? What are we going to do today? We are going to revise our complete biology. Tomorrow we will practice it. So again, it will be NTA authorized 100 MCQs that are picked up. I am going to pick up these topics from your NTA mock test only. Okay? Okay, bache, from NTA mock test only. So make sure you hit the like button and click on this button. Notify me, so you will get the notification of the lecture. You will get the notification of the lecture. So quickly hit the like button now. Right, I want you people to be there in the session. Then only I will take it. Do you want me to take this session? Yes. Do you want me to take this session? Yes or no? Do you want me to take this session? Bache, one student is asking about the application form. Guys, see, the documents which are allowed for your, right, the documents which are allowed for your NEET 2024. This is what you have to check. Things to carry in the exam center. You will get all the details. Okay, you are going to get all the details here, right? And how to fill the OMR sheet. Do not miss this video, right? Mistakes that you can do while filling the OMR sheet. Do not miss that video. Clear, bache? Come back to the topic. So axial skeleton is having cranium, facial bones. It is having your vertebral column. It is having your sternum, and it is having your 12 pairs of ribs. These things, and okay, how can I forget? Hyoid bone. Hyoid bone. It is in the skull part only, and ear ossicles. All these things are in the axial skeleton. All these things are in the axial skeleton, right? All these things are in the axial skeleton. The cranium, the facial bones, the vertebral column, the sternum, the ribs, the hyoid bone, the ear ossicles. Clear, bache? Cranium, facial bone, vertebral column, sternum, ribs, hyoid bone, and ear ossicles. These are the things of axial skeleton. When it is the appendicular skeleton, we will be talking about the limbs, both the limbs, forelimb, hind limb, and the girdles, both the girdles. Okay, both the girdles. So I am saying that most important topic here is the joints. We will also revise ribs and vertebral column, but the most important thing is the joints that you should revise. So joints they are very important for all type of movements, right? For all type of movements, they are very important, right? Involving the bony parts of the body. Okay. Okay, so locomotory movements are no exception to this. So joints are point of contact between bones or between bones and cartilages. So if I will be the examiner, I can frame the question from this particular part. Right, from this particular part, I can frame the question that what are joints? Are they the contact between bones only or between the cartilages? So if you don't pay attention, you can make the mistake here. They are also the point of contact between the bone and the cartilage as well. So force is generated by the muscle which will carry out the movement through joints, right? So joint, they are acting like a fulcrum. Clear, bache? It is acting like a fulcrum. Muscle is exerting a kind of फोर्स बच्चे, राइट, एंड जॉइंट्स विल हेल्प इन कैरिंग आउट दैट मूवमेंट. ठीक है बच्चे. सो वी हैव 3 टाइप्स ऑफ जॉइंट्स, फाइब्रस, immovable, right, very slightly movable and completely movable joints. ठीक है. So 3 type of joints are there, fibrous, cartilaginous, examples are very important guys, cartilaginous and synovial joints, synovial joints. So as I said, this one is immovable, immovable, no movement at all. This one is slightly movable, this one is slightly movable, and this one is freely movable, right? Or you can say that completely movable. These are the 3 things that we have. These are the 3 things that we have. So this one is synarthrosis. That's the word that you are going to use here, synarthrosis, right? That there will be no movement, right? There will be no movement. This is synchondrosis. It is cartilaginous, na? Synchondrosis. This is another name for cartilaginous joints. And last one is diarthrosis. Last one is diarthrosis. These are the words for these joints. So when you are talking about the immovable, the fibrous joint, you will see it in the case of sutures, right? Just you have the skull, cranium, na? So cranium mein, skull bones are fused. They will have sutures. They will have sutures in between. So there is no movement in the skull bone, right? There is no movement in the skull bone. Just focus here. The bones involved are joint, sorry, they do not allow any movement, fibrous joint. Jaise flat skull bones fuse end to end with the help of dense fibrous connective tissue in the form of sutures. So cranium mein, cranium is your brain box. Bones are fused, right? They are immovable. They are having sutures. They are having sutures. So basically these bones, they are fused end to end with the help of dense fibrous connective tissue. Dense fibrous connective tissue. So this is your MCQ. So example, or this dense fibrous this dense fibrous connective tissue. Now when it is the cartilaginous joint, what is it? Now when it is the cartilaginous joint, the bones involved are joined together with the help of cartilages, right? The bone, right, they are joined together with the help of cartilages. So what is the best example here? The joint between adjacent vertebrae in the vertebral column is of this pattern. So this is the MCQ. Just you know na, in the vertebral column you have the vertebrae. In that vertebrae, it is unique to mammals. Intervertebral disc is there. Intervertebral disc is there. Do you know that? Right, so that is the example here. Then synovial, which are movable joints. And what is the characteristic feature here? What is the characteristic feature here? Let's say this is one bone, this is another bone. Here you have the synovial membrane, and in between you will be having the synovial fluid. You will be having the synovial fluid. So synovial membrane is going to form this fluid. So it is what? It is freely movable. It is freely movable. Clear, bache? Clear? So you can relate the arthritis, rheumatoid arthritis here. Rheumatoid arthritis is an autoimmune disorder. What kind of disorder it is? It is an autoimmune disorder where there is the inflammation in the synovial membrane. Are you getting my point? Where there is the inflammation in the synovial membrane. So that is what you need to keep in your mind, students. That is what you need to keep in your mind. Clear, bache? So it is the freely movable joint, right? Right. So synovial cavity is there in between two articulating surfaces of two bones. So this arrangement will allow the considerable movement. ठीक है बच्चे? So ball and socket kind of joint, right? Ball and socket. जैसे ये देखो, humerus pectoral girdle, humerus pectoral girdle, humerus pectoral girdle. ठीक है? Hinge joint, your knee joint and your elbow joint. Hinge, hinge. जैसे you have the laptop, no? Hinge, hinge. ठीक है? Pivot joint. It is in between atlas and axis. What is atlas? Atlas is your first vertebra. What is atlas? Atlas is your first vertebra. What is axis? Axis is your second vertebra. Axis is your second vertebra. Gliding joint in between carpals. Saddle joint between carpals and metacarpals of the thumb. So examples are important. Examples are important. Understood? Examples are important. Clear, bache? Clear, clear, clear. Clear. Next is the vertebral column. Okay? So you know that this is the vertebral column. So come to lunch, stay calm. Everyone, come to lunch, stay calm. Come to lunch, stay calm. Repeat it with me. come to lunch, stay calm. Hanji, come to lunch, stay calm. Yes, come to lunch, stay calm. Everyone repeat it. Right? So it means CTLSC, CTLSC, cervical, thoracic, lumbar, sacral, coccyx. 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 Repeat it. This is what your vertebral column is. So if you will see, right, जैसे ये देखो cervical, thoracic, then lumbar, then sacral and coccyx. So lumbar, this curve, right, these are the curves in the vertebral column. Na? These curves are providing us the bipedal locomotion. Right, it is providing us the bipedal locomotion. Right, right, bache. So you can see this lumbar. How is it directed? Right, so some curves are forward directed, some are backward directed. Right, this lumbar, you can see here. Right, this lumbar, bache. Yes or no? This lumbar curve, you can look at it. Some curves are backwardly directed, some are forwardly directed. Clear, bache? Some are forwardly directed. Right, so basically what you have to see in these, in this vertebral column, there will be the vertebrae. In between there is a central canal. From that central canal, what will happen? Your spinal cord will pass, and in between these two there will be the intervertebral disc. This is what you have to remember. Right, bache? So it is CTLSC, 7 cervical vertebrae, 12 thoracic, 5 lumbar, sacrum and coccyx. They are 5 or 4. They are fused like this. They are fused like this. So if you talk about the vertebral column, so before fusion, if you talk about the vertebral column, before fusion it is 33, after fusion it is 26. Before fusion it is 33, after fusion it is 26. It is 26. You can even count. Right, so basically in a baby it is around 33, and then bones will fuse, it will become 26 in an adult. Right, it will become 26 in an adult. So before fusion 33, after fusion 23. So cervical, thoracic, lumbar, sacral, coccyx. So sacral is formed by the fusion of 5 bones, coccyx is formed by the fusion of 4 bones. So they will fuse and they will form 1 bone. They will form 1 bone. This is what you have to remember. This is important. Okay, जैसे sacral 1 fused, coccygeal 1 fused. Right, right. So cervical vertebrates, they are 7 in most of the mammals. Even if you talk about the camel, camel is having a very long neck, still 7 cervical vertebrae are there. Okay, 7 cervical vertebrae are there. So that is what you need to know, and in between intervertebral disc is there. Okay, intervertebral disc is there. Clear, bache? Baki, this is on the dorsal side. Let's talk about the ventral side. You are having the sternum, the flat bone, the dagger shaped bone. Okay, sternum is there. I always, whenever I explain sternum, I always give the example of a tie. It's something like this. It's something like this. Okay. Now the another important question is 12 pairs of ribs. 12 pairs of ribs. Your ribs are flat bones and they are bicephalic. They are flat bones and they are bicephalic. They are bicephalic. What are they? They are bicephalic. Just let's say this is your rib. Okay. So when you talk about the ribs, I told you 12 pairs are there. But first 7 pairs, right? First 7 pairs. What are they? They are the true ribs. First 7 pair, they are the true ribs. They are also known as vertebrosternal ribs because they are attached dorsally to the vertebral column and ventrally to the sternum. The question will be asked. For sure the question will be asked, so please pay attention. Now 8th, 9th or 10th pair. 8th, 9th or 10th pair. It is of false ribs. Why? Why? Because it is vertebrochondral. Right? It is vertebrochondral. What's that? It is vertebrochondral. Right? So it is attached to the vertebral column. It is attached to the vertebral column. Then it is attached to the cartilage. Right? Then it is attached to what? Then it is attached to the cartilage. So this part clear? It is the vertebrochondral. Hanji. This part clear? That it is the vertebrochondral. Tell me. Quick. It is the vertebrochondral. Quick. And a false ribs. And last is the floating ribs. Last will be what? Last will be the floating ribs. 11th or 12th pair. 11th or 12th pair. But one question will come from this part. So these are the floating ribs that also protect your kidneys. So floating ribs are nothing but they are just the vertebral ribs. Why? Because they are only attached to the vertebral column, right? Let me explain it how. ठीक है, first 7 pair, 8th, 9th or 11th, 12th. Now dorsally they are attached to vertebral column. Let's say this is your vertebral column. Now it is bicephalic. Bicephalic. What's that? It is bicephalic. Bicephalic. So this rib, right? This rib. See dorsally here. It will be having two heads. It will be having two heads. It will be having two heads for the articulation with the dorsal vertebral column, right? It is having two heads for the articulation with the vertebral column. So vertebral column mein these ribs, they are mainly attached to, very specifically if I have to talk, it is attached to thoracic vertebrae, right? It is attached to thoracic vertebrae. ठीक है, okay, जैसे this is the complete rib cage that we have. It is the complete rib cage that we have. Ventrally sternum, ठीक है, this is what we have, right? So what do we have, bache? Ventrally we have the sternum, laterally we have the ribs, and dorsally we have the vertebral column. So this is bicephalic. That is how it will be attached here. So dorsally it is attached to the vertebral column, ventrally it will attach to the sternum. Clear, bache? So bicephalic word should be clear to you. So first 7 pairs, they are true. They are attached dorsally to the vertebral column, ventrally to the sternum, and here when they are attached to the sternum, here also you will see hyaline cartilage, also known as costal cartilage is there. Costal cartilage is there, right? Now, bache, when you talk about the 8th pair, I told you na, जैसे let's say this is 1, let's say this is 7th pair, ठीक है? Let's say this is 1, let's say this is 7th pair. Now it is 8th, 9th and 10th. 8th pair will also be attached to the 7th pair. 9th pair and 10th pair will be attached to the 7th pair. Why are we saying they are false ribs? Because they are not directly articulating with the sternum. Why are we saying these are the false ribs? Because they are not directly articulating with the sternum. They are having the hyaline or costal cartilage. They are having the hyaline or costal cartilage, and with the help of that hyaline and costal cartilage, they will be attached to the 7th pair of rib. They will be attached to the 7th pair of rib. Then 11th, 12th, it is just attached to the vertebral column, not at all concerned with the sternum. That's what you have to remember. Okay, that is what you have to remember. So this is what your rib cage is. So rib cage mein you can see how things are present. Okay, right? And you know that this complete structure is forming the rib cage, also known as thoracic basket, right? Also known as thoracic basket. So it is anatomically airtight chamber. So we will discuss about it in the breathing and exchange of gases. Okay, in the breathing and exchange of gases. Okay. Now let's talk about the muscles and the sliding filament theory. Any doubt? Any doubt? Just for your quick revision. Cranium, 8 bones. Facial, 14 bones. Ear ossicle, 3 here, 3 here. Total 6. Right? Malus, incus, stapes. The trick is miss has. The trick is miss has. Right, bache? The trick is miss has. So it is malus, it is incus, it is stapes. These are the 3 ear ossicles. So miss has means this is like this. Miss has. Malus, hammer shaped. Incus, anvil, okay, stapes, stirrup. This is about the shapes. So stapes is the smallest ear ossicle and it is the smallest bone of our body. It is the smallest ear ossicle and it is the smallest bone of our body. Clear, bache? It is the smallest ear ossicle and it is the smallest bone of our body. Understood? Understood? Sure? Sure? So malus, incus and stapes. Malus, incus and stapes. Malus, incus and stapes. So hammer shaped anvil stirrup. Hammer shaped anvil stirrup. So it is the smallest ear ossicle. What is it? It is the smallest ear ossicle. Clear, bache? Clear, bache? Sure? Are you sure? Right? So cranium 8, skull bone 8, facial 14, ear ossicles total 6, hyoid bone is also there. Hyoid bone, it is the part of skull. Hyoid bone, which is not articulating with any other bone. It is the U-shaped bone which supports the tongue. It is the U-shaped bone which supports the tongue. Okay? So that is for your quick revision. Now we'll be talking about the muscles. Okay? We will be talking about the muscles. So muscles mein, especially the skeletal muscle, do revise the differences in the muscles. Do revise the differences in the muscles. You know na, smooth muscles, they are smooth because they don't have striations. They are uninucleated, they are fusiform, they line the hollow organs of our body, जैसे alimentary canal, uterus, blood capillaries. ठीक है. Then skeletal muscles, due to which voluntary movements are possible. I am doing this because of skeletal muscles. Voluntary movements are possible, right? Voluntary movements are possible. Skeletal muscles are also having striation. In this chapter, that is what we are going to discuss. Now, when you talk about the cardiac muscles which will never undergo fatigue. Skeletal muscles which will undergo fatigue very quickly. That is why lactic acid accumulation is there in the muscles. Then your smooth muscles, that will also take very, take time for the fatigue. But heart muscles, they will work continuously, right? They are not going to stop. And when you people talk about the heart muscles, right, they are also having the striations, they are branched and they work together as a unit. So this is something that I repeat so many times, that when it comes to the cardiac muscles, you will see intercalated disc. What will you see? You will see intercalated disc, right? Just say that membranes, their plasma membranes, they are fused so that they can have continuous, right bache, so that they can have continuous, right? They can have continuous flow. That gap is there. Okay, it's a kind of gap junction there. Okay, cardiac muscles. Okay. Okay, so muscles में, skeletal muscles में, this is what we need to discuss. So muscles में anatomical unit, I'm not saying functional unit, anatomical unit is muscle fiber. Anatomical unit is muscle fiber. This is something that will form the structure. Okay, but when you talk about the functional unit, right, functional unit of muscle fiber, that functional unit will be sarcomere, because it will undergo contraction and relaxation. It will undergo contraction and relaxation. Are you getting my point? It will undergo contraction and relaxation. Okay, so anatomical unit is the muscle fiber. So basically what is happening, let's say there is a muscle. Please understand this thing. It is a muscle. This muscle is made up of muscle bundles. Okay, you have a muscle and that muscle is made up of muscle bundle. Okay, just a minute guys. One second. So you have a muscle, okay? So muscle is made up of muscle bundles, right? In muscle you will see there are so many muscle bundles. There are so many muscle bundles which will make the muscle. Okay? There are so many muscle bundles which will make the muscle. So when you talk about the muscle bundles, so muscle bundle is also known as fascicle, right? Muscle bundle is also known as fascicle, right? They are known as fascicles, muscle bundles, fascicles, muscle bundles, they are known as fascicles. Are you getting my point? So just say imagine this is one muscle bundle, this is another muscle bundle. So you have to keep them together. You have to keep them closer like this, right? So obviously there should be the connective tissue sheath which should bind it, right? And when I'm saying the word connective tissue sheath, I am talking about sheath is for dense irregular, cord is for dense regular tissue, right? Sheath is for dense irregular, cord is the word for dense regular tissue. Okay, dense irregular, okay, cord and sheath. Okay, so now muscle bundles, these are known as fascicles. So these muscle bundles are held together by a connective tissue sheath. Okay, right? So that connective tissue sheath, right, that connective tissue sheath which keep these muscle bundles together is known as fascia. That is known as fascia. What's that? That is known as fascia. Clear bache? that connective tissue sheath is known as fascia. So muscle bundles, they are all together. So this is the fascicle and you have the connective tissue sheath, fascia. This point clear? This point clear? Now within these muscle bundles you will see the anatomical unit, that is muscle fiber. These greenish structures that I am making, this is what? This is the muscle fiber, right? This is the muscle fiber. So now when you talk about the muscle fiber, right, so can I say that many muscle fibers together are making muscle bundles and many muscle bundles are making muscle? This is actually the ultrastructure of muscle. This is actually the ultrastructure of muscle. So I am saying that many muscle fibers together they are making muscle bundle, many muscle bundles together they are making muscles. Obviously I can say so. So when you talk about the muscle fiber, so the outer covering, that outer covering of muscle fiber will be sarcolemma. It will be sarcolemma, and here within you will see sarcoplasm will be there in the muscle fiber. Let's say if this is the muscle fiber, right, the endoplasmic reticulum of muscle fiber will be sarcoplasmic reticulum, which is the storehouse of calcium, which is the storehouse of calcium, right? So you have the muscle fiber. So the outer covering of muscle fiber is known as sarcolemma, right, and within it there will be the sarcoplasm, and you will see sarcoplasmic reticulum there. Sarcoplasmic reticulum there, from where the calcium ions will come out. This is what you need to remember. One more thing here, bache. So this is the muscle fiber. It is basically syncytial. Syncytial means it will be multinucleated. It will be multinucleated. Okay? So let's say this is a muscle fiber. This is just again for your understanding. This is a muscle fiber. So in this muscle fiber you will see there are some parallelly arranged myofibrils. There are parallelly arranged myofibrils. What will be there? There are parallelly arranged myofibrils. They are present in muscle fiber. Okay? They are present in muscle fiber. Now when you look at these myofibrils, let's say I am going to zoom this. So when you see these myofibrils, so these myofibrils are having some bands. Do you know that? These are the myofibrils that are having some bands, okay, and that bands are giving it striations. That is why we say that skeletal muscles are striated, right? These myofibrils are having that band, and you know that it is about the sarcomere. We will discuss about it. Okay? One more thing that you need to know is that when you talk about this muscle fiber, the sarcolemma, at points it forms invagination. At points it forms invagination, right? These muscle fibers at points they form invaginations, and you will, right, these invaginations are nothing, you will call them as T-tubule. What will you call it? You will call it as T-tubule. T-tubule. And here in its surrounding, here you will see the sarcoplasmic reticulum, these invaginations, and here myofibrils are present. As of now, this is what you need to understand. Then we will talk about the sarcomere. Okay? So that myofibrils are that protein fibrils which are having that striations. Clear, bache? Which are having that striations. Clear? So let's revise it. So up to this part all clear? Hanji, up to this part all clear? If there is any doubt, do let me know. Hanji, is it clear? Okay? So look at this. Just say there are some bands, okay? Myofibrils. So myofibrils में there are some bands. ठीक है? You will see I band, you will see A band, I band and A band. I is isotropic. I, light band, right? Light band. I is the word. A band, dark arc A. Okay, it's dark arc A. So anisotropic it is, and dark arc, dark band, right? Dark band is there, right? Dark band is there. Clear, bache? Clear? So I band, right? This I band, it is having actin, actin, A, dark band. Here you will see myosin and actin, right? No doubt, majorly it is the myosin which is present, but actin is also there. Actin is also there. So how do you need to remember this? Dark band, arc band. Just in the dark phases, our friends, they support us. In the dark phases, our friends, they support us. Dark band, our friends, they support us. Arc, dark, है ना? Our friends are, they support us. So same way में dark band में you will have myosin and you will have actin. You will have myosin and you will have actin. ठीक है? You will have myosin and you will have actin. So I band, it is the actin, thin. It is the I band, it is actin, thin. So it will be having the thin filament, it will be having the thick filament. First of all, understand this thing, right? But in human physiology, because it is making the major portion, human physiology mein and plant physiology mein speed will be comparatively slow. Then after that I will be a bullet train. Okay? So I am just telling you this thing. Please be very sincere. Please listen to me very carefully. If you will feel that students are not interested in studying, I am not going to waste your time. I will end the class. The reason is your time is crucial. If you don't want to study in the lecture, you are just chit chatting, I will say, okay, I'll end the class. You just chit chat or you should study. Are you getting my point? You will get the break. But let me finish this topic. Let me finish sliding filament theory. Then there will be a break. Okay? Then there will be a break. Okay? Then there will be a break. Okay? So this part clear, this part clear here, this part clear. So now when you look at this arrangement, this pinky one is the I band, this yellowish one is the A band, and here this is again the I band. Okay? Now in this I band is bisected. What is the meaning of being bisected? What is the meaning of being bisected? It is divided into two equal halves. When you talk about the I band, right? When you talk about the I band, what do you discuss? When you talk about the I band, so it is bisected, right, bache? What is there? It is bisected, right? It is bisected. Clear, bache? Clear. What is it? It is bisected, right? So it is bisected by an elastic fiber, right? So this is nothing but it is an elastic fiber. You will call it as Z line, right? You will call it as Z line. So I band is bisected. Okay, what's the point, bache? I band is bisected. Okay, what is the point, students? Again, I'm telling you, I band is bisected. Understood? Understood? I band is bisected. It is divided into two equal parts. Now when you look at the A band, okay, A band mein, this portion is of A band. In this A band, there is a region where only myosin is there. Actually, this yellow colored is myosin. This thick filament is myosin. This pinky is actin. Okay? Myosin is also attached to the Z line, but with the help of a titin protein. With the help of titin protein, this myosin is also attached to the Z line. Okay? This myosin is also attached to the Z line. So if you will see the A band, so in this A band there is a zone where only myosin is there. It is the H zone, right? So in H zone only myosin is there. Actin is not overlapping it. Like this complete part is your A band. Can you see that? This complete, can you see that? This complete band, this complete thing is your A band. So in this A band, you are having the H zone. You are having the H zone, and that is nothing but the Henson zone. that is nothing but the Henson zone. ठीक है, where myosin is not overlapped by actin. ठीक है, okay, is it clear? Is it clear? And here right in between there will be the M line. What will be there? There will be the M line. Okay, in between what will be there? There will be the M line, and that is nothing but a thin fibrous membrane which is held together, which will held together all these myosin. Okay, so it is thin fibrous membrane. It is thin fibrous membrane. So these alternate dark and light band, alternate dark and light bands, right? These alternate dark and light bands, students, they are making that striations. Okay, they are making that striations. So tell me, up to this point all clear? Up to this part all clear? Hanji, up to this part all clear? Okay, so now look at this part. These two Z line, these two successive Z line, they are making the sarcomere. Right? These two successive is one after another. These two successive Z lines, they make sarcomere, which is the functional unit of contraction. So during contraction, it is the one that will undergo the contraction and relaxation, right? It will decrease its size and then come back to the same position. It is like this, right? It is like this. Is it clear? Is it clear? So it is the functional unit of contraction. What is it? It is the functional unit of contraction. Clear, bache? What is it? It is the functional unit of contraction. Okay? Okay? It is the functional unit of contraction. So in between two successive Z lines. So can I say that two half I band and one A band? Can I say so that two half I band and one A band forms the sarcomere? Can I say so? Two half I band and one A band, it forms the sarcomere. Just see this. In between two Z lines there is a sarcomere. So two half I band and one A band will form the sarcomere. Two half I band and one A band, it will form the sarcomere. Can I say so? Of course we can. So it is the functional unit of contraction. Now the next part. So this diagram clear? This diagram clear? Bache, it is important. This diagram clear? Right? Yes, yes, yes. Tell me, is it clear? Yes or no? Is it clear? Yes or no? Is it clear? Yes or no? I think it is. है ना? I think it is. Right? Just a minute. Okay, so this is about the sarcomere from where the question is going to come. So now if you want to understand the sliding filament theory, so before understanding the sliding filament theory, the structure of these filaments should be clear. Okay, you need to understand the structure of the filaments, right? You need to understand the structure of the filament. Is it clear? What you need to understand? You need to understand the structure of the filament. Let me tell you, let's start with the thin myofilament. Okay, let's start with what? Let's start with the thin myofilament. What we need to start first, students? We need to start the thin myofilament. Can we? Yes, we need to start the thin myofilament. So what is thin myofilament? Hanji, what is thin myofilament? Tell me quickly. What is thin myofilament? What is thin myofilament? Anyone? Actin it is. So when you talk about the thin myofilament, no doubt it is having the actin. You need to talk about the actin first. So what's going to happen, bache? You will talk about the G actin first. What is G? G is globular actin. G is globular actin. Just say, let's say this is your G actin, right? Globular actin. It is the monomer. What's that? It is the monomer, right? G actin is the globular actin. It is the monomer, right, bache? It is the monomer. Now what's going to happen? This G actin, it will polymerize, right? It will polymerize, and for polymerization even magnesium ion is also important, right? You can write it down. Magnesium ion is very important for it. So it will polymerize. So when it will polymerize, it is going to form F actin. That is your filamentous actin, right? That is your filamentous actin. That is your fibrous actin, and that is basically the polymerized one. That is basically the polymerized one. So G actin is the globular. It is having the monomer units, single units. It will polymerize. It will form F actin, right? It will polymerize. It will form F actin. So now two F actins, right? Two filamentous actin, they will be helically coiled like this, right? Two F actin, they will be helically coiled like this. Now you will talk about, in the case of thin myofilament, you will talk about one another protein, that is tropomyosin. That is tropomyosin. Which protein is it? Tropomyosin. Students, in the globular actin, this is the globular actin, this will polymerize, this will form filamentous or fibrous actin. So in this globular actin, you will see there is a site that will bind to myosin, right? There is a site that will bind to myosin. So it is myosin binding site. In the globular actin, what you people will see, that there is the myosin binding site. What you people will see, that there is the myosin binding site. Is it clear? Is it clear? In the G actin. In the G actin. Can you see that? Can you see that? Now I am talking about the another protein, that is tropomyosin. So just imagine this is the structure that you have here. Okay, this is the F actin that you have here. So you can see it is helically coiled. So throughout the length of this F actin, guys, please listen to me. Right, please listen to me. So throughout the length of the F actin, you will see, right, that there is the tropomyosin. Sorry, there is the tropomyosin that will cover it. Just say, let's say you have a copy, right? You are putting a cover over it, right? You have a copy, you are having a cover over it, right, bache? Right? Yes? Is it clear? Is it clear? Yes? Right, so F actin is covered by the tropomyosin. So tropomyosin will also cover it throughout the length, right? Tropomyosin will also cover it throughout the length. Okay? So that is what you need to remember. Okay, that is what you need to remember. This is the first thing, tropomyosin. So why this tropomyosin is covering the F actin like this? Because it has to make sure that the sites which can bind to the myosin, the sites which are present on actin that can bind to the myosin, they should be overlapped, they should be covered. Are you getting my point? They should be overlapped, they should be covered. Are you getting my point? They should be overlapped, they should be covered. Okay? Okay? So that is what you have to remember. Okay? That is what you have to remember. Right? Right? Is it clear? Is it clear? So there is another protein that is known as troponin. There is another protein that is known as troponin. So troponin is a trimeric protein. Troponin is a trimeric protein. What's that? It's a trimeric protein. So troponin, trimeric. So troponin, it's like this. It is like this. Trimeric protein it is. Right? So here throughout the, you will see that this is how troponin is also present on this thin myofilament. So that is important. That is important. Please mark it. That is important. Now when you talk about the troponin, there is a trick here, that is troponin tick. So we have three troponins, right? They are joining and they are forming this trimeric protein now. So troponin T, I and C. So it's tick. Everyone repeat it. It's tick. Right? Everyone repeat it. It's tick. Yes, it's tick. Yes बच्चे, is it clear? It's tick. Is it clear? Yes or no? Is it clear? Yes or no? Tell me, is it clear? Yes or no? It's troponin tick. What is it? It is troponin tick. Everyone repeat it with me. It's troponin tick. It's troponin tick. It's troponin tick. Okay? So what is the meaning of tick? See, T is the part of troponin that will bind with tropomyosin. Okay? C is the part of troponin that will bind with calcium ion. I is the part of troponin that is basically inhibitory, means it will not allow the actin to bind with the myosin. It will not allow the actin to bind with the myosin. So imagine it like this. Just let's say this is your actin filament. It is covered with your tropomyosin. That, and then in that part you will see, right? What will you see here? What will you see here? What will you see here? That troponin is present like this. Right, troponin is present like this. Guys, from my side audio is fine. I can check it in my laptop, I can check it in my mobile phone. From my side audio is fine. Moreover, even I asked the team from the back end, there is no issue with the voice. If you are just here for the spamming, please don't do it. Please don't do it. I don't have time to waste. Secondly, students, it's a humble request. The session is very important, right? I am picking up the most important topics from the physiology, from the genetics, from the evolution, from all the chapters here. Okay, okay, from all the chapters here, right? And that is something very important for the students, right? Some students are, they are literally counting this lecture only. Okay, so kindly focus here. Kindly focus here. Okay, so this is the thin myofilament. Now, let's talk about the thick myofilament. Let's talk about the thick myofilament. So when it is the thick, so thick myofilament is having what? It is having the myosin protein. Myosin. So here you are having the meromyosin. Meromyosin is the monomer here. Meromyosin is the monomer here. So many meromyosins, they will join and they will form the myosin. Many meromyosins, they will join and they will form the myosin. Is it clear? Many meromyosin, they will join and they will form the myosin. Clear bache? Clear, 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 clear. So meromyosin is having two parts. Meromyosin is having two parts, right? Meromyosin, it is having two parts. Which two parts are there? Heavy meromyosin, light meromyosin. Heavy meromyosin, light meromyosin. So heavy, I'm writing it here. Heavy meromyosin, light meromyosin. So when you people talk about the heavy meromyosin, it will be having a globular head and a short arm. Globular head and a short arm. And here you will see the tail. Right, here you will see the tail. Now this globular head is an active ATPase. It is an active ATPase. So it is your NTA's favorite question. Which part of the meromyosin is having active ATPase? That is your heavy meromyosin. That is your heavy meromyosin. That is your heavy meromyosin. Let me draw it. It's something like that. Just this is the tail part. This is the tail part, right? So this is your light meromyosin. This is your light meromyosin. Now here you will see this globular head and a short arm. So this globular head will have sides. This globular head will have sides, right? This globular head, it is going to have the sites, actin binding site and the ATP binding site. So this site is your actin binding site, this site is your actin binding site, and these two are ATP binding site. So it is the globular head, okay, that is an active ATPase, and this part is a short arm, so it is making heavy meromyosin. That is something important. Okay, that is something important. So you can just check this diagram. Right, so yes, question will directly come from the diagram. Question will directly come from the diagram. Clear bache? Clear bache? So there is the light meromyosin, there is the globular head, there is a short arm, right? So you have the cross arm and light meromyosin. ठीक है. So actin binding site is also there, ATP binding site is also there. So what is going to happen? What is going to happen? See, now many meromyosin, they will polymerize. Can you see that? They will form the thick filament. Many meromyosin, they will polymerize. They will form the thick filament. So if it is arranged like this, just imagine, if it is arranged like this, so one meromyosin, another meromyosin, another meromyosin, one meromyosin, another meromyosin, another meromyosin. If you talk about this, okay, if you talk about it, right, bache? So can I say that at regular intervals the head of the myosin, they are, you know, projecting out? Can I say that? Just see, this is one meromyosin, this is next, this is next. So can I say that at a regular interval their head is projecting out? Can I say that at regular interval their head is projecting out? Yes, bache? Yes, bache, can I say so? Yes, bache? Can I say so? Can I say so? At regular intervals it will be like this. So now this structure, this is the structure that you need to understand when it comes to the sliding filament theory, right? If you want to understand the sliding filament theory, firstly the structure should be very clear to you. The structure should be very clear to you. So see, this is your neuron ending, okay? This is your muscle. Neurotransmitters will be released here and obviously muscle contraction will start. So this junction is nothing but it is the neuromuscular junction. This junction is nothing but it is the neuromuscular junction. It is the motor end plate. This is the neuromuscular junction. It is the motor end plate. Are you getting it? Neuromuscular junction, motor end plate, it is the neurotransmitter will be released here. Okay? So this is the muscle fiber. Let's say the neurotransmitter is released here. When neurotransmitter will release now, can you see that neurotransmitter will travel here? This is what? This is the T tubule. Now when you look at this T tubule now, this T tubule may on its sides it is having nothing but it is having the sarcoplasmic reticulum. Right? When the nerve impulse will reach here, what is going to happen? What is going to happen? Right? When this neurotransmitter will reach here, nerve impulse will reach here. This is the invagination. This is the T tubule. Right? This is having the sarcoplasmic reticulum. This is having the sarcoplasmic reticulum. Right, bachi? This is having the sarcoplasmic reticulum. What is going to happen here? The calcium ion will be released. Right? What is going to happen here? The calcium ion will be released. Right? Calcium ion will be released. And this release of calcium is very important for the muscle contraction. Are you getting my point? This release of calcium is very important for the muscle contraction. Are you getting my point? This release of calcium is very important for the muscle contraction. Now, once this calcium ion is released, right, what is going to happen? I told you the structure here. I told you the structure here. See, look at this sarcomere. Look at this sarcomere. This is the thin filament. This is the thin filament. This is the thick filament. Thin filament, thick filament. So you know that thin filament, that actin is having the sites that can bind with the myosin head, and that is what we want. It is the sliding filament theory. Your actin filaments will slide over myosin. Your actin filament will slide over myosin. Right? Your actin filament will slide over myosin. Are you getting my point? Your actin filament will slide over myosin. Clear, bache? Clear, bache? Clear, bache? So when actin filament will slide over myosin, obviously actin filament, they will move towards the center, H zone will disappear. Now how is it going to happen? You know that your actin is covered by tropomyosin, which is further having troponin. Now bache, when calcium ion is released, when calcium is released here, what is going to happen? This will bind to the troponin. I told you that troponin is having three. It is trimeric. It is TIC. I told you troponin is trimeric. It is TIC. C. So that calcium ion will bind to this troponin C. The calcium ion will bind to this troponin C. So when calcium will bind to this troponin, it will slide. When it will slide the tropomyosin, and the sides on the actin, that can bind with the myosin, they'll be open, they'll be exposed. Okay? When calcium ions are in the sarcoplasm, calcium will bind with the troponin, right? So when calcium will bind to the troponin, troponin will slide. When it will slide, it will also slide tropomyosin, and the sites on the actin which can bind with the myosin head, they are exposed. They are exposed. Now, ATP will come here, right? ATP will come here. So when ATP will bind to this, this will hydrolyze, ATP will hydrolyze, right? Right, this is the this is the ATPase, ATP will hydrolyze. So when the ATP is hydrolyzed, energy is released. When the ATP is hydrolyzed, energy is released. So that energy will help the myosin head to bind with the actin. That energy will help the myosin head to bind with the actin, right bache? So just look at it. So what is going to happen bache, right? So when the ATP hydrolyze, when it is ADP plus PI, when to the myosin head ADP plus PI is inorganic phosphate is attached, so that is basically the energy which will be provided. The globular head will join with the actin and it will slide it towards the center. So when myosin head joins with the actin, the cross bridge formation is there. The cross bridge formation is there. Secondly, here they are going to ask this question, students. They are going to ask this question that what is going to happen when ADP and PI is attached to the myosin head. When they are attached, the cross bridge will form. Okay? So what is going to happen? The actin filaments, they will slide over myosin. Actin filament, they will slide over myosin. Actin filament, they will slide over myosin. Okay, bache? So once that obviously ADP and PI, they are released. So when ATP will bind again, the cross bridge will form. So it is a previous year question, Samiksha. It is a previous year question, Salman. It is a previous year question, Vijaya. Right, bache? Right, bache? That when ATP binds to the globular head, what is going to happen? When ATP will bind, cross bridge break. Right? Means that connection break. Now once that ATP will hydrolyze, ADP plus inorganic phosphate form, then cross bridge form. So when ATP bind to the myosin head, cross bridge will break. That is how they Siti, you have to revise it. That is how they Siti, you have to revise it. Is it clear? That is how you have to revise it. So these are the direct points from where the question is going to come, right? That during muscle contraction, right, these are the points that you need to take care. During muscle contraction, what will happen? Length of I band gets reduced. Length of I band gets reduced. This is the quick revision, students. Length of I band gets reduced. Please write down, these points are important. Length of A band remains same. Length of I band, it gets reduced. Length of A band remains same. A band, its length will be same, it will not change. It is the I band, it is the actin which will slide over the myosin. Okay? Then Hansen zone will disappear, but before that you have to write that length of sarcomere decreases. Right? So length of sarcomere decreases. This is the contraction now. Length of sarcomere decreases. Right, bache? So after that, obviously, if length of sarcomere decreases, it means length of myofibril will decrease. In return, that muscle will contract, of course. And then, bache, very important, H zone, that is your Hansen zone. H zone, that is your Hansen zone, they disappear during muscle contraction. They disappear during muscle contraction. H zone disappear during muscle contraction. So remember, it is the length of bands that will get reduced, but the length of actin and myosin will not change. If it is 2 centimeter actin is there, 5 centimeter myosin will they will stay as such. It's just that they are contracting, so the length of band will decrease, but the length of actin and myosin filament will remain same. Okay, length of actin and myosin filament remains same. Length of actin and myosin filament remains same. Is it clear? Is it clear? That will remain same. So that is what you need to keep in your mind. This is all about the sliding filament theory. Please take a screenshot. Please take a screenshot. And the next topic that we need to understand is neuron, and we will be talking about the urine formation and counter current mechanism in a very crispy way. In a very crispy way. So are you guys ready? Yes, are you people ready? Thanji, are you people ready? So this is what we need to understand, that is your nephron, right? Nephron. So excretion, this is the topic that we need to revise. So yes, do not forget to revise the examples of a monotalic, ureotalic, uricotalic. Okay, do not forget to revise the examples of a monotalic, a ureotalic, uricotalic. Clear bache? Clear bache? And tomorrow morning you guys can see, tomorrow morning I will be taking a, right, I will be taking 100 MCQ revision which will be having the question from this particular topic, right? From that today's marathon, right? From today's marathon, I'm going to pick up the questions here, most important concepts here, and this is what we are going to practice tomorrow morning 9 AM. So please stay tuned to this, and after my class your Wazeem sir is going to take the session. Okay, where chemistry revision will be there. So up to this part all clear. So nephron. So nephron is the functional, structural and functional unit of kidney. It is the structural and functional unit of kidney. You know it very well. And in each kidney there are near about 1 million nephrons. In each kidney there are about 1 million nephron. How many nephrons are there in each kidney? There are 1 million nephron. Okay, 1 million nephron are there. So when you look at the structure, okay, when you look at this structure, see this. This is the structure, right? This is the structure, right? This is the structure, right? Right, nephron it is. So see this. It is something like this, right? Directly let's come to the point. If you will understand this part now, the counter current mechanism will be very easy for you. It is going to be very easy for you. Okay, nephron. So when you talk about the nephron, you know it very well, this cup shaped structure. It is nothing but it is the woman's capsule. It is the woman's capsule. Okay, bache. So now this part, this next part to it is PCT, proximal convoluted tubule, and here you have to remember that brush bordered cuboidal epithelium is there. What kind of epithelium is there? Brush bordered cuboidal epithelium is there. Yes students, what type of epithelium is there? Brush bordered cuboidal epithelium is there. Now when you look at this part, it is nothing, it is the DCT, distal convoluted tubule, right? Distal convoluted tubule. Now this U-shaped structure is nothing, this is the loop of Henle. This is the loop of Henle, right bache? So this is the thick part, this is the thick part, this is the thin part, and it is of descending limb of loop of Henle. It is of descending limb of loop of Henle, right? What is it? What is the meaning of this DL here? It is the descending limb of loop of Henle. Descending limb of loop of Henle. And this part is what? It is the ascending limb of loop of Henle. Okay, ascending limb of loop of Henle. So descending limb of loop of Henle, ascending limb of loop of Henle. This part is descending from cortex to medulla. This part is ascending from medulla to cortex. ठीक है बच्चे? ठीक है बच्चे? Okay. So here, see, the flow will be in this direction. It will come down. It will come down like this. And here, that is how the flow will be. That is how the flow will be. So this is your nephron ka structure. So this point is very important. PCT is having the brush bordered cuboidal epithelium, right? PCT is having the brush bordered cuboidal epithelium. So this is what you people need to take care, right bache? This is what you people need to take care, right? So now when you look at this part, this kind of yellowish, what is it? It is the blood supply. It is the blood supply. Now students, you know that from the blood, right, from the heart, your dorsal aorta is coming. From the heart, your dorsal aorta is coming. That will obviously, that will be having the oxygenated blood. That will further break and form different branches to innervate different parts. So it will form renal artery. And that renal artery will carry the oxygenated blood to the kidney. That renal artery will carry the oxygenated blood to the kidney. Now this artery, it has to break further. It will form, bache, arterioles. What will it do? It will form arterioles. It will divide into smaller capillaries. So jaise, let's say it will form afferent arteriole. Afferent arteriole. Then it will form glomerulus, the tuft of blood capillary. Then it will form efferent arteriole. Then it will do what? It will form efferent arteriole. Then it will form peritubular capillary network. It will form peritubular capillary network. Clear, bache? What will it do? It will form peritubular capillary network. Then you know that this peritubular capillary network, that is also the vasa recta, and then bache, there will be the venules, right? That will be the, there will be the venules, and that venules are going to form that veins, the renal vein. This is how the blood flow of kidney is. Do you know about it? First of all, tell me, do you know about it? Because if you know about it, then I will explain one more topic, right? Then I will explain one more topic. Tell me quickly. Do you know about it? Yes or no? Hanji, yes or no? Quick, this is the blood flow to the kidney. This is the blood flow to the kidney, and if there is any mistake in this blood flow, do let me know. If you can see any mistake here in this blood flow, do let me know. If there is any mistake here in the blood flow, do let me know. And I'm telling you there is a mistake. Right? There is a mistake. Quick. There is a mistake. Quick. Student, these are the most important parts, and I think you should know about it. Okay. So what is the kind of mistake? What is the mistake here? What is the mistake here? Tell me. What is the mistake here? Acha, one mistake. Which mistake? Acha. Anything else? Anything else? Bache, there is no mistake. There is no mistake. Heart, dorsal aorta, renal artery. Dead. See, when you discuss the structure of the nephron, it's like this. Okay? It is like this. So you have the woman's capsule. You have the woman's capsule. Okay, and here you have the tuft of capillary, that is glomerulus. That is glomerulus. Okay, bache? So these two are known as renal capsule. These two are known as renal capsule. It is also known as Malpighian capsule. It is also known as Malpighian capsule. This is the renal capsule. It is also known as Malpighian capsule. Is it clear? Now here, when you see this part, it is the afferent arteriole. So when you look at the afferent arteriole, its diameter is more, right? This is the efferent arteriole. Here the diameter is less. So this difference in diameter will create a pressure here, will create a blood pressure here, and that is very important for the first step of the urine formation, and that is the ultrafiltration, right? That is the ultrafiltration. So you know it very well. The first step of urine formation is ultrafiltration, which is also known as glomerular filtration, which is also known as glomerular filtration. Okay, so it is the ultrafiltration, which is also known as glomerular filtration. Okay, the first step of urine formation. Are you getting my point? It is the first step of urine formation. So this difference in arterioles, their diameter, so it will create a pressure here. That is very important from the urine formation. And here in the lumen of woman's capsule, you will get the ultrafiltrate. You will get the ultrafiltrate. What you people are going to get here? You will get the ultrafiltrate. Okay, bache? So see, afferent, glomerulus, efferent, then that will form peritubular capillary network. So when this peritubular capillary network is around the loop of Henle, it is forming vasa recta. Then there is the venule, right? And then there will be the renal vein. And finally, you know that blood will pass to the vena cava, right? right? From renal vein, it will pass to the vena cava and finally to the heart. Finally to the heart. This is actually the blood flow. This is actually the blood flow. Are you getting my point? This is actually the blood flow. So tell me, the diagram clear? The diagram clear? Dekho students, in detail I have discussed it in my marathon sessions. So here you know that the pressure that is helping for this ultrafiltration is your net effective filtration pressure. Yeah, you can see the, you can write down that is effective. That is effective filtration pressure. What is it? That is effective filtration pressure. What is it? That is effective filtration pressure, and it is somewhere in between. It is somewhere 10 mmHg, 10 to 25 mmHg it is. Okay? It is somewhere 10 to 25 mmHg. This is the net effective filtration pressure. So basically here you have glomerular blood pressure that will favor filtration, but there will be capsular hydrostatic pressure that will oppose filtration. There will be the capsular hydrostatic pressure, and there is blood colloidal osmotic pressure. Blood colloidal osmotic pressure and capsular hydrostatic pressure, these two, they oppose filtration, but basically the blood glomerular blood pressure will favor filtration. So let's not enter there, but remember this is the effective filtration pressure that is helping in the ultrafiltration. That is helping in the ultrafiltration. So this is the one form of structure. This is the one thing that you need to understand. Now the another thing is, if you really want to understand this topic, please pay attention. You know that this is the loop of Henle. You know that this is the loop of Henle. This is the loop of Henle, and here in this loop of Henle, this is the descending limb, downwards, downwards. This is the ascending limb, like this, like this. है ना? Descending, it is descending from cortex to medulla, it is ascending from medulla to cortex. ठीक है? Surrounding में you know that medullary fluid is there, right? If you talk about the, if you remember it very good, if not please revise it. You have cortex, you have medulla. ठीक है? So this part of the neuron, sorry, this part of the nephron, especially of, there are two types of nephron, cortical nephrons बच्चे, cortical nephrons, and there is juxtamedullary nephron. There are two type of nephrons, cortical nephrons and juxtamedullary nephrons. So cortical nephrons are making 85% of the total nephrons, juxtamedullary are making 15%. In the cortical nephron, this loop of Henle part is very short. Very short. It is not even descended in the medulla. And here when you talk about this now, this woman's, when you talk about this Bowman's capsule, this proximal convoluted tubule, right? So this is basically near to the this peripheral part of the kidney, right? Even the DCT, right? Even the part of the collecting duct. So where will you see? You will see it near to the periphery of the kidney. Okay, near to the boundary of the kidney. Now juxtamedullary nephron, and in cortical nephron you will see this loop of Henle is quite short. It is not very long, right? It is not very long. Now when you are talking about the juxtamedullary nephron, right? So here in the case of juxtamedullary nephron, this PCT, this Bowman's capsule, right? They are basically at the junction of cortex and medulla, and you will see that there is a very long, right? You will see that there is a very long loop of Henle here, right? So this is your juxtamedullary nephron, juxtamedullary nephron. And remember, it is your juxtamedullary nephron that will help in the counter current mechanism, that will help in making the urine concentrated, right? That will help in making the urine concentrated. Are you getting my point? That will help in making the urine concentrated. Clear bache? Clear bache? So this is the descending limb. It is descending from cortex to medulla. This is the ascending limb. Now bache, in the juxtamedullary nephron, right? Basically your nephron, it is covered with a U-shaped, this part of loop of Henle is covered with the, it is covered with what? It is covered with the U-shaped, yes students, it is covered with a U-shaped peritubular capillary network, sorry, vasa recta. This is nothing but it is the vasa recta, right? Your loop of Henle is covered with what? Your loop of Henle, right? Your loop of Henle is covered with the vasa recta. It is covered with what? Vasa recta. So vasa recta is that U-shaped capillaries that are covering your loop of Henle. So in the case of juxtamedullary nephron, because there is a long loop of Henle, so there is a long vasa recta, well developed vasa recta which is covering it. Okay? So now when you look at this vasa recta here, it is having the ascending limb. The flow is like this. This is the descending limb of vasa recta. That's what you need to understand. Okay? You have to remember this thing. You have to remember this thing, students, right? You have to remember this thing, that descending limb of loop of Henle, is having ascending limb of vasa recta in its vicinity, right? Descending limb of loop of Henle is having, right, it is having ascending limb of vasa recta in its vicinity, So ascending limb of loop of Henle is having descending limb of vasa recta in its vicinity. Are you getting my point? It is having this. Are you getting my point? If this is clear, send me the thumbs up in the chat section quick. If this point is clear, send me the thumbs up in the chat section quick. It is something very important. Yes? Yes? If it is clear, do let me know. So you have descending limb of loop of Henle, ascending limb. In the vicinity of descending limb of loop of Henle, you have ascending limb of vasa recta, and here you have descending limb of vasa recta. Okay? You have descending limb of vasa recta. So when you see this loop of Henle, here the flow of the filtrate is down, up. It is in counter current direction, opposite direction. Here in vasa recta also the blood flow is in opposite direction, and even if you compare descending limb of loop of Henle and ascending limb of vasa recta, it is also in counter current direction, in the opposite direction. That's the point that you need to understand. And where all the things are present, they are in the medullary fluid, right? They are in the medullary fluid. What is the meaning of medullary fluid? Interstitial fluid. What is the meaning of medullary fluid? Interstitial fluid. ठीक है बच्चे? And NaCl and urea, right? Each and every point is important. They maintain osmolarity here. They maintain solute concentration here, right? They maintain osmolarity here. They maintain solute concentration here. Is it clear? So NaCl and urea, they maintain the osmolarity here. They maintain the yes bache, they maintain the solute concentration here. Now look at the nephron structure again. Look at this nephron structure again. So ultrafiltrate will form here. This ultrafiltrate contains glucose, it contains amino acid, it contains many essential things which we cannot afford to lose. Then what is the next step here? What should be the next step here? So now in the PCT there will be the tubular reabsorption. So now come to the kidney part, right? Sorry, come to the nephron part. Just have a look of the structure, guys. So you know that when there is the filtration, okay, let's directly come to the urine formation. So first step is the glomerular filtration. Also known as ultrafiltration. So again I am repeating this. So on an average 1100 to 1200 ml of blood is filtered by kidneys per minute. 1100 to 1200 ml of blood is filtered by kidneys per minute. Right, bache? What will be done here? 1100 to 1200 ml of blood is filtered by kidneys per minute. Yes or no? It is filtered by kidneys per minute. ठीक है बच्चे? And it is roughly 1/5 of the blood pumped by each ventricle of the heart. It is roughly 1/5 of the blood pumped by right each ventricle of the heart in the minute. ठीक है? So another important information that you need to remember here is that there are 3 layers by which this will happen. Okay, there are 3 layers. How many layers are there? There are 3 layers. Just for an example, you have the glomerulus. So endothelial of glomerulus. Even it is having some pores in between. Okay. So you have the endothelial of glomerulus. What do you have? You have the endothelial of glomerulus. Now when you talk about the woman's capsule is having inner layer of woman's capsule, right? I know diagram is not so appropriate, but still it will help you to revise it. So when you talk about the inner layer of woman's capsule, podocytes, special cells having feet-like arrangement, they are present. Podocytes are present here, right? Podocytes are present here. So podocytes are making inner layer of woman's capsule. Podocytes are making inner layer of woman's capsule. What are they doing? They are making inner layer of woman's capsule. Are you getting my point? Hanji, are you getting my point? Done? Okay. Okay. So podocytes, inner layer of woman's capsule, endothelial of glomerulus, and in between these two there will be the basement membrane. There will be the basement membrane. You know that this is the example of simple epithelial tissue, and these cells, they are going to lie on the basement membrane. So when you talk about the podocytes, they are having feet like arrangement. They are arranged in such an integrated manner, right? They are arranged in such an integrated manner that you will see that there will be some filtration slits in between. What will be there? There will be some filtration slits in between. What will be there? There will be some filtration slits, some slit pores in between. So blood will be filtered here and ultrafiltrate will be passed to the lumen. Okay? So this is containing many essential things, so it will be reabsorbed. Okay, so here you guys can see, so obviously filtrate will form here, and what is the rate of that filtration? So the amount of filtrate formed by kidney per minute is your GFR, glomerular filtration rate. That is your GFR, glomerular filtration rate, and that is approximately 125 ml per minute. Okay, that is approximately 125 ml per minute, and it is 180 liters per day. This is 125 ml per minute, and this is 180 liter per day. 125 ml per minute, and this is 180 liter per day, right? 180 liter per day. Are you getting my point? Are you getting my point? Are you getting my point? Okay, so tubular reabsorption will be there. देखो, urine output is 1.5 liter. Filtrate formed per day is 180 liter, but urine output is 1.5 liter. Obviously, these are variable things. It depends upon diet and the fluid intake as well, right? These are the 2 points. So 99% of the filtrate will be reabsorbed. 99% of the filtrate will be reabsorbed, right? So it will be reabsorbed actively or passively. 99% of the filtrate will be reabsorbed. So it will be reabsorbed actively or the passively. It will be, right, reabsorbed actively or the passively. This point clear? This point clear? So, right, glucose, amino acid, sodium, they will be reabsorbed actively, right? Nitrogenous base like your urea, they are passively reabsorbed. Okay? So reabsorption will also be there in the initial segment of nephron. Okay, and when third step of urine formation is tubular secretion, where H positive, where your K positive and ammonia will be released into the filtrate. That is very important step for maintaining the ionic concentration, right? That is very important step for maintaining the ionic concentration. So again I am repeating, your PCT is lined with simple cuboidal brush bordered epithelium. So what is the meaning of brush bordered epithelium? Cuboidal cells are having microvilli. Right, cuboidal cells are having microvilli. What's the meaning here, students? What is the meaning here? That they are having the microvilli. Is it clear? Is it clear? Yes, everyone? Yes, everyone? So what do they have? They are having the microvilli. Clear, bache? So all the essential nutrients, 70 to 80% of the electrolytes and water are reabsorbed by this segment. 70 to 80% of the electrolytes and water are reabsorbed by this segment. So PCT helps in maintaining the pH and ionic balance, because there will be the selective secretion of hydrogen ions, ammonium ions into the filtrate and reabsorption of bicarbonate. Mark it. So here in PCT, what will be secreted? Your H positive and your ammonia. Right? What will be reabsorbed? Your bicarbonate. So potassium is not mentioned here. Don't consider it. This is from your new NCERT. Okay. Now Henle's loop. Come to the Henle's loop. Another important point. Come to the Henle's loop. Another important point. So look at this diagram. Where is our diagram? Okay. So Henle's loop. Very important, students. Very important. So you have thick part of descending limb, thin part. It's like this, right? It's like this. Okay? It is like this. Okay? So this part, right? This descending limb of loop of Henle is permeable to water, right? It is permeable to water and impermeable to electrolytes, and it is impermeable to electrolytes. It is permeable to water and it is impermeable to electrolytes. And this part, okay, this ascending limb of loop of Henle, it is permeable to electrolytes. Yes, bache, it is permeable to electrolytes, but impermeables to, right? But impermeable to water. Understood? But impermeable to water. So remember this thing, that from this thin part, right, that electrolytes, they'll be reabsorbed passively. Okay, these electrolytes will be reabsorbed passively, and from thick part they will be reabsorbed actively. This is another important point. So descending limb of loop of Henle is permeable to water, impermeable to electrolyte. This is permeable to electrolyte, impermeable to water. Okay, so actively, passively is the thing. So imagine when the filtrate is coming down like this, so water will be taken, water will be reabsorbed. Where that water will go? Obviously in the surrounding you are having the medullary fluid. Right? You are having the medullary fluid, also known as interstitial fluid. You are having the medullary fluid and you have the interstitial fluid, isn't it? Yes or no? Isn't it? Yes or no? Yes or no? Tell me. This is what we have. So you have descending limb of loop of Henle, right, which is permeable to water. So means water can move in and out. So basically when filtrate is coming down, the water is reabsorbed. That water is entered here in the medullary fluid. So when filtrate is coming down, don't you think that filtrate will be concentrated when it will reach here? All the water from the filtrate will be taken out, will be reabsorbed. So don't you think that filtrate will be concentrated? Right? Filtrate will be concentrated. Yes or no? Filtrate will be concentrated. Yes or no? Yes or no? Filtrate will be concentrated, students. Yes or no? Hanji. Obviously. So here when it will reach, the filtrate will reach here, it will be highly concentrated. Now filtrate is moving up, right? When it is moving up from the ascending limb, so electrolytes will be reabsorbed. Dekho, there are two ways, right? You have a solution, you are taking out the water, the solution will be concentrated. Now again, if you have to dilute that solution, you can either add water or you can remove solute. So here we are removing the solute, we are removing the electrolytes here. Here we are removing the solutes, we are removing the electrolytes here. So from this side your NaCl and all is coming out, right? From this side your NaCl and all is coming out, and what's going to happen? So when the filtrate will move up, right? Yes bache, when the filtrate it will move up, what is going to happen? The filtrate will be diluted now. Okay, it will be diluted now. This point clear? The filtrate will be diluted now. Remember this diagram. I am going to use this diagram, right? Yes, students. I am going to use this diagram for the, what do we call it? I'm going to use this diagram for your counter current mechanism as well. Okay, for the counter current mechanism as well. So here in this point, this is what they have explained. Okay, Henley's loop mein, this is what they have explained. Now DCT mein, again, what is going to happen in DCT? There will be the conditional reabsorption of sodium and water. Why conditional? Because if required, if it is required to conserve the water in the body, then it will be reabsorbed, otherwise it will not. Right? Right. So conditional reabsorption of sodium and water will be there in the segment, and DCT is also capable of reabsorption of bicarbonate, but secretion of hydrogen, potassium ion and ammonia. Dekho, in the PCT, we didn't mention the secretion of K positive ion. That is what you need to take care here. That is what you need to take care here. So look at this diagram. So here we are not talking about the secretion of K positive, but here we are talking about the secretion of K positive. Okay? So H positive will be added, ammonia will be added here. K positive, H positive and even ammonia will be added here. Right, bache, and bicarbonate will be reabsorbed. So look at this diagram. Any doubt? Look at this diagram. Any doubt? So you can see the NaCl. The NaCl is reabsorbed. So some part of water will be reabsorbed from collecting duct, and even from the collecting duct, urea will be reabsorbed, and here urea will be entered to the filtrate. Okay? Urea will be entered to the filtrate. Urea will be added to the filtrate. Okay? This is what you need to remember. This is what you need to remember. Okay? This is what you need to remember. Is it clear? Is it clear? So this is the diagram. Now let's talk about the counter current mechanism. Okay? Let's talk about the counter current mechanism. So this chapter is quite important. You know that after finishing the counter current mechanism, we will be talking about the RAS mechanism. Okay? After it, what are we going to discuss, students? We'll be talking about the RAS mechanism. So up to this part all clear? Hanji, up to this part all clear? Up to this part all clear? Let me finish this, then you will get a break. Okay? Let me finish this, then you will get a break. I think we should finish this chapter, excretion chapter, because then we will move to that body fluid wala chapter and breathing and exchange. So we are about to finish it. Then plant physiology. You know why I started with the physiology? Because I know right now you are quite fresh. You will be able to retain it. Okay? You will be able to retain it. And then after it, we will move to the diversity part. We will move to the sections of anatomy. Then finally class 12 syllabus. Okay, finally class 12 syllabus. Okay, so any doubt? Any doubt? So let me finish this, then you will get the break. Okay, let me finish it, then you will get the break. Okay, so I am saying, dekho, you have to remember something very simple. We don't even have time to understand that concept in detail. So you have to remember something very simple. This is your cortex of kidney. This is your medulla. We divide cortex in kidney into this part, na, cortex and medulla. So here you will talk about the osmolarity. It is the solute concentration and its units are m osmol per liter. Its units are m osmol per liter. Okay? So when you move from cortex to medulla, especially when you move to the deeper lay part of the medulla, you will see that there is a change in the solute concentration. For an example, let's say here it is 300 m osmol per liter, 400 it is, 500 it is, 600 it is. So when you reach to the deeper layer, it will be somewhere 1200 m osmol per liter. It will be 1200 m osmol per liter. Right? It will be 1200 m osmol per liter. So jaise, let's say in our body, you know that there is a system. Right? If this is one cell, this is another cell. Let's say this cell is having more water, this cell is having more solute. So water will move from this cell to this cell. Osmosis is there. Right? So basically that dynamic, basically isotonic state will be maintained. The dynamic, this equilibrium is dynamic. The work done is there always. Okay? But it will, net will be zero, but basically what is happening? The amount of water that is moving from cell A to B will be same from B to A. Basically isotonic conditions, they will be maintained in our body na. Just one cell is having more water, another cell is having less water and more solute, the water will move like this. Same is the case here. Same is the case here. Just say you know that you will be having the limbs here. ठीक है, this is the descending limb, this is the ascending limb, this is the descending limb, this is the ascending limb. So obviously water will come out, H2O will come out here. From this side your NaCl will come out. So where is it entering? It is entering in the medullary fluid. It is entering in the medullary fluid. Actually in the medullary fluid the osmolarity is maintained in such a way that from this limb we will be able to reabsorb water. We will be able to reabsorb water, and here it is maintained in such a way that from this limb we will be able to absorb the electrolyte. Now one thing that you need to remember is, you know that blood vessel, the vasa recta is covering it. So vasa recta is not having these type of tantrums that I will reabsorb water, I will reabsorb electrolyte only. Vasa recta is a very simple thing. Vasa recta is like yaar let's do something. Okay, vasa recta is like yaar chalo let's do something. है ना, let's do something. So what, देखो, the water that is coming from the descending limb of loop of Henle, it will be picked up by the water vessel, the blood vessel. ठीक है, whatever water is released from the descending limb of loop of Henle, it will pass in the medullary fluid. From the medullary fluid, it will be picked up by, right? It will be picked up by this. Okay, it will be picked up by this blood capillary. It will be picked up by the ascending limbs. Okay, it will be picked up by the ascending limb. Are you getting it? Ascending limb of vasa recta. Are you getting it? This is what you have to remember. First thing that you have to remember in counter current mechanism, that descending limb of loop of Henle is having ascending limb of vasa recta in its vicinity. This is the first point that you need to remember, that descending limb of vasa recta, descending limb of loop of Henle is having ascending limb of vasa recta in its vicinity, and ascending limb of loop of Henle is having descending limb of vasa recta in its vicinity. This is what you need to remember first of all. So another point that you need to remember is, that DL is sending out H2O in medullary fluid, and your AL of vasa recta is picking up that water. Here NaCl, right, your ascending limb of loop of Henle is throwing out NaCl in the medullary fluid, that will be picked up by descending limb of vasa recta. Matlab, one is throwing it, another is picking it up. One is throwing it, another is picking it up. One is throwing it, another is picking it up. That's the whole story here. That is the complete story here. So it is like I consider vasa recta is like a baby. Dekho, there is a mechanism behind it. There is the science behind it. There is that osmosis thing behind it. But right now, obviously, you will not be able to process that much of information. So whatever is required for answering the question, let's focus on that. Okay, whatever is required for answering the question, let's focus on that. Okay, bache? So I consider vasa recta blood capillaries is like a baby. It is picking up NaCl from this side, so it is like, oh my god, oh my god, oh my god, I am taking NaCl. Chalo, I'll give out my water here. This one is like, oh wow, I'm picking up water, I'm picking up water, I'm picking up water. So this one will be like, chalo, I will give the NaCl here. I will give the NaCl here. So basically this NaCl is going nowhere. This NaCl is going nowhere. It will be there in the medulla only. It will be there in the medullary fluid only. Okay? It will be there in the medulla only. It will be there in the medullary fluid only. So it will not go anywhere. That is how it maintains the osmolarity. Okay, that is how it maintains the osmolarity. It is not going anywhere. It will stay in the medullary fluid only, right? From this side of NaCl, okay, this side of NaCl is picking up the, this limb of vasa recta is picking up the NaCl. This limb of vasa recta is throwing the NaCl back to the medullary fluid. This side is picking up the water. This side is giving the water once again. So this arrangement is made in such a way, that we will be able to reabsorb more and more water. Right, this arrangement is made in such a way we have to absorb more and more water. This is the agenda of counter current mechanism. This is something very important in the case of higher vertebrates, like in the case of birds and mammals, so that they can conserve the water in their body. Right, they need to conserve the water in their body. Right, so our urine is 4 times more concentrated than the filtrate. Right, filtrate and urine is 4 times more concentrated than the filtrate because of this counter current mechanism. So it is something that we have adapted. It is something which is very important for our survival. Okay, so that is something you need to remember. Don't make the mistake here. Descending limb is throwing out water, Ascending limb is throwing out NaCl. So whatever is in its vicinity, it will pick it up. Now, when the filtrate is moving down, 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 it is getting concentrated. So obviously its concentration and medullary fluids concentration will come to the same level. I told you, no, isotonic conditions will be attained. So when filtrate will reach here, right, it will also be having the osmolarity 1200 m osmol per liter, and the same is in the medullary fluid. So this is how the isotonic conditions will be maintained here. Okay, okay. So when water will come out, this water will pass in the blood capillary, right, it will be there in the body, of course. Then again we will be able to take more and more water here, more and more water here. That is how the osmolarity will come same. And here also, when you are talking out NaCl, osmolarity will decrease. Again it will become 900, 800, 700, 600, and again when it will reach here, it will reach to 200 like this. Then conditional reabsorption will be there from the DCT. Okay? So I will just read it for you from this side. Trust me, if you will focus on these points only, you will be able to answer all the questions from this particular topic. Let's revise it very quickly. Mammals have the ability to produce the concentrated urine, yes or no? Mammals have the ability to produce the concentrated urine, yes or no? Yes or no? Mammals, they have the ability to produce the concentrated urine, yes or no? Yes or no? Yes or no? Yes or no? Guys, quick, quick, quick. Yes or no? Of course, yes. Okay. So Henle's loop and vasa recta play a very significant role in this. Yes, ma'am. So flow of filtrate in the two limbs of loop of Henle is in the opposite direction, and that is why there is a counter current. That is why there is a counter current. Of course, yes, it is true. Right? Right? The flow of blood in the vasa recta is also in the counter current. So proximity, closeness between Henle's loop and vasa recta is also in counter current. That will also maintain the osmolarity. So they are saying outer medullary cortex is having this osmolarity, 300 m osmol per liter is in the cortex, and 1200 m osmol is in the inner medullary fluid. It is in the inner medullary fluid. Clear, bache? Clear, bache? So who is going to maintain this osmolarity? NaCl and urea. Who is going to maintain this osmolarity? NaCl and urea. Is it clear? Who is going to maintain the osmolarity? It is NaCl and urea. It is NaCl and urea. Clear, bache? So NaCl is transported by ascending limb of loop of Henle, which is exchanged with the descending limb of vasa recta. Can you understand this? NaCl is transported by ascending limb of Henle's loop. Visualize it. Okay? It will be exchanged with the descending limb of vasa recta, and NaCl is returned to the interstitium by the ascending portion of vasa recta. Right? So similarly, small amount of urea will enter the thin segment of ascending limb, which is transported back to the collecting tubule. So this arrangement is important for making the urine concentrated. So it will make urine 4 times more concentrated than the filtrate. So see this, human kidneys, they can produce urine 4 times more concentrated than the initial filtrate. Right? 4 times more concentrated than the initial filtrate. So look at this diagram. So this part is your vasa recta. So this one is ascending limb. Can you see that? Ascending limb. How can you say that? Obviously arrow is going upward. Arrow is going upward here. Okay, this is the ascending limb. So ascending limb and this descending limb is in vicinity. Right? So this is how it is. Right? So this is about the mechanism of urine. This is about the concentration of the urine. Is it clear? So next is the regulation of kidney function. That is what we need to revise. So any doubt? Any doubt? Any doubt? Yes? Do you have any doubt here? Pakka? So it is important. So on the basis of it, you can answer all the questions. You can answer all the questions. Okay? Chalo. So the next part is a regulation of kidney function. So when it comes to the regulation of kidney function, there is one more paragraph that we need to understand this thing. Dekho, the arrangement of structure is in such a way, just let's say this is your woman's capsule. Here you are having your arteriole. you know, in the kidney, nephrons are present in such a way that the part of DCT also touch here, right? I'm just trying to show you that structure. The part of DCT touch here, this arterioles. So the part of distal convoluted tubule that is coming in contact with these arterioles, here some cells are getting modified. So right now I am talking about juxtaglomerular apparatus, which is very important. Right now I am talking about juxtaglomerular apparatus, which is very, very, very important for maintaining the GFR. Juxtaglomerular apparatus, which is very important for maintaining the GFR. So in juxtaglomerular apparatus, you have JG cells, that is known as juxtaglomerular cells, that are also known as granular cells, right? That are also known as granular cells. So it is juxtaglomerular cells, which are also known as granular cells, right, bache? Which are also known as granular cells. Clear? Which are also known as granular cells. Clear, bache? Clear, 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 clear. Second type of cells are macula densa cells. They are the cells of distal convoluted tubule. Okay, these are the two cells. So juxtaglomerular cells, granular cells, and they are the macula densa. So these juxtaglomerular cells are present here in afferent arteriole. Somewhere here in afferent arteriole you will see these cells. Okay, somewhere there. This part of afferent arteriole, it is modified now. Some JG cells are present here. Basically here where, you know, DCT is coming in contact with this arteriole na, right? Here you will see JG cells. So these JG cells, why do we call them as granular cells? Because they have the renin. They have the renin. They have the granules of renin. That is what you need to understand. And what are these macula densa cells? These are the special modified cells of distal convoluted tubule. So distal convoluted tubule, when it is coming in contact with the atriole, it is coming in contact with the atriole, the cells are getting modified, right, bache? So they will just sense when there is, you know, change in that GFR is low or fast like this. So renin is released. Now in the blood, right, in the blood, in the plasma of that blood, in the plasma of that blood, you are having one protein. This is inactive protein, angiotensinogen. What is the name of that protein? It is angiotensinogen. What is the name of that protein? It is angiotensinogen protein. It is inactive, of course. So you can even mention that this protein is synthesized by the liver. Where is it present? It is present in the plasma. Who's going to synthesize it? Your liver. Now renin, when renin is released, and when that renin will release, when bache your blood volume is less. Okay, blood volume is less means blood pressure is less. Blood pressure is less means glomerular filtration rate is less. So when in our body GFR is less, what will happen? JGA, juxtaglomerular apparatus, will get activated, and because of that, what is going to happen? Your renin, right? Your renin will be released. So renin will act on angiotensinogen. It will convert it into angiotensin 1. So angiotensin is activated, angiotensinogen is inactivated. So this angiotensin 1 will be converted to angiotensin 2. Okay, it will be converted to angiotensin 2. And this will be done with the help of enzyme ACE. What is it? It is angiotensin converting enzyme. It is angiotensin converting enzyme. What's that? It is angiotensin converting enzyme. Clear, bache? Clear, bache? So it is released by lungs, right? By the epithelium of lungs. It is released by lungs epithelium, right? It is released by lungs epithelium. Now, bache, this angiotensin 2, it's a vasoconstrictor. It constricts the blood vessel, and mainly it will act on your proximal part of the nephron. Okay? So it is also a vasoconstrictor. It will constrict the blood vessel also, and it will mainly act on the proximal part of the nephron. So proximal part pe it will act, and it will help in that water absorption, one thing. Then it will also act on adrenal cortex. Be very specific that it is adrenal cortex. Okay? So in response to that, adrenal cortex will release a mineralocorticoid, aldosterone. The hormones of adrenal cortex are also the steroid hormones, cortisols. Their receptors are also intracellular. Remember that. So aldosterone will be released. So you know that aldosterone will act on the distal part of the tubule, and it will help in the conditional reabsorption of sodium and water. In the conditional reabsorption of sodium and water. So when more and more water will be reabsorbed, right bache? So what is going to happen? What is going to happen? Your GFR, right? GFR will increase, right? Blood pressure will increase. In response to that, GFR will increase. Are you getting my point? In response to that, GFR will increase. So you can see here that your angiotensin 2 also activates, the adrenal cortex. Okay? Aldosterone will cause the reabsorption of sodium and water from the distal part. So blood pressure will release. So this is your renin angiotensin mechanism. This is your RAS mechanism. Okay, this is your renin angiotensin aldosterone system. Yeah, this is your RAS mechanism. So this is one of the most important topics. Okay, okay, done. Okay, so basically ANF, atrial natriuretic factor, the hormone which is released from the heart, it is a vasodilator. It dilates the blood vessel. So it acts like a check on the RAS mechanism. This part done, right? This is the one thing. Secondly, bache, osmoreceptors in the body, they are also activated by the changes in the blood volume, body fluid volume and ionic concentration. So when there is excessive loss of fluid from the body, osmoreceptor will pass this message to the hypothalamus. Right, they are going to pass this message to the hypothalamus. So you know that hypothalamus, right, it forms two hormones, oxytocin and vasopressin. You remember vasopressin. So vasopressin is also known as antidiuretic hormone. It is also known as antidiuretic hormone. So this hypothalamus will form this hormone, and it is stored in the posterior lobe of pituitary. Okay, it is stored in the posterior lobe of pituitary. That is your pars this nervosa, right? That is your pars nervosa. That is your neurohypophysis. So when osmoreceptor will give the signal to hypothalamus will tell that thing to the false endocrine gland, that is your posterior lobe of pituitary, that will release ADH, antidiuretic hormone. So antidiuretic, what is the meaning of diuresis? Diuresis means excess of urination. So if it is antidiuretic, it means it will prevent the excess of urination, right? It will store the water in the body. That is how it is going to work. And one more thing, though we have covered it in our disorders section, but still hyposecretion of ADH can result in the disease which is known as diabetes insipidus. What is it? It is diabetes insipidus. So this is all about this chapter. Okay. So next is the blood group. Baki micturition, you know that it is a basically a kind of response, right? Your CNS is also involved there. So when there is a stretching of urinary bladder, right? So stretch receptors will send the signal to the CNS. CNS will pass the motor message, and basically there will be the contraction of smooth muscles of the bladder. Okay, so urethral sphincter will relax, urine will be released. So on an average 25 to 30 gram of urea is there in the urine, and analysis of urine can help in the diagnosis of many metabolic disease. Just if in the urine glucose is present, glycosuria, ketone bodies are present, ketonuria, that indicates diabetes mellitus. Okay. That indicates diabetes mellitus. Okay. So now let's take a break, right? You can have your breakfast. So let's meet at 10:30. Okay. So after it, you are not going to get break for next 3 hours or 4 hours. Fine? Chalo. So I am back, right? So breakfast done. Breakfast done. Breakfast, washroom, all done. Chalo, let's start the session, right? So human physiology, good ma'am, नींद आ रही है, क्या करें? सो जाओ बेटा, सो जाओ. Yes. बच्चे, my voice is perfectly fine, my mic is fine, there is some issue with your system, right? Kindly change your system. You can change your phone, you can change your laptop. Okay? So if someone is feeling sleepy, please go and sleep. Okay? Go and sleep. Ma'am, please question practice itself. It's already done. And tomorrow at 9 a.m. we have another practice session, and you can say that last practice session. Okay, you guys can say that it is a last practice session. Okay, so we are done with the excretory product and its elimination. Then now the next part that we need to start is the blood group, that is body fluid and circulation. So before starting it, show me in the chat section, guys, do you have that energy, yes or no? Do you have that energy, yes or no? After breakfast, are you feeling sleepy or not? Yeah, I had my breakfast. I just had. Yes, 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 some more better emojis, yaar. Quick. Quick. Yes? Done? Okay, okay. So let's start the class, guys. Let's start the class. Okay, so we are going to start with the body fluid and circulation. What are we going to start? We are going to start with the body fluid and circulation, right? Body fluid and circulation, that is what we need to start. So from body fluid and circulation, your ECG is a very important topic, cardiac cycle is a very important topic, ECG is a very important topic, your cardiac cycle is a very important topic, and bachche nodal tissue. So in this particular, and blood clotting, yes, how can I forget blood clotting? So let me tell you one thing here, students, right, that when you talk about the body fluid and circulation now, when you talk about this chapter body fluid and circulation, so if you understand the respiratory system, okay, if you understand the respiratory, the nodal tissue, then all the topics are related to that nodal tissue only. Okay, all the topics are related to that nodal tissue only. Okay, so can I start it? Yes, students, can I start it? Body fluid and circulation. So let's start with the blood group first. So when you talk about the blood group, let's add a bit genetics here. So you know that in the case of blood group, ABO blood grouping, who gave it? Landsteiner. Who gave it? Landsteiner, right? And when you talk about the AB blood group, right? So AB blood group was, so Carl Landsteiner, he gave the ABO blood grouping, and when it comes to the AB blood group, so it was done by, yes bache, it was given by the students of Carl Landsteiner, that is D. Castello and Sterling, right? That is D. Castello and Sterling. They gave the AB blood group, right? So AB blood group is what? Is it showing the codominance? Yes, ma'am. Is it showing the codominance? Yes, ma'am. So in the case of blood group, you know that the gene I, it is the gene I. Dekho, now it's the complete biology. So don't expect that, ma'am, why are you mixing physiology and genetics? You know the blood group. Right now it should not be class 11th or class 12th biology, right? Right now it should be complete biology. It should not be class 11th, it should not be class 12th biology, it should be complete biology. Is it clear? Is it clear? Are you okay with it? Yes, people, tell me in the chat section. Are you guys okay with it? Yes, are you people okay with it? Quick, quick, quick. Are you all okay with it? Yes? Sure? Sure, sure, sure. Very good, very good. So basically gene I is responsible for blood group. So you have three alleles here, IA, IB and I. So blood group is the example of multiple allelism, right bache? It is the example of multiple allelism, right bache? How many alleles are there? Multiple alleles are there. Multiple alleles are there. This is what blood grouping is, right? So you guys are going to get three alleles. So here in blood group you will see dominant recessive relationship and you will also see codominance. Now what's the point bache? We are having the RBC, that is your red blood cell, that is your red blood corpuscle. RBC, red blood cell, red blood corpuscle. So this RBC, you know it very well, right? You know it very well. Its membrane is permeable. It is having the special permeability. It is more permeable for chloride ion and bicarbonate ion. It is not permeable for sodium and potassium. Rather it is permeable for the chloride ion and bicarbonate ion. So this membrane is also known as Donan's membrane. RBC's membrane is also known as Donan's membrane. So RBC, when it is the mammalian RBC, we know it very well. It will be biconcave. It will be biconcave. It will be enucleated at maturity. It is biconcave. It is enucleated at maturity so that it can have more and more hemoglobin within. So we have an exception also. We have an exception also, your camel and llama, right? They are also the mammals. Camel and llama, they are also the mammals, but their RBC, the RBC is going to be oval and it is going to be biconvex. It is basically going to be the nucleated one. And yesterday when we were practicing the sessions, when we were practicing the question, again and again we were getting one question. You remember, Devanshi? We were getting one question. What was that question, students? What was that question when we were practicing that? So we were practicing one question again and again, that human RBC is about, what is the size of human RBC? What is the size of human RBC? Anyone? What is the size of human RBC? Students, what is the size of human RBC? 7 micrometer, that is what you have to remember. So when you look at the RBC, here you are going to see some antigen, right? RBC is on the antigen surface, right? RBC on surface, what will you see? What will you see on surface? You will see the antigen, right? So if that antigen is A, we will have A blood group, right? We will have A blood group. If that antigen is B, we will have B blood group. Okay, B blood group will be there. If there is right, AB antigen is there, so you know that universal recipient AB blood group will be there. If there is no antigen, then which blood group do we have? If there is no antigen, which blood group do we have? O blood group. O blood group. What do we have then? We have O blood group. What do we have then? We have O blood group, right bache? So now when you talk about the blood people, in the case of blood you have plasma. In the case of blood you have formed elements. What do you have there? You have plasma, you have formed elements. You have plasma, you have formed elements. So that formed elements are basically RBC, WBC and platelets, right? And platelets, right bache? So they are making 45% of this blood and it is making 55%. So obviously RBC is having the antigen on its surface, so our plasma will be having the antibody. Our plasma will be having the antibody. So if my blood group is A blood group, if a person is having A blood group, so plasma may antibody against B blood group will be there, that is anti-B. That is anti-B. Is it clear? Right? The person will have anti-B antibody, right? So just look at this part, guys. Just look at this part. So how many of you are targeting 320 marks in biology? How many of you are targeting 320 marks in biology? Tell me quickly. How many of you are targeting 320 marks in biology? If it's a yes, I want to see some green hearts in the chat section. Quick. Green or yellow hearts in the chat section if you are targeting 320 marks in the biology. So I am not giving you false hopes. I know right now you don't have the time to check my previous marathon session. But today's marathon is about the important topics of biology. You guys can check previous year paper. Basically concepts, they are repeated. So yesterday also you got the NTA predicted paper. You got the NEET replica. Tomorrow also at 9 AM in the morning, you people will be getting one NTA authorized 100 top MCQs. So guys, I'm just telling you one thing, that please be consistent in this particular lecture. Be consistent in this particular lecture. Whatever topics I am picking, I'm also teaching you the subtopics there that are important, that topics are important for your paper. Okay. Okay, after the paper, in the comment section, right, do let me know ki yes ma'am, this session was useful. After that biology part, do let me know in the chat section ki hanji madam, session was useful. So if you are looking for something revision, something for a session where you can revise something, so this is just like I'm your live book here, right? So I'm just picking up the most important topics with you all, right? So I need your support today. I don't need any spamming. We are here to study. We have the today only. Tomorrow I'm not going to disturb you. I will just take your 1 hour tomorrow. I will just take your 1 hour tomorrow. I'm not going to post anything, right? And on 5th of May also, we are not going to have any class, right? We will not take any class because that is for the your revision, right? So please students, please be sincere and let's focus here. Be sincere and let's focus here. So if you are targeting 320 plus marks, promise me that ma'am, we will be there with you till the end. And yes, we will attend this tomorrow's marathon lecture also. We will also attend this particular lecture tomorrow. Just tell me, we will also attend this particular lecture tomorrow. Tell me this thing. So make sure you hit the like button here. Okay, so we'll meet you tomorrow as well. So now come back to the topic. Do not forget this. Blood group A, antigen on RBC. So antigens are on RBC, antibody is in plasma. So when the blood group is AB, then there will be no antibody, right? And when the blood group is O, there will be both the antibodies, but there will be no antigen. So one basic antigen is common, that each antigen, and further as per the gene, further groups are attached. That is not of your concern, so remember this table. Now there is one more antigen, that is your rhesus antigen, right? That is your rhesus antigen, right? Which antigen is there? That is your rhesus antigen. So it was discovered by Landsteiner and Wiener. Who discovered it? Landsteiner and Wiener. Who discovered it, students? Landsteiner and Wiener. Please repeat it with me. Who discovered it? Landsteiner and Wiener. Landsteiner and Wiener. Landsteiner and Wiener. It was discovered in rhesus monkey. So if rhesus antigen present, so blood group is Rh positive. If rhesus antigen is present, the blood group will be Rh positive, and if rhesus antigen, if it is absent, okay, the blood group will be Rh negative. Rh negative. जैसे AB blood group is the universal recipient. Why? Because they don't have any antibody, right? They have both the antigens. So in the plasma, they don't have any antibody, right? My blood group is AB positive. So how many antigens do I have? 3 antigens. AB positive means rhesus antigen is present in my blood. So which one will be the universal donor? You know that O blood group is the universal donor, and if I have to be very specific, then it will be O negative. O negative means no antigen, not even the rhesus antigen is present. No antigen even means the rhesus antigen is not present there, right? Even the rhesus antigen is not present there. So now I will give you a very classic example of the this incompatibility, that is erythroblastosis fetalis. Erythroblastosis fetalis, right? Erythroblastosis fetalis, right? Now in your syllabus, right, it is just telling you mother is Rh negative, baby is Rh positive, like this. But you know, in higher studies, we also study that in which blood groups, in which cases, like let's say mother and baby is having different blood groups, still Rh incompatibility is there, but there are chances where still no issues will be there. So this topic is very deep and very interesting. As of now, we have to stick to the NCERT only. So erythroblastosis fetalis, it is basically the example of Rh incompatibility. Rh incompatibility. Rh incompatibility, right? It is the case of that. So you know that. So see this. Just let's say there is a lady, right? She is having the Rh negative blood group. So Rh negative means her body doesn't know that there is something which is known as Rh. There is one antigen, that is rhesus antigen, right, that is even existing. Rh negative means this body is not familiar with the rhesus antigen. Now she is pregnant and that baby is having Rh positive blood group. Why that baby is having Rh positive blood group? Why that baby is having Rh positive blood group? Because father is having the Rh positive blood group. Now during first pregnancy the issue will not be that severe. You know that we are humans, we are having the intimate connection placenta, right? We are having that placental connections. So you know that, right, from mother's side, right? I'm sorry, I'm going to mix the biology today. I'm sorry, I'm going to mix the biology today. It is fun. So from mother's side, you know that in the case of placenta, from mother's side, yeah, your endometrium is playing the role, your decidua vesicalis, है ना? And from fetus side, you know that what do we have? From fetus side, you are having the chorionic villi. You are having the chorionic villi, that is extraembryonic membrane. So that is how they are making that intimate connection placenta. So it is not like blood is mixed. From mother side, the essential things will pass to the baby through diffusion. We know it very well, right? So there will be the diffusion, we know it very well. Okay, there will be the diffusion, we know it very well. Okay, bache. Now what is the next point here? What is the next point here? Right? The next point here is that during first pregnancy, obviously this baby is getting the essential supply from the mother's placenta, but during first pregnancy the issue will not be there. At the time of childbirth, at the time of parturition, at the time of childbirth, at the time of parturition, of course, when you know that uterus mein oxytocin is released, basically the smooth muscles will show vigorous contraction and relaxation, that blood connections, that intimate connections will break. So at that time the fetus blood, right, the blood of the fetus will, some RBCs will enter in mother's circulation. Some RBCs will enter in mother's circulation. Okay, they will enter in mother's circulation. So when they will enter in mother's circulation, mother's body will be like, here, what is that? What is that? Matlab, mother's body will encounter Rh positive. Mother's body will encounter rhesus antigen. Mother's body will encounter rhesus antigen. So now childbirth is there. Okay, childbirth is there. Okay, mother's body is going to encounter what? Mother's body is going to encounter that rhesus positive antigen. So here what's going to happen, bache? Here's what's going to happen. Now childbirth is there. Mother's immune system will process. You know that it will take time, because it is the example of, right, it is the example of what? It is the example of active immunity. So obviously it is going to take time. So what will happen here? Mother's body will be like, acha, there is one intruder. Mother's body will form the antibodies against it. So in first pregnancy the issue will not be there. Now when there is the second pregnancy, in second pregnancy mother is again pregnant with the positive blood group. Now what is going to happen? Obviously now mother's body is having the rhesus mother's body is having the antibodies against rhesus antigen. Mother's body is having the antibodies against rhesus antigen, right? Against rhesus antigen, mother's body is having the antibodies. So now that antibodies through this, right, placenta will enter in the will destroy the RBCs of that baby. Right, this is the issue. This is the Rh incompatibility. That is why it is advised that in such cases, after the first pregnancy, mother should take anti-Rh injections against that antibodies. Right? Let me mention it here. So that is why it is advised. That mother should administer antibodies against that. Right? Injections against that Rh antibodies. So anti-Rh antibodies should be taken by mother after the delivery of first child. So this is something very important. Okay, this is something very important, right, bache? Now let's talk about the coagulation of the blood. That is also known as blood clotting. So you people tell me, which cells are responsible for blood clotting? Hanji, tell me which cells are responsible for blood clotting. Quick. Which cells are responsible for blood clotting? Cells, exactly. So cells that are responsible, they are platelets. They are also known as thrombocytes. right? They are also known as thrombocytes. They are the platelets. They are also known as thrombocytes. This is the one thing. Their lifespan on an average is 3 to 4 days, right? 3 to 4 days. And you know that these platelets, they are developed from megakaryocytes, right? The cells having very, right, megakaryocyte cells of the blood are going to form the platelets. Done, bache? They are going to form the platelets. This part clear? This part clear? So platelets are also non-nucleated. Okay? These platelets are also non-nucleated. Okay? So we need platelets for the blood clotting. Other than that, calcium ion is very important for blood clotting. Vitamin K is very important for blood clotting. So if they are not there, obviously it can result in the issues in blood clotting. Okay, it can result in the issues in blood clotting. Now what's the point that we have, right? What is that blood clotting? Dekho, in our body we are having a chemical known as, we are having heparin. We are having heparin in our body. What is that heparin? Heparin is the natural anti-blood coagulant. It is the natural anti-blood coagulant agent, means it is something which will not allow our blood to clot. Okay? So now in our body we have intact blood vessel. What is the meaning of intact blood vessels? The blood vessels which are not damaged. So in that intact blood vessels, basically there will be the blood flow, and this blood flow is very important, right? This blood will pass to the organs and they will get the oxygen. This is very important. So in our body we do not want our blood to clot. So that's why heparin is present in our body. That is why heparin is present in our body, because we don't want the clots to form in our body. So heparin is there. Heparin is there. Okay, bache? So it is the natural anti-blood coagulant. And if by chance in intact blood vessel, right, if in within our body, if in blood vessels clots will form, so we will use the word thrombus for it. We will use the word thrombus for it, and this is known as thrombosis. Okay? So thrombus is the blood clot in the intact blood vessel. It is the blood clot in intact blood vessel, the blood vessels which are not damaged, and within the body it is formed. It is something unhealthy, heparin is there. But now when someone is getting the injury, just say I have my chintu, okay, mera chintu, my chintu, what will happen to my chintu, right? My chintu, let's say my chintu got a cut, right? My chintu got a cut. So you know that what is going to happen. You know that what is going to happen. Obviously, if my chintu is going to get the cut here, right, the blood flow will be there. So if there will be excessive blood flow, my chintu can die because of minor cut. So whenever we have the injury, you know that blood clots, they form, right? Blood clotting occur, which will not allow the blood to flow excessively. So when it comes to the blood clotting, some factors are required. So in general, there are total 13 clotting factors. In general, there are total 13 clotting factors, and this blood clotting ka process, it is a cascade. What is the meaning of cascade? It's not a single step process. Multiple steps are there. One step, then after that one step, next step, then next step, then next step, then next step. Now let's say if someone is not able to make the blood clots, right? So minor injury can kill that person. So hemophilia is that disease. Hemophilia is that disease. So I hope you remember hemophilia is what? It is the bleeder's disease. Hemophilia is what? Bleeder's disease. So in that case, that individual will not be able to make the blood clot, right? Person will not be able to make the blood clot. So here itself you can write down that it is sex-linked recessive disorder. It is sex-linked recessive disorder, means that defected allele is on the X chromosome. So here males are affected, right? Yeah, males are diseased, right? Females are the carriers only. Okay, because they have two X chromosomes. So females are the carriers only. Okay, so female will not have hemophilia ever, because that is a lethal combination which will not exist. Okay, that is a lethal combination that will not exist ever, right? In the case of female, it is not possible that both the X chromosomes will have defected allele. Why? Because this is a lethal combination, so it will not form. We will not have any fetus like this. We are not going to get any fetus like this. Okay? So that's the point. So it is X-linked recessive disorder. Now the thing is the cascade one after another, right? So there will be it is the process, right? It is the process where some steps are going to take place. So one after another, right? One after another it will be done. Okay, ji? one after another it will be done. Okay, so first of all, at the site of injury, right, at the site of injury, what is going to happen? At the site of injury, what is going to happen? Platelets will come to this part, platelets will come to this part, right bache? So when there is any injury, it will stimulate platelet in blood, it will stimulate platelets in blood. Okay, so platelets in blood, they will be stimulated, they will reach to the site of injury, right, they will reach to the site of injury. Also the tissue at injury site, the tissue at injury site, I'll give you one example. Just let's say there is a rupturing, so when there is a rupturing of that skin layer or something, the collagen will be exposed. You know na, collagen, the most abundant protein of animal biosphere. So when collagen is exposed na, that's a signal कि there is an injury. जैसे when we are having any injury, right बच्चे, right, the collagen here will be exposed, so that is also a sign that it is the injury. The blood flow will start, right, the blood flow will start to that particular position. So as platelets are also stimulated, so both that things are going to stimulate the release of some factors, right? Because of these two things, there will be release of factors. What will be there? There will be release of factors because of these two things, right? Right, certain factors will be released. Are you getting my point? Certain factors will be released. Do you know that factor, bache? Do you know that factor? That factor is nothing but it is the thromboplastin. Hanji, it is the thromboplastin. That is nothing but the thromboplastin. Even your, right, even that like tissue at injury site, even that platelets, they will release the thromboplastin. So obviously it is exo and endo part, but that we are not going to discuss. So thromboplastin will be released. ठीक है बच्चे, ठीक है बच्चे, okay. So now this thromboplastin, now from these thromboplastin, this thromboplastin will interact with calcium ions. It is going to form an enzyme, that is prothrombinase. It will form an enzyme prothrombinase. It is also known as thrombokinase, right? It is also known as thrombokinase. Are you getting my point? So thromboplastin, these are the factors that will be released, bache, right? So injured tissue will also release it, platelet will also release it. So these thromboplastin, they will react with some plasma protein in the presence of calcium ion, and they will form prothrombinase or thrombokinase enzyme. They will form prothrombinase and thrombokinase enzyme. And moreover, what is going to happen? It will inactivate heparin at that site also, because we need to make the blood clots there. So we have to inactivate the heparin also. So we have to inactivate the heparin. We have to inactivate the heparin. So now in the blood plasma, we have prothrombin. Now in the blood plasma, we have prothrombin. So prothrombin is inactive. You know na, in the blood plasma, we have prothrombin. So this this thrombokinase, this prothrombinase, it will act on that prothrombin, and what will you get? You will get thrombin. What will you get? You will get thrombin. So question can come like this. Out of prothrombin and thrombin, which one is active? Thrombin. Who's going to active thrombin? Your prothrombinase. What is the another name of enzyme prothrombinase? It is thrombokinase. Which ions are required for this blood clotting? Calcium ion. Which vitamin is required for blood clotting? Your vitamin K. Done. Now in the blood itself, you have fibrinogen. Who synthesizes fibrinogen? Liver. Where is it present? It is present in plasma. So it is also inactive and it is soluble. Okay? It is soluble. Now thrombin will act on this fibrinogen. Thrombin along with calcium ions, this fibrinogen will be converted to fibrin. Are you getting my point? This fibrinogen will be converted to fibrin, and this fibrin, bache, it is insoluble. This fibrin, it is insoluble, and it will, right, it will form some, are you getting my point? So it will form some, you know, some meshes where blood cells will be trapped and the clot will form, right? So fibrin will form network where dead and damaged cells of the blood, they will be trapped, and you will have the clot or coagulum. You will have the clot or coagulum, right? You will have the clot or coagulum. Is it clear? Is it clear? So stimulate platelets in blood, tissue at the site of injury, factors will be released, and that factors are nothing but the thromboplastin, which will also inactivate heparin, and with calcium and some plasma protein, this is what they will form. So this is important. This is important. Is it clear? Is it clear? Yes, everyone. This is the blood clotting. This is the blood clotting. Now next, let's talk about the nodal tissue. Okay, let's talk about the nodal tissue. In the nodal tissue, you will be talking about SA node, AV node, AV bundles, which are also forming left and right bundle. Basically, you can simply write bundle of his. Okay, and we will talk about the Purkinje fiber. What are we going to discuss? We'll talk about Purkinje fiber. This is what your nodal tissue is. So if you understand nodal tissue, everything will be easy for you. Okay, everything will be easy for you. So obviously I'm going to make a pathetic diagram, but again my pathetic diagrams are still good to understand the topic. Okay, so you know that when you talk about the human heart, it is myogenic. Myogenic mane, it is the muscular heart, right? Here it will be having a special modified patch of muscle that will initiate the wave of contraction by itself. So directly, indirectly, CNS is going to control the heartbeat. Indirectly, CNS is going to control the heartbeat, but not directly. That's what you have to remember. So heart is myogenic, heart is muscular. Where is it present? It is present in the mediastinum. What is that mediastinum? It's a space in between two lungs. So our heart is present in center, a little push towards the left side. A heart is present in center, little push towards the left side. Take a myogenic heart we have. Okay, so we know that it is four chambered and we are the humans and we are warm blooded, right? We are warm blooded. You know it very well, right, students? So see this. This is your right auricle. This is your right ventricle. This is your left auricle, this is your left ventricle. When you talk about the external structure in between auricle and ventricle, again there is a groove which will separate it, septum there which will separate it. Now when you talk about the internal structure, so you know that in between auricles there is interatrial septum, yeah, interauricular septum. There is a septum which will divide it, right? There is a septum which will divide these auricles also. And when you talk about the auricular septum, it is having a fossa ovalis, which is a thin area, that marks the opening of, it is a thin area that marks the opening of foramen ovale, right? That marks the opening of foramen ovale. Okay, it marks the opening of foramen ovale. Jaise during the embryonic development, heart is there. In between auricle, left auricle and left ventricle, there is a opening, that is fossa ovalis. When the heart grows, that opening will get closed and it acquire a thin area. So in that thin atrial septum, or thin auricular septum, there is a thin area which we are calling as fossa ovalis that marks the opening of foramen ovale. So during development, if this fossa ovalis will, if this foramen ovale will not get closed, that is the condition when we say that heart is having a hole. Okay, heart is having a hole. So this is what you need to remember. Okay, right? So now when it is the, see this, ventricles. So ventricles maybe you see interventricular septum is there. What will we have? We will have interventricular septum. What will we have? We have interventricular septum. Clear, bache? Now in between the auricles and ventricles, because blood will pass. So remember the trick lard, right? You have to remember the trick lard. So what is the meaning of lard? Left means LA, right? The trick is, sorry, my bad. Lard is in breathing and exchange of gases. The trick is Lord, my bad. Here the trick is Lord, Lord. So it means left side is having oxygenated blood. Okay? Right side is having deoxygenated blood. Left side is having oxygenated blood. Right side is having deoxygenated blood. Right side is having deoxygenated blood. Okay, bache? So you know that in the case of humans, we will see double circulation. Which circulation we are going to see? Double circulation, right? Left side will have oxygenated blood, right side will have deoxygenated blood, which will not get mixed, right? That is why we are having the better efficiency and even our energy demands are more. So from right auricle to right ventricle, there is the presence of auriculoventricular bundles here. So when it is the right side, you will talk about the tricuspid valve, right? Right side, you will talk about the tricuspid valve. Which valve are you going to talk about? Tricuspid, right? It is having that three flaps. It is having that three flaps. So what do we have? We are having the tricuspid valve. We are having the tricuspid valve. And when it is the left side, we are having the bicuspid valve, which is also known as mitral valve. right, which is also known as mitral valve, which is also known as mitral valve, bicuspid and tricuspid. Again, important MCQ. Okay. Now in the ventricle, when you look at the musculature, you know that inside it is not smooth, right? Inside it is not smooth, so it will be having the, right, inside it is not smooth, so it is having some triangularly projected papillary muscles. Do you remember that? Triangularly projected papillary muscles. Yes, papillary muscles are there, and to that papillary muscles, you know that here these cords, these are the chordae tendineae. These are the chordae tendineae which are attached to these flaps also. Okay, which are attached to these flaps also. Is it clear? Is it clear? Do not miss this part. This is important. Okay, do not miss this part. This is important. So this is about the structure. So from the right side, you know the proper diagram, but I always explain it in this way. Right, I always explain it in this way. I believe that this topic is quite easy then. Okay, one more thing. Your right side will be having the deoxygenated blood, so it will take that blood to the lungs only, right? It is going to take that blood to the lungs only, and it will to the body parts other than lungs. So here, when you talk about the musculature of the auricles, it is comparatively, auricle walls are comparatively thin, right? They are thin in comparison to the ventricles. Moreover, when you compare right ventricle and left ventricle, because right ventricle has to pump the blood to the lungs only, left ventricle has to pump the blood to the complete body parts. So left ventricle is 3 times, right? It is 3 times more thicker. Its musculature is 3 times more thicker than right ventricle. Okay? Its musculature is 3 times more thicker than right ventricle, right? 3 times more thicker than right ventricle. So right auricle, right ventricle, left auricle, left ventricle. Again, tricuspid valve, I am writing T here. Bicuspid or mitral valve, I am writing B here. So from the right ventricle, you know that what do you have? You have pulmonary aorta. So this is an exception. This is an exception. So this is an exception because this is the artery that will carry deoxygenated blood. Why am I saying this is an exception? Because this is an artery that is carrying deoxygenated blood. So it will carry that deoxygenated blood to the lungs, and in the lungs there will be the oxygenation, right? There will be the oxygenation of blood. The oxygen will be added in the lungs. Okay? Now from the lungs, right? So write down the exception. This is the pulmonary artery, right? From the lungs you have pulmonary vein. So this is also an exception, right? This is also an exception. Why? Because it is the vein that carries oxygenated blood, right? Because here vein, it is the vein that carry oxygenated blood. Otherwise veins, they carry deoxygenated blood. Okay? Otherwise veins, they carry deoxygenated blood. So this is the vein that carries oxygenated blood. So veins, pulmonary veins will carry that blood to the left auricle. So there are 4 pulmonary veins, 2 from each lung. Okay? 4 pulmonary veins are there. Now from the left ventricle, it is your dorsal aorta. It is your dorsal aorta that will carry the oxygenated blood to the different body parts except lung. So this is double circulation. So this is pulmonary. When will it be pulmonary circulation? When your lungs are involved. When your lungs are involved, right? So from right ventricle to the lungs, right? And then lungs are passing that blood to the left auricle. This cycle is of pulmonary circulation. This cycle is of pulmonary circulation. And now from your left ventricle, dorsal aorta will carry the oxygenated blood to all the parts of the body, right? To all the parts of the body, of course, except lungs. Okay? Except lungs, it will carry the oxygenated blood to the complete body. So this is the systemic circulation. This is the systemic circulation. Is it clear? This is the systemic circulation. Is it clear? Is it clear? And this dorsal aorta is also known as systemic aorta. This dorsal aorta is also known as systemic aorta. Understood? Understood? Sure. So this is that double circulation question can come. So in fishes, in amphibians, right, even in reptiles, there is in fishes single circulation. Because their heart is two chambered, they pump the deoxygenated blood, so we call it as venous heart, right? Gills will do the oxygenation. When it is the amphibian and reptiles, because three chambered heart is there in the reptiles, the exception is crocodile. So what is going to happen in their case? What is going to happen in their case? Incomplete double circulation, because in ventricle oxygenated and deoxygenated blood will get mixed. Birds or mammals may double circulation will be there. This is the first point. Now because your right auricle, right ventricle, left auricle, left ventricle, so it will receive the deoxygenated blood, so it will receive veins, so it is going to receive superior vena cava from upper part of body, right, from upper part of body. So it is having no valve, so it is as per the gravity, na, it is not against the gravity. So inferior vena cava, superior vena cava, right? Then we have inferior vena cava. Inferior mane from lower side of the body. This large vein will bring the deoxygenated blood. It will give it to the right auricle. Okay? Then you have coronary sinus. So what is the meaning of coronary sinus? Coronary arteries are the one that will carry the blood to the heart muscle, and coronary sinus will bring back the deoxygenated blood. Right, bache? It will bring back the deoxygenated blood. Is that clear? It will bring back the deoxygenated blood. Clear, bache? Clear. Yes. So basically it is the coronary sinus. So this is extra information. You want to write it, you can. So inferior vena cava is having eustachian valve. Valve will make sure that unidirectional flow is there, and here it is the sebaceous valve. It will just make the unidirectional flow, right? But here when it is the upper superior vena cava is bringing the deoxygenated blood from the upper side, it is having no valve. Now one more thing that you have to remember is, dekho, this is the right side, this is your pulmonary aorta, this is your left side, this is your systemic or dorsal aorta. Okay, so at the base of these aortas, you will have semi-lunar valves. Right? You will have semi-lunar valves. Is it clear? You will have semi-lunar valves. Is it clear? Right? So one thing that you can write down, I will also explain the structure there. Okay? So closure of AV valves. When there is the closure of AV valves, auriculoventricular valves, when there is the closure of AV valves, auriculoventricular valves, it simply means when there is a closure of bicuspid and tricuspid valve, it will produce the heart sound love. Okay? And when there is the closure of semilunar valve, right, the semilunar valve, SL valve, semilunar valve, it will produce the heart sound dove. Okay? So L for love, L for low pitch, L for long lasting. Okay? So obviously dove will be of high pitch and it will be of short duration. So here intensity is also low, here intensity is more. This is a direct PYQ. Clear, bache? This is the direct PYQ. Now look at this SA node. Where is your SA node? SA node means sino-auricular node. Which is also known as natural pacemaker. Okay? AV node. Okay? So you have SAN, that is sino-auricular node, which is also known as natural pacemaker. Okay? Then you have AV node, auriculoventricular node, which is known as natural pace setter. Then you have AV bundles, which will further divide into right and left. Then you have Purkinje fibers. Now one thing that you have to understand, that your heart is a hollow muscular organ. Your heart is what? Your heart is a hollow muscular organ. What is your heart? Your heart is a hollow muscular organ. It is made up of muscles. But the musculature of auricle and ventricle, it is not continuous. But the musculature of auricles and ventricles, it is not continuous. This part clear? This part clear? Yes or no? Yes or no? Yes or no? Right. So the musculature is not continuous. Musculature is not continuous. I'll give you one example. Let's say there is a building. The ground floor belongs to, right, it's the same building. But let's say ground floor belongs to Sheikh and the first floor belongs to Hansuri. Okay? So they are two different person, but the building is same, but the owner of ground floor is someone else and first floor belongs to someone else. Okay? So auricles and ventricles, they don't have the continuous musculature. This is also a PYQ. Now here in the auricle, in the right side, in the upper right corner, you will see some modified patch of muscle, SA node. So this SA node is the one which is auto-excitable. It will initiate the wave of contraction, right? So when it is the contraction, the word will be systole. When there is the relaxation, the word will be diastole. Okay? When there is the contraction, the word that we are going to use here is systole, and then when there is the relaxation, the word will be diastole. Right? Doctor, DR, diastole relaxation. Doctor, DR, diastole relaxation. Okay? Okay? Right? Right. So auto-excitable, systole is for contraction, diastole is for relaxation. Systole is for contraction, diastole is for relaxation. Are you getting my point? Are you getting my point? So SA node is present here in the upper right corner of right auricle, which is auto-excitable. So it will, when it will start the contraction of auricles will be there, and that will pass the blood to the ventricles. So here at the junction of auriculoventricular, at the junction of this auriculoventricle, okay, at the junction near to this AB septum, auriculoventricular septum, what will you see? You will see AV node. What will you see? You will see AV node, auriculoventricular node, right? AV node. Okay? So it is near to this atrial ventricular septum. So when the SA node will contract, this SA node can form, see, all of them are contractile. AV node is also contractile, but the highest action potential, right, means that maximum action potential can be generated by SA node, right? Maximum action potential will be generated by SA node, that is somewhere 75 times per minute. That's why on an average we are having our heartbeat somewhere in 70 to 72 times per minute. So SA node can also have, SA node can generate maximum action potential somewhere 72 action potentials. Okay, so here you have the AV node. So when SA node will contract, it will contract the atria. So SA node is present in the upper right corner of right auricle. AV node is present at the junction of this AB septum, and here it is towards the left side. Now from this AB node, there will be the AV bundle. That AV bundle will divide into right and left. Okay, the AV bundle will arise. Why? Because the musculature of ventricle is different from the auricles. It is not continuous. So from auriculoventricular node, right, your auriculoventricular bundle will arise. So it is divided into right and left bundle, students. It is divided into left and right auriculoventricular bundle, and then these bundles, they will innervate the ventricles, and they are going to form these small fibers. We are calling it as Purkinje fiber, right? Purkinje fiber. So in the musculature of the ventricles, Purkinje fibers are there. So this AV bundle and right and left auriculoventricular bundle is known as his bundle of his. Okay? So we also call it as bundle of his. Okay? Bundle of his. So this auriculoventricular bundle, along with this right and left bundle is making bundle of his, and then Purkinje fibers are there. Are you getting my point? So this wave of contraction from SA node will pass to AV node, then AV node will carry it to the AV node will carry this wave of contraction to the AV bundle and right and left AV bundle, and from Purkinje fibers the wave of contraction will pass from to the ventricles. So in the case of heart, this is the apex, this is the base. So obviously ventricle will start contracting from apex towards the base. That is how they will push the blood vessel. So this is what you need to understand, right? So this AB bundle, bundle of his is present in interventricular septum. It is present here in between interventricular septum, and then Purkinje fibers will transmit that wave of contraction to the ventricles. This is what you need to remember. If it is clear, I want to see some fire emojis in the chat section, guys. I want to see some fire emojis in the chat section if it is clear. Hanji, if it is clear, I want to see that in the chat section. Quick. Quick, quick, quick. Yes, bache, quick. Sure, sure. So when heart will contract, so it is auto-excitable, it will pass the wave of contraction to AV node. Why am I saying it is natural pace setter? It is the pacemaker because it will initiate that contraction. Why am I saying it is the pace setter? Because it will delay that wave of contraction by 0.1 second, because it wants to ensure that these auricles, right, they will just pass their blood completely to the ventricle. They should be empty. That is why it is like that. Then further wave of contraction will be passed through the ventricles. So this is the nodal tissue, okay? And this is also the working of the heart. You know that when we discuss the working of the heart, we talk about the cardiac cycle, isn't it? When we discuss the working of the heart, we talk about the cardiac cycle, isn't it? Isn't it? That's what we discuss. We talk about the cardiac cycle. How many of you know this? How many of you know this? How many of you know this, that we talk about the cardiac cycle there? So when you people talk about the cardiac cycle, okay, when you talk about the cardiac cycle, so cardiac cycle will tell us how that one heartbeat will form, right? Cardiac cycle is for 0.8 second. So basically in 0.8 second, one heartbeat will form, right? Right. So it will tell us about that heartbeat thing. Okay, so I'm directly coming to the important points, bache. So myogenic heart clear, its functioning clear. So you know that maximum action potentials will be generated by your SA node 70 to 75 times per minute, right? And then others can also generate it, but maximum rate is of this only. Okay, okay, bache. So cardiac cycle, it will tell us about the beginning of one heartbeat to the beginning of the next. Okay, beginning of one heartbeat to the beginning of the next. This is it. This is it. So it is for 0.8 second. So here you will discuss about 3 steps: joint diastole, atrial systole, right? Atrial systole, joint diastole, atrial systole, and you will talk about ventricular systole. Joint diastole, atrial systole, and you will talk about ventricular systole. This is what we have. Again, I'm repeating: joint diastole, atrial systole, and ventricular systole. This is what we have. So when you talk about the joint diastole, it is for 0.4 seconds. When you talk about the atrial systole, 0.1 second. When you talk about the ventricular systole, 0.3 seconds. That's what we have. Okay, that is what we have. So it is total for 0.8 seconds. Joint diastole, when atria and ventricles both are relaxing. So when both are relaxing, right, when it is the joint diastole, means resting potential. Resting potential. Now you understand this terminology, isn't it? Now you understand this terminology. So resting potential mane at this time polarization is there. It is not depolarization, polarization is there. So that is how you need to relate the things. So at the time of joint diastole, your AV valves, they are open. They are open. Okay? So without any extra force, but still blood is getting passed from this atria to the ventricle. But yes, here you will see semilunar valves, they are closed. They are closed. Okay? They are closed. Now when there is the atricular systole, again, your AV valves, they are open. AV valves, they are open. And again your semilunar valves, they are closed. Right? They are closed. Right? So here also heart filling of this blood ventricle filling is going on, but when atria will start contracting, so that ventricle filling will increase by 30% spandana. Ventricle filling will increase by 30%. Am I right? That ventricle filling will increase by 30%. That's what you need to keep in your mind. Now here you guys can see the circle. So let's say outer circle is for, right? Let's say outer circle is for atria and inner circle is for ventricle. So you know that this cardiac cycle is telling us about the heartbeat, the beginning of one heartbeat to the next. This is the cycle. So let's say it is 0.1 second, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 and 0.8. This is the cardiac cycle. So you know that your atria will contract at 0.1 second. So overall in cardiac cycle, it will contract for just 0.1 second, right? It will contract for just 0.1 second. So I can say that na ki for 0.7 seconds atria are going to relax. Can I say that 0.7 second atria they are going to relax? They are going to relax. Yes or no? Yes or no? Yes or no? है ना? So for 0.1 second, I am telling you outer circle is for, I am telling you your outer circle is for what? Your outer circle is for the atrial contraction. Your inner circle is for the ventricular contraction. So obviously I can say that ki for 0.1 seconds atria they are contracting. So for 0.7 second they will relax. Now your ventricular systole is for 0.3 seconds. Your ventricular systole is for 0.3 seconds. So obviously at this point it will start, ventricle will start contracting, they will contract for 0.3 seconds, right? So in that cardiac cycle, if I look at this in this way, if I look at it in this way, if I look at it in this way, right? So 0.2, 0.3, 0.4, 0.2, 0.3, 0.4, 0.2, 0.3, 0.4. This is what we have. 0.2, 0.3, 0.4. This is what we have. So basically ventricles are contracting for 3 seconds only, and in the case of cardiac cycle it will start from this 0.2 wala second. So for how long your ventricles will relax? 1, 2, 3, 4, 5. Dekho, overall joint diastole, what is the meaning of joint diastole? Joint diastole mane when both are in relaxed state. So that is of 0.4 second. If in the paper they are asking that individually for how long atria is going to relax, then it is 0.1 second. If they are asking about the ventricle, that for how long ventricle is going to relax, that will be 0.5 second. That is how you can relate it. Joint diastole mane when both are in relaxed state. When both are in relaxed state. Are you getting my point? When both are in relaxed state. Okay? So when there is the ventricular contraction, kindly mark this thing. When there is the ventricular contraction, please mark this thing, your AV valves they will close. ठीक है, ये देखो, bicuspid, tricuspid valves are open. Blood from the pulmonary veins and vena cava will come to the left and right ventricle respectively through the left and right atria. Through the left and right atria. So semilunar valves are closed at this stage. Means when there is joint diastole, semilunar valves are closed. That's your PYQ. Then SA node will generate action potential, that is depolarization. That will stimulate atria to contract, right? And then this time the flow of blood into the ventricle will increase by 30%, already discussed. Now action potential will pass to the ventricular side by AV node and then by the AV bundle, right? Then ventricular muscles will contract, the atria will relax at that time. Okay, so ventricular systole increases the ventricular pressure and there will be the closure of AV, closure of bicuspid and tricuspid valve, and this is the stage when first heart sound love will form. First heart sound love will form. Closure of bicuspid and tricuspid valve will form the first heart sound love. So as the ventricle pressure increases, semilunar valves which are guarding the pulmonary artery and aorta, they will open. Imagine ventricles are putting pressure, semilunar valves will open. Ventricles are putting pressure, semilunar valves will open. So blood will flow to that large blood vessels. Blood will flow to that large blood vessels, obviously. So when ventricular pressure will come down, semilunar valves will close. So by the ending of ventricular systole, semilunar valves will close. So see, so ventricles, when they relax, the ventricular pressure falls, causing the closure of semilunar valves, which will prevent the backflow. So when there is the closure of semilunar valves, the second heart sound dove will form. So it is L for low pitch, L for long duration, L for low intensity. So this is the heart sound which will be having low pitch, which will be for long duration, which is having low intensity. Here high pitch, right, and you guys can relate it further. Okay, so as ventricular pressure declines, tricuspid, bicuspid valves, they are pushed open by pressure in the atria exerted by the blood. So it was emptied into the veins. So blood now once again move freely to the ventricles. So ventricle and atria, they are in relaxed state, right bache, right. So soon the SA node will generate a new action potential, event described above will be repeated. So this is about the cycle, and I already told you about the nodal tissue, and see, SA node can generate maximum number of action potential, right, and it is important for initiating the rhythm. So imagine one heartbeat is for 0.8 seconds, okay, and per on an healthy in a healthy individual you will see average 72 beats per minute, okay, 72 beats per minute, okay. Now next topic, cardiac output. So when you check the cardiac output, how can we calculate it? It is heart rate, and it is multiplied by stroke volume. Everyone please mark it, heart rate and it is multiplied by stroke volume. Heart rate and it is multiplied by stroke volume. What is it? It is heart rate which is multiplied by stroke volume. Are you getting my point? It is heart rate which is multiplied by stroke volume. ठीक है, heart rate माने beats per minute, beats per minute. What is it? It is beats per minute. Stroke volume माने blood pumped by each ventricle. It is blood pumped by each ventricle, right, with per heartbeat. In every heartbeat, what is the blood pump, what is the amount of blood pumped by each ventricle? That is the stroke volume. So it is 72 into 70, so it will be near about, so cardiac output will be near about, what should be the correct answer? You have to multiply 70 to 70, you have to multiply 72 to 70. Hanji, what should be the correct answer? So obviously from this side, from this part, the question can come. Yes, bache. Yes, bache. Exactly. So it is because it is 70 ml, so it is 5050 ml. So roughly can I say that it is 5 liter, right? Roughly can I say that it is 5 liter. So if there is change in the heartbeat, cardiac output will change. If there is the change in the stroke volume, cardiac output will change. So yes, this is very important. Yes, this is very important. Doubt, guys, doubt. So now see, this is the 5 liter, right? And if you relate it with the kidney part, so kidney mein you know that it is the 1100 or 1200 ml of blood that will be, right, filtered by kidney per minute. So obviously it is the 1/5 of this. It is the 1/5 of this. Okay? So that's how you have to relate the things. So tell me, are you enjoying the lecture or not? Are you enjoying the lecture or not? And I you know what, I am not able to realize, right? I'm moving literally very fast. Okay? Right? I have covered all the important topics, guys. I have covered all the important topics. Literally, I have covered all the important topics. Even I am not realizing that I can move that fast. I felt sleepy. Go and sleep then. If you are feeling sleepy, go and sleep. Take a rest. Whenever you will feel fresh, then join the class. Right? If you are feeling sleepy, you are listening to me, that is not helpful. Yes बच्चे, class is very important for you. You guys can score 300 plus. So I believe that you know something from these topics, and these are the most important topics. I believe you know something from biology. ठीक है? Then this class is going to be very helpful for you, very helpful for you. And tomorrow morning 9 a.m. do not forget this session. Do not forget this session, guys. NT authorized complete biology in 100 MCQ. All the 100 topics will be revised. So number of likes are quite less here. Quickly hit the like button. Quickly hit the like button. What you people are doing? It's still 72, right? More than 600 students are watching my lecture. So quick, like this session, right? I want to see that increase here. Quickly, like it right now. Like it right now. Go to the live section of the channel and like it. Go to the live section of the channel and like it. Quick. Wow, only one like, yaar. Seriously. Seriously, very lazy people you are. You guys are very lazy. Just one like. Yes, I will cover 12th biology also. I will cover 12th biology also. Quick. Wow. Thank God 89. Thank God 89. So let's make it 500 plus, yeah. More than 600 students, 700 students are watching the lecture, and likes are so less. ठीक है? Likes are so less. Chalo, like it. So see you all tomorrow. And again, bache, here you will get all the instructions for the paper, right? I will post a video today also how to attempt the paper. But what you need for the examination hall? Arey yaar. What you need for the examination hall? What you should take care? What you need to avoid? Everything is discussed here. ठीक है? ठीक है? चलो. So come to the next topic, electrocardiograph. So what you need to take care, it is electrocardiograph. So when it is the graph, it is that machine. Sorry. It is that machine. Graph is machine. ठीक है? ECG, see, electrocardiograph is machine. So if it is electrocardiogram, focus here. Graph is machine. Graph is machine. So if it is electrocardiogram, right? If it is electrocardiogram, then that graph that you are going to get, right? Where your heart activity will be there. Okay? Where your heart activity will be there. So ECG is the graphical representation of electrical activity of the heart during a cardiac cycle. It is the graphical representation of electrical activity of the heart during a cardiac cycle. Right? ECG is a graphical representation of electrical activity of the heart during a cardiac cycle. Are you getting my point? When during a cardiac cycle. Are you getting my point? Are you getting my point? So it's a graphical representation of activity of heart during a cardiac cycle. Okay? So next is, this is what we need to keep in our mind, right? Just say you have P wave, T wave, blunt waves they are. Q, R, S, they are pointed. So make sure you mark it correctly. This one is Q, this one is R, this one is S. So P shows us atrial systole, means contraction of systole, and QRS will tell us about the ventricular systole. It will tell us about the ventricular systole. And when it is your T wave, so end of T wave marks end of systole. That's what you have to remember. So P wave represents electrical excitation or depolarization of our atria. Depolarization माने contraction माने systole माने action potential. QRS depolarization of ventricles. ठीक है? The contraction, so after Q and marks the beginning of systole. So contraction starts shortly after Q and it marks the beginning of systole. So T wave represents return of ventricle from excited to the normal state. So end of T waves marks the end of systole. End of T wave marks the end of systole. End of T wave marks the end of systole. Now let's move to the mechanism of breathing. Okay? Next chapter. So this is what respiration is. Let's move to the mechanism of breathing, capacities, and then oxygen hemoglobin dissociation curve, and then let's start the photosynthesis. Then let's start the photosynthesis. Ready? Ready? Hanji, Nawaz, please follow the session till the end. But ready? Hanji. Okay. Yes or no? Okay. Yes. Is it clear? Is it clear? So what is the step here? It is the respiration. So respiration mein you know that firstly there is the exchange of gases. ठीक है? Firstly there is the exchange of gases, which is the breathing or pulmonary ventilation, right? So by which atmospheric air is drawn in and CO2 rich alveolar air is released out. ठीक है? So it is the pulmonary ventilation. This is the first step. Then diffusion of gases, transport, diffusion of oxygen and CO2 across alveolar membrane. So when it is the thing, this is the external respiration. This is the external respiration. When there is the diffusion of oxygen and carbon dioxide between blood and tissue, this is also known as internal respiration. ठीक है बच्चे? And finally, when oxygen will be utilized by cell, right बच्चे? So what is it? It is the cellular respiration. It is the cellular respiration. ठीक है? So let's start the mechanism of breathing. So you all are aware of this structure. ठीक है? You all know about this thing. You know this is how the things are. देखो, our lungs, they are bilobed structure. They cannot increase or decrease their volume by itself. Understand this thing. Understand this thing. They cannot increase or decrease their volume by itself. They cannot increase or decrease their volume by itself. That is something that you need to keep in your mind. Are you getting my point? That is something that you need to keep in your mind, that it is cannot increase and decrease its volume by its own. So it is arranged in this thoracic chamber, right? It is arranged in this thoracic chamber in such a way. It is arranged in this thoracic chamber in such a way that if there is any change in the volume of thoracic cage, it will show the change in the volume of lungs as well. If there is any change in the volume of thoracic cage, that will be reflected as a change in the volume of lungs. Means these two are arranged in such a way. Jaise let's say if in last 5 days, 3 days, 4 days you will not revise, then you will see a direct decrease in your marks, right? You will see a direct decrease in your marks. This is the thing. This is the thing that you need to take care. So you know that we are having a rib cage. So rib cage is anatomically airtight chamber. It is anatomically airtight chamber. So when you look at it, you know that dorsal side pe you will have vertebral column. Vertebral column may be thoracic vertebrae specifically. Ventral side pe we see the dagger shaped bone sternum. Laterally what will you see? You will see the rib cage या ribs, ठीक है? And posteriorly, ठीक है? Posteriorly what will you see? You will see the diaphragm. Posteriorly what will you see? You will see the diaphragm. Clear बच्चे? Posteriorly what will you see? You will see the diaphragm. So dorsally vertebral column, ventrally sternum, laterally ribs and posteriorly there will be the diaphragm. So diaphragm is something unique to mammals. This diaphragm, right? This diaphragm is a this diaphragm, it is something, this muscular tissue, it is something which is dividing the thoracic cavity and the abdominal cavity. It is something which is dividing the thoracic cavity and abdominal cavity, and it is something unique to mammals. Yes, bachcho, write it down. It is something unique to mammals. Everyone, it is something unique to mammals. It is something unique to mammals. Clear, bache? Clear, bache? So now your lungs are placed here. Now, can you see the muscles? Can you see the muscles in between these ribs? Can you see the muscles in between these ribs? Can you see the muscles in between these ribs? That red colored muscles. They are intercostal muscles. What are they? They are intercostal muscles. What are they, students? Hanji. What are they? What are they? They are ICM, intercostal muscles. They are ICM, they are intercostal muscles. So you have two intercostal muscles. You have external intercostal muscles. You have internal intercostal muscles. You have external intercostal muscles. You have internal intercostal muscles. Okay? You have external intercostal muscles and you have internal intercostal muscles. This is what you people have. Okay? So these are the ribs. Let's say these are the ribs. obviously the muscles towards the outer side, they will be external intercostal muscle, the one towards the inner side internal. Just let's say, imagine these two fingers, they are ribs, okay? These two fingers, they are ribs. Just imagine it like this. So in between the muscles which are towards the outer side, they are this black colored part is the external intercostal muscle. It is the external intercostal muscle. Now this grayish part is the internal intercostal muscle. So just say these are two ribs, outer side external intercostal muscle, internal side internal intercostal muscles, external intercostal muscles, internal intercostal muscles, external intercostal muscles, internal intercostal muscle. This is what you have. This is what you have. Are you getting my point? Are you getting my point? Plus, we will also talk about the peripheral muscles of diaphragm. Okay? Peripheral muscles, they are of diaphragm. Okay? What are they? They are of diaphragm. They are of diaphragm. Now, let's start with the inspiration. Inspiration mane inhalation, mane to inhale, to take the air in. How is it possible? Outside there should be more partial pressure of oxygen, inside there should be less, right? This is how the inspiration will. Whenever you talk about the air, right? Whenever you talk about the air is what? Air is a mixture of gases. What is air, students? Air is a mixture of gases. Yes or no? What is air? What is air? Air is a mixture of gases. What is air, people? It is a mixture of gases. So because it is a mixture of gases, each gas is having it is going to contribute in its pressure. So that's why we use the word partial pressure. We don't say the pressure of oxygen. Why? Because it is oxygen is not making the entire air. It is just a component of the air. So it is having its partial pressure, right? The pressure exerted by the pressure of oxygen in that air, right? So partial pressure will be the term. Now, when it comes to the mechanism of breathing, you need to focus on one thing, that is your Boyle's law. Okay? You need to focus on one thing, that is your Boyle's law. So when you people talk about the Boyle's law, here it is saying volume and pressure, they are inversely proportional to each other. What is it? It is volume and pressure, they are inversely proportional to each other. Right? Volume and pressure, it is inversely proportional to each other. What is it? It is inversely proportional to each other. Means if volume will increase, pressure will come down. If pressure will increase, volume will come down. They are inversely proportional to each other. Now I want to take the atmospheric air in the lungs, within the lungs. Okay? Within the lungs. So obviously in the lungs, pressure should be low, volume should be high. If I want to inhale, that should be the condition. Pressure should be low, volume should be high. So low pressure means we will talk about the negative intrapulmonary pressure. We will talk about the negative intrapulmonary pressure. What are we going to discuss, students? We will be talking about the negative intrapulmonary pressure. Negative intrapulmonary pressure, that within the lungs the pressure will be low. This is the Boyle's law. So in the inspiration, you will talk about two type of muscles, your diaphragm muscles, right bache, and your external intercostal muscles, diaphragm muscles and external intercostal muscles. Okay? So diaphragm muscles. So remember dance steps. This is what you have to do. This is what you have to do. What is the meaning of this? Dekho, normally your diaphragm is dome shaped, right? When there is the exhalation normal statement, diaphragm is dome shaped. So when diaphragm muscles, they see these two muscles are the inspiratory muscles. Why? These two muscles are the inspiratory muscles. Why? Because they will contract during inspiration. Why? They will contract during inspiration, right? They will contract during inspiration. Clear? So diaphragm muscles, right? When they will contract, diaphragm will become flat. So if diaphragm will become flat, so in that thoracic cage, don't you think that volume will increase towards anterior-posterior axis? Volume will increase towards anterior-posterior axis. Don't you think so? Volume will increase towards anterior posterior axis, right? Because diaphragm is getting flat. So remember here the volume change in the thoracic cavity is equal to the volume change in the pulmonary cavity. Lungs cannot change their volume by their own. So lungs are arranged in thoracic cage in such a way that if there is any change in the volume of thoracic cage, that will reflect in the volume of lungs. Okay? This is the thing. So when external intercostal muscles will contract, right? When external intercostal muscles will contract, so rib cage will move upward and outward. Rib cage will move upward and outward, right? Rib cage will move upward. See, that is why this is the sign: upward, outward, upward, outward. Diaphragm flat, rib cage upward, outward, upward, outward. That is what you need to keep in your mind, right? So it will contract, rib cage will move upward and outward. So when this is the thing, so the volume will increase towards dorsoventral axis. Volume will increase towards dorsoventral axis. So if volume is increasing, pressure will be decreasing. So that's how the air will come in. That is how the air will come in. Is that clear? That is how the air will come in. Is that clear? Sure? Are you sure? Are you sure? Are you sure? Okay, so this is the inspiration. So inspiration is an active process. It takes energy. It is an active process. It takes energy, right? It is an active process. It will take energy. Okay, it is for near about 0.3 seconds. Okay, so this is an active process. It takes energy. Now in the expiration, what is going to happen? Now in the expiration, what is going to happen? In the expiration, right? Expiration is passive. Okay, no energy will be used. So obviously your external intercostal muscles, your peripheral muscles, your diaphragm muscles, right? Your diaphragm muscles and external intercostal muscles, first of all, they will relax. They will relax. I think this part is clear. First of all, they will relax. Again, volume will decrease. Here, the pressure will increase. So CO2 will go out. This is the first thing, right? They will relax. And here your internal intercostal muscles, right, and they will contract. They will contract. So bache, basically in the expiration there will be opposite, and in the expiration one thing that you need to keep in your mind, and yes, here your diaphragm will again be dome shaped. So because the muscles will relax, so during expiration diaphragm is dome shaped, right? Diaphragm is dome shaped. So look at the ribs here. So you have the ribs, in between you have the muscles, okay? In between you have the muscles. That is how muscles are present, right bache? So see this, when there is the inhalation, lungs will be inflated, ribs move out, diaphragm will be curved down, flat. When there is the exhalation, right, lungs will be deflated. That is how the position will be. Okay, okay bache? Okay, so here you can see, so relaxation of the diaphragm and intercostal muscle return the diaphragm and sternum to their normal position, reduces the thoracic volume and reduces the pulmonary volume. So thoracic volume and pulmonary volume. So change in thoracic volume will be seen in the change in the pulmonary volume. So there will be an increase in intrapulmonary pressure slightly above the atmosphere. So expiration में क्या होगा? Expiration में relaxation of these muscles will be there, and बच्चे we can even increase the strength of inspiration and expiration with the help of additional muscles in the abdomen. ठीक है? So when there is the expiration, it is passive, but if it is forceful expiration, so forceful expiration is active. ठीक है? So during forceful expiration, your internal intercostal muscle, your abdominal muscles, they all will contract. ठीक है? Your internal intercostal muscle, your abdominal muscles, they all will contract when there is the forceful expiration. Is that clear? When there is the forceful expiration, is that clear? Is that clear? Sure, sure. So we can increase the strength of inspiration and expiration with the help of additional muscles in abdomen. Understood? Understood? ठीक है? ठीक है? So on an active 12 to 16 times, we take the breath per minute. 12 to 16 times, right? per minute. And you know that how can we measure it? We can measure it with the spirometer. We can measure it with the help of spirometer. Okay bache? Okay, so remember 12 to 16 times per minute, right? So 12 to 16 times per minute. Okay, this part clear? This part clear? So spirometer is used for it. So do not forget the diagram. Do not forget the diagram as well. Diagram is very important. Diagram is very important. Now bache, just to check the functioning of our lungs, we talk about certain pulmonary volumes and we talk about the capacities. So when you talk about the volumes, this is what you are going to discuss. This is what you are going to discuss. Okay? Tidal volume, inspiratory reserve, expiratory reserve and residual volume. Everyone type it in the chat section. Everyone type it in the chat section. Inspiratory tidal volume, inspiratory reserve volume, expiratory reserve volume, residual volume is there. Tidal volume, inspiratory reserve volume, expiratory reserve volume and residual volume is there. Quick, residual volume is there. Quick. Tidal volume, inspiratory reserve volume, expiratory reserve volume and residual volume will be there. Just type it in the chat section, quick. Just type it in the chat section, quick. When it is the capacity, right, lung capacity, pulmonary capacity, capacities are combination of volumes. Capacities are combination of volume. What are capacities? Capacities are combination of volume. जैसे inspiratory capacity, expiratory capacity, vital capacity, total lung capacity, functional residual capacity. Inspiratory capacity, expiratory capacity, vital capacity, total lung capacity, functional residual capacity. So here, first of all, in these first four, keep tidal volume constant. Keep tidal volume constant. Tidal volume will always be considered. Now, because it is the inspiratory capacity, you will have to add inspiratory reserve volume. Expiratory capacity, add expiratory reserve volume. Vital capacity may add both, because you are checking vital capacity, you have to consider both. When total is there, so in total you have to include the residual volume as well, and functional residual may capacity may residual volume plus ERV. So that is what you have to remember. It's easy. देखो inspiratory capacity, देखो tidal volume you have to keep for all the cases, leaving functional residual capacity. Inspiratory capacity में add inspiratory reserve volume, expiratory capacity में add expiratory reserve volume, vital capacity में add both, total lung capacity में inspiratory, expiratory and residual volume, और functional residual capacity में residual volume plus expiratory reserve volume will be added. This is the formula. It is the simplest thing. I don't know why do you make it difficult. Now question can come from their values. So when it is the tidal volume में volume of air inspired or expired normally. I'm talking to you. It doesn't mean that I am not breathing in, breathing out. Obviously I'm doing that. So volume of air inspired or expired during a normal respiration is approximately 500 ml. Right bache? It is approximately 500 ml. What's that? It is approximately 500 ml. Yes or no? Yes or no? Right. So this is the volume per breath. So on an average 12 to 16 times per breath. On an average, a healthy individual will do what? 12 to 16 breath per minute. Okay? So accordingly, you can multiply 12 with 500, 16 with 500. This will be the answer, 6,000 to 8,000 ml of air per minute. 6,000 to 8,000 ml of air per minute. Right? It will be 6,000 to 8,000 ml of air per minute. Understood? 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 So then it comes the inspiratory reserve volume. So inspiration, inhalation, so additional volume of air that you can inspire by forcible expiration. You have to check inspiratory reserve volume. So forcibly, what can you inspire? 2,500 to 3,000. So expiratory will be the opposite. What can you expire forcibly? That is 1,000 to 1,100 ml. Then functional residual capacity may remaining will be considered, right? Because lungs, they cannot be empty always. They will have the residual volume. This is this. Okay? And out of that 500 ml of tidal volume, 300 ml is available for, 350 is available for exchange, 150 ml will be in the dead space. It will be there in the dead space, not used for that exchange of gases. Not used for that exchange of gases. right? So inspiratory capacity, now you have to check the capacity of inspiration. So volume of air a person can inspire after a normal expiration. Normally expiration के बाद what can you inspire, ठीक है? You know the formula. Total volume of air a person can expire after normal inspiration. Functional residual capacity में volume of air that will remain in the lungs after a normal expiration, right? Right? So vital capacity में maximum number of volume of air a person can breathe in after a forced expiration, right? Maximum volume of air a person can breathe in, after a forced expiration, ठीक है बच्चे? So total में total volume of air accommodated in the lungs at the end of forced inspiration, right? The total volume of air accommodated in the lungs at the end of forced inspiration. Clear बच्चे? Clear बच्चे? So that is it. बाकी बच्चे, when it comes to the exchange of gases, here this is the table that you should know. So atmospheric air में this is the partial pressure of oxygen. Alveoli में this deoxygenated, oxygenated and tissue. ठीक है? CO2 का this value is important. This table is important. And I hope you remember amount of CO2 level in oxygenated blood, or you can say that CO2 level in oxygenated blood, या you can say that atrial blood, because arteries are going to carry the oxygenated blood now. So carbon dioxide level in the atrial blood induce inspiration. So if this level will increase, the inspiration will be there. If this level will increase, the inspiration will be there. Is it clear? If this level will increase, the inspiration will be there. Clear bache? Clear? Now this is double circulation, you know it already. So this is the external respiration, internal, and when cell is using the oxygen to oxidize the glucose, that will be cellular respiration. ठीक है? So systemic artery carrying oxygenated blood. So oxygenated blood में partial pressure of oxygen is 95, of CO2 is 40. Here in deoxygenated blood, partial pressure of oxygen is 40 and CO2 is 45. That's what you have to remember. Lungs में partial pressure of oxygen is 104 and CO2 का 40. Understood? Understood? This is the next important image, right? The MCQ can come. So this is alveoli. So alveoli is lined with simple squamous epithelium. It is lined with simple squamous epithelium. Your capillaries are lined with endothelium. So in between there will be two basement membrane, right? Basement membrane. So this is the respiratory membrane, bache, right? And here its thickness should not be more than 1.5 micrometer. Okay? Thickness should not be more than 1.5 micrometer. Is that clear? Is that clear? So in the blood, the CO2 solubility is maximum 20 to 25 times higher than that of the oxygen. Clear bache? Clear, clear, clear? Clear? So now when it comes to the transport of gases, it's a very important topic. So you know that when it is the oxygen will join with hemoglobin. They will form oxyhemoglobin. That is how oxygen will be transported. So 97% of the oxygen is transported by RBC in the blood. 3% will be in the dissolved form. And when it is the CO2, 20 to 25% of CO2 is transported by RBCs, right? And 70%. And remember, when CO2 join with hemoglobin, it's a very important thing, because majority of students, they make the mistake here. When carbon dioxide and hemoglobin, they join. When carbon dioxide and hemoglobin, they join, this is carbaminohemoglobin. What is it? It is carbaminohemoglobin. What is it? It is carbaminohemoglobin. And when carbon monoxide and hemoglobin will join, it is carboxyhemoglobin. So sometimes we do not pay attention on such things, and obviously we end up in losing our marks, right? We end up in losing our marks. So when it is carbon dioxide and hemoglobin, right, it is carbaminohemoglobin. When carbon monoxide plus hemoglobin, carboxyhemoglobin. Don't make the mistake here. Do not make the mistake here. ठीक है बच्चे? Right? Do not make the mistake here. ठीक है? Okay. चलो. So transport of oxygen. देखो. Formation of oxyhemoglobin. You know that blood will transport. It is the blood that will transport our oxygen, right? And how will it transport the oxygen? By forming oxyhemoglobin. 90% will be done by this. So when it is the formation of oxyhemoglobin, it is basically the, you can also call it as oxygenation. Oxygenation of hemoglobin means you are adding oxygen to the hemoglobin, right? It means you are adding oxygen to the hemoglobin. It doesn't mean oxidation. Oxidation is incorrect word here. You are adding oxygen to the hemoglobin, and this formation is temporary. Why is it temporary? It is temporary and it is reversible. It is temporary and it is reversible. Why? Because if oxygen and hemoglobin will bound permanently, then my cells will wait for the oxygen only. The oxygen will come, right, and we will use the oxygen to oxidize the glucose. Obviously they will like this, अरे यार when will it come, when will it come, when will it come. ठीक है बच्चे, ठीक है बच्चे, yes बच्चे, लक्ष्मी, okay, okay, right, right. Yes, yes, है ना. So obviously it is temporary and reversible. This is the oxygenation. So how can it be achieved? How can it be achieved? Right? See, this is very important. For the oxygenation, for the addition of oxygen to the hemoglobin, where will it occur? Where will it occur? Obviously in the lungs, in the alveoli. So here partial pressure of oxygen should be high, partial pressure of CO2 should be low, H positive concentration should be low. If H positive is low means pH is high, and the temperature is also high here. Temperature is also high here. If these are the conditions, the oxygen will be added. So it's all the matter of partial pressure. High partial pressure. देखो, hemoglobin is like this कि whatever I will write, whosoever is more, I will bind with that. ठीक है. Hemoglobin is like कि यार if CO2 is more, I will bind with CO2. If oxygen is more, I will bind with oxygen. Hemoglobin is chill. Hemoglobin is not having true love, right? Hemoglobin is having no true love. Hemoglobin is one is like, okay, I'm getting oxygen, I will bind with oxygen. I'm getting carbon dioxide, I will bind with carbon dioxide. ठीक है. So hemoglobin is like this. Hemoglobin is like this. Are you getting my point? Are you getting my point? So hemoglobin is like, oh my god, oxygen baby is more, its partial pressure is more, let's make oxyhemoglobin. Hemoglobin is like, CO2 is more, CO2 is more, let's make carbaminohemoglobin. Hemoglobin is like this. ठीक है. No to rule out, no to rule out. ठीक है. Now this is the condition for the oxygenation. This is the condition for the oxygenation. You know that we discussed one thing known as oxygen hemoglobin dissociation curve. Do you remember that? We discussed one thing that is known as oxygen hemoglobin dissociation curve. What is it? That is oxygen hemoglobin dissociation curve, isn't it? That is oxygen hemoglobin dissociation curve, and this curve is nothing, it is S shaped, right? This curve is nothing, it is S shaped, it is sigmoid, it is S shaped, it is sigmoid in nature. So this x-axis will tell me about the partial pressure of oxygen, y-axis will tell me about the percentage saturation of hemoglobin, right? It will tell me about the percentage saturation of hemoglobin. Are you getting my point? It will tell me about the percentage saturation of hemoglobin. ठीक है, ठीक है, x-axis and y-axis. So it is S-shaped, and here we talk about the shifts, we talk about the left shift and we talk about the right shift. We talk about the left shift and right shift. This is what we need to understand. So oxygen hemoglobin dissociation curve will tell us that at which partial pressure how much percentage of oxygen is saturated. Jैसे we consider if partial pressure of oxygen is somewhere near about 25 mmHg, so 50%, it will be P50, means 50% of the hemoglobin will be saturated. Just for an example, you know that when you talk about the RBC, right? When you talk about the RBC, right? So shape is not proper, but still RBC, it is enucleated. Why? Because it wants more and more space for hemoglobin. So RBC is just dependent on glycolysis for energy. RBC is just dependent on glycolysis for energy. It doesn't contain the cell organelle, the mitochondria here. Okay? So RBC is fully loaded with the hemoglobin that has to bind with the oxygen. So let's say here 200 hemoglobin, and now when you talk about the hemoglobin, what kind of protein it is? It is the quaternary protein. It is the quaternary protein. It is having 2 alpha chains and it is having 2 beta chains. It is having 2 alpha chains and it is having 2 beta chains, and iron is the central metal ion. Am I right? Iron is the central metal ion. So is it ferrous or ferric? Is it ferrous or ferric? Is it ferrous or ferric? Tell me quickly. Is it ferrous or ferric? Quick guys. What is it? In hemoglobin, iron is the central metal ion. Iron is the central metal ion. So in which oxidation state it is present? +2 या +3? +2 या +3? Which is the oxygenated state? +2 या +3? This is a previous year question, students. Is it +2 or +3? Is it +2 or +3? Is it +2 or +3? Guys, I am going to punish you otherwise. Temperature is low. Temperature is low here. Acha, by mistake I mentioned high temperature. My bad. This is temperature is low here. Obviously temperature is low here. It's not high. Right? By mistake I mentioned the high, but it is low here. Okay? So what am I saying? I am talking about the iron. So iron will be in +2 oxidation state. It will be in +2 oxidation state. You should mention it. Iron will be in +2 oxidation state, means it is ferrous. It is ferrous. This is also important. It's a PYQ. It is also important. It's a PYQ. So iron, if it is in +2 oxidation state, so you know that this iron can bind with the 4 oxygen. This iron can bind with the 4. Just say hemoglobin mein, what do you have in hemoglobin? What do you have in hemoglobin? Heme. Globin is the protein part, heme is the pigment part. This heme is having central metal ion which is in +2 state. So obviously one ion can bind with 4 oxygen molecule. Right? One ion can bind with 4 oxygen molecule. If I am saying that hemoglobin is fully saturated, right? Sorry. Arey yaar, my bad. So how many chains do we have? We have the 2 alpha 2 beta chain. So one hemoglobin can bind with 4 oxygen molecule. First of all, write it down. One hemoglobin can bind with 4 oxygen molecule. Write it down. Quick. Hemoglobin is having 4 units now. So one ion is in +2 state, that is ferrous. So each hemoglobin, right? Each hemoglobin, just say you are having 4 polypeptide chain now. So each hemoglobin, that was incorrect. So each hemoglobin which is in ferrous is in it is having ferrous, iron is in +2 state, so it is having the 1 can bind with oxygen. So hemoglobin is having 4 chains, so obviously, right, this is how we draw it now. 1 2 3 4, so 2 alpha 2 beta chains, and it is having the heme. So heme is that pigment, globin is that protein part. So heme is having the iron, so it will bind with oxygen, it will bind with oxygen, it will bind with oxygen, it will bind with oxygen. So one hemoglobin can bind with 4 oxygen. One hemoglobin can bind with 4 oxygen. One hemoglobin can bind with 4 oxygen, right? So when hemoglobin is fully saturated, it will carry 4 oxygen molecules. It will carry 4 oxygen molecules, right, bache? Right, bache? That is the important point that you need to take care. That is the important point that you need to take care. So if I am saying at 25 mmHg, if I am saying at 25 mmHg, 50% of the hemoglobin is saturated, what is the meaning? Let's say in one RBC you have 100 hemoglobin. I am saying that when partial pressure is 25 mm of Hg, 50 hemoglobin molecules are saturated. Means 50 hemoglobin molecules are binded to the oxygen, right? They are binded to the oxygen. Is that clear? Is that clear? 50 hemoglobin molecule are binded to the oxygen. Is that clear? Is that clear? Are you getting my point? Are you getting my point? Are you getting my point? This is something very important, right? This is something very important. So that curves and shifts are going to tell us this thing. That curves or shifts are going to tell us this thing. Okay, so left shift, right shift is there. So we will be talking about we will be talking about the trick here. So are you ready for the trick? Again, are you ready for the trick? So here the trick is lard. It is not lord here, it is lard. The trick is lard here. The trick is lard here. What is the trick? The trick is lard. So L means left, A means association, A means association, R means right, R means right, and D means dissociation here. So L means left, A means association, R means right, D means dissociation. So means if the curve is taking left shift, can I say so? If the curve is taking left shift, association to associate, what will associate? Hemoglobin and oxygen will associate, means oxyhemoglobin will form. Oxyhemoglobin will form. So you know that what are the conditions? Low partial pressure of CO2, high partial pressure, low partial pressure of CO2, high partial pressure of oxygen, right? There will be low H positive. Low H positive means high pH will be there, and there will be low temperature. That will be the condition. Am I right? That will be the condition. Is there any need to cram here? No. No, no, no. There is no need to cram this part. There is no need to cram this part. If you know this trick, this is how you can revise. This is how you can revise. This is how you can revise. Are you getting my point? Yes? Are you getting my point? Are you getting my point? Sure? Are you sure, students? Are you sure? है ना? है ना? So this is what we have in left shift. Association is there. So if in the paper they are asking about the left shift, so you can see, you can say that these are the conditions which are responsible for the left shift, because it is association. Right is a dissociation. Right means dissociate means to break. There is the breakup. There is the breakup. Right? There will be the breakup. So B for breakup, B for Bohr's effect. B for breakup, B for Bohr's effect. Everyone repeat it with me. After this we will be starting the plant physiology. After it we will be starting the most important topics of plant physiology. So guys, speed up. Right, guys, speed up. Right? So breakup, B for breakup, B for Bohr's effect. So can I say that when there is the right shift, it means the Bohr's effect is there. When there is the right shift, it means there is the Bohr's effect. There is the breakup. There is the breakup. Bohr's effect is there. Can I say so? Can I say so? Yes or no? Can I say so? Of course, yes. Of course, yes. B for breakup, B for Bohr's effect will be there. So obviously you have to reverse the conditions for breakup. So hemoglobin, you know that if hemoglobin will see that there is high partial pressure of CO2, hemoglobin will be like, oh my God, leave oxygen. I will just go and I will have the CO2. Okay? Then there will be the low partial pressure of oxygen. Then there will be the high H positive, which means low pH. I will tell you the transport of CO2, you will understand why is it so. And there will be the high temperature, right? So B for breakup, B for Bohr's effect. So can I say that when there is the right shift, it means Bohr's effect? Can I say that when there is the right shift, there is Bohr's effect? If it is a yes, I want to see the fire emojis in the chat section quick. If it is a yes, I want to see the fire emojis in the chat section quick. Right? Yes, ma'am, it's a fact. Yes, ma'am, it's a fact. Hanji, if you are getting it. Breakup, Bohr's effect. Breakup, Bohr's effect. So left shift means association. So where hemoglobin will form? Obviously in the alveoli. Right? Where that breakup will occur? Obviously in the tissue. Right? So this breakup was meant to be. You know, it was destined. It is destiny. Why? 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 Why is it so? Why? It is destined. Right? The hemoglobin and oxygen, they cannot stay together for the lifetime. You know why? Because if they will stay together for the lifetime, our cells, they will not get the oxygen and they will die. They need oxygen. So they want they really want the oxygen and hemoglobin to break up. So this breakup is very important for our survival. If this breakup will not occur, our cells will not get oxygen. So can I say that it is the Bohr's effect which is responsible for transport of oxygen? Obviously it is responsible for transport of oxygen, because if this breakup will occur, our cells will get the oxygen. So left shift is in the lungs, and it is basically the Haldane's effect. It is basically the Haldane's effect. Okay? So Haldane's effect माने patch up. So Haldane's effect माने the oxygen and hemoglobin will join. It is patch up, so it will be there in the alveoli. This will be the condition. So Haldane's effect is responsible for transport of CO2. It is responsible for transport of CO2. I will explain it to you. So now tell me these shifts clear. So look at this shift. Look at this shift. One more factor is there, but it is not given in NCERT. So when there is the left shift, there is low 2,3 diphosphoglycerate. It should be bisphosphoglycerate rather, right? There should be low 2,3 bisphosphoglycerate. This is what you can write down when there is the left shift. Okay, right shift mein it will be high. That is what you guys can consider. Okay, chaliye. Now let's come to the transport of CO2. Okay, oh my god, I killed one mosquito. Ruko. Oh ho ho. I just killed one mosquito. Oh, sorry, my bad. I'm a murderer, है ना? I'm a murderer. I killed mosquito. Chalo, I'll wash my hands later. Right now, let's focus here. Let's focus here. I think it is more important. So, transport of CO2. Right? Transport of CO2. So, you know that, right? Maximum will be in the form of bicarbonate ion. Maximum will be in the form of bicarbonate ion. So, it is carbonic anhydrase. It is carbonic anhydrase which is responsible for it. So it is the fastest enzyme that you know. It is the fastest enzyme that you know, and its concentration is very high in RBC. Its concentration is very high in RBC, right? Its concentration is very high in RBC. So RBC में भी carbonic anhydrase is there, even in the plasma. You know na, plasma. Plasma is also having carbonic anhydrase, but in negligible amount. Right? But in the negligible amount. It is also having carbonic anhydrase, but in the negligible amount. So it is more in in RBC. So what is going to happen because of that? CO2 plus water. Because of this enzyme, they will join. They will form a weak acid carbonic acid. They will form a very weak acid carbonic acid, that is H2CO3, right? They will form a very weak acid, that is carbonic acid, right? That is a weak acid carbonic acid. Then it will immediately dissociate. Again, due to the presence of this enzyme, you will get bicarbonate and H positive. Now you guys can relate one thing. You guys can relate one thing. Whenever we talk about the CO2, we say that pH will be low because there will be more H positive, right bache? pH will be low because there will be more H positive, yes or no? pH will be low because there will be more H positive, yes or no? Right? Right. So see, now you can understand how is it possible. Okay, how is it possible? So you know that hemoglobin is also there. Just let's say you have oxyhemoglobin. Okay, so now when H positive is increasing na, so hemoglobin will be like, oh my god, I have to release my oxygen. I will bind with this H positive. I will form hemoglobinic acid. Hemoglobin is a buffer there. Okay, when H positive is increasing, this H positive will bind with the hemoglobin. It will form hemoglobinic acid, right? It will form hemoglobinic acid, that is acting like a buffer. This is the one thing that you have to remember. Moreover, these bicarbonates are more within the RBC. Now they were like, meh, I have to go out, right? They are like this. ठीक है बच्चे? Guys, is there any issue with the voice? Yes? Guys, is there any issue with the voice? Or is it fine? Yes, students are saying low voice is there. Now is it fine? Now is it fine? Now is it fine? Yes, now is it fine? If it is fine, then please send me the thumbs up. Please send me the thumbs up. I have to finish this topic. Let's move to the plant physiology. Let's move to the plant physiology quickly. Okay. So CO2 and water, carbonic anhydrase is there. So it is the carbonic acid and that will dissociate and there will be the bicarbonate and H positive. There will be the bicarbonate and H positive, right? What is there? There will be the bicarbonate and H positive. Clear bache? Clear bache? So now when you talk about these bicarbonate ion, they are crying that, oh my God, I cannot stay just in the RBC, I have to go out. Right? They will start increasing. They will start demanding, nahi yaar, I have to go out. I have to go out. I have to go out. They are like this. Right? So obviously if we will send and their concentration is more within the RBC, their concentration is less in plasma. So they will move to the plasma. Bicarbonate ion will move to the plasma. But bache, if they will keep moving to the plasma, ionic disturbance will be there. So just to balance that, if bicarbonate ion is going out, chloride ion will enter. Chloride ion will enter. So MCQ can come like this. So bicarbonate is moving from RBC to plasma or plasma to RBC. Bicarbonate is moving from RBC to plasma. Bicarbonate is moving from RBC to plasma. Bicarbonate is moving from RBC to plasma. Now chloride ion will move from plasma to RBC. Chloride ion will move from plasma to RBC. Clear bache? Chloride ion will move from plasma to RBC, right? Plasma to RBC. ठीक है बच्चे? ठीक है बच्चे? So this is basically the chloride shift. This is basically the chloride shift. It is also known as Hamburger phenomena. It is also known as Hamburger phenomena. This is the chloride shift. Not given in NCERT, but you will get the question on the basis of that. Right? So that is how bicarbonate will be transported. Okay, and CO2 also joined with the hemoglobin, it form carbaminohemoglobin. This is about the transport of CO2. This is about the transport of CO2. So see, this is happening in the tissue, right? This is the best diagram. Carbonic anhydrase is the fastest enzyme. CO2 plus water, it will form carbonic anhydrase. So it is the carbonic acid. So they will dissociate. So HCO3 positive will go to the plasma. Chloride will enter and that is the chloride shift. I told you H positive will join with hemoglobin. You will get hemoglobinic acid that is basically acting like a buffer. Okay. And moreover, this is basically when H positive is increasing, hemoglobin and oxygen will dissociate. So this hemoglobin is basically binding with the H positive. Clear bache? Clear, clear, clear. So that is how it is going to occur. So in the plasma also, right? In the plasma also you are having carbonic anhydrase, but that is comparatively less, so it is slow, right? It is comparatively less or it is slow. So that's how it works. Okay. Now in the alveoli, there is the reverse chloride shift. Yeah, you can say that. You can say that what is going to happen? There is a reverse chloride shift. I'll tell you how. In the alveoli, you know that conditions are this. Now here, this by CO2 and water, basically now here what is going to happen, bache? Chloride shift is reversed. What is the meaning of that? Now bicarbonate. So in the paper, read the question carefully. If they are asking chloride shift in plasma, so in basically in that tissue, in that, right? So what is happening? So bicarbonate, HCO3 negative will come out from RBC, right? Chloride will enter. But if they are asking the reverse chloride shift, it is in alveoli, so your chloride will come out from RBC, bicarbonate will enter. This bicarbonate will join with the hemoglobin, right? They will form carbonic acid. Carbonic acid will again dissociate here. CO2 plus water is formed and CO2 will be released. CO2 will be released. This is about the transport of gases. This is about the transport of gases. Okay? Now, under normal condition, how can I forget that? You know that 100 ml of blood, 100 ml of blood contains 15 gram of hemoglobin. 100 ml of blood contains 15 gram of hemoglobin. 1 gram of hemoglobin, it transports 5 ml of oxygen. Right? Okay. 100 ml of blood contains 15 gram of hemoglobin. 100 ml of blood contains 15 gram of hemoglobin, and 1 gram of hemoglobin, it binds to the 1.34 ml of oxygen. So that is why 100 gram of blood is having approximately, 20, I'm telling approximately it is having 20 ml of oxygen, yes or no? 100 ml of blood is having 15 gram of hemoglobin. 1 gram of hemoglobin can bind to 1.3 ml of oxygen. It can bind to 1.3 ml of oxygen, and 100 gram of hemoglobin, so 15 into 1.34, somewhere in between 20. ठीक है जी, somewhere near about 20. ठीक है? Yes or no? Yes or no? हाँ जी, yes or no? Tell me quickly. 1 gram of hemoglobin can transport 1.34 ml of oxygen, and 15 gram of hemoglobin is approximately having 20 ml of oxygen, right? It is having, so if 1 gram is having this 15 gram, so 15 into 1.4, you can measure it. Okay? Now when you talk about the deoxygenated blood, in the case of deoxygenated blood, what will you see? You see that 100 ml of blood is having somewhere 15 ml of oxygen. So from that we judge that 5 ml of O2 is transported, right? 5 ml of oxygen is transported by 15 gram of hemoglobin. You can write it down. 5 ml of oxygen is transported by 15 ml, right? 5 ml of oxygen is transported by 15 gram of hemoglobin. By 15 gram of hemoglobin, that's what you need to keep in your mind. And 4 ml of CO2 will be transported. Okay? 4 ml of CO2, 4 ml of carbon dioxide will be transported by 100 ml of blood. That's what you need to keep in your mind. So it is under the normal condition. So let's talk about the photosynthesis. ठीक है जी? Let's talk about the photosynthesis. Any doubt? हाँ जी students, any doubt? Any doubt? If up to this part all clear, do let me know. Do let me know in the chat section if everything is clear up to this part, right? So human physiology, all the important topics are done and dusted. Now in next maximum in 2.5 hour, let's finish the plant physiology, then let's move to the next part. Let's revise the important topics of anatomy, let's revise the important topics of plant kingdom, animal kingdom, and then let's move to the next part. So is it clear? Is it clear? Is it clear? I have to finish all the important 60 topics. So guys, whatever time it is going to take, I will, right? So I didn't it is not final that I'll take the lecture for 10 hours, for 12 hours, for 13 hours. Maybe I'll finish it within 7 hours, maybe in 8 hours. It depends. We have to complete the topics first. So this is the chloroplast. So chloroplast may, you know that light, chloroplast, right? So this is the chloroplast, this is the stroma. So in the stroma, there will be the dark reaction, because all the enzymes for this dark reaction are present in stroma. So dark reaction is a misnomer term that doesn't mean the reaction will occur in darkness. It's just that it doesn't need light directly. It is dependent on the product of light reaction. Here you will also see this thing. You are calling it as grana. So granum is singular, grana is plural. Okay? So what is the thing that you need to notice here is thylakoid. Okay? What you need to take care, you need to talk about the thylakoid. So thylakoid is a membranous sac. What is thylakoid? It's a membranous sac. So many thylakoid, they will pile up, and they will form granum. Right? They will pile up, they will form granum. So these thylakoid, the lumen here, the membrane of the thylakoid here, this membrane will show the light reaction. It is going to show the light reaction. Clear, bache? So it is in chloroplast. So obviously surrounding me you have the stroma. This is the point. This is the lumen of the thylakoid. This is granum. Now one more thing is there, right? So this is the non-appressed part of the granum. This membrane, this portion is the appressed part. Now this is right bache? So this is the thing. So this is one granum, this is another, so plural is grana. So in between this part is your fret lamella, right? This is your fret lamella. It is also known as stroma thylakoid. It is fret lamella. It is also known as stroma thylakoid, right? It is also known as stroma thylakoid. It is also known as intergranal thylakoid. It is also known as intergranal thylakoid. Clear bache? Clear bache? So this one will contain only PS1. Okay. Now in the thylakoid lumen, the oppressed part is there, the non-oppressed part is there. Oppressed part is there, non-oppressed part is there. So mainly here you will, in the granum overall you will see photosystem 1 and photosystem 2. But in the case of fret lamella you will only see PS1. You will only see PS1. What are you going to see there? You will only see PS1. This is important, but here you will see both. Now, what is this photosystem thing? What is this photosystem thing? If you will check my top 60 topics wala video, you know that this topic is there. So when you talk about the photosystem, it is made up of, it is basically the group of the pigments. What are pigments? That can absorb the sunlight. That can absorb the sunlight. So now when you talk about the photosystems, you have two things. One is the reaction center. One is the reaction center, right? And another is the, one is the reaction center and another is the antenna complex. The antenna complex is also known as light harvesting complex, LHC. It is also known as light harvesting complex, LHC, right? It is also known as light harvesting complex, LHC. So reaction center mein you will also have only have chlorophyll A. It is the universal pigment and it is the pigment of reaction center. Now in antenna complex you will have other pigments, like chlorophyll B, carotenoids, right, etc. So they are also known as shield pigments. They are also known as a shield pigment because bache they will protect this chlorophyll A from the photo oxidation by sunlight, right? From the photo oxidation by sunlight they are going to protect it. They are the shield pigment. So antenna complex will have other pigments other than chlorophyll A. So chlorophyll A will also absorb the light. Other pigments will also absorb the light, but here these other pigments can absorb the different wavelengths of light. So ultimately all of that will be passed to the reaction center and reaction center will exude the electron. So electron will flow in that light reaction and that flow of electron will create the proton gradient and finally ATP will be formed, right? Finally ATP will be formed. That is the point here. Finally ATP will be formed. That is the point here. Understood? Understood? So photosystem, this is what we have. Now when you talk about the photosystem 1 and photosystem 2, right? So I told you basic thing is same. So their name is as per the order of their discovery, not as per their function. The name is as per the order of their discovery, not as per the function. PS1 is involved in both. It is involved in both cyclic, I'll explain each and every term here, cyclic photophosphorylation and non-cyclic photophosphorylation. Cyclic and non-cyclic photophosphorylation both are going to have this. Okay? Both are going to have this. Cyclic bhi and non-cyclic photophosphorylation both are going to have this PS1. But PS2 will only be there in the non-cyclic photophosphorylation. Okay, bache? So, right, so this is something very important. PS1 is present in granum. It is also present in, PS1 is present in granum and it is also present in the fret lamella. You guys can see that, right? You guys can see that. Hanji, you guys can see that, yes or no? Yes or no? Yes or no? Here you will see it is P700, it is P680. Means it can absorb the light wavelength, light at 680 nanometer and here at 700 nanometer. So it is having, Hanji, PS1 is having, it is reducing, it has a reducing nature. It has oxidizing nature. It has oxidizing nature. Is it clear? One is having reducing nature, another is having oxidizing nature. Is that clear? Is that clear? Yes or no? Yes or no? Yes or no? Right? So reaction center and light harvesting complex is making PS1. So it will show maximum absorption at this and it is at this. So this difference is very important. Photosystems are very important. Their location is very important. Their location is very important. Now chlorophyll 1 and chlorophyll A and B. Chlorophyll A में देखो central metal ion always in chlorophyll is magnesium. Central metal ion is magnesium. But when it comes to the biosynthesis of chlorophyll, you need iron. You need iron. ठीक है, and light is very important for the synthesis of chlorophyll, and for the synthesis of chlorophyll you even need the amino acid glycine, right? You even need the amino acid glycine. Is that clear? Right? So glycine is very important for the chlorophyll A synthesis, light is important, and for biosynthesis iron is required, but central metal ion is magnesium and it is having tetrapyrrole ring. And here in 6th ring at 5th position, chlorophyll A will have methyl group, chlorophyll B will have aldehyde group. This is a very common difference. Aldehyde group in chlorophyll B, methyl group in the chlorophyll A. This is the difference. Mark it. Right? Question can come from this part. Please mark it. Question can come from this part. Please mark it. Quick. Quick. Now look at this graph. It is telling us about the absorption. So chlorophyll A, right? Chlorophyll A is having bright or blue green color in chromatogram. Chlorophyll B is having yellow green color in chromatogram. Xanthophyll is having yellow color in chromatogram, and carotenoids yellow to yellow orange, right? It is yellow to yellow orange. A is having bright or blue green color. B is having yellow green. Xanthophyll is having yellow. Carotenoids is yellow to yellow orange. Understood? Understood? So this is basically the absorption spectrum. Absorption spectrum. So you know that blue and red light will be absorbed more and they are having the maximum efficiency of photosynthesis. So if you will look at the chlorophyll B, it absorbs more blue light in comparison to red light, and chlorophyll A absorbs more red light in comparison to chlorophyll B. Okay, that is also, this is also a way to compare, right? So blue and red light will have maximum efficiency here. This graph is rate of photosynthesis, absorption of photosynthesis. Sorry, this is absorption, this is action spectrum. Action spectrum tells us about the rate of photosynthesis. So in blue and red light, maximum rate of photosynthesis is there. So one question will come from this graph. One question will come from this graph. Okay, one question will come from this graph. Okay, next. Right? So absorption and action spectrum. Next part, photosystems clear. Photosystems clear. Okay? Now there is the thylakoid membrane. Thylakoid membrane. Chalo, let's consider the thylakoid membrane only. Okay? So here you have the lumen of thylakoid. Here obviously stroma is in the surrounding. So here na the light reaction will occur. Right? Light reaction, which is also known as photochemical reaction, will occur. Light reaction, which is also known as photochemical reaction, it will occur. It is the Hill reaction. So here you have the presence of certain photosystem. So electron will move from PS2 to PS1. That's what you need to keep in your mind. The movement of electron. I am directly telling you the correct answer. Right? Right? I am directly telling you the correct answer, the MCQs. If you want to revise it in more detail, you can check my class 11th botany marathon. You can check my class 11th botany marathon. Otherwise, focus here. Okay? Electron movement will be there in this light reaction. That, dekho, photosynthesis mein you talk about two reactions. You talk about two reactions. One is the light reaction, another is the dark reaction. So dark again is a misnomer term. So it is dependent on light but indirectly. Light reaction mein oxygen will release, ATP will form, NADPH will form. Here dark reaction mein CO2 will be reduced and your glucose will form. Okay? Or you can say that carbohydrate will form. Right? Carbohydrate will form. So this dark reaction, it needs ATP and NADPH. If it will not get ATP and NADPH too, it is not going to reduce the CO2. Right? So light reaction will be in the thylakoid membrane, dark reaction will be in the stroma. Okay, these are the two parts. So here electron transport will be there, and electron will transport from photosystem 2 to photosystem 1. So when you look at this thylakoid membrane is there, lumen is there, stroma is there, PS2 will send the electron to PS1. So what is going to happen here? Just say this is the PS2, then unknown is there will be the electron acceptor pheophytin. You will talk about the quinone there, okay? Quinone there, then cytochrome B6F complex. So that is how it is present. So basically right now, what am I talking? I am talking about the non-cyclic photophosphorylation. Non-cyclic photophosphorylation. So I know that you don't even know the meaning of cyclic and non-cyclic photophosphorylation. So firstly, let's discuss that. Okay, firstly, let's discuss that. Dekho. The word is non-cyclic photophosphorylation. Here it is cyclic photophosphorylation. Cyclic photophosphorylation. So phosphorylation माने addition of phosphate. Phosphorylation माने addition of phosphate. What is the meaning here? It means addition of phosphate, right? It means addition of phosphate. But bachche, photo is the word. Photon माने light. In the presence of light, phosphate is added, right? It means in the presence of light, phosphate is added. In the presence of light, phosphate is added. In the, again I'm repeating, presence of light, phosphate is added. So non-cyclic. जैसे PS2 से electron will go to PS1. Okay. Here you will also see photolysis of water. You know that photolysis of water में what is going to happen, right? Man ka college. What's the trick, students? Man ka college. What is the trick? Man ka college. These three ions are obtained. So you will have 4H positive, 4 electrons and oxygen will be released. Plus here you will see ATP will form, NADPH2 will form, and obviously oxygen will be released. Okay? Here cyclic. If something is starting from A, it will come back to A. Right? So here only PS1 is involved. Only PS1 is involved and only ATP form. Take care, only ATP form. Why? Because here enzyme NADP, FNR, ferrodoxin NADP reductase. FNR is absent. Right? FNR is absent. Means ferrodoxin NADP reductase. Ferrodoxin NADP reductase is absent here, right? And here it is absent. So these are some general difference from where the question can come. These are some general difference from where the question can come. These are the direct topics. If you don't understand Z reaction, that zigzag reaction, the light reaction, at least focus on these points, okay? At least focus on these points. So where are that pigment molecules located? They are located in the thylakoid membrane. Where are they located? They are located in the thylakoid membrane. Come to this part. Dekho, your photosystem 2, because we don't have time to draw and to draw or something, that's why I am taking the reference of images. And if you have studied this Z scheme first, then it will be easy for you. Otherwise, it will be little difficult. Okay? And yes, how can I forget? Dekh rahe ho? We are ready with the paper discussion as well. Okay, we are ready for the with the paper discussion as well. So on 5th of May, right at 5:20, we will be live for the detailed paper discussion. So again, hit the like button and click on the notify me. Take a click on the notify me. Right. So after the paper, just open the YouTube channel and come to this part. Okay, open our YouTube channel and come to this part. Okay. Now here. देखो डिसऑर्डर्स का वन शॉट इंपॉर्टेंट लेक्चर है और कंप्लीट बॉटनी मैराथन ऑफ क्लास 11 दिस इन दिस सेशन इन डिटेल वी हैव डिस्कस्ड. ठीक है, इन दिस सेशन ऑफ कंप्लीट बॉटनी मैराथन ना इन डिटेल वी हैव कवर्ड दैट photosynthesis and this Z reaction, but still I will tell you the PYQs, right? I will tell you the PYQs. We will discuss the PYQs, so you can check this session if you want to revise it. Now come back to this. So imagine this is how your Hanji. So this is how everything is present, right? So when it is PS2, right, towards the lumen side it is having OEC, oxygen evolving complex. So here the photolysis of water will occur. Here the photolysis of water will occur. Now here you will see some mobile electron carrier. Just here in between you will see pheophytin and all, quinine and all. So then here you will also see cytochrome B6F complex, right? So that is how it is present. Now when you talk about the PS1, so towards the stroma side it is having FNR, this enzyme, and this enzyme ultimately reduce, right? It is ultimately going to reduce NADP to NADPH2. Now come to that Z scheme. Why do we call it as Z scheme? It's not like that your electron carrier, electron transporters will be present in this way. No, it's just the flow of electron. Because of the flow of electron, just say PS2 to pheophytin, this is the uphill transport, right? Here electron will transport from one electron carrier to another, and it will be done as per the redox potential, as per the oxidation reduction potential. You know that there is a molecule, there is an entity, if it is having low redox potential, and there is another molecule, if it is having high redox potential, high oxidation reduction potential, so it is having more tendency to take the electron. That is how the electron flow is. Are you getting my point? So that is how electron will flow. Now here it is zigzag. So simply you can remember from PS2, electron will pass to the electron carrier, the first acceptor of electron. First electron acceptor here is the pheophytin. So this first electron transport is as per, it is uphill against the redox gradient. That's all. This is the important point. PS2 to pheophytin, when electron will pass, only this is uphill transport. Matlab PS2 is having high redox potential, pheophytin is having low redox potential, still electron will move. That is why it is uphill, and remaining will be downhill. Just pheophytin to that plastoquinone will form plastohydroquinone, then it will pass the electron to cytochrome B6F complex, then it will pass the electron to plastocyanin, that will pass it to the to the PS1. So you can only remember it if you have studied it before. So if not, this is what you can revise. That will be helpful for you. Already I told you about the reaction of photolysis, right? So this is how it can help. Okay, so see this PS2 P680, it will absorb the light, right? Obviously it will exude its electron, it will come to the excited state. After it will pass its electron to the first electron carrier, electron acceptor, that is your pheophytin. So if pheophytin is going to accept the electron, it will be reduced and your P680 will be oxidized. So if any molecule is oxidized, means it is in excited state. We have to bring it back to the normal state. Right? So for that, photolysis of water is there. So in photolysis of water, the electrons that are released, that will be passed to the P680, it will come to the ground state, and H positive will be there in the lumen. Now from pheophytin, electrons will pass to the plastoquinone. Guys, one thing that you have to remember is that plastoquinone is also the hydrogen acceptor. It is not just the electron carrier, it is the hydrogen acceptor. So it will pick up the hydrogen from stroma. Ultimately here in this thing, what we have to do, this is your lumen of thylakoid, in the surrounding there is stroma. We have to increase more and more H positive within the lumen. Or surrounding mein, stroma mein, there should be less. This is what we have to achieve. So when plastoquinone will pick up the hydrogen from stroma, it will form plastohydroquinone. If quinol is the word, this can be asked as a question. Plastohydroquinol. If quinol is written, you should understand that it is yes, what is it? It is reduced. it is reduced. If quinol is the word, it is reduced. Plastohydroquinol, it is reduced, right? So when this plastohydroquinone, you can also write it like this PQH2 because it is the hydrogen carrier. So plastoquinone will pass the electron to it. H positive will also be picked up by stroma. So when it will pass its electron to cytochrome B6F complex, one more H positive will be sent within. Then plastocyanin will receive the electron and then it will pass it to the P700. So P700, that is your photosystem 1, is also simultaneously absorbing the energy. It is also exuding the electron. So that electron will be accepted by unknown electron acceptor and finally by the ferrodoxin. So ferrodoxin is associated with an enzyme FNR. What is that FNR? This is ferrodoxin NADP reductase. I will tell you the PYQs here directly. If you are not able to understand it, please focus on the PYQs. Ferrodoxin NADP reductase. So this enzyme, because it is associated here towards the stroma side it is. So here it will reduce, NADP is oxidized, it will reduce it, it will form NADPH2. It will form NADPH2. So what is the difference in NADPH and NADPH2? If NADP will receive 1 electron, 1 proton, it is NADP. If it receives 2 electrons, 2 protons, it is NADPH2. It is NADPH2. It is NADPH2. This is the flow of electron. Now, what we have to remember? Electron will flow from PS2 to PS1. This is the first point, right? So when PS2 is oxidized, who's going to give it the electron to reduce? Right? Photolysis of water. Right? Water is going to give it the electron. When your PS1 is oxidized, who's going to pass the electron to it? Priyanka Chopra, that is your plastocyanin. Okay? So in this complete process, which one is the, these are the direct PYQs asked from this particular topic. These are the PYQs of this particular topic, right? PYQs of this particular topic. So what is the next part here? This is the one thing that you need to understand. What is the next part? So one is oxidized, another is reduced. This part clear? The next part is which one is the hydrogen carrier also, that is your plastoquinone. It is not just the electron acceptor, it is also the hydrogen carrier. These are the direct topics. Clear bache? These are the direct topics. Clear? These are the direct topics. Understood? So this is what your non-cyclic photophosphorylation is. So cyclic is very rare, it will start from PS1. Cyclic is occasional, it will start from PS1. So electron, can you tell me where will the electron go? From PS1? Anyone in the cyclic photophosphorylation, right? So electrons will go to that ferrodoxin reducing substance. Then it will go to ferrodoxin. Okay. So ferrodoxin will pass that electrons to cytochrome B6 complex. That will pass it to PQ. That PQ will further pass it to cytochrome F complex. This is how it is. Cytochrome F complex. This is how it is. And finally to the plastocyanin and finally to the PS1. So what you have to remember here for the PYQs, if it is cyclic photophosphorylation, PS1 is involved. So it will be taken in fret lamella. Where will it occur? In the fret lamella. What will be formed? Only ATP. Which enzymes are absent? Ferrodoxin NADP reductase. No oxygen will be released. So these are the PYQs that you can cover from this topic. That's it. That's all. Next is chemiosmotic hypothesis. Obviously, you know that CF0, CF1 is there. Right? CF0 and CF1 is there. CF0 and CF1 is there. Okay? Can you see that? CF0, CF1. So CF0 is traversing, means it is in the membrane. It is traversed, it is in the membrane. Your CF1, which include head and stalk, it is in stroma. This is the question. This is the one question that can come. This is a PYQ. Again, I am mentioning it, bache. I am just dealing with the PYQs right now. I am dealing with the PYQs here right now. This is a direct PYQ. Now you know that more H positive. During this process, more H positive is in lumen. This is also a question. More H positive is in lumen. More H positive means within lumen, low pH is there. Low pH is there, and here this is your mobile carrier plastoquinone is present here, which will form plastohydroquinone. This position should be clear. So low pH is there in the lumen, and stroma mein there is high pH. Why? Because it is having low H positive. So you know that these H positive cannot cross the membrane directly. They need, right, as per the concentration gradient they will move, but they need a channel by which they can move, right? So it is a kind of facilitated transport. So H positive, right, will move from this, right? It will move from this ATP synthase. It will move from this ATP synthase, right? And basically when it will move, right, see, this is the inside is having high electrochemical potential gradient, outside is having low. So when H positive will move, energy will be produced. So ADP plus PI will join and ATP will be produced. That is it. That is it. This is also a PYQ. This is also a PYQ. Next point, where is plastocyanin located? It is located towards the lumen side. It is located towards the lumen side. This is also a PYQ. Where is the photooxidation of water will occur? Towards the lumen side. This is also the PYQ. Remember this diagram, remember the PYQ. You will be able to answer all the questions asked from this topic if you will focus on this part. Trust me, if you will focus on this part, you can cover all the important topics. Clear, bache? You can cover all the important topics. Right? That is the point. Okay? That is the point. Understood? Understood? So you will be able to answer all the question if you will just mark the PYQs. So you know that where will they use? Where are we going to use the? Where are we going to use these ATP and NADPH2? In the dark reaction. Where are we going to use the ATP and NADPH2? In the dark reaction. At least 3 questions. Minimum 3 questions are expected from this portion. Minimum 3 questions. I'm not talking about the light reaction. I'm talking about the dark reaction. Minimum 3 question, mane 12 marks. So are you willing to get your 12 marks? Guys, my back-end team is saying my volume is fine. My family, right, they are also listening to the lecture. They also checked my lecture on the laptop. They are saying volume is fine. I can't do anything with the volume. Okay, this is the best I can do right now. This is the best I can do right now. If there is any issue with the volume, please don't waste your time. You can revise by your own. Okay? So, minimum 3 questions. So, are you willing to complete it? Dark reaction mein se, I am not saying overall chapter. Light reaction mein se 3. So, if 6 questions you are going to get from photosynthesis means 24 marks. 24 marks, and it can be more than that, and it's worth it. Right? So I know it's difficult to understand. I know it's difficult to understand light reaction at this point of time. I know it is difficult to remember light reaction at this point of time, but it is not difficult to remember the PYQs. And I have discussed all the PYQs with you. Okay? I have covered all the PYQs. I have discussed all the PYQs with you. So are you ready? If it is a yes, so I want to see some excitement in the chat section, people. What are you doing? Chalo. So I want to see some excitement in the chat section. Quick. Quick. Yes. Yes. Pakka. Minimum 3 questions from dark reaction. Again, we will discuss the important things only. We are going to discuss the important things only. Okay? Chalo ji, let's go. Dekho. Dark reaction will be in stroma. First point. Dark reaction will be in stroma. This is the first point. First point. CO2 will be reduced here, right? And we will be needing ATP and NADPH. We will be needing ATP and NADPH. Okay? This is the point. So obviously it is enzymatically based. Enzymes are needed here. ठीक है. Now what's going to happen? In the dark reaction, we have to understand C3 cycle, we have to understand C4 cycle. When it is the C3 cycle, it is Calvin cycle also, Calvin-Benson cycle also. ठीक है जी, ठीक है. Why is it C3? Because first stable product is a 3 carbon containing compound. It is a 3 carbon containing compound. First stable product is a 3 carbon containing compound. Right बच्चे? Right बच्चे? Now in the C4, right? Why is it C4? Because here first stable compound, first of all understand this, first stable compound is 4 carbon containing compound. It's 4 carbon containing compound. Are you getting my point? It's a 4 carbon containing compound. ठीक है, ठीक है बच्चे. So C4 cycle is also known as Hatch-Slake pathway. It is also known as Hatch-Slake pathway. And you know that this C3 cycle will be in all the plants. It will be in all the plants. In all the plants you are going to see this. And when it comes to the C4 cycle, you will see it in the plants that are growing in dry tropical regions, the plants which are facing extremely high temperature. ठीक है, the plants that are having extremely high, which are growing in extremely high temperature, they will have the C4 cycle. And when it comes to the C4 cycle, these plants are going to have one anatomy, that is Krenz anatomy. So yes, this is important, right? They are going to have Krenz anatomy. This is important. Clear बच्चे? This is important. So Calvin and Benson cycle, C3 cycle it is. So let's discuss it. So let's start with the C3 cycle. So when you talk about the C3 cycle, how many steps will be there? 3 steps. ठीक है, I'll tell you the questions directly, MCQs directly. 3 steps will be there. So here carbon dioxide will be assimilated. So first step will be carboxylation. Second step will be reduction, and third step will be regeneration. So in how many steps Calvin cycle will be done? Will be completed in 3 steps. I'm telling you the PYQs directly. ठीक है. Obviously we know that we cannot understand or cram the plant physiology, right? If we didn't revise anything, it is not possible for us to understand this thing. But yeah, we can understand the MCQs. We can remember that. That is what we are doing. So Calvin cycle mein how many steps are there? 3 steps. First step is carboxylation, means addition of carbon dioxide. So one thing that you need to remember here is, where is it going to occur? In the stroma of the chloroplast. ठीक है. So leaf में mesophyll cells are there. Mesophyll cells are having the chloroplast, where it will be done. ठीक है. Now what's the point here? Fixation of carbon dioxide, reduction and regeneration. देखो, 1 CO2. Basically in stroma you have to make the carbohydrate, right? You have to make the carbohydrate. You have to reduce this CO2. ठीक है. So let's say if you have to make the glucose, how many carbons are there in glucose? It is C6H12O6. What is it? It is C6H12O6. What is it? It is C6H12O6. Yes, it is C6H12O6. Am I right? Yes people, am I right? What is it guys? It is C6H12O6. Yes or no? It is C6H12O6. Yes or no? Yes or no? है ना? It's a yes, right? It's a yes. So carbon dioxide will be reduced, right? You will have the carbohydrate. Carbon dioxide will be reduced. You will have the carbohydrate, and you know it very well, students. You know it very well. Yes, बच्चे, you know it very well that what is going to happen here, that 6 carbon containing compound will form. So 1 carbon dioxide assimilation cannot help here. So there will be the 6 turns of Calvin cycle. So how many turns of Calvin cycle are required for the formation of one glucose? That is 6 turns. PYQ, that is 6 turns. PYQ. Secondly, right, why is it a Calvin cycle? Cyclic process. In cyclic process you have to regenerate the first acceptor. ठीक है. So now this is the thing. In reduction, 2 ATP in this particular step, 2 ATP, 2 NADPH2 will be used. In the regeneration, 1 ATP will be used. So in each Calvin cycle, ठीक है, 3 ATP and 2 NADPH2 will be used. 3 ATP and 2 NADPH2 will be used. ठीक है, it will be used. This is what you need to write down. This is what you need to write down. So for the formation of one glucose, for the formation of one glucose, right, because 6 turns will be done. So 6 into 3, 6 into 2. So 18 ATP and 12 NADPH2 will be used. 18 ATP and 12 NADH2 will be used, obviously, right? So one question you will get from this part. One question you will get from this part. Now come to this side. Dekho, first of all, there is a 5 carbon containing compound. 5 carbon containing compound. What is it? 5 carbon containing compound is there. That 5 carbon containing compound is RUBP, ribulose 1,5-bisphosphate. Ribulose 1,5-bisphosphate. That is ribulose 1,5-bisphosphate. So this is the step where carbon dioxide will be accepted by RUBP. So RUBP is the acceptor of carbon dioxide, and here there is an enzyme which is known as ribisco. So ribisco, you know that what is ribisco? You know that what is ribisco? So it is the most abundant protein of biosphere. It is the most abundant protein of biosphere. What is it? It is the most abundant protein of biosphere. So it is ribulose bisphosphate carboxylase oxygenase. It is ribulose. Ul is the word. It's a ketose. It's a ketose. Ribulose bisphosphate carboxylase oxygenase. This enzyme can bind with the CO2, it can bind with the oxygen. If CO2 and oxygen are in same concentration, it can bind with CO2. But if CO2 is less, it can bind with oxygen. So if it binds with oxygen, ठीक है, it can cause photorespiration. So what is photorespiration? It is a wasteful process. What is photorespiration? It is a wasteful process. It is the C2 cycle, and here your organelles Chintu, Papa, Mummy, they are involved. Which organelles are involved here? Which organelles are involved here? Chintu, Papa, Mummy. Bolo Chintu, Papa, Mummy means chloroplast, peroxisome, mitochondria. Chloroplast, peroxisome, mitochondria. Chloroplast, peroxisome, mitochondria. Chloroplast, peroxisome, mitochondria. Repeat it. Chloroplast, peroxisome, mitochondria. Chintu, Papa, Mummy. Chintu, Papa, Mummy. Okay? So it is Chintu, Papa, Mummy. Repeat it. Right? Chloroplast, peroxisome, mitochondria. These three are basically there in the C2 cycle. So photorespiration is a wasteful process. Okay? Photorespiration is a wasteful process. What is it? It's a wasteful process. Clear, bache? Clear, bache? Clear, bache? Right? So that is what you have to remember. So 3-phosphoglycerate will form 3-PGA. It's a 3 carbon containing compound. That's why it's a step. So it's PGA, phosphoglycerate. It is acid. It is not aldehyde. Then reduction made 2 ATP, 2 NADPH will be used. You will form triose phosphate, sucrose and starch will be there. Or regeneration mein, you have to regenerate this 5 carbon compound again, 1 ATP will be used. So they can even give you this cycle, right? They can ask you what is at point A, what is at point B, what is at point C. They can ask you this thing, right? They can ask you this thing as well. Arey yaar, where is it? This thing as well. Okay, this is what they can ask you. Okay, this is what they can ask you, right? So now I hope this part is clear to you. Next, move to the C4 cycle. Hatch and Slake pathway. C4 cycle. Hatch and Slake pathway. Hatch and Slake pathway. What's that? Hatch and Slake pathway. Clear, bache? Clear, 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 clear. That is what we have. So here, first stable product. Dekho, unstable intermediates are many, but we talk about the first stable product. That's a 4 carbon containing compound. That's a 4 carbon containing compound. What's that? That's a 4 carbon containing compound, and that is OAA, oxaloacetate. That is OAA, oxaloacetate. Right? That is OAA, oxaloacetate. clear बच्चे, that is OAA, oxaloacetate. Okay, that is OAA, oxaloacetate, right? That is OAA, oxaloacetate. ठीक है, this is the first stable carbon compound. Now obviously it's C4 cycle. C4 cycle में what we have to understand, what we need to understand, that there is something called Krebs anatomy, right? Krebs anatomy. देखो, here you will talk about, see, mesophyll cells will be there. Mesophyll cells will be there. That mesophyll cells are also going to have the chloroplast. They will contain the chloroplast. Here you will see that vascular tissue is covered with, ठीक है, you will see that vascular tissue is covered with bundle sheath cells, right? You will see that vascular tissue is covered with bundle sheath cells. How is it covered? How is it covered, बच्चे? It is covered with bundle sheath cells. How is it covered? It is covered with bundle sheath cells, है ना? How is it covered? Yes, बच्चे, it is covered with bundle sheath cells. Bundle sheath cells are also having the chloroplast. So so it is arranged like a wreath na, right? This arrangement is like a wreath na. So surrounding में bundle sheath cells, surrounding में mesophyll cells are there. So what's the point here when you talk about the chloroplast? In the case of C4 plants which are going to grow in the dry tropical region, they are the one which will grow in very high, right? They are the one which will grow in very high temperature regions. So you will have 2 chloroplasts. How many chloroplasts are you guys going to have? 2 chloroplasts, right? So chloroplast is dimorphic here. This is a direct PYQ. Chloroplast is dimorphic here, direct PYQ. So chloroplast में large chloroplast will be in the bundle sheath cells. बच्चे, this is the direct question that you need to note down. Bundle sheath cells, ठीक है, ठीक है. Bundle sheath cells will have large chloroplast. Small chloroplast will be there in the mesophyll cells. In the mesophyll cells. Now, this is a, please write down direct MCQ. Bundle sheath cells में, right, PEP case, phosphoenol pyruvate carboxylase is absent, rubisco is present. Rubisco present. ठीक है, this is the gist of this topic, right? This is the part from where MCQ will come. Bundle sheath cells में C3 cycle will occur and C4 cycle is absent. Why? Because bundle sheath cells में PEP case is absent but rubisco is present. Now in mesophyll cells C4 cycle will occur. Why? Because they have an enzyme PEP case, right? It is present here and this is the enzyme which is required for the C4 cycle, and here rubisco is absent, right? Rubisco is absent, so the question will come from this part. The question will come from this part. The question will come from this part. Krebs anatomy, examples of C4 cycle, which one is present where, which one is absent. Okay? So you guys can see this. Examples of C4 plants. So C4 plants में the examples which are given in NCRTs, maize or sugarcane, maize or sorghum, even sugarcane is also the example. So examples of C4 plants are important. Examples of C4 plants, they are important. Now, here, in the case of this C4 cycle, in the case of C4 cycle, no photorespiration will occur. Why? Because we have enzyme PEP case. This is phosphoenol pyruvate carboxylase. What is the full form of PEP case? Even this can be asked as a question. It is phosphoenol pyruvate carboxylase. Phosphoenol pyruvate carboxylase. Phosphoenol pyruvate carboxylase it is. Okay? So here which one is the acceptor? It is your PEP. Phosphoenol pyruvate, 3 carbon containing compound, is the carbon dioxide acceptor here. It is the carbon dioxide acceptor here, direct MCQ. It will accept the carbon dioxide, it will form C4 acid. First of all, it will form OAA, oxalic acid. That oxalic acid will form malic acid, fumaric acid and malic acid. Take care. ठीक है, what will it form? This OAA will convert into malic acid. In simple words, that is what you can remember. It will be converted into malic acid. ठीक है, ठीक है बच्चे, it will be converted into malic or the aspartic acid ultimately. This is what you can remember, right? It will be converted into malic acid or aspartic acid. So this malic acid will be transported to bundle sheath cells. So here it's what is going to happen, right? The decarboxylation will occur. What is going to happen here? The decarboxylation of this acid will occur. Then you will get C3 acid. right? You will get C3 acid here. So when there is the decarboxylation mein CO2 will release in bundle sheath cells. In bundle sheath cells, CO2 will release. That will be used by fixation by C3 cycle. C3 acid, it is your pyruvic acid that will be transported back, and here from C3 acid na phosphoenol pyruvate is formed. So this C3 acid is nothing, it is your pyruvic acid. It is your pyruvic acid, right? So bache, here one NADH2 will use, but it will reform. But here one thing that you need to remember is that when there is the regeneration, right, when there is the regeneration of, right, regeneration of phosphoenol pyruvate, which is a 3 carbon containing compound, use 2 ATP. Right, this step use 2 ATP. Okay? So when from T3 acid, when from pyruvic acid, you form phosphoenol pyruvate, we use 2 ATP. So can I say that in C4 cycle, देखो C4 cycle में, right, in one turn you have used 2 ATP here. ठीक है? You will use one NADPH2, but that will be reformed. So I am not counting it. I am not counting it. So at C4 cycle में क्या हो रहा है? In C4 plants, what is happening? In C4 plants, what is happening? In C4 cycle 2 ATP will be used, plus in C3 cycle, you know that 3 ATP and 2 NADPH2 will be used. है ना? So overall, if I talk about 6 turns here, because we have to make 1 glucose, right? So if you talk about the 6 turns of C4 cycle, so total 5 ATP and 6 turns, 30 ATP will be used, and 12 NADPH2 will be used. If you understand the logic, very good. If you don't, this is for your MCQ that you need to remember. This is for the MCQ that you need to remember. Okay? This is for the MCQ. This is the MCQ. Hanji, what is the doubt, Gayatri? What is the doubt? What is the doubt? So why is it not having the photorespiration? Because phosphoenol pyruvate carboxylase is not at all affected with low concentration of CO2. It is highly affected in low concentration of CO2. And obviously decarboxylation is occurring in the bundle sheath cells. So that is why they doesn't bother if CO2 concentration is low. No photorespiration will occur. Okay ji? No photorespiration will occur. So photorespiration I told you already. Next move to the glycolysis. So glycolysis, again direct PYQs. I will directly tell you the PYQs. Again, oxygen independent. It's the common step. It's the partial oxidation of glucose. Lysis means breakdown, glucose lysis. So glucose will give you 2 pyruvic acid or 2 pyruvate. So it is oxygen independent. Where will it occur? It will occur in cytoplasm. So in all the organisms, aerobic and anaerobic will have this. Right? All the organism, be it aerobic or anaerobic, they are going to have it. ठीक है? They are going to have the glycolysis. Clear बच्चे? They are going to have the glycolysis. Understood? Understood? Right, let's finish the plant physiology, then I will give you one break. ठीक है? Then I will give you one break. ठीक है? So this is the first thing that you have to remember. Now come to this side. अरे रे रे रे. No need to consider this particular diagram. It is inserted here by chance. Okay? So, glycolysis mein, I am again telling you direct steps. Glucose to pyruvate will form. So, how many steps? How many steps are reversible here? How many steps are, so maximum steps are bache reversible. So, you should know how many steps are irreversible. Anyone in the class who can tell me the irreversible steps of glycolysis? Anyone in the class who can tell me the irreversible steps of glycolysis? Yes, bache. Irreversible steps of glycolysis. Anyone? Anyone? Irreversible steps. Glycolysis is a total 10-step process now. हाँ जी, how many steps are irreversible? How many steps are irreversible? Anyone? 4 steps, guys. 4 steps. It's 1, 3, 7, 10. It's 1, 3, 7, 10. In how many steps substrate level phosphorylation will occur? In how many steps substrate level phosphorylation will occur? Substrate level phosphorylation means when the substrate will pass its phosphate to the ADP so that it can form ATP. So there are how many steps, bache? There are 2 steps where substrate level phosphorylation will occur. Step number 7 and 10. Okay? Step number 7 and 10. Okay? This is what they can ask you. Then here, first 5 steps are preparatory. Why are they preparatory? Because here ATP will be used. Okay? ATP used. How many ATP used? 2. Payoff में total how many ATP form? Payoff में energy currency will form 4 ATP form. ठीक है? 4 ATP form and 2 NADH2 form. 2 NADH2 form, NADH form basically. 2 NADH form. ठीक है बच्चे? ठीक है? So NADH is nicotine amide adenine dinucleotide. Now net gain, total gain will be 2 ATP, because see we have used 2 ATP, so 4 minus 2 will be 2 and 2 NADH, right, and 2 pyruvate. This is the net gain. This is the net gain. The question will come from this part. This is the net gain. How many steps are irreversible? Step number 1, 3, 7 and 9, 7 and 10. In how many steps substrate level phosphorylation will occur? 7th or 10th. So which step is the 7th step? Which step is the 10th step? This can be asked in paper. So when it is 1,3 bisphosphoglycerate, when it is 1,3 bisphosphoglycerate, this step will form 3 phosphoglycerate. So imagine 1,3 bisphosphoglycerate to 3 phosphoglycerate. What is this 1,3 bisphosphoglycerate? Right, it is having 2 phosphates. It's a 3 carbon compound. 1 phosphate will be here, another phosphate will be here. So what is going to happen here? Your ADP, right? In this step from your ADP, ATP will form, because this compound will give its substrate to the ADP. Okay, it will give its substrate to the ADP. Okay, bache? So enzyme uses phosphoglycerate kinase. Enzyme used is phosphoglycerate kinase. So please remember, this question can come from this part. So you can use your logic here. You can use your logic here even in paper if you will get the question. Bisphospho means 2 phosphate. 3 phospho means 1 phosphate. So matlab 1 phosphate is given to the ADP. That's how we have to remember this. Okay? Right? So next step में क्या होगा? Right? Next step में 3 your 2 phosphoglycerate. Sorry. Next step is also phosphoenol pyruvate. Phosphoenol pyruvate, right? Which is known as PEP. Which is known as PEP. Phosphoenol pyruvate will form the pyruvate here, right? It will form the pyruvate here. So 2 ADP, 2 ATP. Why? Because they are also 2. So it will form pyruvate. So imagine phosphoenol pyruvate, so it is giving its pyruvate here. So water, right? So one thing that you need to remember is that here it is the second step of the substrate level phosphorylation. Take a second step of the substrate level phosphorylation, and again because phosphorylation is there, so it is pyruvate kinase. So if you can remember these 2 steps from glycolysis, you will get 4 marks. Your 4 marks are confirmed, right? Your 4 marks are confirmed here. Okay, again your 4 marks are confirmed. So these are the steps which are showing substrate level phosphorylation, which are showing substrate level phosphorylation in the case of glycolysis. Okay, let's come to the fermentation. So you know that 2 type of fermentation is there. 2 type of fermentation is there. One is lactic acid fermentation, that is in the case of lactic acid bacteria and in our muscle cell. So it's a single step, right? It's a single step and enzyme complex is used, single step process. So complete oxidation of glucose will not be there. One is alcoholic fermentation. In the case of yeast, you will see this. So you know that 2 steps are there, decarboxylation and reduction. How many steps will be there? Decarboxylation and reduction. decarboxylation and reduction. ठीक है बच्चे. So in alcoholic fermentation, two products will form, carbon dioxide plus ethanol, and here you will only get lactic acid. ठीक है बच्चे, ठीक है बच्चे, you will only get lactic acid. Okay, and NaDH2 will be used. ठीक है. So pyruvic, if it is giving you ethanol plus CO2, here two steps are used. Right, so 2 pyruvate will form 2 ethanol, 2 CO2, so 2 steps, so decarboxylation and reduction, right? And here it is the one step lactic acid fermentation, so lactic acid dehydrogenase enzyme will be used. Which enzyme will be used? Lactic acid. हाँ जी बच्चे, which enzyme will be used? Which enzyme will be used? Lactic acid. Anyone in the class? Which enzyme will be used? Anyone in the class? Which enzyme will be used? Lactic acid. What's the next step? Hanji, what is the next one? I don't know. You tell me, please. Hanji, bache, I don't know. You tell me, please. I seriously don't know. Which enzyme will be there? And are you sure? And here in the alcoholic fermentation, which enzyme will be there? In alcoholic fermentation, which enzyme will be there? Which enzyme will be there? One is lactate dehydrogenase, but here which enzyme will be there? Please, quick. Which enzyme will be there? Quick. Two steps are there, I'm telling you, but which enzymes? Hanji, no one is answering it, hai na? Alcoholic obviously decarboxylase is there, and pyruvate decarboxylase and alcohol dehydrogenase. Excellent. Pyruvate decarboxylase and alcohol dehydrogenase will be used. Very good. Okay, very good. And I think it is given here also. Okay, so in both lactic acid and alcohol fermentation, not much energy is released, less than 7% of energy of glucose will be released here, right? And yeast can poison itself to death. If you know that, alcohol concentration can increase. Okay, so steps are important, enzymes are important, जैसे lactate dehydrogenase is given, alcohol dehydrogenase, pyruvic acid decarboxylase is given. So these are the important MCQs. ठीक है. बाकी glycolysis is also known as, if you remember it, very good. If you don't remember it, you can write down, right? That glycolysis is also known as EMP pathway, Embedon-Meyerhoff-Paranas pathway. Embedon-Meyerhoff-Paranas pathway. Embedon-Meyerhoff-Paranas pathway. ठीक है जी. Now let's move to the Krebs cycle, right? In between, you know that pyruvate, if oxygen is there, it will go for the complete oxidation for Krebs cycle. This is the link reaction. So pyruvic acid, when coenzyme A is added, NADP is there, so enzyme pyruvate dehydrogenase is used, magnesium ion will form acetyl coenzyme A. So pyruvate is 3 carbon containing compound, it will form 2 carbon containing compound, so decarboxylation will occur, NADH will form. So this is the link reaction, this is the gateway reaction, it is the reaction that link your glycolysis and Krebs cycle, and it is also known as the transition reaction. If you can remember it, that will be helpful for you, right? They can ask you the question from the enzyme, they can ask you the question that in link reaction what will form, NADH2 CO2. So this is important, this is important. Now next is the Krebs cycle, which is also known as tricarboxylic acid cycle, TCA cycle, also known as citric acid cycle, right? So why tricarboxylic acid cycle? Because first stable product is your citric acid, which is having 3 COH group, group. So here OAA, oxaloacetate, is acceptor. It is acceptor of acetyl coenzyme. Okay, right? So what you need to remember, there is a trick. Everyone just repeat it with me. There is a trick. There is a trick. The trick is come in and kick. come in and kick, scooter, fastly move on. 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 ठीक है जी. So C stands for citrate. ठीक है. I stands for isocitrate. And kick means alpha ketoglutarate. Okay, scooty means succinyl coenzyme A. Then you have scooter means succinate. Fastly move on, fumarate, malate, oxaloacetate. This is what Krebs cycle is. This is what Krebs cycle is. Come in and kick, scooter, fastly move on. Come in and kick, scooter, fastly move on. So it's a 6 carbon containing compound. It is also a 6 carbon containing compound, 5 carbon containing compound, 4 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 carbon containing compound. ठीक है. It is also a cyclic process, right बच्चे? So whenever something is cyclic, we have to regenerate the acceptor here. So oxaloacetate will accept 2 carbon containing acetyl coenzyme A. ठीक है, right? So this is also a 10-step process, but we don't discuss all the steps. So it is amphibolic, where catabolism and anabolism both are going on. In between citrate and isocitrate, there is the formation of cis aconitate as well, which is again unstable. In both the steps, enzyme aconitase is used. So why am I telling you this? Because it is a previous year question. Why am I telling you this? Because it is a previous year question. It's a previous year question. So when you look at the Krebs cycle, come in and kick, 6 carbon to 5 carbon, matlab decarboxylation will occur here, CO2 will release here. Alpha ketoglutarate to succinyl coenzyme A, again CO2 will release here. These are the 2 steps where carbon dioxide will be released. And here you have dehydrogenase enzyme. So here also from NAD you will form NADH2. Here also from NAD you will form NADH2. ठीक है बच्चे? So Krebs cycle takes place in the mitochondrial matrix. Okay, where will it occur? In the mitochondrial matrix. All the enzymes are in mitochondrial matrix, but succinate to fumarate. Okay, here there is one enzyme, succinate dehydrogenase. There is one enzyme, that is succinate dehydrogenase. So it is the only enzyme of Krebs cycle, right? That is also a PYQ. Please write down. Only enzyme of Krebs cycle. Only enzyme of Krebs cycle that is in mitochondrial, that is in inner mitochondrial membrane. That is in inner mitochondrial membrane. That is in inner mitochondrial membrane. And here in this step, your FAD will form FADH2. Right? FAD will form FADH2. Okay? Your FAD will form FADH2, and here also one more NADH2 will form. Okay? So this is what you need to remember, okay? This is what you need to remember, everyone. This is what you need to remember. Understood? So see, when your malate will form oxaloacetate, this is the step where NADH2 will form. Isocitrate to alpha ketoglutarate NADH2, and one more thing, alpha ketoglutarate to succinyl coenzyme. So one more step. So in Krebs cycle, there is only one step where substrate level phosphorylation will occur. There is only one step where substrate level phosphorylation will occur, and that is succinyl coenzyme to succinate. GTP will be formed, which will immediately convert to a GDP, and it will form ATP. So this is the only step where substrate level phosphorylation will occur, again PYQ. So if you will cover all that PYQs, trust me, right, you can complete the entire plant physiology. Whatever question I'm telling you in this session, if you will complete them, you will complete entire plant physiology. Okay? So now let's talk about the energy currency. Your glucose is giving you 2 pyruvate. Okay? That one pyruvate is forming acetyl coenzyme A, and that will enter here in the Krebs cycle. So here you are getting NADH. Here you are getting NADH. Now, when it is going in Krebs cycle, so it is making 3 NADH. it is making 1 FADH, it is making 1 GDP. Now how many pyruvate do we have? How many pyruvate do we have? We have 2. We have 2. So if we have from one glucose, right, from one glucose, if I have to count, right, from one glucose, what you people are getting, you are getting in glycolysis, you people are getting 2 ATP, you people are getting 2 NADH2. In link reaction, you are getting 2 NADH2. Why? Because you have 2 pyruvate. In Krebs cycle, you will get, Hanji, 6 NADH2, you will get 6 NADH2, you will get 2 FADH2, and you will get 2 ATP. So this is the energy currency that you need to remember, right? This is the energy currency that you need to remember. Finally, it will go for the electron transport chain, and finally everything will be formed. So electron transport chain I will not discuss. You are not even going to understand that right now, right? If you have studied it before, then it will be easy for you. So this is the video that I had made few days back, right? So this video is having your complete route of the electron transport chain. Here all the PYQs are discussed, so you have to give your 10 minutes here. Okay? The mobile electron carrier, the route here, everything is discussed here, and even it is also covered that how many ATPs will be formed. So now just for your quick reference, 1 NADH2 will give you 2.5 ATP. After electron transport chain, 1 FADH2 will give you 1.5 ATP. 1.5 ATP. Okay, so this is as per new NCRT and as per that electron flow. As per that new NCRT, as per that electron flow. Now let's move to the next part, and that next part is your plant growth and development. Okay, that next part is your plant growth and development. So what is the time? So by 4, okay, maximum by 4, because we have to take one break. Maximum by 4, 11th will be completed, and maximum till 7, 12th will be completed. 12th will be completed, and 12th May I will start from the genetics, because we missed to discuss that in our marathon. We'll start with evolution, then in the reverse order we will cover it. Okay ji? Okay ji? So obviously arithmetic growth, 1 cell will form, 2 will form, 3 will form, 4 will form 5. Geometric mein 2 to 4, 4 to 6, 6 to 8, 8 to 2 to 4, 4 to 8, 8 to 16, 16 to 32, like this. So in arithmetic growth, 1, then 2 cells, then 3, then 4, right? Geometric mein this is the thing. So when zygote divide initially, geometric phase will be there where all the cells are dividing, then only few will divide and one will grow. So when it is the, right, so when this is the condition, okay bache, when this is the condition, you are talking about the arithmetic growth. So here arithmetic growth mein you have to take this expression, LT is equals to L0 plus RT, right? So it is the linear curve that you are going to get. This is your MCQ. It is the linear curve that you are going to get, right? So only one daughter cell will divide and other will differentiate and mature. So height of the plant can be explained by this. Height of the plant can be explained by this, right? Height of the plant can be explained by this. Clear bache? Clear bache? So LT is equals to length at time t, L0 is equals to length at time 0, R is the growth rate and elongation per unit time. Okay? Okay bache? Now when it is the geometric growth mein S phase is there, sigmoid, lag, exponential, which is also known as log phase, stationary phase. Okay? So this is your sigmoid growth. Okay? This is your sigmoid growth. Is it clear? This is your sigmoid growth. Understood? Understood? Oh, some questions are mixed here, na? Okay. So baki ye dekho, I'll come back to this. RQ value, volume of CO2 evolved to the volume of oxygen consumed. So in the case of carbohydrates, RQ value is 1. So RQ say one question can come. This is important MCQ. So RQ value is 1 in the case of carbohydrates, bache. 1 in the case of carbohydrates, and in the case of fatty acids it will be 0.7. So the formula of tripalmitinic acid is given, so that's what you have to remember. So volume of CO2 evolved to the volume of oxygen consumed, and it will be 0.9 in the case of It will be 0.9 in the case of 0.9 in the case of proteins. Understood? Understood? Now this diagram is also very important. So you know that meristematic cell, it will show the cytoplasmic growth, protoplasmic growth. This is the plasmatic growth. So then because of this plasmatic growth, the elongation will occur, expansion. Okay, then it is DM. Always remember it is DM. Firstly differentiation, then maturation. If it is written like this, if the order is given like this, maturation first and differentiation later, it is incorrect. Maturation first and differentiation later, it is incorrect. But if it is written like this, maturation first, differentiation, then maturation, it is correct. So this graph, this table you guys can get, right? This kind of flow chart you guys can get. Maybe they will show nothing here. They will ask you what is at A, plasmatic growth. So after plasmatic growth, cell will divide again, right? Because there is the disturbance in surface to volume ratio, nuclear to cytoplasmic ratio. Then these cells, they will also expand. They will elongate. The differentiation, maturation, mature cell, senescence, death. This is the complete development. So development माने growth plus differentiation. Development माने growth plus differentiation. What is development? Development माने growth plus differentiation. What is development? What is development, people? Development माने growth plus differentiation. हाँ जी, what is development, students? What is development? Development माने growth plus differentiation. Clear बच्चे? Clear, clear, clear. Growth plus differentiation. ठीक है? So PGRs, PGRs, PGRs. So PGRs में their main function and they are formed of what? This is important. And after it, let's move to the biomolecules. Let's move to the biomolecules. So let's talk about the PGRs. So I will ask you the question. You have to answer me you have to answer it to me. Auxin is formed by. Auxin is formed by. Answer it to me. Their discovery is serendipity now. You tell me auxin. हाँ जी. Yes बच्चे. Yes. Quick. Quick. देखो, all of them, right? Serendipity. The discovery here is serendipity, माने by chance discovery. So when it is the auxin, where is it? One question is sure. Indole compounds are going to make it. You also need the zinc for the auxin and you need one amino acid. Can you tell me that amino acid? The name of that amino acid which is required for the auxin formation? Tryptophan. Okay? Which is the aromatic amino acid. It is the tryptophan which is required. It is the tryptophan which is required. Okay, ji? So adenine derivative 6 purpuryl aminopurine, right bache, your kinetin. Then carotenoids, your abscisic acid, stress hormone, terpenes, gibberellic acid, gases mein ethylene will be there. So that's what you have to remember. So your GA, gibberellic acid, and your ABA, abscisic acid, they are antagonists. Their functions are opposite. Ethylene is the only plant hormone which is gaseous. ठीक है बच्चे? Auxin, gibberellin, cytokinin, they are mainly the growth promoter, and inhibitors are ethylene and ABA. But ethylene can also work like an promoter as well. ठीक है बच्चे? So that is what we have to understand here. That is what we have to understand here. Now when you are talking about the auxin, right? So auxin, first time observed by Darwin and his son, but it was isolated by this FW Went from the oat seedlings. So don't make mistake here. It was isolated from oat seedling and it was discovered for the first time by Darwin and his son in the colutiles of canary grass. Okay? Next question. When it is the gibberellic acid, so you know that Gibberella fusicorae, the bacane, the foolish seedling disease of the rice. Right, so it was a fungal pathogen, Gibberella, right? E. Kurosawa reported it, right? So rice seedling, they were growing, right? They were growing unnecessarily, excessively, and then they were getting destroyed. So when they, the seedlings, when they were treated with filtrates of fungus, they were growing like this. So they identified this. Then Skoog and his co-worker, again, right, from the internodal segments of tobacco stem. So they can ask you how cytokinin or kinetin was discovered when scientists they were working on the tissue culture, right, of the tobacco plant. So what is callus? It is the mass of undifferentiated cell. What is callus? It is the mass of undifferentiated cell, right bache? So it is proliferated only if addition to oxygen the nutrient medium was supplemented, and in that nutrient medium extract of vascular tissue, the yeast, coconut milk or DNA. So this later on Miller et al. Means his friends, right? So they identified and crystallized the cytokinesis promoting substance they termed as kinetin. So it is a PYQ in the NTA mock test. It is the PYQ in the NTA mock test, right? PYQ of NTA mock test. Are you getting my point? It is the PYQ of NTA mock test. Do you know that? Do you know that? So please do not miss this part. Do not miss this part. And tomorrow at 9 AM when I will be taking that session, we will discuss such questions. Okay, we will discuss such questions. Okay. Then the three independent researchers, they discovered inhibitor B, abscission 2 and domin, right bache? So it was ABA. And then cousins, they confirmed the volatile substance, that is nothing but ethylene. So in the case of ethylene, that one thing that you need to remember is triple response. Baki auxin, A for auxin, A for apical dominance. A for auxin, A for apical dominance. Very important character. Okay? Then natural auxins are indole 3-acetic acid, indole butyric acid. But, right, IAA and IBA, they are the natural auxins bache, but your NA, naphthalene acetic acid and 2,4-dichlorophenoxy acetic acid is a synthetic auxin. This is the direct question. This is the direct question. Okay? Baki apical dominance. See, auxin also promote flowering in pineapple. You know na, ethylene is also helping there. Ethylene is also helping there. So mark this point. Please mark this point. So auxin promote flowering in pineapple, right? Right? They help to prevent food and leaf drop at early stage. Okay, so apical dominance means what is happening when you have the apical bud, it will not allow the lateral buds to grow. So counteraction of cytokinin can be done there. Okay, bache? And apical bud, if apical bud it will be removed, lateral buds will grow. So we will use it, right? We will use it in the growth of the tea plantation and hedge making. That's it. That's it. Okay. Now when it is the, so T424D, it is also the VD side. It is also a VD side, that's what you have to remember. And auxin also controls xylem ka differentiation and helps in cell division. Right? Xylem differentiation is done by this. Xylem differentiation is done by this. Okay, bache? Next is gibberellin. So gibberellin may direct points, obviously it's kind of growth hormone. So bolting. Do not forget bolting. The growth of internodes just before the flowering in rosette plant. Very important here. Very important in the case of bolting. Okay? Very important in the case of this gibberellin. Okay? So see this. Look at this. So they produce a wide range of responses. They increase length of axis to increase the length of grape stalks. Right? So apple will get a better shape if gibberellin spray will be there. It will delay senescence, but the main hormone that is associated with delaying senescence is your cytokinin. Okay, bache? So this sugarcane store carbohydrates. So spraying sugarcane with gibberellin increase the length and the productivity will be increased, right? So this bolting point is very important. So it is in the case of beet, cabbage and many plants with rosette habitats, or spraying juvenile conifers with GA as in the maturity period. So this question is basically given in NTA mock test. This question is given in NTA mock test. Remember that. Next one, cytokinin. So cytokinin may do not forget Richmond-Lang effect. So that Richmond-Lang effect is saying delay of senescence. So it is mainly helping in the cell division, right? And it will delay senescence. It will helping in the cell division. It will delay senescence. So that is something very important related to this. Okay? So kinetin is basically a modified form of adenine. It was obtained from the autoclaved herring sperm. Herring is a fish. Okay? It doesn't contain naturally in plant. Natural cytokinin-like compound is zeatin. Natural is zeatin, which is obtained from maize and the coconut milk. Okay, maize and the coconut milk. ठीक है, so it will be used in tissue culturing. Auxin and cytokinin will be used in tissue culturing. I told you already, right? So it will delay the senescence, right? It will delay the senescence and it will help in overcoming the apical dominance. ठीक है बच्चे, very important it is. Now ethylene के केस में only gaseous hormone, so you have to remember triple response. ठीक है, you have to remember triple response in the case of ethylene. Means whenever the seedling will face any obstacle, right, the stem will be grows. The stem will grow the stem will grow horizontally. It will be thick and apical hook will form. Stem will grow horizontally. It will be thick. Apical hook will form. Ethylene. ठीक है, so ethylene promote senescence and abscission, especially of leaves, and it is highly effective in fruit ripening. It increases the respiration rate, very important. It also breaks the seed dormancy and bud dominancy, ठीक है, and initiate germination in potato tubers and peanut seeds. Now this question was an NTA's mock test. It is also important. ये this one, ethylene promote rapid internode and petiole elongation. So please do not make the mistake here. It is the role of ethylene. Do not confuse it with the gibberellin. It is the role of ethylene. Do not confuse it with the gibberellin. ठीक है, so ethylene also promote root growth and hair formation, thus helping the plant to increase the area of absorption. ठीक है, it will be the role of ethylene. It will be the role of ethylene. And in the pineapple, it will initiate the flowering and synchronize the seed set. So you can relate with the auxin here. Okay, auxin here, right? So baki ithphone is an aqueous solution which is absorbed and transported within the plant and release ethylene. Baki it will increase the fruit ripening in tomato and apple and accelerates their abscission. That's it. Okay, baki abscisic acid is the stress hormone in the case of plant. Why stress hormone? Because it is released in stressful condition. It will protect the plant. So when conditions are not favorable, it will not let the seed to grow. It will not let that plant to grow. It will maintain that in dormant condition. If there is water stress, it will close the stomata. So closure of stomata, this point can be asked. ठीक है बच्चे, ठीक है बच्चे. So it's the stress hormone. Okay, so in seed development, maturation and dormancy, it will play the role. It induces dormancy, it helps the seed to withstand desiccation and unfavorable condition. That is what you have to remember. ठीक है, ठीक है. Next is the biomolecule and we have to see the structure, enzymes and amino acid here mainly. ठीक है, structure, enzyme and amino acid mainly, and then बच्चे we will talk about the anatomy part, the cell part, right? So this is what we have to cover and let's move to the next topic. So I'll give you the break. ठीक है, so break time till 2:30. ठीक है, have your lunch break. Have your lunch break. Hi everyone, can you see me, hear me? Am I audible? So students are not spamming here, they are not asking that why ma'am is late, because they are busy in chit chatting, right? They are busy in chit chatting, hai na? Hello, hello. Guys, seriously, if you are not interested, please tell me. I would love to end the session. Okay, I will end it. I will end it. I will end it, don't worry. Okay, chalo, let's start. So, guys, quickly share the session link with your friends and tell them that I have started the class. So now we are going to talk about the biomolecules. So most important topics from biomolecules. So when it comes to biomolecules, yes, they can ask you bond formation. Okay, so it is something very simple as well. Okay, it is something very basic. Let's revise it again. So you know that when it is the carbohydrate, which bond will be there in the carbohydrates? In the carbohydrates, we will talk about the glycosidic bond, right? And this bond is also formed when there is the, right, this bond will also form by the dehydration. Now when you talk about the proteins, right, amino acids, they will also join with the help of what? They will also join amino acids, they will join with the help of peptide bond. Now when you talk about the fats, you will see the ester bond there, right? What are you going to see? The ester bond there. In the case of nucleosides, okay, in the case of nucleosides, you will see N-glycosidic bond. You will see N-glycosidic bond. When you talk about the nucleotide, okay, when you talk about the nucleotide, so you will see N-glycosidic bond, N-glycosidic bond, N-glycosidic bond, and you are going to see, right, the phosphoester bond. Which bond are you going to see? You are going to see phosphoester bond, right, bache? So when you are going to see, when you will see dinucleotide, when you will see dinucleotide, so in the case of dinucleotide, what will you have? You will have N-glycosidic bond, right? You will have N-glycosidic bond, but here you are not going to have phosphoester, but it will be phosphodiester bond. It will be phosphodiester bond. Is that clear? So one question will come from the bonding part. One question will come from the bonding part. Okay, bache? So now when it is the carbohydrate, in the case of carbohydrates, right, when there will be the joining of many monosaccharides together, when many monosaccharides will join, so in the straight chain, mostly you will see alpha 1,4 glycosidic linkage, right? Alpha 1,4 matlab first carbohydrate, first monosaccharide is having first carbon involved in the bond formation, next is having fourth carbon. So it will be alpha 1,4, right? It's not mandatory that it will be alpha only, but yes, mostly the examples that we have given we study in the NCERT, they are having that alpha 1,4 linkage. In cellulose, beta 1,4 linkage is there. So wherever there will be the branching, at the point of branching, okay, at the point of branching, just let's say 1 or 2, this is a straight chain, right? So let's say here you are having the branch. So wherever you are having the branch, there you will see alpha 1,6 glycosidic linkage. So at the point of branching, alpha 1,6 glycosidic linkage will be there. Kindly mention it in the chat section, everyone. Kindly mention it in the chat section. Yes, please mention it in the chat section. Bache Chandu, already I have posted a video on ETS, so please revise it, right? So this is about the bonds, right? This is about the bonds. So 1,6 is there, then peptide bond is also formed by dehydration, ester also, and you know about the other bonds. Okay, bache, you know about the other bonds. So now when you look at the structure, okay, they can ask you this thing, right? So palmitic acid, glycerol, which is also known as trihydroxypropane. It is also known as trihydroxypropane, right, bache? And here you have your triglyceride. So in the case of triglyceride, you can see this thing, right? How can you make that ester bond? I'm just giving you a okay, demo here. Jaise fats ke case mein, you will say that fatty acids plus glycerol, they will join. fatty acid and glycerol, it will join. So what is glycerol? Glycerol is C, C and C, then OH, then OH, then OH. So it is CH2, you just have to satisfy the valency of carbon. It's like this, and then you have to add the fatty acid. So it is acid, okay, you have to add the fatty acid. So it is an acid, it is an acid. So C double bond OOH will be there, C double bond OOH will be there. Yes bache, C double bond OOH will be there. Okay, 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 okay. C double bond OOH will be there. Fatty acid it is, fatty acid it is, right? So R1 is nothing but it is the carbon hydrogen chain. So it is the fatty acid, C double bond OH carboxylic group will be there. So what's going to happen here bache? There will be the dehydration. Okay, there will be the dehydration. Are you getting my point? So obviously water will be released from this side, water will be released from this side, and that is what you are going to get. This is your ester bond, right? So if with one glycerol, one fatty acid, monoglyceride, one glycerol, two fatty acids, diglyceride, one glycerol, three fatty acid, triglyceride. That's what you have to remember, right? That is what you have to remember, okay? That is what you have to remember. Is it clear? Is it clear? Okay, so that is the point. Understood? That is the point. Understood? That is the point. Understood? Right? So if three fatty acids are there, they can be same, they can be different. So it is the most common type of fat that is known as triglyceride. That is known as triglyceride. That is what you need to keep in your mind about the bonding, right? Baki peptide bond is your CONH. Baki they even asked you about the phospholipid lecithin. So when you look at this phospholipid lecithin, it is most commonly, it is the most abundant phospholipid. So here also you guys can see, right, see this is the ester bond, ester bond, ester bond. So because it is phospholipid, phosphate group is there, and here you will see this choline also. This is lecithin na, you will see this choline also, and cholesterol, the most decorated molecule, right, biomolecule here, right? It is the most decorated biomolecule here. Now let's talk about the enzymes, because one topic will be definitely be there from the enzymes. Okay, from the bonding part it is sufficient. Now when you talk about the enzymes, you know it very well that mostly they are proteins, right? They are the biocatalysts, they are very important for the reactions, right? They are the biocatalysts, they are very, very, very important, right? Why are they very important? They are the biocatalysts. I am saying that they are very important. Why are they very important? Because they will catalyze the chemical reaction, they will increase the rate of the chemical reaction, right? They will increase the rate of the chemical reaction, they will catalyze the chemical reaction. But if in the living body there is no reaction which can occur without this biocatalyst, right? There is no reaction which can occur without catalyst. ठीक है बच्चे? ठीक है? Okay? Okay, okay, okay. Yes or no? Yes or no? Yes or no? है ना? ठीक है? So it is the biocatalyst. So mostly enzymes are protein. देखो, almost all enzymes are protein. Almost is the word. So you cannot say that all the enzymes without any exception they are protein. No. So we have the ribozyme as well. We have the ribozyme as well. So what is ribozyme? Here RNA act as nucleic acid. Here RNA act as nucleic acid. Right? Here what's going to happen? The RNA act as nucleic acid. Are you getting my point? Sorry, my bad. Nucleic acid, RNA. Ribozyme mane where nucleic acid is acting like an enzyme. So RNA acts like an enzyme. So RNA is what? RNA is what? RNA is an, right? RNA is a nucleic acid. So when nucleic acid is acting like an enzyme, this is the ribozyme. Here RNA is acting. So if you want to, do you remember the example 23S ribosomal RNA in the case of prokaryotes? In the case of prokaryotes, 23S ribosomal RNA during protein formation, during translation, this is the ribozyme, right? This is the ribozyme that will catalyze the peptide bond formation. Understood? Understood? So enzyme, like any protein, it is having primary structure, means that straight chain, right? Amino acid sequence is there, right? But it is also having secondary and tertiary structure. So you remember now when you talk about the tertiary structure, Do you remember when you talk about the tertiary structure? It is the tertiary structure students, it is the tertiary structure students that is biologically very active. You know that the tertiary structure where the folding of this protein chain is there, and because of the folding of this protein chain there will be the formation of crevices, right? There will be the formation of crevices, and these crevices are nothing, these are the sites where the substrate will fit, right? So there should be a compatibility in between enzyme and substrate site. So when it comes to the enzyme and substrate binding, you also talk about in the lock and key hypothesis, that the substrate which is compatible to the enzyme which right, they should have the compatibility, then they will bind with each other, one question, right? Then they will bind with each other, one question. Now what is the second point, students? The second point is, what is the second point? Induced fit hypothesis, which says that these sites, these active sites are not static, right? So whenever substrate will approach, there will be some conformational changes and then they will bind, right? Then they will bind. So that is what you need to keep in your mind, okay, right? So basically they will fold, right? They will crisscross, protein chain will crisscross over itself, right? And many crevices are made, right? Many sites are made which are the active site where substrate will bind. Done, bache? Done. So enzymes, they are different from inorganic catalysts. Why? Because enzymes cannot work under very high temperature, right? They cannot. Inorganic catalyst can. ठीक है बच्चे, inorganic catalyst can. The enzymes can get damaged at very high temperature. Okay बच्चे, okay. So that is why the organisms, some organisms, you know the archaebacteria, right? The organisms that are living in hot vents, in the sulfur springs, right bache? Right. So in their case, their enzymes can work under very high temperature. Their enzymes can work under very high temperature. Their enzymes can work under very high temperature. So they have the property of thermal stability. That is what you need to keep in your mind. Clear bache? That is what you need to keep in your mind. Clear bache? So they are the biocatalysts, right? They are the biocatalysts. They will increase the rate of the reaction. So today itself we discussed the carbonic anhydrase. I told you it is the fastest enzyme. Right, what's that? It is the fastest enzyme. So imagine in the absence of this enzyme, the reaction is slow with about 200 molecule of carbonic acid being formed in an hour. After adding this enzyme, you will see 6 lakh molecules will form in every second. 10 million increase in the rate. Imagine 10 million increase in the rate. Okay? 10 million increase in the rate. Can you see that? What will be the increase in the rate, bache? 10 million times. Imagine, this is the power of, this is the power of what? This is the power of enzymes. Understood, bache? This is the power of enzymes. So now how are they going to speed up the chemical reaction? How are they going to speed up the chemical reaction? So you need to talk about the activation energy. Guys, are you interested in understanding this topic, or you know it already? Yes, bache. Do you know this? Do you want me to explain it, or do you know it already? Nahi, madam, it's done. Leave the topic. Tell me quickly, because we have to finish the complete class 11th biology, right? Then we have to go for class 12. Okay? We have to go for the class 12 syllabus. I'll be starting with genetics and evolution. So tell me, if you want it, I want to see some emo in the chat section. Yes. Arey. Yes. Quick. If it is a yes, then do let me know. Otherwise, leave the class. Do you want to revise it or not? Chaliye. So now let's focus here, guys. Let's focus here. So you know that what is going to happen. We have already understood the idea of an active site, right? So substrate will form the product, right? Substrate will form the product. We know it very well. Now look at this graph. This is something which is very important. देखो बच्चे, when enzyme will bind with the substrate, ठीक है, enzyme plus substrate, they will form enzyme substrate complex. Now what's going to happen? There is the making and the breaking of bond. Enzyme will never itself involve in the reaction. After the reaction, we can obtain the enzyme as such, right? After the reaction, we can obtain the enzyme as such, isn't it? After the reaction, we can obtain the enzyme as such. This is what we have to do. ठीक है बच्चे? This is what we have to do after the, right bache, after the reaction enzyme can be obtained as such. So when they will bind, the making and the breaking of bond will be there, and in between you are going to get the transition state, right? So transition state is a state which is highly unstable, which is unstable, but it is a state having high energy, right? It is the state having high energy. When this making and breaking of bond is going on, so we will have the transition state which is not stable, which is unstable, and making and breaking of bond will be there. It is having high energy. So obviously from this transition state always it will come to the product. So once enzyme will form the product, so enzyme will release from that product, enzyme separate, product separate. That is how it works. So here we discuss the concept of activation energy. What are we going to discuss, students? We are going to discuss the concept of activation energy, and what enzymes are going to do? They will decrease the activation energy. What that enzymes are going to do? They will decrease the activation energy, right? What will they do, students? They will decrease the activation energy, right? So what is activation energy? Bache, activation energy is the minimum amount of energy, right? It is the minimum. What is it? It is the minimum amount of energy. What is that activation energy? It is the minimum amount of energy which is required, right, to convert a reactant into a product. Minimum amount of energy which is needed to convert the reactant into the product. So obviously there is a kind of threshold, na? So reactants, they have to, right, when they will get the energy, right, when they will get the energy, when they will cover that, when they will overcome that energy barrier, right, that minimum amount of energy that they are demanding, when they will overcome that energy barrier, then definitely they will form the product. So activation energy, what is, right, so it is the minimum amount of energy which is required to convert the reactant or the substrate into the product, and enzyme will decrease it. So obviously if their energy demand will be less, right, just let's say reactant and product, right, I am telling you reactant needs the minimum amount of energy which is required so that it can get converted into the product. So just keep it in your mind, guys, just keep it in your mind. If that energy demand will be less, obviously reactant will immediately form product. That is how the lowering of activation energy will be done there. That is how it is helpful here. Just say, obviously my example, favorite example, your Chintu is standing here, right, and Chintu wants to go there. Okay, your Chintu is standing here and your Chintu wants to go there. So obviously what is going to happen? If this wall, if it will be tall, it is going to take time, right? Chintu has to cross this wall. So if it is quite, right, if its height is too much, then obviously Chintu will take time, right? So now let's say if the height of the wall is not much, the Chintu will just jump and will reach here. So this height, this wall is nothing. This wall is nothing. It is the activation energy. This wall is nothing. It is the activation energy. What is that? It is the activation energy, right, bache? It is the activation energy. So enzyme will decrease that activation energy, right? So now look at this graph. Okay, so x-axis is telling me about the progress of the reaction. Y-axis is telling me about the potential energy, right? X-axis is telling me about the progress of the reaction. Y is telling me about the potential energy. Now look at this graph. This is the substrate. The substrate energy is here. This is the product. Product energy is here. So without activation energy, just look at this. Look at this. Without enzyme, activation energy is high. With enzyme, activation energy is low, right? Now when you look at this graph, substrate is having more energy, product is having less, means the heat energy is released, means it is exothermic reaction, right? Exothermic reaction, because substrate is having more energy, product is having less, means energy is released. Exothermic reaction. So what will be the endothermic reaction? What will be the endothermic reaction? This. When substrate is having less energy, product is having more, means this reaction needs the, this reaction is having the energy demand. It absorb energy. This will be endothermic reaction. Understood? This will be endothermic reaction. Understood? Understood? So these are the 5 steps, right? These are the 5 steps that you can remember, that substrate will bind to the active site, will fit into the active site. Substrate induce the enzyme to alter its shape, fitting more tightly around the substrate. So active site, when it is in close proximity of the substrate, it will break the chemical bonds and new enzyme product complex will be formed, and finally product will be released. ठीक है जी? ठीक है जी? So now look at this graph again. Look at this graph again. So for pH and temperature, it is this x-axis is telling us pH or temperature status, and this is y-axis is telling me enzyme activity. So you know that enzymes need optimum temperature and pH. What do they need? They need optimum temperature and pH. What do they need? They need optimum temperature and pH. Is it clear? Is it clear? Is it clear? Is it clear? Optimum means if they will get the pH and temperature in that range, the rate will be high, enzyme activity will be there, otherwise it will decline. So optimum temperature and pH is required. Now when it comes to the substrate concentration, x-axis substrate concentration, y-axis is telling me about the velocity of the reaction. X-axis substrate concentration, y is telling me about y is telling me about what? Y is telling me about the, yes bache, y is telling me about the, tell me quickly. Hanji, y is telling me about what? Y is telling me about what? Quick. Guys, quick. Yes. Just a minute, guys. Just 1 minute. So you can see this, right? So substrate concentration, and here you have the velocity, right? Substrate concentration and here you have the velocity. Clear bache? So when you talk about the substrate concentration here and the velocity, so Km is given. Km is what? This can be asked as a question, please mark it. It is your Michaelis-Menten constant. What is Km? Km is your Michaelis-Menten constant. What is Km, guys? It is your Michaelis-Menten constant. Michaelis-Menten constant. So it is the concentration of, right? It is the concentration of substrate at which, it is the concentration of substrate at which velocity is half maximal, right? What is the meaning of this thing, bache? Let's say maximum velocity is 100, right? But when the substrate concentration is 20, 50 velocity is obtained, it's like that. So Km is the amount of substrate concentration. Km is the amount of substrate concentration which tells us, so it is the amount of substrate concentration where the velocity is half maximal, right? It is half of the maximum velocity. If maximum is 100, so here at Km it will be 2. So Km and this relationship tells us about the affinity of the substrate and the enzyme, right? It tells us about the affinity of the substrate and the enzyme, as it is not explained here in NCERT. I am not picking it up, but I am telling you why that relationship is important. ठीक है जी. बाकी see, देखो, competitive inhibition, you know that inhibitor is the one which will stop that chemical reaction. So competitive inhibition, where your inhibitor looks like that substrate, it will bind with that enzyme and it will not allow the reaction to occur. So examples are important. Okay, so substrate and inhibitor, they are having close similarities, right bache, right? So substrate cannot bind and the enzyme action declines. Jaise inhibition of succinic dehydrogenase by malonate, right? What's the point here? Inhibition of succinic dehydrogenase by malonate, okay, which closely resembles the substrate succinate in structure. So inhibition of succinic dehydrogenase by malonate, which closely resembles the structure succinate in structure. Okay, bache, so it will control the other example is bacterial pathogen. Now everyone repeated with me OT Halil. Everyone repeated with me OT Halil. Yes bache, it's OT Halil. OT Halil. Everyone repeated with me OT Halil. Quick. I want to see it in the chat section. It's OT Halil. Yes students, it's OT Halil. Quick. Yes students. It's OT Halil. है ना? It's OT Halil. What is the meaning of that? O माने oxidoreductase. OT Halil is the trick. Oxidoreductase. T माने transferase. H माने hydrolase. ठीक है? H माने hydrolase. ly माने lyase, right? ly माने lyase, I माने isomerase, and then you have L, that is ligase. So OT Halil, OT Halil. So it is the classification, right? So these are the six, right? Six enzyme classes, right? Six main classes of the enzyme. Oxidoreductase, which is also dehydrogenase. Transferase, that will transfer the functional group. Hydrolase, hydrolase where there is the breakdown but without the hydrolysis of, the hydrolysis will be there here, right? The breakdown will be there. Then lyase, double bond will be there but no hydrolysis will occur. One form will convert into another isomer. Ligase, which is the molecular glue. So OT Halil, revise it, everything is done and dusted. OT Halil, revise it, everything is done and dusted. So focus on this point. This is something which you need to focus. Hydrolase mein hydrolysis will be there. In the presence of water, breakdown will be there. So aster ether peptide glycosidic, aster ether peptide glycosidic, aster ether peptide glycosidic, right? They basically their hydrolysis will occur. Lyase mein there is the removal of group from substrate by mechanism other than hydrolysis. Here also the group will remove, here also the group will remove, but what will be the point here? Here also group will remove, right? But hydrolysis will not be there and the double bond will form, and the double bond will form. Clear bachche? And the double bond will form. ठीक है? Ligase, you know that molecular glue. So catalysis of carbon and oxygen bond, it can join carbon with sulfur, carbon with nitrogen, and PO bond can also be ligated here. ठीक है? Then next is cofactor. Next is cofactor. Another important point that you are not allowed to miss, right? Another important point that you are not allowed to miss. Cofactor is the word. What is the word? Cofactor. देखो, before cofactor we need to understand one more thing. Do you want me to discuss it? You will get two questions from this part. You guys are going to get two questions from this part. Guys, be quick. Students, please don't just chit chat. It demotivates a teacher as well, right? It demotivates a teacher. Yes, please. You want me to explain it? Because yes, it is one of the most important topics. It is one of the most important topics. Yes. So will you please tell me? Will you please tell me? Quick. Quick. Very good, very good, very good. So obviously you know that there are some simple enzymes, there are some complex enzymes which are also known as conjugate enzyme, right? There are simple enzyme, then complex enzyme which are also known as conjugate enzyme, right? There are complex enzyme which are also known as conjugate enzyme. So there are two words here. The protein part is apoenzyme. The protein part, these are the enzymes which are not just having the protein component. Just a simple enzyme, they are only proteinaceous. When you are talking about the complex or the conjugate enzyme, they are having the protein part as well as the non-protein part. So apoenzyme is the protein part, and when you talk about the cofactor, it is the non-protein part. When you talk about the cofactor, it is the non-protein part. Are you getting my point? It is the non-protein part. Okay? So non-protein part mein you have three things. One is your prosthetic group. One is your prosthetic group. Another is your coenzyme. Coenzyme. Third is your metal ion. Right? Third is what? Third is your metal ion. These are the three things that you need to focus. Okay? So prosthetic group is there, coenzyme is there, and then you have the metal ion. Clear bache? Clear bache? Done? Okay, so when you talk about the prosthetic group and the coenzyme, they both are organic. They both are organic, right? And metal ion is what? It is inorganic. Metal ion is what? It is inorganic. Are you getting my point? So now when it is the complex or the conjugate enzyme having the protein part and the non-protein part, so it is hollow enzyme in totality. What's that? It is hollow enzyme in totality. So it will be having apoenzyme part and it will be having cofactor. It will be having apoenzyme part and it will be having cofactor. Are you getting my point? right? So prosthetic group, as I said, it is also organic, it is tightly bound, it is tightly bound, ठीक है बच्चे, and it is loosely bound, it is loosely bound. That is something very important, that is something very important. So here just revise the examples quickly, just revise the examples quickly, that prosthetic groups are the organic compound, right? So they are tightly bound to the apoenzyme, जैसे peroxidase and catalase, in their case breakdown of hydrogen peroxide to water and oxygen, right? So here what is this? Heme is the prosthetic part in this enzyme, ठीक है, it is the part of active site of enzyme. So heme is the prosthetic part, right? Heme is the prosthetic part. What is heme? Heme is the prosthetic part. Then coenzymes are also the organic compounds. Coenzymes are also the organic compounds, but their association with apoenzyme is only transient. Their association with apoenzyme is only transient. It is usually occurring during the course of catalysis, right? So it is loosely bound. So you have the examples, बच्चे, जैसे you have many coenzymes are vitamins, जैसे coenzyme nicotinamide adenine, here, right? Coenzyme nicotinamide adenine dinucleotide and NADP contains the vitamin niacin. So mainly these coenzymes, they are having the vitamins, ठीक है. बाकी metal ions में you know that zinc is a cofactor for the proteolytic enzyme carboxypeptidase, right? Do not miss the examples, do not miss the examples. Next important topic is of amino acids, ठीक है. Next important and the obvious topic is of amino acids. Amino acids, guys, are you feeling confident? Are you feeling confident? Are you feeling confident? Yes people, yes people, guys, just allow me 1 minute. Let me ask it from my team, okay? डन बच्चे, डन. आर यू फीलिंग कॉन्फिडेंट और स्टिल लो कि नहीं मैडम, नो कॉन्फिडेंस, नथिंग एट ऑल? आर यू फीलिंग कॉन्फिडेंट? येस और नो? येस और नो? मैडम वी आर हियर फॉर चिट चैटिंग, है ना? वी आर नॉट हियर टू रिवाइज समथिंग, वी आर हियर फॉर चिट चैटिंग, वी आर नॉट हियर फॉर रिवाइज समथिंग. सो दैट इज वाई वी आर कॉन्फिडेंट ओनली, है ना? वी आर जस्ट कॉन्फिडेंट ओनली. चलो कोई बात नहीं, एज पर योर रिस्पॉन्स ओनली आई विल कंटिन्यू द सेशन, अदरवाइज आई विल एंड इट अर्ली. ओके, वॉट एवर आई हैव प्लान आई विल ड्रॉप दैट आइडिया एंड आई विल एंड इट अर्ली. ठीक है, चलो लेट्स स्टार्ट द अमीनो एसिड. सो इन द केस ऑफ अमीनो एसिड सी, दैट्स द थिंग. ठीक है, सो वन साइड दिस इज अमाइनो ग्रुप, right? Basically in our body we have L amino acid. The amino group is at this side, right? The L amino acid amino group will be at this side, then COH group will be there, you will have hydrogen, and here you can have alkyl group or hydrogen. So amino acids are also known as substituted methanes. They are known as substituted methanes, or right, substituted methanes, because methane is CH4 and here you are changing the group and it is the alpha carbon, right? Alpha carbon mane it is the anomeric carbon, it is basically the alpha carbon. Here if four sides are having different groups. Okay, now here you have to remember one thing, that is glycine. Glycine is nothing but it is the simplest amino acid. Glycine is nothing but it is the simplest amino acid. In the case of glycine, that will be the case, right? That will be the thing. In the case of glycine, that is the thing. Can you see that? In the case of glycine, that will be the thing. In the case of glycine, this is not alpha carbon, this is not anomeric carbon, this is not alpha carbon, this is not anomeric carbon. ठीक है बच्चे? Why? Because two sides are having same group. So glycine is the simplest amino acid. ठीक है, बाकी you know that I remember the name of the amino acid, but I know you don't know, so I'm directly giving you the quick PYQs. So Hall is a trick for basic amino acid, right? Hall is a trick for basic amino acid. So Hall mane histidine, arginine, lysine. Hall means histidine, arginine, lysine. These are three basic amino acids. So see which amino acids will be the basic, which is having two amino groups, right? These are having 2 amino groups. They are having 2 amino groups. ठीक है बच्चे? Now when you talk about the acidic amino acid, now when you talk about the acidic amino acid, so acidic में you have 2 things, aspartic acid, right? Aspartic acid and glutamic acid. Aspartic acid and glutamic acid, right? So what will you see in the case of acidic acid? You will see 2 COH group. What are you going to see, people? You will see 2 COH group. So this basic amino acid is what? It is positively charged. It is positively charged. This acidic one is what? It is negatively charged, right? It is negatively charged, right? It is negatively charged, right? Right? So remaining 15 are neutral, like your valine and others. Okay? So you should also know the examples of aromatic amino acid. Can you just tell me the examples of aromatic amino acid? Can you just tell me the examples of aromatic amino acid? Aromatic. Yes, aromatic amino acid. So aromatic mein you have the examples of tryptophan. You have the example of your phenylalanine. You have the example of, yes bache, tyrosine. And tryptophan is the complex amino acid. Jaise simplest is your, right? So everyone repeat the examples in the chat section right now. Repeat all the examples in the chat section right now. Quick. Repeat all the examples in the chat section right now, because this is important. At least 1 or 2 questions. You guys will get 1 or 2 questions from this part. You people will get 1 or 2 questions from this part. Yes. Quick. Quick. Yes, very good, very good, very good. So examples are important. Examples are important. Clear, bache? So next is, okay, so here essential amino acids. Which amino acids are essential? Which amino acids are essential? The one which are not synthesized by our body, but they should be the part of our diet. So here the trick is private Tim Hall. Private Tim Hall. Private Tim Hall. So L is leucine, L is lysine. If you remember it very good, I remember the order alphabetically also. Okay, then it is arginine. Okay, then it is histidine. So basically all the basic amino acids are your essential. M stands for methionine. Okay, M stands for methionine. I stands for isoleucine. I stands for isoleucine. Right? P stands for phenylalanine. V stands for valine. Okay, V stands for valine. Right, bache? So tyrosine, sorry, not tyrosine, threonine and tryptophan will be there. Right, threonine and tryptophan will be there. Okay, threonine and tryptophan will be there. So is it clear? So these are the examples of essential amino acids. Okay, ji? These are the examples of essential amino acid. Done? Done? Any doubt? Hanji students, any doubt? These are the examples of essential amino acids. Right? So private Tim Hall is the trick. Private Tim Hall is the trick. What's the trick? Private Tim Hall is the trick. Quick. What is the trick, students? Private Tim Hall is the trick. Quick. Private Tim Hall is the trick. Okay? Sure? Sure, sure, sure. Sure. Private, again I'm repeating, private Tim Hall is the trick. Essential amino acids. Okay? Now when you talk about the amino acid, you know that in different pH they behave like a cation and anion. Jaise, if positive charge is there, right, obviously it is what? It is cation. If negative charge is there, what is it? It is anion. Okay? If negative charge is there, what is it? It is anion. And what is this? This is the Zwitter ion. Zwitter ion means when it is dipolar, right? When it is dipolar. So when you have one plus charge, one minus charge, so it is electrically neutral. It is electrically neutral. So COH will give its H here. It is NH3 positive. It is negative. Zwitter ion. This is what you have to remember. It is amphoteric in nature. It is amphoteric in nature. It is having plus and minus. Both the charges are there, right? Plus and minus. Both the charges are there. Clear, bache? Clear, bache? Now, see, sir, What is that CM sir? CM sir माने cysteine methionine sulfur containing acid. Chief Minister sir, cysteine methionine sulfur containing acid. Cysteine methionine sulfur containing acid. Clear बच्चे? Clear बच्चे? So बाकी ये देखो ribose, deoxyribose, you should not miss such structures. You know that in the case of deoxyribose, this is the beta ribose. How can you say beta? देखो alpha beta में only one difference is there. Alpha above, beta below. Alpha above, beta below. When your hydrogen is above alpha, when your hydrogen is below, it is beta. Right? When your hydrogen at first carbon is below, beta. If this hydrogen will be up and OH will be down, it will be alpha. ठीक है जी? So alpha, so ribose and deoxyribose. So in deoxyribose at second carbon, oxygen is missing. So this is an exception to the general formula of monosaccharides. Okay, this is an exception to the general formula of monosaccharides. ठीक है जी? So now this is the glycosidic bond formation. So you know that maltose is formed when there is the joining of two glucose. Your right, lactose is formed when there is the galactose and glucose. Clear बच्चे? When there is the galactose and glucose, your lactose will form. And sucrose is the non-reducing sugar. It is the non-reducing sugar. So it will be having the glucose and fructose. Right? It is sucrose. Right? It can, it is also known as invert sugar. So these are the structures given in NCERT. So do not miss it. Glucose का structure ribose. So glycine simplest amino acid. See, alanine में R is CH3, serine में CH2OH. Very important. Next, it is already done. So ये देखो बच्चे, adenine nitrogenous bases में you remember purine is guanine adenine, and then puga and cut माने cytosine, uracil, thymine, they are pyrimidine. So purine is a 9-membered ring at 1, 3, 7, 9, you will see nitrogen. Here pyrimidine is a 6-membered ring at 1 and 3, you will see nitrogen. ठीक है बच्चे, you will see nitrogen. Clear बच्चे? Clear. So when it is adenosine, it is nitrogenous base plus sugar. N plus S माने nucleoside. ठीक है? And when it is adenylic acid, it is nitrogenous base plus sugar plus phosphate. Clear बच्चे? So you know the bonding already. Okay? ठीक है जी? चलिए नेक्स्ट बच्चे, प्राइमरी और सेकेंडरी मेटाबोलाइट. यू नो दैट प्राइमरी विच आर प्लेइंग डायरेक्ट रोल इन द ग्रोथ, सेकेंडरी विच आर फॉर द ह्यूमन वेलफेयर, दे आर हैविंग नो डायरेक्ट रोल हियर. सो दिस टेबल इज वेरी इंपॉर्टेंट. 1 MCQ can come from this part. So pigments, carotenoids, anthocyanin is water soluble. Alkaloids में morphine and codeine is there. Codeine is in the cough syrup. It is again a PYQ from the NTA side. Tomorrow morning the PYQs that I'm going to practice now. Right? Tomorrow morning, see this. First of all, mark your attendance here, students. You know that we are going to solve the paper. Right after your NEET examination, there will be the paper discussion. And tomorrow morning at 9 AM, I will be taking this session. 100 most important questions. Right, bache, 100 concept that will be repeated in your NEET 2024. Right, tomorrow morning 9 AM. And right after my class, your Wazeem sir is going to take this MCQ session. Okay, chalo, come back to this. So terpenoids में monoterpenes, diterpenes, essential oil में lemongrass, toxins में abrinoricin, lectins में concanavalin. So again, this is homework. I want the answer to be in the chat section, comment section after the class. What are lectins? Baki drugs and this. So this table is important. Okay? Now let's move to the cell chapter. Then anatomy, morphology. Okay? Cell, then anatomy, morphology, and then to the diversity. So we will be, right, we are going to start the class 12 syllabus soon. So guys, interested or not? Ki I can end the class. Interested or not? Cough syrup में codeine is used, Sarath. Codeine. Interested or not? Tell me. Yes, bache, I will be finishing all the chapter, Manasa. Final revision is there, yaar. How can I leave you people? How can I leave you people? But one thing that I'm expecting from you, that today after the class, okay, in the comment section you will tell me whether this session is helpful for you or not, right? Whether this session is helpful for you or not. And if you will be free after your NEET examination, you can mention it in the comment section that how many questions you got from this session directly, right? Chalo. So this is what we are going to start. We will be starting with the cytoskeletal element of the cell chapter. Just allow me 1 minute. ठीक है, cytoskeletal elements. So cytoskeleton में in the case of cell, what do you discuss? What do you discuss when it comes to the cytoskeletal element? You talk about the microtubules. Again, we'll discuss it to the point. Microtubules will be there, microfilaments will be there, which will include of course your actin filament. Then you will have intermediate filaments, right? Then you will have intermediate filaments. These three are cytoskeletal elements. Okay, these three are cytoskeletal element. Tell me this part clear? These three are cytoskeletal element. Tell me this part clear? This part clear? Quick. Quick. Hanji, this portion clear? Sure? Sure? Cytoskeletal element I'm talking about. So when you talk about the microtubules, microfilament, intermediate filaments. So you know that microfilaments, they are contractile in nature, right? They will undergo contraction and relaxation. So they are contractile. This is also non-contractile. This is also non-contractile, and here you will also see it is also non-contractile. Okay, it is also non-contractile. So this is as per size: microtubules, intermediate, and microfilaments. So intermediate filaments are having size in between microtubules and microfilament. Microfilament is also known as actin filament. When you talk about this microtubule, it is made up of tubulin protein. Okay? So you have alpha tubulin, beta tubulin, alpha beta, alpha beta, alpha beta, alpha beta. These tubulins will join. Alpha beta, alpha beta, alpha beta, alpha beta. These tubulins will join. Right? They will polymerize. They will form protofilaments, and many protofilaments together. Right? 10 to 11, yeah, 11 or 13. 11 or 13 protofilaments together will form microtubule. So in simple words, you have to remember it is made up of tubulin protein. It is made up of tubulin protein. And if you remember, microtubules are very important for the formation of spindle apparatus. They are very important for the formation of spindle apparatus. They are very important for the formation of your cilia in eukaryotes and flagella in eukaryotes. Right? Cilia and flagella in eukaryotes. Your centrioles are also having the microtubules. Microfilament. You remember amoeba? Amoeba forms pseudopodia. Amoeba forms false feet, pseudopodia. So pseudopodia mein just below this cell membrane, here what will you see? You will see these actin filaments. You will see this microfilament. Baki desmosomes. Do you remember the desmosomes? Do you remember the desmosomes? Desmosomes, you know, which are basically for cell linking. Here, with these desmosomes also, you will see intermediate filaments are associated. So like your keratin, vimentin, they all are intermediate filaments, right? They all are intermediate filament. Is it clear? They all are intermediate filament. Now, we should start with the structure of the centriole. Okay? Right, let's come to the point directly. Let's start with the structure of centriole having 9+0 arrangement. So centriole, you know that it's a non-membrane bound organelle. What kind of organelle it is? It's a non-membrane bound organelle. It's a non-membrane bound organelle. What is it? It is the centriole. And where are you going to see it? In the animal cell, right? In the animal cell. okay, not in the plant cell. 9 plus 0 arrangement. देखो what is this 9 here? 9 plus 0 में peripheral, right? These are the peripheral triplets, right? 9 is what? 9 is nothing but it is the peripheral triplet. What is it? It is the peripheral triplet. What is it? It is the peripheral triplet. ठीक है? One more thing I would like to mention here. जैसे you know ना nuclear membrane, just below the nuclear membrane there is a lamina. There is that nuclear lamina. So that nuclear lamina, because it is a PYQ, so I thought I should discuss it with you. That nuclear lamina is basically the intermediate filaments, right? That is basically the intermediate filament. So this point clear? This point clear? Sure, bache? Sure. So next is the structure of centriole that we have to discuss. Next is the structure of centriole that we have to discuss, and I told you 9 plus O arrangement is there. ठीक है? Centriole में which arrangement is there? 9 plus O, 9 plus 0 arrangement is there. ठीक है? Centriole में there is the 9 plus 0 arrangement. So are you ready to discuss it? Yes बच्चों, are you ready to discuss it? हाँ जी, are you ready to discuss it? So what will you see? The 9 is the triplet here. The 9 is the triplet here, right? And this triplet is peripheral, means periphery per you will see that these microtubules, they will form triplet like this. These microtubules, they will form triplet like this, right? What these microtubules will do, they will form triplet like this. So just say 1, 2, 3, 4, 5, 6, 7, 8 or 9. Just say let's say A, B, C. A, B, C. Then you have A, B, C. Matlab, what you need to observe here, let me show you. Let me change the color. Focus on this word. 9 plus 0 arrangement is there. 9 plus 0 arrangement is there. ठीक है? Okay, so it is having A, it is having B, it is having C. A, B, C. A, B, C. A, B, C. That's like this. Now, this C is not complete. जैसे ये देखो A, B, C. C is basically semi. So C will join with A here. Obviously, proteins are going to join. So you will see AC linker here, right? C will with A, C 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 with A, and C with A, and C with A. It's something like this. It's something like this. This is the centriole. Oh my God, diagram is not bad. Good, Ambu. And a diagram is not bad. It is good. And here in the center, you will see the central hub. It is also the protein. Here you will see the central hub. Here you will see the central hub. Okay. Okay. So you will see the central hub here, right? Central hub here. These are the radial spokes here. So this is the structure of the centriole. ठीक है बच्चे? This is the structure of the centriole. So central rod hub is there. This is made up of protein. These are 9 radial spokes. These are 9 radial spokes. So this is what your centriole is. Clear? So isn't it cartwheel-like structure? Isn't it cartwheel-like structure? Yes or no? Isn't it cartwheel-like structure? Yes or no? Yes or no? Yes or no? So you will have A, B and C linker. So hub, it is nothing protein. This is also the radial, right? This is also the radial spoke. So that is what you have to understand. Okay, that is what you have to understand. So next is the cilia and flagella. Okay, so what kind of arrangement is there in cilia and flagella? Right, what type of arrangement is there in cilia and flagella? What type of arrangement is there in cilia and flagella? Everyone. Cilia and flagella में 9 plus 2 arrangement. ठीक है? So cilia and flagella. So this is the cilia and flagella of your eukaryotes. It is not of your prokaryotes. It is of your eukaryotes. Cilia and flagella. Okay? It is cilia and flagella. So it is in the case of. Yes, बच्चों, it is in the case of eukaryotes. Prokaryotes mein flagella is very simple, that will be having flagellin protein. So now again 9 is the triplet, right? Sorry, 9 is the peripheral doublet. 9 plus 2 arrangement na, it is the peripheral, means these microtubules will be on periphery and it's a doublet, not the triplet, and it is a central singlet, right? It is central singlet. Let me explain this language to you. This is central singlet. One second. Please understand the diagram. I believe this time you will get a question on the basis of it. It's something like this. It's something like this. So this is A, this is B. Like if I have to draw it here, you guys can see this. This is A, this is B, and here you have two arms. A and B, then you have two arms. So it is also made up of microtubules, है ना? It is also made up of microtubules. So this is the outer arm, of course, right? This is the outer arm, of course, and this one is the inner arm. Can you tell me that these arms are made up of? Can you tell me that these arms are made up of what? जैसे ये देखो ना, this one is your outer arm, this one is your inner arm. So it is made up of, anyone in the class, it is made up of, these arms are made up of, anyone in the class, the topic is important. These arms are made up of, outer and inner arm is made up of, anyone? Outer and inner arm. देखो ना, A and B. So A is incomplete, B is complete, outer inner arm, and in between this, right? In between this is linker. ठीक है? In between this is linker. जैसे A, B, these are outer arm, inner arm. A, B, outer arm, inner arm. A, B, outer arm, inner arm. A, B and outer arm, inner arm, outer arm and inner arm, outer arm and inner arm, then outer arm and inner arm, outer and an inner arm. So it is connected. So what is it here? It is the linker. It is basically the nexin protein. It is basically the nexin protein, and these outer inner arms are nothing but it is made up of dynein protein. Okay, it is made up of dynein protein. So here you will see the central singlet, right? Basically there will be two central singlet, means there will be two single microtubules. These are the subtubules na, A and B. So A is half, B is complete. So this central singlet is covered with a sheath also. It is covered with a central sheath, and you know that there will be the radial spokes. This is the meaning of 9 plus 2. Take it, bache, this is the meaning of 9 plus 2. Can you see it? This is the meaning of 9 plus 2. है ना? So they are covered with the central sheath. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So can you see that? What is it? These are the radial spokes, right? These lines are nothing but these are the radial spokes. So center mein you can see that there is the singlet which is attached together. There is a single bridge, and here you will see the central sheath. Okay, what will you see? You will see the central sheath. So this is 9 plus 2 arrangement. So here the triplet is there at periphery. Triplet is there at periphery. Center mein there is no microtubules, but rather than other so diagram should be very clear to you, right? Diagram should be very clear to you. So you see cilia and flagella ka diagram, no? Just let's say there is cilia and flagella. So that rod like structure which is showing 9 plus 2 arrangement is exoneme, and then it is covered with the plasma membrane, right? But centriole is non-membrane bound organelle, right? So nexin protein is for the linking, and outer and inner arm is there, that is of dynein, and that are active ATPase, right? That arm is active ATPase. Clear, bache? Now let's move to the sections. Let's move to the sections. Hanji, let's move to the sections. Can we revise the sections again? Right, one thing that should be very clear to you, whenever it is the stem, and dark arrangement of xylem will be there, and conjoint collateral vascular bundle. What type of vascular bundle will be there? Conjoint collateral vascular bundle. What type of vascular bundle will be there? Conjoint collateral vascular bundle. Conjoint collateral. Just you remember this type of vascular bundle. So you know that inner will be the xylem, right? Inner will be the xylem, ठीक है, and outer will be the phloem, right? Outer will be the phloem, inner will be the xylem, outer will be the phloem. That is what we have. So it is conjoint collateral. What is the meaning of this? It means that xylem and phloem is at same radius. It is at same radius. So that is something that you are going to see in the case of dicot stem. In the case of stem, this is the arrangement, conjoint collateral. Now, what is the meaning of endark? Endark mane protoxylem is facing pith, right? Protoxylem is facing pith. So if protoxylem is facing pith, obviously metaxylem is facing periphery. So it is the centrifugal type of arrangement. Okay, right? So this type of vascular bundle will be there. So one more thing that you have to understand, one more thing that you should understand here, just a minute. Right, this is the point that I have. So it is the closed vascular bundle. Why? Because there is no cambium. This one is the open conjoint collateral. So open will be in the dicot stem, and here you can remember one thing, right? This is the cambium. This cambium is also known as yes bachche, intrafascicular cambium या vascular, intrafascicular cambium. You call it as intrafascicular cambium because it is within this bundle. Clear bachche? It is within this bundle. Can you see that? So closed vascular bundle where there is no secondary growth, and you know that monocot stem will not show the secondary growth. But dicot stem will, because it is having the cambium. Okay? So conjoint collateral and endark arrangement is there. So just look at this ring like arrangement is there. This is dicot stem. Dekho, pith is conspicuous. Endodermis is starch sheath here. So you can see these vascular bundles are arranged in ring. Okay? So parenchyma, epidermis, below epidermis you will see collenchyma. Hypodermis is of collenchyma. Then you can see this endodermis is the innermost layer of the cortex, and here endodermis is nothing but the starch sheath. Okay? So when you look at the vascular bundle, you can see that, right, the cambium is there in between, and here the bundle sheath is sclerenchymatous. That is important. Okay? So whenever you talk about any of the vascular bundle here, it is covered with the semilunar bundle sheath. This bundle sheath is not covered. It is in patch and it is sclerenchymatous. Important feature. Take an important feature. Please mark it. Please mark it. Okay? Now when it is monocot stem mein there is no such differentiation, right? Here the hypodermis is sclerenchymatous, and vascular bundles are scattered. Scattered like this. So central vascular bundles will be larger, peripheral will be smaller. So vascular bundles are scattered here. ठीक है जी, vascular bundles are scattered here. So periphery पे the vascular bundles which are present smaller in size and they are larger in size. So this is how it is present. So here also bundle sheath is basically the sclerenchymatous, and that is how beautifully it is present. ठीक है जी. So now you have the comparison in monocot and dicot stem, hypodermis, collenchymatous, sclerenchymatous. Here it is proper differentiation of cortex, endodermis, pericycle pith, nothing like that. Starch sheath present here, absent here. Medullary rays present here, absent here. Vascular bundle में I told you. ठीक है जी. Okay, okay. So now even in the case of roots, this is root here, this is root here. Okay, in the case of root, what is the point? In the case of root, what is the point? Right, this is the main thing that you need to understand from anatomy. Root ke case mein R for root, R for radial. So what type of vascular bundle? Radial will be there, and this will be exarch, means centripetal arrangement of xylem. ठीक है, exarch में what is going to happen? Your protoxylem faces periphery. Your protoxylem faces periphery. ठीक है, it is faces periphery. So radial vascular bundle माने xylem and phloem is at different radius. ठीक है, xylem and phloem is at different radius. Okay, xylem and phloem is at different radius. Clear बच्चे? Xylem and phloem is at different radius. Okay, okay. So in the case of dicot root and monocot root, dicot root में देखो pericycle will give rise to the lateral roots. Pericycle will give rise to the lateral roots. ठीक है, here also, right? But along with lateral roots, pericycle will also form cork cambium. It will also form vascular cambium. So dicot roots will also show the secondary growth, but monocot roots में no. बाकी vascular tissue देखो, limited number of xylem and phloem. It is diarch to tetrarch, somewhere to tetrarch or hexarch, है ना? So if it is polyarch, monocot में it is polyarch. Okay. बाकी see this, cells are differentiated into vascular cambium. Here it is sclerenchymatous. Conjunctive tissue में here it is sclerenchymatous, and then xylem is usually tetrarch, polyarch. ठीक है, cambium appear as a secondary meristem. The cambium is absent in monocot root. So these are the sections which you need to compare. Okay, which you need to compare. ठीक है जी. Now look at the leaf structure. So you know that when it is dorsiventral, right, two different surfaces are there, upper, lower. Upper will have palisade parenchyma, lower will have spongy. That is how it is. Isobilateral will be there in the monocots. ठीक है बच्चे? It will be there in the monocot. So you know that epidermis will cover both the surface, upper and lower. Upper surface is adaxial. ठीक है? Upper surface is adaxial. देखो, you know how do I remember Delhi University? Delhi University, DU, Delhi University. ठीक है? ठीक है? Delhi University, DU. So dorsal माने upper epidermis. ठीक है? Dorsal माने upper epidermis. Okay? Okay, right, right. So dorsal माने upper epidermis. So lower surface में there will be abaxial. Okay, so conspicuous cuticle is there. So abaxial epidermis will have more stomata than the adaxial. So later may even lack stomata. So tissue between the upper and the lower epidermis is called mesophyll. Right, the tissue which is in between the upper and lower epidermis is called the mesophyll. Right, it is the ground tissue. It is that ground tissue of the leaves. Okay बच्चे? Okay, so parenchyma, spongy, is it done? Done ma'am. Sections, done ma'am. So vascular system, obviously it will be in the veins and midriff. Size depend on the size of vein. So vascular bundles are surrounded by a layer of thick bundle, that is bundle sheath cell. Okay. Baki, this is the snapshot for the complete comparison. After this, let's move to the morphology. Right, this is the snapshot for the total comparison. Then let's move to the morphology. So morphology में I'll tell you the most important topics. Right, morphology में I will tell you the most important topic. देखो, morphology done. So morphology के बाद we are about to finish it. Then we will move to the class 11. Now, if you are thinking that ma'am, what about meiosis? हाँ, after it we will move to the plant kingdom, biological classification. We will move to the plant kingdom. We will move to the it is mixed. Biological classification, and then we will move to the genetics part. So if you want to revise mitosis, meiosis, ye dekho. Yesterday I re-uploaded this. Right? So this will be helpful for you for the quick revision. Right, cell cycle and cell division in less than 16 minutes. All the important points will be covered here. ठीक है, all the important points will be covered here. Let's move to this. So phyllotaxy, arrangement of leaves. Phyllotaxy, arrangement of leaves. This is important. This is important. Bache, if you are asking, you are expecting me to cover everything today, right? That is a myth. Okay, I am saying complete biology marathon. I specified important things will be discussed. If you are expecting me to discuss each and every detail, it is not possible for me. Why? And it is not possible for you to retain as well. So already I have taken marathon sessions where in detail we have revised the most important chapters. Okay, and if even I will, even if I will, you know, keep teaching you that, you will not be able to retain it. Do you know that? You will not be able to retain it. Right? So as of now, focus on the most important things. ठीक है जी? Focus on the most important things. Focus on the most important things. That's something very important. That is something very important. Are you getting my point? That is something very important. Okay, so tissue is already discussed. Only examples are there. Only examples are there. So phyllotaxy is the arrangement of leaves on this branch. So you know that at the nodes the leaves will grow. Okay? So it is the pattern of arrangement of leaves on the stem or branch. Okay? So this is of two types: the alternate, also known as spiral, the opposite and the opposite and the whorl. Alternate, opposite, whorl. So alternate, ये देखो, spiral it is at one node, second node, third node, fourth node. So it is also known as spiral. ठीक है? Opposite is this, and whorl is this. At one node, so many leaves they will grow. ठीक है? This is this arrangement, right? So remember the example. Alternate में it is China rose, mustard and sunflower. It is China rose, mustard and sunflower. Right बच्चे? Right बच्चे? Right? So A, C, Miss Sun. Right? A, C, Miss Sun. So alternate में China rose and mustard and sunflower. ठीक है? Okay. Opposite में you know that calotropis and guava is the example. Right? Calotropis and guava is the example. Right बच्चे? So GOC is the trick here. GOC is the trick here. So guava opposite calotropis. Guava opposite calotropis. बाकी world में there is only one example, that is Elstonia. That is Elstonia. ठीक है? Now the next thing is related to the flower. So say mummy, daddy, chilling America. Mummy, daddy, chilling America. Right? You can also remember it MD car. This is your wish. Either you can remember it like this, MD car, or mummy, daddy, chilling America. So M stands for, right? M stands for, of course, mustard. M stands for mustard. D stands for dhatura, mummy, daddy, chilling America. C stands for Chile, and A stands for actinomorphic. Why R? R is telling me that actinomorphic flower is having the radial symmetry. Actinomorphic flower is having the radial symmetry. So radial symmetry mein this is the symbol. This is the symbol. Bolo, mummy, daddy, chilling America. Repeat it. Mummy, daddy, chilling America. Quick. Mummy, daddy, chilling America. ठीक है? ठीक है? Mummy, daddy, chilling America. Quick. Mummy, daddy, chilling America. Understood? Okay, right? So this is PUBG-C. You all have, you know that PUBG-C. So PUBG-C is for zygomorphic. PUBG-CG, zygomorphic. Zygomorphic will be bilateral, right? It will be bilateral. So it's like this. It will be bilateral. It's like this. So P, bean, gulmohar, cassia. P, bean, gulmohar, cassia. Zygomorphic. ठीक है? P, bean, gulmohar, cassia. So asymmetric में only one example is there, your canna. Canna. Done? Done. So flower may be trimerous, tetra or pentamerous. It depends upon the floral appendages. So if brackets are there, right, if flowers with brackets means reduced leaf found at the base of pedicel, bracteate and ebracteate. Okay. Now this is very important. MCQ can come from this part. So you should be clear. Hypogynous, perigynous, epigynous. So epigynous mein, in epigynous your ovary is inferior. Your ovary is inferior. देखो, hypo means low, epi means above. Hypogynous flower में your ovary is superior. What type of ovary is there? It is superior. But superior ovary means ovary is present above all the floral appendages, right? Why are we saying it's a primitive flower? Why are we saying it is a hypogynous flower? Why are we saying it is a primitive flower? Why are we saying it is a hypogynous flower? Tell me. Why are we saying it's a primitive flower? Why are we saying it is a hypogynous flower? Why? Why? Because if ovary will be above the ovary is present at the topmost position, its level of protection is less, right? The level of protection that it is getting is less. Okay? And ovary mein ovules are there which will form seeds. So that is why superior ovary mane hypogynous flower. So is it the symbol? Is it the symbol? Is it the symbol? Right? Maybe I am incorrect here. Is it the symbol? I am just asking you people. I am asking you people, if ovary is superior, are we going to use this symbol? Are we going to use this symbol? Are we going to use this symbol? Superior ovary is the word. Superior ovary is the word. Right? So yes, bache, we are going to use this symbol, means flower is hypogynous. Now epigynous mein ovary, can you see that even thalamus is fused here? Right? So ovary is getting better level of protection. So ovary is inferior, flower is epigynous. So this is perigynous, the half inferior ovary is there. Half inferior ovary is there. Okay? So let's revise it. It is something very important. One question is expected from this part in morphology. In morphology, if you have revised it, if you know the examples, very good. If you don't know the examples, whatever I am discussing here, kindly revise it. Okay? Whatever I am discussing here, please revise it. Okay? Please revise it. Understood? So based on the position of calyx, corolla and andrecium, based on the position of calyx, corolla and andrecium, right, in respect of the ovary and thalamus, flowers are described as hypogynous, perigynous and epigynous. Hypogynous mein flower, the gynoecium occupies the highest position. Other parts are situated below it. Mustard, China rose and brinjal, right? Mustard, China rose and brinjal, right? Mustard, China rose and brinjal. Gynoecium mein it is situated in the center and other parts of the flower are located on the rim. Right? They are located on the rim of the thalamus. So do not miss this. Rim of the thalamus. Rim of the thalamus pe other parts are there. Perigynous. Right? So plum, rose, peach. Plum, rose, peach. Okay? Plum, rose, peach. Perigynous. Okay? Epigynous mein margin of the thalamus grows upward. It will cover the ovary completely. It will fuse with it. This is the inferior. So okay, so yeah, guava and cucumber is the example. Guava and cucumber is the example. So see this placentation, this is the next topic. Most advanced placentation is this basal, this is free central, this is parietal, this is your axile and this is your marginal. Right? So do not make the mistake here. Do not make the mistake. So placentation is arrangement of ovules within the ovary. Right, bache? So marginal, axile, parietal, basal, central, free central is there. Marginal mein, you know that placenta will form a ridge. Ye dekho, this is marginal. Placenta will form a ridge along the ventral suture of the ovary. Ovules are born on this ridge in two rows. Just whenever you open the pea pod, one side will have the peas, other will have that. So basically you can see there are two rows. There are two rows. So when the placenta is axile and ovules are attached, right? So axile mein multilocular ovary will be there. Multilocular ovary. So in Rutaceae family, in China rose, tomato, lemon, you will see this. It's a very commonly asked question. Parietal mein ovules will develop on the inner wall of ovary or the peripheral part, right? So parietal mein a false septum, raflum will form. Parietal mein a false septum, Rhapllum will form. So it is a false septum, it can divide the ovary, but it is a false septum. It is a false septum is there. So what is the name of that false septum? Rhapllum. So question can be like this, that where are you going to see the false septum? Where are you going to see the false septum? So mustard and argemone is the example, and when ovules are on central axis, dianthus and primrose. Okay, basal placentation, you know it very well. Sunflower, marigold. Okay, this is the. So now let's move to the plant kingdom. So I believe these are the most important topics. Again, I am not promoting myself, but yeah, whatever is available here na, you guys can take a benefit. You guys can take the benefit. Arey yaar. New plant families, revise it. If anyone is interested in revising new plant families, here you guys can see the lecture. ठीक है, चलो जी, plant kingdom. Plant kingdom में I always start it with the life cycle. Some students are saying life cycle is not the part of syllabus. Life cycle is not the part of syllabus. But if life cycle is not the part of syllabus, how can you understand the words sporophyte and gametophyte? How can you understand where will you have the thallus haploid, where will you have the diploid? So for understanding that part of algae, bryo, pterido, gymno and angio, life cycles are very important. ठीक है, life cycles are very important. So kingdom plantae, kingdom is plantae. So you have in kingdom plantae, you have algae, you have bryophyte, pteridophyte, gymnosperms and then angiosperms. When you talk about the gymnosperms and angiosperms, they are having diplontic life cycle. ठीक है, diplontic life cycle. When you talk about the algae, haplontic life cycle. Right, haplontic life cycle. And when you talk about the bryo and pteridophytes, you will see haplodiplontic life cycle. What will you see? You will see haplodiplontic life cycle. Now here one thing that you need to understand, pteridophytes, gymnosperms and angiosperms, these three are considered as tracheophytes. These three are considered as tracheophytes. Why? Because they have the vascular tissue. They have the vascular tissue, they have xylem and phloem. They have the vascular tissue, that is xylem and phloem. ठीक है, xylem and phloem. Now when you talk about the algae, algae में zygote is the only diploid cell. Zygote is the only diploid cell. It is the only cell of diploid generation, rest everything is haploid. So mainly, main plant body is haplontic here, haploid here. You discuss two words. One is gametophyte, the structure that form gamete. Obviously it is haploid. One word is sporophyte, the structure that forms spore, and the sporophyte is diploid. ठीक है, gametophyte is haploid, sporophyte is diploid. Everyone repeat it with me in the chart section. Gametophyte is diploid, gametophyte is haploid, sporophyte is diploid. Answer it with me. Go green. Jimmy for everyone. Acha. Jaya Uma, Subha. Guys, don't worry. Let your paper come. You will get the good feel there. Don't worry, you will get the good feel there. One second, huh? Hanji, quick. Guys, 1 second, please. 1 second. Yes, this part clear. This part clear. This part clear. है ना? So gametophyte is haploid, sporophyte is diploid. So here it is haplontic life cycle. So gametophyte is the dominant, mainly haploid plant will be there. So gametophyte will be the dominant one, it will be the photosynthetic one, it will be the photosynthetic one, right bache, it will be majorly for the life cycle. And sporophyte, zygote represents only cell of sporophytic generation, zygote represents only cell of sporophytic generation, right, only cell of sporophytic generation, ठीक है. So haplontic algae में there is no embryo even, right, there is no embryo even. Your zygote will form in algae, zygote will form, that is diploid. Your zygote will undergo meiosis, right, that's why it is the meiospore as well, and it will form the haploid spores that will germinate and that will form the gametophyte again, that will form the gametophyte again. So this is what you need to focus, okay, this is what you need to focus, okay, this is what you need to focus. Clear bache, clear, 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 clear. ठीक है. Guys, now my audio is fine, right? Now my audio is fine, right? Some students are complaining about the audio. Now is it fine? Now my audio is fine, right? Fine na? If it is fine, it's bit louder na? It is bit louder. Yes. Tell me. Tell me. So if it is fine, can you just send me the thumbs up? Right? It's louder, right? Arey yaar, it's better. Thank God. Thank God. Thank God. I changed my phone. Dekha, even after changing the phone, you are getting the good voice. Yes, bache Rajeshwari. Okay. ठीक है, just 1 second. हाँ, अरे यार, just 1 second please. Now I think it's better. Now it's better, right? Just a minute. Now it's fine, right? Now it's fine, right? Or not? Now I think it's fine. Yes? Bache, I wish I could tell you all the questions, but that is not possible. I can just guess. Okay. So that we will do tomorrow. Tomorrow morning at 9 AM there will be a session where I will tell you this is going to be a NEET paper. Okay. This is going to be a NEET paper. So sound is better than before, right? Sound is better than before. Is it better than before? If it is a yes, then tell me. Hanji, it's better than before, right? No, this is not the deleted syllabus. I am relating everything here. So haplodiplontic mein, your bryophytes mein, main plant body here is also haploid. Main plant body is gametophyte here. What is it? Main plant body is gametophytic here. It is gametophyte, isn't it? Main plant body, it is gametophyte. It is gametophyte, haploid. So sporozoite is dependent on gametophyte. Ab pteridophytes mein things are bit different. Dekho, pteridophytes mein main plant body means which will be there for the majorly which will be there for the lifespan. Main plant body is sporophyte. ठीक है, it is the main means it is the dominating one. Okay, it is the dominating one. ठीक है, it is the sporophyte. What is it? It is the sporophyte. Of course, it is photosynthetic. But what is the most important thing here in the pteridophytes? That here gametophyte is also independent. This is the most important thing here. Gametophyte is green and independent. Right, here gametophyte is not dependent on sporophyte. Gametophyte is independent. Right, gametophyte is also independent. This is something very important. Diplontic life cycle mein main plant body is sporophytic, means diploid phase will be for a longer period and haploid phase will be dependent on it. Right, haploid phase will be dependent on it. Is that clear? The haploid phase will be dependent on it. Clear bache? Clear bache? So see this, right? Examples are important. So sporophytic generation is represented only one celled zygote in the case of algae, right? So zygote will undergo meiosis here, where in the case of algae. So haploid spores will divide mitotically, they will form gametophyte divide, right? Because the main plant body, the thallus here, the main plant body, the thallus here, yes bache, the main plant body, the thallus here is haploid. So of course, so when it comes to the gamete formation, mitosis will form the gametes here. That gametes will again germinate, right? They will fuse first of all, they will form zygote which will undergo meiosis again. So this is how it works, okay? Okay, so Volvox, Spirogyra, some species of Chlamydomonas. Then haplodiplontic में देखो gametophyte, sorry, firstly diplontic life cycle. So diplontic life cycle will be there in your angiosperms and gymnosperms. So here sporophyte is the dominant one, means diploid plant. जैसे mango है, mango mainly if you will check the cell all are diploid. So this is main, this is photosynthetic, ठीक है, this is main, right? This is main, this is photosynthetic, and the gametophyte, that is the haploid cells, right? Gametophyte, that is the haploid cell, it will be dependent on the sporophyte, ठीक है? So gametophyte is represented by single to few celled haploid gametophyte. So this is the diplontic life cycle. This is the diplontic life cycle. So let's relate it with the sexual reproduction in flowering plants. So you remember pollen grain? Do you remember pollen grain? Pollen grain is the male gametophyte. Pollen grain is the male gametophyte, and your embryo sac is the female gametophyte, right? So sometimes you have to understand this thing, right? If you want to, right? So this plant kingdom and sexual reproduction in flowering plants is also somewhere related, right? It is also somewhere related. So male gametophyte and the female gametophyte. Clear bache? Male gametophyte and the female gametophyte. Clear? Clear, clear, clear? Male gametophyte and the female gametophyte. Clear bache? Clear? Clear? Done? Yes? Done? Sure? Sure, sure, sure? Are you sure? right? So in addition, all seed bearing plant, gymnosperms and angiosperms follow this pattern. Then haplodiplontic life cycle बच्चे where both the phases are multicellular, right? So dominant independent photosynthesis synthetic thalloid or erect phase is represented by haploid gametophyte, right? It is represented by haploid gametophyte. How is it represented बच्चे? It is represented by haploid gametophyte, right? Right, and it alternates with the short-lived multicellular sporophyte. So only in algae sporophyte is single-celled, otherwise sporophyte will always be multicellular. ठीक है, ठीक है. So sporophyte is totally or partially dependent on the gametophyte. Right. Now on the another hand, this is something very interesting. Please pay attention, everyone. This is something very interesting. Please pay attention. It is something very interesting. Right, it is something very interesting. Please pay attention. Kindly pay attention, everyone. Kindly pay attention. Quick. Hanji, quick. Quick. Right, so when it is the pteridophyte, so diploid sporophyte is dominant, independent, photosynthetic and vascular. Here the dominant independent phase is gametophyte and bryophyte. This is about the bryo, this is about the pterido. So it alternates with multicellular saprophytic, multicellular autotrophic या saprophytic independent but short-lived haploid gametophyte. देखो, if it is a diplontic life cycle, gametophyte, if it is a diplontic life cycle, gametophyte is dependent. Gametophyte is dependent on the sporophyte. If it is the haplontic life cycle, sporophyte is dependent on gametophyte. In the bryophytes, again, sporophyte is dependent on gametophyte, but in the pteridophytes, this is something unique that you are going to see. This is something unique that you are going to see. So in the pteridophytes, you will see that gametophyte is also independent, sporophyte is also independent. Gametophyte is also independent, sporophyte is also independent. It's just that gametophyte will be short-lived. It will be short-lived. ठीक है जी? It will be short-lived. Clear बच्चे? Clear बच्चे? It will be short-lived. Right? Done? Okay, chalo. So now let's move to the next part. This part clear? Now let's move to the next part. Yes bache, let's move to the next part. Chalo, right? Let's move to the next part here. Okay, so here in some algae also haplontic, algae are haplontic, right? But your Ectocarpus polysiphonia kelps, they are haplodiplontic. Do not miss this point. Okay, do not miss this point. Please do not miss this point. Right? These examples are important. Right? These examples are important. If you don't know this, you can miss it as well. Right? If you don't know this, you can miss it. I don't have any problem, guys. I don't have any problem. If you are not able to remember it, you can miss that also. Right? But remember, fucus is the only algae which is diplontic. ठीक है, which is diplontic. So examples are important. ठीक है बच्चे, examples are important. And yes बच्चों, I missed this topic in the morphology part. Do revise the estivation as well. ठीक है, volvate, where volvate simply, right, petals are touching each other's end but they are not overlapping. Right, twisted में one end is overlapped by the another. Right, imbricate में this overlapping is not proper. This one is overlapped from both the sides and then it is like this, and this is the papilionaceous corolla, right? 1 plus 2 plus 2 arrangement is there. So standard vexillum, wings or alae, keel or carina. ठीक है, keel or carina, that is what you have to remember. Okay, that is what you have to remember. Okay, everyone? So that's what you have to remember. I'm back. Yes, I'm back. So is it clear? Is it clear? It's fine, right? Okay, so this is also important. Papilionaceous one is the important one. Okay, so now let's focus on the algae part. Okay, let's focus on the algae part, right? Let's focus on the algae part. So you can see here chlorophyce, phaeophyce, rhodophyce, right? Chlorophyce, phaeophyce, rhodophyce. Everyone repeat it with me. Chlorophyce, phaeophyce, rhodophyce. Right? What do you have here? Chlorophyce, phaeophyce and rhodophyce. Yes? Yes? Right? Chlorophyce, phaeophyce and rhodophyce. Okay, chlorophyce, phaeophyce and rhodophyce, that is the thing. So green algae, brown algae, red algae. Dekho, green algae just like higher plants AB, it is brown algae. So brown algae, phaeophyce, dekho, ACAD. Rhodophyce, D is there. So A and D. A is the universal pigment. All the plants are going to have this. So green में AB, brown में AC, rhodophyce में D, AD. ठीक है, AB, AC, AD, AB, AC, AD. So brown color is due to fucoxanthin, MCQ. Red color is due to phycoerythrin, MCQ. And here in the red algae, you will also see phycobilins. You will also see phycobilins. What will you see? You will also see phycobilins. Clear, बच्चे? So stored food green algae में starch, brown algae में mannitol. So mannitol is the sugar alcohol. ठीक है, it is the sugar alcohol. It is laminarian also. बाकी Floridian starch again. D, rhodophyce, red algae, D, phycoerythrin and Floridian starch. So cell wall में cellulose here, cellulose and algin here, and so बाकी बच्चे equal flagella, unequal and lateral flagella will be there in brown algae. Unequal and lateral flagella will be there in brown algae. Or red algae में there is no motile stage. This is another important question. ठीक है, red algae में there is no motile stage in the life cycle. This is the important question, right? There is no motile stage in the life cycle. It is important. Clear, बच्चे? It is important. Understood? Understood? Now see the examples. So do you want the trick for examples or not? Do you want the tricks for example or not? Do you want the trick for examples or not? Done? Done, bache? Yes? Okay, very good. So US has very clean college. US has very clean college. That trick is for green algae. That trick is for green algae. So U means Eulothrix, U means Eulothrix, S means Spirogyra. ठीक है, V means Volvox, C means Chlamydomonas, college means Cara. ठीक है, these are the examples of green algae. These are the examples of green algae. What are they? These are the examples of green algae. So green, and for the brown algae, the trick is self DP. What is the trick? The trick is self DP. What is the trick? Self DP. Sargassum, Actocarpus, Laminaria, Fucus, Dictyota, Phaeophyce. Sargassum, Actocarpus, Laminaria, Fucus, Dictyota and Phaeophyce. So Fucus is the algae with air bladders. ठीक है, Fucus is the algae with air bladders and Fucus में life cycle is also diplontic. ठीक है, so this is your Laminaria which is edible as well. This is Fucus, so Dictyota which is dichotomously branched. So self DP, and from brown algae you will obtain algin. You will obtain algin, right? PYQ it is. You will obtain algin. Move to the next part. Volvox and Eulothrix. I told you Spirogyra, Chlamydomonas, Cara is the example. Spirogyra, Chlamydomonas, Cara is the example. ठीक है जी? Okay. Then for the red algae which is having no motile structure, the trick is P2G2. The trick is P2G2. What is the trick? The trick is P2G2. P means porphyra, ठीक है, P means polysyphonia and G means gelidium and gracilaria. Gelidium and gracilaria, right? It is gelidium and gracilaria, and here you will have agar. ठीक है, here you will have agar, you will get agar from it. So gelidium and gracilaria, gelidium and gracilaria, so agar is there. So porphyra and polysyphonia, this is the example P2G2. So from red algae you will obtain agar, you will also obtain carrageen. ठीक है, this is another PYQ. No motile stage is present here. Okay, no motile stage is present here. ठीक है जी. Now who gave the 5 kingdom classification system? Mr. R.H. Whittaker. Mr. R.H. Whittaker, right? So what he considered, बच्चे, he even considered the mode of nutrition, body organization, nuclear membrane, cell wall, cell type, and even he considered the phylogenetic relationship. He even considered the phylogenetic relationship. He even considered the phylogenetic relationship. Are you getting my point? Are you getting my point? Are you getting my point? ठीक है. So you know that it is kingdom Monera is the only kingdom having the prokaryotic cell. Remaining 4 are having the eukaryotic cell. And Protista is the kingdom of unicellular eukaryote. Fungi में you have the example of yeast, and here you will have the example of chlorella. So yeast, other than even chlorella is also placed here in the kingdom Protista as per R.H. Whittaker. ठीक है बच्चे, ठीक है बच्चे. So Monera में you know that in bacteria what kind of cell wall will be there? Remember peptidoglycans. Remember peptidoglycans will be there in the bacteria. Yes students, do you remember that? Do you remember that? What will be there in the bacteria? Peptidoglycan. Peptidoglycan. You remember murines, they are NAMNAG, NAMNAG. N-acetyl muramic acid, N-acetyl glutamic, N-acetyl muramic acid, N-acetyl glucosamine, N-acetyl muramic acid, N-acetyl glucosamine. ठीक है बच्चे. Protista में you know that present in some. Protista में you remember Euglena में we talk about the pellicle. In the case of Euglena we talk about the pellicle which is flexible, which is proteinaceous, which is flexible, which is proteinaceous. Fungi में chitin is there, which is also known as fungal cellulose, and it is basically the homopolysaccharide made up of N-acetyl glucosamine. ठीक है. Plantae में cellulose is there. Animals are without cell wall. Animals are without cell wall. So this is important to remember. ठीक है. Now the most important thing here is the kingdom fungi. Now just for your quick reference, diagrams के लिए बच्चे, for the examples, right? You can just quickly revise it. So Protista में, everyone repeat, C D E S P, C D E S P. Repeat it with me. C D E S P. Everyone in the class, just repeat it with me. Just repeat it with me. C D E S P. हाँ जी, C D E S P. Guys, quick. C D E S P. 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 Quick. C D E S P. So C stands for chrysophytes, dinoflagellates, euglenoids, slime mold, protozoa. So chrysophyte में diatoms and desmids will be there. Diatoms and desmids will be there. So which dinoflagellate can form the red tides? Goniolix. ठीक है, goniolix. How many flagella are there in euglenoids? 2. Slime molds में you know that when many cells they come closer, they fuse together, they will form a syncytial, cynocytic condition, syncytial condition, and you are also call it as plasmodium. ठीक है. So plasmodium is not only the malarial parasite, but in the case of slime mold this condition is also the plasmodium. So let's talk about the fungus. Let's talk about the fungus, right? So fungi, you know that they are, this is a unique kingdom, right? Why? Because they are having great diversity, right? You can see the fungi on a moist bread, you can see it on the rotten fruits, right? Some fungi can grow within our body as well. They can grow on leather, they can grow on dung, they can grow on the plant, they can grow everywhere. Okay? So common mushroom and toadstools are also fungi, right? So this question is important. White spots seen on mustard leaves are parasitic fungus. So this is your homework. You have to tell me what is the name of this parasitic fungus? What is the name of this parasitic fungus? White spots seen on the mustard leaves. White spots seen on the mustard leaves. White spots seen on the mustard leaves, they are due to the parasitic fungus. So can you tell me the name of that parasitic fungus? Very good Yadha bache, right? So some unicellular fungi yeast are used to make bread and beer. ठीक है, some fungi जैसे Puccinia, you know ना Puccinia, so what will you do? It will cause wheat rust disease, right? So antibiotics में you have penicillium. So these are the examples you should not miss. Okay, Baki, you know that fungi, they are achlorophylous, they are without chlorophyll, they have extracellular digestion, right? So they are saprophytic. What are they? They are saprophytic. They can absorb the organic matter, they can absorb the organic matter from the dead substrate. They can absorb the organic matter from the dead substrate. Is that clear? Is that clear? Is that clear? Right? So most fungi, they are heterotrophic, they absorb soluble organic matter from the dead substrate, so they are saprophytes. What are they? They are saprophytes. Yes students, what are they? They are saprophytes. So those dead dependent, so Baki, in the symbiotic relationship, mycorrhiza, you know that fungal hyphae and pinus roots, lichens, algae and fungi. Okay, so reproduction can be vegetative, right? जैसे fragmentation, fission, budding can be there. जैसे budding you will see, where will you see buds? In the yeast also, right? Fragmentation and fission is there. So asexual reproduction is by the spores. So asexual spores, this question can come from the fungus. Asexual spores are conidia, sporangiospore, zoospore, right? Right, these three are the example of asexual spore. Conidia, you remember in the ascomycetes, right? Exogenously the spores that form, they are conidia, non-motile of course. Sporangiospores, the spores that form within the sporangium. Okay, so it is endospore of course, right? Zoospore which is having the flagella. So if it is having the flagella, it is motile. So these two type of spores, they are non-motile, that one is motile. These two type of spores, they are non-motile, that one is motile. So this is very important MCQ. This is very important MCQ. Clear bache? This is a very important MCQ. Now sexual reproduction is by oospore, ascospore, basidiospore. These three, okay, these three will show the sexual reproduction. Oospore, ascospore, basidiospore. 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 Done. So various spores are produced in distinct structure called fruiting bodies. ठीक है बच्चे? So in the sexual stages there are 3 steps, right? So yesterday also when we were practicing the question from the authorized NTA paper, right? Then again the question was there from this part, from the sexual reproduction part. So 1 or 2 questions can come from this side. Okay, 1 or 2 question can come from this part. So in the first step of the sexual stages, you know that 2 cells will come closer, they will fuse their protoplasm. So fusion of protoplasm between motile or non-motile gamete, plasmogamy. Fusion of protoplasm doesn't mean that nucleus will fuse. Nucleus will be like this only. So this will be the dikaryon phase, या dikaryon stage. 2 nuclei will be there. 2 nuclei will be there, right? So after the plasmogamy, you will see the dikaryo phase. What will you see? You will see the dikaryo phase. You will see 2 nuclei, right? 2 nuclei will be there. Then karyogamy, where nuclear fusion is there. Where nuclear fusion is there. Now in this zygote, immediately meiosis will occur and the haploid spores will form, right? And the haploid spores will form. Clear, bache? And the haploid spores will form. Is it clear? Any doubt? Is it clear? Any doubt? Any doubt? Okay. So when a fungus reproduces sexually, 2 haploid hyphae of compatible mating types will come together and fuse. So fusion of 2 haploid cells immediately result in the diploid cell, right? Fusion of 2 haploid cells immediately result in the diploid cell. So fungi, ascomycetes and basidiomycetes, right? They are having that dikaryotic stage, right? So जैसे phycomycetes में immediately 2 nuclei will form, they will fuse. But here in ascomycetes and basidiomycetes, for some time that dikaryotic stage will be there, right? You will see that cells are having 2 nuclei, right? Right bache? Right bache? So later on they will fuse and they will become diploid. So this is something very important. Please highlight this. Please highlight this. Please highlight this. Question can come from this part, guys. Question can come from this part. Yes, question can come from this part. So please go for it. Go for it. Go for it. Done, bache? Sure? Are you sure? Are you sure? Yes? So this is what you have to remember. This is what you have to remember. Okay? Okay. So Phycomycetes, alkyl fungi, Rhizopus, Mucor, Albugo, examples. Rhizopus, Mucor, Albugo, example. So members of Phycomycetes are found in aquatic habitats, on decaying wood, and even in the moist damp places. So here mycelium is aseptate, and the mycelium is aseptate. Here देखो, these are the mycelium. So mycelium is basically the network या group of hyphae. So many hyphae. So they don't have septa. So it means they will have many nuclei. They don't have septa. It means they will have many nuclei. What do they have? They are having many nuclei. Yes, they will have many nuclei. Can you see that? Can you see that? Right. So yes, it is the primitive one. So here you will see that mycelium is aseptate and cenocytic. This is the MCQ. Asexual reproduction में only it will be having zoospore motile or aplanospore non-motile. ठीक है? So spores will form within the sporangium. So they are endogenous. If they are formed within the structure, endogenous. ठीक है? Endogenous they are. ठीक है बच्चे? Right. So zygospore is the one that will undergo meiosis. When zygote will undergo meiosis, you will call it as zygospore. So it is formed by fusion of two gametes. Right. So if gametes are similar in morphology, isogamous. If dissimilar in morphology, oogamous, anisogamous or oogamous. So example में I told you already, Mucor, Rhizopus, Albugo. So here Phycomycetes में the trick is Ram. ठीक है? What is the trick? Ram. What is the trick? Ram, Rhizopus, Albugo and Mucor. So Mucor is the dung mold, Rhizopus is the bread mold, Albugo is the parasitic fungi on the, it is a parasitic fungi on the mustard, right? It is parasitic fungi on the mustard. ठीक है बच्चे? ठीक है बच्चे? So Ascomycetes, it is the sac fungi. It is the sac fungi, right? It will have the ascus where ascospores will form. ठीक है? So it is the sac fungi, multicellular. Yeast is the only unicellular example of the Ascomycetes here, right? So penicillium from antibiotic, I hope you know that. So they are decomposer, saprophytic, parasitic, right? They can grow on the dung. So this is the word coprophilous. Coprophilous is the word for the fungus that can grow on dung. Coprophilous is the frog word for the fungus that can grow on dung. ठीक है बच्चे? ठीक है? So here also mycelium is branched and septate. So mycelium will be cenocytic in the case of Phycomycetes only, right? In the case of Phycomycetes only. So asexual spores will be conidia, MCQ, right? Exogenously formed. ठीक है? So conidia will germinate, they will produce mycelium, and sexual spores are ascocarpus, which are produced in ascus. ठीक है? This is the ascocarp, right? So many ascus together will form ascocarp. This is a single ascus. Within it the spore will form. ठीक है? ठीक है? So examples में aspergillus. What will you get from aspergillus? Citric acid. What will you get from clavicep? It is the ergot rye. It is the ergot rye. ठीक है? This is important to people. LSD, lysergic acid diethylamide. Neurospora. It is also known as Drosophila of plant kingdom because many biochemical experiments are conducted on it. It is the Drosophila of plant kingdom. Drosophila of plant kingdom. And morels and truffles, which are basically edible, they are the delicacies. Here, do not miss the examples of Ascomycetes. Do not miss the examples of Ascomycetes. ठीक है? Do not miss the examples of Ascomycetes. Then Basidiomycetes, club fungi, right? So here what are you going to see? What are you going to see? You will see that mycelium is branched and septate. Rust and smut will be discussed here. So asexual spores are generally not found. This is our question. ठीक है? Asexual spores are generally not found here, right? Asexual, जैसे red algae में no motile structure. So here in Basidiomycetes, ascocarps, sorry, asexual spores are generally not found. ठीक है. So fragmentation is common but asexual spores are not there. So sex organs are absent but plasmogamy is brought by fusion of two vegetative or somatic different strains. Dikaryon will form. So basidium will be there. There will be a structure like this. So on this structure here, जैसे this is the structure, ठीक है. So here you will see the spores will form like this. Okay. So karyogamy and meiosis will be there. 4 basidiospore will form. ठीक है. So they are also exogenous because this is how the spores are going to form. Done बच्चे, done. So agaricus, mushroom, astilegosmut, puccinia is the example. Again simple it is. So deuteromycetes, fungi imperfecti. Why do we call it as fungi imperfecti? Because it doesn't have any sexual stage. And let's say if any genus is there in the deuteromycetes, and in near future if we will get the sexual stages of that genus, so that genus will be placed in the different class. So deuteromycetes simply means the one which are not having the sexual stages. Okay, the one which are not having the sexual stages. Is that clear? Is that clear? Right. So alternaria is the example. It causes early blight of potato. Coletotrichum is the example that causes red rot of sugarcane. Trichoderma, you remember? Trichoderma polysporin will give you cyclosporin A. So that is how you have to relate and revise. That is how you have to relate and revise. So what do you want me to start from class 12th? What do you want me to start from class 12th? Right? Do you want me to start the evolution first, the genetics first, the biotech first? Evolution, genetics, biotics. What do you want me to start first? Hanji, what do you want me to start first? I'll read your charts. Tell me quickly. Tell me quickly, genetics. Yeah, what? Okay, many students are saying that they want me to start the evolution first. Don't worry, we will start with the evolution. Okay, majority of students are saying evolution and then genetics. So let's pick up the most important topics of evolution. Just a minute please. Sorry, it's taking some time. Got it. Again I missed it. Screen is not supporting it, bache. Screen is like I am not going to work. See? Just a minute. Finally. Okay. So when you talk about the evolution, okay, when you talk about the evolution, you need to start with this particular diagram. You know that there are different theories. We have the theory of Operon and Helden as well, which is also known as chemical theory, which is also known as naturalistic theory, and that was the theory which explained the origin of life. Okay. So in the case of Operon and Haldane theory, how do we start the things? We talk about the chemogeny first, right? Then we talk about the biogeny. Right, we talk about the chemogeny and then we talk about the biogeny. So chemogeny is the chemical evolution, biogeny is the biological evolution. So as per Operon and Haldane's theory of naturalistic theory, या you can say that chemical theory, या theory of origin of life it is, right बच्चे, right, या modern theory of origin of life. So this theory says that as per the conditions which are there in on the primitive earth, that is reducing atmosphere, right? What was the main condition? Reducing atmosphere. So they said firstly chemical evolution occurred. Chemical evolution occurred matlab, you know that the temperature, it was coming down, the temperature was very high by then. So basically atoms, they joined to form the molecules, the atoms, they joined to form the molecules, they started forming the elements has formed the compound has formed that inorganic compounds, organic compounds are there, monomers, polysaccharides. This is how it works. Okay, ji, this is how it works. See, so this is what they explain in the chemogeny, that reducing atmosphere, it favored the things. Okay, and even if you will read it from the NCERT, you know that it is clearly mentioned that NH3, that is ammonia and water, probably, right, ammonia and water, probably the first inorganic compounds of the early inorganic compounds, probably. And when it is the CH4, that is methane, it is considered as the organic compound, right? Just let's say if someone will ask you which one is the most inorganic compound, which are the inorganic compounds, right? So water and ammonia, they are probably the inorganic compounds, right? And methane, right, this is the organic compound on the early earth. What is it? It is the organic compound on the early earth. Is it clear? Is it clear? Now we are talking about this experiment. So this is the Urey and Miller's experiment, right, bache? This is what? This is Urey and Miller's experiment. What is it? It is Urey and Miller's experiment. Are you getting my point? Are you getting my point? Right, so it is the experiment that confirmed that yes, it is whatever O'Brien and Helden were saying in their chemogeny, in their chemical evolution, it is true. So question can come from this experiment. So they basically set the early earth conditions in the lab itself, right? So let's say this is the apparatus, they are boiling the water. Okay, so now when you look at this part, right, this is a gas chamber. So electrodes are there for the for that spark and discharge. So here in this experiment, the temperature maintained was 800 degrees Celsius. So they conducted the experiment for 18 days, and in the gas chamber they took methane, ammonia, H2O and H2. Okay, so now what you need to focus here, just you have ammonia, right, you have H2 and you have the CH4, right, you have the methane, and then you have the water vapors. Bachcho, what you need to focus here, right, that's methane, dekho, ammonia, A for first letter of the alphabets, right, first letter it is. So it is in one part, these two are two parts, like this. Just what's the meaning of this line? What is the meaning of this line? This line is having simple meaning. Just you talk about the methane, you talk about the ammonia, and if you talk about the hydrogen, right, if you talk about the hydrogen, so there will be one part of ammonia, two parts of methane, two part of hydrogen. It was taken like this, right, it was taken like this. But what you have to do not focus, right, just remember one thing, A for ammonia, it is the first alphabet, so it is the first letter rather, right, so it is in one part. So now let's say I'll change the sequence, I'll write it like this, ki ammonia, then methane, right, ammonia, then methane, then hydrogen. So tell me what will be the ratio now? If it is ammonia, methane and hydrogen, what will be the ratio now? Tell me quickly. If it is ammonia, methane, ammonia, hydrogen, what will be the ratio? Yes, bache, tell me. Quick. Tell me. Then the ratio will be 1, 2 and 2. Basically it is the one part of ammonia. So this is a PYQ, okay? It is what? It is a PYQ. That is what you need to focus, right, bache? So after it you can see that when it will pass from condenser, so when they obtained the liquid water here, so they found the amino acid, right, amino acid. Just they got alanine, they got aspartic acid and they got glycine, है ना? alanine, aspartic acid, glycine. So many scientists, they repeated this experiment, and they also repeated the experiment. They took the different gases and they were like, yes, it is possible to have the chemical evolution as per the early Earth's condition. So that is reducing atmosphere. So this is something very important from the chapter evolution. Okay, this is something very important from the chapter evolution, right bache? So next is basically another important topic is HDAC. Another topic is HDAC. So what is that HDAC? What is that HDAC? It is the homologous and the analogous. It is the homologous and the analogous organ, right? One confirmed question. So HDAC. Why? Because if you are talking about the homologous organs, right, and obviously it is the example of divergent evolution, right? It is the example of divergent evolution then. It is the example of what? It is the example of divergent evolution then. AC में analogous, then convergent evolution, analogous, convergent evolution, diverge and converge. Diverge माने let's say this is a common point, one is going this side, another is going this side. Converge में it will be something like this. Now what is the meaning here? When you talk about the homologous organ, you are saying that the organs having common structure, right? Basically they are having common structure, right? Yeah, common origin, right? Common structure या common origin, but the function is different, right? Common structure या common origin is there, but the function is different. जैसे take the example of mammal, human, take the example of cheetah, right बच्चे? So you know that humerus, radius, ulna, carpal, metacarpal phalanges are there, but in our case, how are we using our hand and how are they using their hand? ठीक है? How are we using our hand and how are they using their hand? That is the important point. Are you getting my point? That is the important point. Are you getting it? Are you getting it? This is the divergent evolution. So divergent evolution या homologous organs में you say that there is the common ancestry. There is the common ancestry. From one common ancestors, right, there is the common ancestry. So from one common ancestor, right, as per the adaptation to the different condition, the species, right, the speciation will occur. Accordingly, the speciation will occur. So the ancestor is common, right? Who is common? Ancestor is common, and then you will see in different directions the evolution will occur. Divergent it is. Now let's say convergent, where structure is, origin is different but function is same. Origin is different but function is same. ठीक है, function is same. So obviously when you are taking the species of different ancestors, ठीक है, when you are taking the species of different ancestors, right, in that case what is happening? In that case what is happening, right? So but they are living in same conditions, so they will adapt to. So basically they are having different ancestors but they are living in same condition, so the structure will be different but the function will be same. That is analogous, example of convergent evolution, right? So homology is the example of, homology means common ancestry. Homology means common ancestry. Is it clear? Is it clear? Homology means common ancestry. Is it clear? Right? So this is one. Okay. So here you guys can see the examples, right? So they are saying that these four limbs they perform different. Four limbs, they perform different function in these animals. They have similar anatomical structure. ठीक है, all of them are having humerus, radius, ulna, carpal, metacarpal phalanges. Right, बच्चे? Right, but the function is different. So homology indicates common ancestry. Doubt? Homology indicates common ancestry. Doubt? So other examples are vertebrate, heart or brain. Right, heart or brain. So structure is same, the function will vary. जैसे brain, even heart में structure is same but incomplete circulation, double, it will be like this. Then बच्चे thorns and tendrils, right? Thorns and tendrils of bougainvillea and cucurbita. Thorns and tendrils of bougainvillea and cucurbita, right? Thorns and tendrils of bougainvillea and cucurbita. So it represents homology. So it is based on the divergent evolution, whereas analogy is the situation which is totally opposite. जैसे wings of butterfly, right? It is just the membranous extension. Or birds, they are having the feathers. They are still having the same function but anatomically they are different. Convergent evolution. ठीक है, eye of octopus and of mammal, the function is same right? Vision, but the structure is different. Flippers of penguin and dolphin, function is same, but the structure is different. One very common example is sweet potato. Sweet potato is a root modification, it's a root tuber, and your potato is a stem tuber. So this is also another example of analogy. So structure is different, but the function is same, storage of food. Storage of food. Okay. So thorns of bougainvillea, tendrils of cucurbita. So this is the example. Let's move to the next part. So okay, so it is basically the recapitulation theory, है ना? Recapitulation theory. So biogenetic law, right? Firstly, you know na, it is born where law, then it will be biogenetic law. ठीक है जी, recapitulation theory. So recapitulation theory में the thing that you need to remember is ontogeny repeats phylogeny. What's that? Ontogeny repeats phylogeny. What is it, students? Ontogeny repeats phylogeny. Ontogeny is that developmental history. ठीक है, phylogeny is the evolutionary history, right? So it is the evolutionary history. Clear बच्चे? So as per this recapitulation theory, ontogeny repeats phylogeny. So ontogeny में आ जाएगा your developmental history, that during the development, right, that from the zygote to the adult stage, that structure is going to repeat its phylogeny, right? It is going to repeat its phylogeny. That is the point. That is the evolutionary history, right? जैसे in between you will see that we are not able to distinguish the embryos of early stages. They are having same structure. So it is believed that here during the developmental stages, right, they are showing their evolutionary history. That is the point here. Okay, that is the point here. So ontogeny repeats phylogeny is important. Okay, so now the natural selection, the very important topic, natural selection. Let's revise the natural selection. So natural selection comes from, right, very common observation is coming from the England. This is in the collection of moth. Which moth is there? Western Vestularia. ठीक है बच्चे? So in 1850, before industrialization means pollution was not there, right? Before industrialization माने pollution was not there. So white winged moths on the trees were more than the dark winged. Why? Because देखो ना, pollution was not there. So because of that, what was happening? Just let's say this is a tree. So this tree will be having the lichens. So that lichens are what? These lichens are light colored, right? These lichens are light colored. So that white colored moth can sit on them and they will not be recognized by their predator, right? So it is something before industrialization. Now after industrialization, what is going to happen? The pollution will increase. What is going to happen? The pollution will increase. Yes, बच्चे, what is going to happen? The pollution will increase. So lichens are the pollution indicator. They will not grow when there is the pollution, especially the sulfur pollution. ठीक है, they will not grow when there is the pollution and when it is the sulfur pollution. So lichens will not be there. So these light colored moth, because the bark is dark colored, it will be exposed to the predators, right? So their number was decreasing after the industrialization. So this is the example of your natural selection. ठीक है जी, this is the example of your natural selection in peppered moth. ठीक है, so in polluted area, right, later on more dark colored moths will be there in comparison to the light colored. ठीक है जी, okay. So what is adaptive radiation? Next topic, what is adaptive radiation? Adaptive radiation and divergent evolution is considered as same. ठीक है, adaptive radiation and the divergent evolution is considered somewhere as same. ठीक है, but still there is a difference. Can you tell me what is it? Can you tell me? मतलब it is somewhere same, but we focus on the one point here. Tell me. We'll focus on one point there. I'll tell you. So adaptive radiation. So during his journey, Darwin went to the Galapagos Island, which is also considered as the live, basically the lab of the evolution. Okay, Galapagos Island. You know, on HMS Beagle, he was for that 5-year voyage. HMS Beagle, it is the name of that ship. Okay, so on Galapagos Island. So he observed an amazing diversity of the creatures there. What he observed? A very amazing diversity of the creatures. He observed a very amazing diversity of the creatures, right? And small black birds, later called Darwin finches, amazed him. He realized that there were, please understand it, huh? Please understand it. He realized that there were, many variety of finches in the same island, right? Many variety of finches in the same island, and all the varieties he conjectured evolved on the island itself. Matlab, he was like he observed the things, he saw the finches there, and he was like, they are having different beaks, and he saw that they all are present on the same island. So matlab, in the adaptive radiation, we have to keep the same geographical area. The geographical area is the same. Okay? So from the original seed eating features, many other forms with altered beak, basically the ancestor was seed eating feature. So other forms with altered beak, they arose. Okay? So it is enabling them to become insectivorous and vegetarian finches, right? It is enabling them to become insectivorous, okay, bache, and vegetarian finches. Okay? Some are insectivorous, some were the vegetarian. So here, in a given geographical area, right, in a given geographical area, starting from a point and literally radiating to other species of the geography. So basically in adaptive radiation, what is happening? The evolution of different species in a given geographical area. You have a geographical area, in that given geographical area, species will evolve, then they will move to the different habitat of that area. Okay? Of other area, it is the adaptive radiation. So you will have given geographical area, then evolution of different species will be there, and then they will move to the different habitat. This is something very important. This is something very important. Okay, bache? So Darwin finches, they represent one of the best example of this phenomena, right? And other than Darwin finches, Australian marsupials. Australian marsupials. So Darwin finches, from the common ancestor, you will see the different types of beaks will be there as per their evolution. Baki marsupial radiation is also there. Marsupial radiation is also there. This is important, please pay attention. जैसे marsupial में भी geographical area is common. You know ना, marsupial जैसे during the continental drift they got separated, they moved to the Australia, right? That is why they are surviving there, because they just moved to that Australia before the evolution of these placental mammals. That's why they are able to survive, right? That's why they are able to survive there. So marsupial radiation में again common geographical area, common ancestor, and this is what you are going to get. जैसे Tasmanian wolf, tiger cat, sugar glider, marsupial mole, koala, bandicoot, womber, kangaroo, marsupial rat, banded anteater. So they can ask you, they can give you one example, and they can ask you whether it is from the placental mammals or marsupial radiation. Whether it is from the placental mammal or marsupial radiation, this is the point. Okay? Whether it is from the marsupial radiation or the placental mammal. So this question can come in paper. Okay? This question can come in paper. Okay? Okay? So when more than one adaptive radiation appeared to have in an isolated geographical area. Okay? जैसे let's say now another example, देखो individually when you study Australian marsupials, right? Australian marsupials, the way they evolved, it is also adaptive radiation. Even the placental mammals, the way they evolved from the given geographical area, then they move to the different habitat, that is also adaptive radiation. But these two are compared as convergent evolution, parallel evolution. Let me tell you. जैसे focus on this line. Please focus on this line. That's why I'm going slow. Kindly focus here. Kindly focus here. देखो, please understand this thing. When you are saying adaptive radiation, you are talking about a common, yeah, given geographical area. Then from that geographical area, you will see that from that common ancestor, species will evolve in different direction. Okay, species, they will evolve in different direction. This is what we have observed. Understood? This is what we have observed. Understood? Now, when we are saying that more than one adaptive radiation, right? More than one adaptive radiation appeared to have occurred in an isolated geographical area. There are two areas. Area, just let's say this is one room, this is another room. In both the rooms, they are not aware. Two persons are sitting there, they are not aware. They are doing the same thing, they are reading the same topic, something like this. Okay, something like this. ठीक है, जैसे you are talking about the marsupials, they are also the example of adaptive radiation. Why? Because in a given geographical area they evolved, right? You are even talking about the placental mammals, they also show the adaptive radiation when you are considering these examples individually. ठीक है, now you are comparing the placental mammals and Australian marsupials. You are comparing, so you will see that they show convergent evolution. They show kind of parallel evolution. Let me show you why. They are saying when more than one adaptive radiation appeared to have occurred in isolated geographical area representing different habitats. Okay, you are taking the example of the adaptive radiation, but the area is different. Now, not in the same area, but the area is different, habitat is different. This is the convergent evolution. जैसे placental mammal in Australia also exhibit adaptive radiation in evolution, in evolving into varieties of such placental mammals which appear to be similar to the marsupials. Okay, so placental mammals, right, individually they are also showing the adaptive radiation. Marsupials are also showing the adaptive radiation, but when you compare them, you see that area is isolated, but still the kind of structures, they have the similarities. Let's compare it. जैसे ये देखो, placental mammal mole, Australian marsupial mole. So individually your placental mammals, they are also showing adaptive radiation. Individually Australian marsupials are also showing adaptive radiation. But when you are comparing, you will see that their areas are very much isolated. Still they are having same kind of structures, right? So this is what convergent evolution is. So mole and marsupial. Anteater is a placental mammal. Numbat, it is the marsupial. Mouse, placental marsupial mouse is there. Lemur and spotted cuscus. So they can ask you this thing. Lemur, is it the example of placental mammal or Australian marsupial? Placental mammal. Spotted cuscus, is it the example of placental mammal or Australian marsupial? Of course, Australian marsupial. Flying squirrel, flying phalanger. Bobcat, Tasmanian tiger cat. Wolf, Tasmanian wolf. So that's what you need to know. Okay, that's what you need to know. So you are comparing these two. Okay, you are comparing these two. Okay, बच्चे. So now let's move to the next topic. Doubt. Hanji, doubt. Any doubt? Hanji guys, any doubt? Yes, बच्चे. Clear. Sure guys. ठीक है. So biological evolution. में Darwinian theory mainly they are considering. So Darwin, you know that, natural selection. ठीक है. Herbert Spencer has given this term fittest of the survival, right? And that was basically explained as natural selection by Darwin. Okay, and Darwin was quite impressed by the work of Thomas Malthus. Thomas Malthus worked on that population thing na. He gave that population that theory of the population growth. So Thomas Malthus, he was quite influenced by his work. Okay, he was quite influenced by this work. ठीक है बच्चे. So rate of appearance of new form is linked to the life cycle, of course, right? Microbes, they divide fast, they have the ability to multiply and become million of individuals. So colony of bacteria growing on a given medium has built-in variation in terms of ability to utilize that component. So if you will change their nutrient medium, right, the only a part of population will survive, and the survive, that will propagate, they will add more and more individuals. Okay, so what is the point that we need to pick from this paragraph? These two things. These are the things that we need to pick from this paragraph, that branching, descent and natural selection. Branching, descent and natural selection, they are the two key components of Darwinian theory. Branching, descent mane you have the common ancestor, so as per the change in that, as the ancestor is common, and with further modification new species will form, new organism will form, and obviously with time, when all that changes, variations will accumulate, that will result in the formation of new species. So nature will select, right? Natural selection, nature is going to select the fittest. ठीक है बच्चे, so this is very important. Branching, descent, right? जैसे the next generation, it will be having the better modification than the previous one, so it's like this. So now this is the part that we need to understand from that stabilizing part. ठीक है, this is the thing that we need to understand from the natural selection mainly, right? This is the thing that we need to understand from the natural selection mainly. Clear बच्चे? Clear बच्चे? So look at this. Look at this part and look at these three curves. So yes, question can come from this part, so please pay attention. So you have one graph, okay? You have one graph. You have one graph, ठीक है? अरे ये देखो, look at this. So it is the number of individual with phenotype. In phenotype favored by natural selection, medium sized individual will be favored. So basically number of individuals with phenotype. What's the first point? What's the first point? This y-axis will show number of individuals with phenotype. This is important, please pay attention. Number of individuals with phenotypes. We will also practice the Hardy-Wingber law. Okay, so please pay attention. Number of individuals with phenotype. Right, bache? Right, bache? So do you want me to continue this? Tell me quickly. I'll be back in a minute. Yes? Okay? Hanji? Yes? Tell me. Tell me. So natural selection, this is what we have to consider. Dekho, we have three types of natural selection. We have the balancing one, stabilizing one, the directional one, and the disruptive or diversifying one. Okay? Balancing one, also known as stabilizing, directional, progressive basically, then disruptive, right? Disruptive or diversifying. Okay, so this is what we have, right? When you look at this peak, if you will look at this peak, this is what you have to understand. When you look at this peak, this is what you have to understand. These sides, right, these are the extremes. They will show homozygous conditions. Just say, let's say this is the homozygous dominant. And this is the homozygous recessive. This is the homozygous dominant and this is the homozygous recessive. Right, this is the homozygous recessive, and this thing, the middle one, it shows the heterozygous individual. Please try to understand, right? It shows the heterozygous individual. So homozygous dominant mane, this will be the condition. Homozygous recessive mane, this will be the condition. And here heterozygous mane, this is the condition. We will see that in some selections, the extremes are preferred. What is the meaning of preferring the extreme? Extremes are preferred mane, these, the ends. Basically the homozygous individuals are preferred. Sometimes we see that in some selections, this part will be preferred. Which part will be preferred? The mean will be preferred. right? The mean will be preferred. What will be preferred, students? The mean will be preferred. Mean माने heterozygous will be preferred. ठीक है? Average phenotype will be preferred. Now when it is the balancing or the stabilizing selection, you will see the average is preferred. Yeah, you can see that, you can say that the mean is preferred, or you can say that heterozygous is preferred. Now what's the meaning of that, right? So it is a type of selection, it is a type of selection where heterozygous individual will be favored. जैसे for an example, right, जैसे human height, right, when you talk about the human height, what is preferred? Human height के case में what is preferred? Average human height is preferred. हाँ जी, what is preferred when you talk about the human height? Average human height is preferred, yes or no? हाँ जी students, yes or no? Average human height is preferred or not? Average human height is preferred or not? Yes, tell me quickly, average human height is preferred or not? Let's not waste the time, let's finish it very quickly, right? Stabilizing, it is human height, average human height is preferred. जैसे optimum birth weight favored by stabilizing selection is 7.3 pounds, right? जैसे birth weight by babies is 7.3 pounds, that will be preferred, right? So if the babies, they are having the weight less than 5.5 pound, it is not preferred, they will die. If their weight is above 10 pounds, they will die. So average, somewhere average, heterozygous is preferred. Okay? So when you will look at that curve, right, it will be like this. Because these two will be eliminated, this peak will become narrower, like this. This peak is narrower now. Why? Because heterozygous, they are preferred. This peak is narrower now because the heterozygous is preferred, right? Heterozygous is preferred. ठीक है बच्चे? Now directional. Evolution is in one direction. जैसे industrial melanism. Obviously this thing is going to favor the evolution. Industrial melanism is the example here, right? Your pest resist, DDT resistant mosquitoes are the example. Your evolution of horse, right? Your evolution of horse is also the example of directional one. So direction में evolution, directional में only one character is preferred. So basically in one direction evolution will occur, one character, any one character will be preferred. Any one character will be preferred, it can be anything that will be preferred there. Now when it is the disruptive में बच्चे extremes are preferred, means homozygous will be selected here. So homozygous selected माने देखो, extremes will be disrupted, the two curves will be, the heterozygous will be destroyed, the two curves will be obtained, homozygous dominant and recessive will survive. ठीक है, homozygous dominant and recessive will survive. जैसे shell pattern in limpets, right? The example here is shell pattern in limpets, and you have even the example of some barnacles. Shell pattern in limpets, and you have even the example of some barnacles here. So when you talk about the shell pattern in limpets, right बच्चे, the white or light colored limpets, they can camouflage with white barnacles, right? जैसे देखो ना, we have the shell pattern in limpets. So limpets are of mollusca, obviously they are. So they are of two types. They have different colors. So the white one, right, they can camouflage with the barnacles, they are also light colored. Dark one can camouflage when there is the with the rock. But there are some limpets which are having mixed color, right, but they are not able to camouflage anywhere, they cannot protect itself from the predator. So in that case, what will survive? The dark and the light one, the gray will be destroyed here. ठीक है, the black and white will survive, the gray will be destroyed here. So this is what you need to understand. So when the evolution, peak shifts in one direction, directional evolution, peak is getting higher and narrower, it is the stabilizing selection. ठीक है, the two peak forms are formed, it is the disruptive or diversifying. ठीक है, so let's focus on the NCERT language. I hope after it the language of NCERT is easy for you. Natural selection can lead to stabilization, in which more individual acquire mean character value. Mean character value माने average is preferred. Mean character value माने average is preferred. Is that clear? Mean character value माने average is preferred. Done बच्चे? Then direction में more individual will acquire value other than mean character. So mean is not preferred, other than mean will be preferred. Disruption में more individual will acquire peripheral character, माने extreme, right, of this distribution curve. Okay, so industrial melanism clear. Okay, Hardy Wingber. अरे what's the issue here? होए होए, चलो कोई बात नहीं. देखो, Hardy-Wingber equilibrium, it is based on certain assumptions. If you talk about the Hardy-Wingber equilibrium, you say that population is non-evolving. देखो, when before starting this, before starting it, one more thing that we need to discuss is genetic drift. देखो, Lamarckism was there, which talked about the inheritance of acquired character. Then Darwinism, natural selection, branching descent. Then comes your Hugo de Vries. As per Hugo de Vries, so Hugo de Vries, you know na, he worked on Oinothera lamarckiana. Right, he worked on Oinothera lamarckiana. So basically it was evening primrose, and he observed that next generation is ditto. It is not like the parent generation, right? They are totally different. So he gave the thing known as mutation. Right, bache? Mutation. So as per the Hugo de Vries, evolution is not a slow process. Jaise Darwin was saying, evolution is a slow process where variations will accumulate for generation to generation, and one day it will result in evolution. Okay? But Hugo de Vries was saying that evolution is a jerky process. As per him, evolution is a jerky process. What is evolution? Evolution is a jerky process as per Mr. Hugo de Vries. What is evolution? Evolution is a jerky process as per Hugo de Vries. So as per him, it is something in single step. Just he mentioned a saltation, single step large mutation. Right, single step large mutation. What's that? It is single step large mutation. ठीक है. In one step evolution will be there. जैसे Encon ship is the example. This is what the Hugo de Vries saying. Evolution is something very fast, but as per Darwin, it's a slow, gradual process where changes will accumulate. Then finally, there comes a theory which is also known as Neo-Darwinism, that included natural selection also, that included mutation also. ठीक है, for the evolution. Right, bache? So mutation you know already, recombination you know already. I need to explain something which is known as genetic drift. Okay, I need to explain something which is known as genetic drift, which is also known as Sewall-Ritt effect. Sewall-Ritt effect, because it was discovered by Sewall-Ritt effect. Okay, so genetic drift is also a force for the evolution, and it is applicable on small population. You cannot apply this on large population. You have to consider the small population here. What do you need to consider, guys? You need to consider the small population here. What do you need to consider here? You need to consider the small population here. So genetic drift is the word. Sewall-Ritt effect, small population. Okay? So genetic drift mein what is happening? Population is evolving. You will talk about the founder's effect, and you will talk about the bottleneck effect. Founder's effect will be there and bottleneck effect will be there. Right, founder's effect will be there and bottleneck effect will be there. Okay? So when it is the founder's effect, so it is saying this is, let's say a population is living in an area. Some people, they will leave this population, they will move to the new area, they will start living there, reproducing there, and with time what is going to happen? Even this population will evolve into a new species. So founder's effect. Bottleneck effect is basically dealing with the natural calamity. Right, just let's say there is any natural calamity. It can be earthquake, it can be flood, it can be anything. Now when there is देखो, genetic drift is applicable on small population, and it is a by chance event. It is something random. And it is a by chance event. Right, it is not going to select some particular genes. No, it is something very random. Just let's say right? Let's say bottleneck effect is there. Let's say what is there? Bottleneck effect is there. What is there? Bottleneck effect is there. So now when you people talk about the bottleneck effect, there will be the natural calamity. What will be there, students? What will be there, students? There will be the natural calamity, and that natural calamity will do what? That natural calamity will do what? Right, there will be the natural calamity, and because of that natural calamity, what is going to happen? Right, some population will be destroyed, and it will be random, by chance. There is no selection. Maybe in that case, ठीक है, maybe in that case ki some harmful genes even they can survive and useful can destroy, and some useful can survive and harmful can die. Anything can occur, anything can occur. So I think you should remember that colored bottle, orange, blue, different colors are there, but only few individuals are left. Now when they will reproduce, they will propagate their genes, right? They will pass on their genes and only they will survive, right? So those who die, those who died, obviously they will carry their alleles and genes with them only, right? So genetic drift is by chance, small population, and yes, it is playing role in evolution. Now when it is the Hardy-Wingber equilibrium, when it is the Hardy-Wingber equilibrium, what is it? Hardy-Wingber equilibrium. Basically it is concerned with the non-evolving population. How is it concerned? It is basically talking about the non-evolving population, right? It is basically talking about the non-evolving population. Are you getting my point? Are you getting my point? Okay, with the non-evolving population. So here we have to consider certain assumptions. Here we assume, right? We assume that population is not evolving. So remember, Hardy-Wingber equilibrium is applicable on large population. Here you are not considering small population, and this population is non-evolving, because this is what we have to consider. Why do we consider it as a non-evolving population? Because we will apply all the possible conditions for non-evolving population. Then we will see if that value will vary, that deviation will tell us ki, okay, this is the amount of evolution that has occurred. Okay, this is the evolution that has occurred. Are you getting my point? So assumptions, right? There are some assumptions that basically population will be very large, right? Large size population is there where there is no recombination. There will be no recombination. There will be no mutation, right? There will be no genetic drift. There will be no gene migration. Okay? And even the random mating will be there. Random mating will be there, right? Random mating, then selection will not be there. These are the assumptions of the Hardy-Wingber, right? These are the assumptions of the Hardy-Wingber population. What are the assumptions of the Hardy-Wingber population? What are the assumptions of the Hardy-Wingber population? Right, what are the assumptions of the Hardy-Wingber population? Yes, bache, the assumptions are that there will be the random mating, there will be no migration, there will be no mutation, there will be no gene recombination, nothing will be there. So do you think it is possible? Do you think it is possible? Hanji, according to you, do you think, what do you think? Is it possible? Is it possible? Yes. Is it possible? Large population, no recombination, no mutation, no genetic drift, no gene migration, and the randomly mating will be. So it is saying that we are not favoring certain character, right? Nothing, no change will be there. You know that in nature it is not possible, but yeah, still we will assume it. So here you know about P plus Q is equals to 1. That tells us about the allelic frequency. P plus Q is equals to 1. That will tell us about the allelic frequency. ठीक है बच्चे? ठीक है? And 1 is P square Q square plus T PQ is equals to 1. That basically tells us about the genotypic frequency. This one is allelic, this one is genotypic. This one is allelic, this one is genotypic. ठीक है? This one is allelic, this one is genotypic. देखो P, it is the frequency of dominant allele. You know na, dominant allele is expressed as a frequency of dominant allele. It is frequency of dominant allele, ठीक है, P, and it will be the frequency of recessive allele. So what is this P square? P square माने AA. What is this Q square? It is AA. What is this 2PQ? It is, what is this 2PQ? It is heterozygous. It is heterozygous, right? Let me show you how. Let me show you how. So PQ, PQ. So P2, PQ, PQ, Q2. ठीक है. So P2 माने AA, right? This PQ, PQ, 2PQ माने 2PQ माने you are talking about the heterozygous individual, and Q2 is this. Q2 is this. This is what you have to remember. So P plus Q is equals to 1. By using this formula, you can explain it. ठीक है. Now बच्चे, I added, yeah, I have already added so many questions. I don't know why this pattern is changed. I literally don't know. But चलो ठीक है. ठीक है. I'll check if I have. ठीक है. I have one question. Let's try to solve it. Okay, let's try to solve it. You will get to know that how to apply the formula. Then let's talk about the then let's talk about the evolution of man, then microbes, then human health and disease, and let's be very fast. Okay, let's be very fast. Chalo, tell me quickly. Tell me. In a population of 1000 individuals, 360 belongs to genotype AA, 480 belongs to AA, and remaining 160 to AA. You have to tell the frequency of allele A. You have to tell the frequency of allele A. Quick guys, you have to tell the frequency of allele A. You have to tell the frequency of allele A. Yes, bache, tell me. In a population of 1000 individual, 360 belongs to genotype AA, 480 to AA, and what? Dekho, 360 individuals, they belong to AA. Matlab, what can you calculate? You can calculate P2. How? 360 by 1000. Okay, so it will be 0.36. So 0.36 is your P2. 0.36 is your P2. So if I have to calculate P, it will be like this. It will be like this. So 0.6 will be your P. 0.6 will be your P. So if you know the P, you know that P plus Q is equals to 1. So if P is 0.6, then it is obvious your Q is going to be 0.4. Your Q is going to be 0.4. Right? Your Q is going to be 0.4. So that is, so they are saying based on the data frequency of allele A. So P, it is the frequency of allele A, and you know what is the answer here. Okay, you know what is the answer here. Okay, bache. So now next is the human evolution. Next is the human evolution. So for human evolution, you know what is the trick that we have. For human evolution, you know what is the trick that we have. It is Dara H2HE-NFS. It is Dara H2HE-NFS. It is Dara H2HE-NFS. Dara H2HE-NFS. Everyone please repeat. Dara H2HE-NFS. Quick. Dara H2HE-NFS. Dara H2HE-NFS. This is about the human evolution. So this sequence, जैसे D stands for Dryopithecus, R stands for Ramapithecus. ठीक है बच्चे. So in this sequence we have to remember it. A stands for Australopithecus. ठीक है बच्चे. A stands for Australopithecus. Then there is the Homo habilis. Then there is the Homo habilis. Then there is the Homo erectus. What is there? Homo erectus. Then there is the Homo sapiens neanderthalensis. Homo sapiens neanderthalensis. ठीक है. Homo sapiens neanderthalensis. ठीक है बच्चे. Then Homo sapiens fossilis. Okay. Then Homo sapiens sapiens. So that's the point that we have. Are you getting it? So this is the human evolution. This is a trick for the human evolution. So Dara H2HE-NFS. Dara H2HE-NFS. Dara H2HE-NFS. Right bache? Right bache? Right. Dara H2HE-NFS. Okay. Okay. So read it from NCERT 1. So Homo erectus, probably they ate meat. This is what you need to remember. It is the erect man. Neanderthal man with a brain size of 1400 cc. Yes, some MCQ can come from this part. Okay, so they lived in near East and Central Asia between 1 lakh to 40,000 years back. So they used hides to protect their body and buried their dead. So yes, they can ask you which as per the evolution, which one used to hide, bury their dead. So Homo sapiens, they arose in Africa and moved across continents and developed into distinct races. During Ice Age, between 75,000 to 10,000 years ago, the modern Homo sapiens arose. So prehistoric cave art developed about 18,000 years ago. So one such cave painting by prehistoric man can be seen at Bhimbetka Rock Shelter. So this is basically, read it from NCERT. ठीक है बच्चे, read it from NCERT. So yes, this question has been asked in the NTA mock test. Agriculture came around 10,000 years back and human settlement started. Okay, it was there in the NTA. So remember the sequence, you can revise the human evolution. Remember that sequence, you can revise the human evolution. ठीक है बच्चे, ठीक है बच्चे. Okay, so you can see this again. You can see this. Okay, so Dryopithecus 24 million years ago, then Ramapithecus, Australopithecus, Homo erectus. So Homo erectus में Java man and packing man. Neanderthal man में Homo sapiens neanderthalensis, Homo sapiens fossilis and Homo sapiens sapiens. So this is basically the Cro-Magnon man, direct ancestor of modern man. Cro-Magnon man is the direct ancestor of modern man. ठीक है, Cro-Magnon man is the direct ancestor of modern man. This is what you need to remember. Clear बच्चे? Clear. चलो, next let's move to the microbes in sewage treatment. From the chapter, from this particular chapter, you can also get one question. ठीक है, you will definitely get two questions from that bioactive compounds, right? You can get, they say Aspergillus niger will give you citric acid, Acetobacter aceti will give you acetic acid, yeah, Clostridium butylicum will give you butyric acid, right? Streptococcus will give you streptokinase, which is the clot buster. Monescus will give you the statin, and your Trichoderma polysporum will give you cyclosporin A. One or two questions will be there from this part. Okay, now when it is the microbes in sewage treatment, the first step is primary or physical treatment. Right? So when it comes to the first step, there will be the filtration, and then there will be the sedimentation. Jaise we will have sewage, the municipal waste, right? So that will undergo filtration. So after filtration, there will be the sedimentation, right? It will be filtered out, right? The floating debris will be removed. Okay, filtration will be there, and then there will be the sedimentation. So I make one flow chart here, right? I hope you have attended my last biology's botany's marathon, right? So in that marathon we discuss it. Okay, in that marathon we discuss it. Okay, that flow chart is sufficient enough to, that flow chart is sufficient to revise it. So sewage will undergo filtration and then sedimentation. So filtration mein floating debris will be removed, and then there will be the sedimentation. So sedimentation mein what will be do? There will be the sediment and there will be the effluent. Now this is sediment, the thing which will settle down at base. It is also known as primary sludge, right? It is also known as primary sludge. So primary sludge formed due to the physical treatment or the primary treatment. Just let's say this is the dirty water, you are passing the water, right? You are filtering out the floating debris. Just let's say you are saying ki, I need to clean the swimming pool. So if there is any water bottle there, any plastic bottle there, you are removing it. So floating debris will be removed. Are you getting my point, right? Floating debris will be removed. Then after that, right? So primary sludge is formed. Okay, what is going to happen? Okay, so they will be removed, and then after sedimentation, that pebbles and all, they will allow to settle down at the base. So that will be the primary sludge. Sediment. Okay, and the remaining part is the effluent. So the effluent of primary treatment will go for the secondary treatment, and this sediment will be used for landfilling, for compositing, like this. It can be used for landfilling, for compositing, composting. Okay, then this is the effluent. This effluent will pass to the secondary treatment, right बच्चे? This effluent will pass to the secondary treatment. ठीक है बच्चे? So when you talk about the secondary treatment, right? When you talk about the secondary treatment, which is also known as biological treatment, secondary treatment which is also known as the biological treatment. So here what's going to happen? Why biological? Because microorganisms will be used here. So effluent of primary treatment will go for the secondary treatment. ठीक है, effluent of primary treatment will go to the secondary treatment. So secondary treatment में there will be aeration tanks, right? So aeration tanks में you know ना, mechanical agitation will be there, air will be pumped there. So mechanical agitation will be there, and in the aeration tank, right, mechanical agitation will be there and flock formation is there. Mechanical agitation will be there and flocks formation will be there. What will be there? Mechanical agitation and flock formation will be there. So what are that flocks? What are that flocks? You know that it is the aeration tank, air is there. So fungal filament which are having bacterias, fungal filament which are having bacterias. So effluent will be passed to the aeration tank where flocks will form, and they will feed on the organic matter there, right? They will feed on the organic matter there, right बच्चे? They will, देखो, now there is one thing that is known as BOD. What is BOD? What is BOD? There is one thing that is known as BOD. That BOD is biochemical या फिर biological oxygen demand. That BOD is biochemical या फिर biological oxygen demand. What's that? It is biochemical and biological oxygen demand. What is it? It is the BOD. What is it? It is the BOD, biochemical or biological oxygen demand. ठीक है, biochemical and biological oxygen demand. Now let's say you have the water. In that water you are having the organic content, you are having the organic matter. Now what's going to happen, right? जैसे our excrete, our potty, it is also the organic matter. Our waste is a food for, right? Our waste is a food for some organism. So some aerobic organisms, they will feed on this organic matter. They will need oxygen to feed on this organic matter, to destroy this organic matter, right? So oxidize this organic matter so that they can take the energy. ठीक है? So if in the water organic matter is there, so aerobic bacteria, right? Aerobic bacteria, right? So if in the water organic matter is there, if in the water organic matter is there, so what is going to happen? What is going to happen here, bache? The aerobic bacteria, right? What is going to happen here? The aerobic bacteria, they will demand the oxygen to destroy this organic matter. So the amount of oxygen, okay, the amount of oxygen required by these aerobic bacteria, amount of oxygen required by these aerobic bacteria, again I'm repeating, it is the amount of oxygen which is required by this aerobic bacteria, ठीक है, in milligram per liter, in milligram per liter. So it is the amount of oxygen required by aerobic bacteria to decompose the organic matter, right? To decompose the organic matter present in 1 liter of solution, to decompose the organic matter present in 1 liter of solution. Are you getting it? So this is the BOD, right? This is the BOD. Clear bache? This is the biochemical demand, oxygen demand. So obviously if there is high BOD, high demand for oxygen, it indicates more organic matter, and that indicates there is more pollution. So high BOD means water is highly polluted. High BOD means water is highly polluted. ठीक है, water is highly polluted. That is the meaning of high BOD. ठीक है, that is the meaning of high BOD, that water is highly polluted. ठीक है, so our main purpose in sewage treatment plant is to reduce the BOD. ठीक है बच्चे, to reduce the BOD. So you are having the aeration tanks, right? You are having the aeration tanks. ठीक है बच्चे, so aeration tank में mechanical agitation and flock formation is there. So when BOD will decrease, right? When BOD decreases, when biochemical oxygen demand, when it decreases, then where are we going to pass it? We will pass it to the settling tank. So in the settling tank, this flock will settle down at the base. This flock will settle down. जैसे ये देखो, this is the settling tank, the flock, because now there is no organic matter, less organic matter is there. So flock will settle down at the base, and this is known as this sediment is known as the activated sludge here. ठीक है? Right, this sediment here, the sediment means the same thing that will settle down at base. It is the activated sludge. What is it? It is the activated sludge. What is it? It is the activated sludge. And effluent can pass to the tertiary treatment. Okay, effluent can go to the tertiary treatment where chemicals will be added, okay, or it will be discharged in the rivers, in the lakes. Okay, because BOD is less, so it can be directly discharged, or it can be go for the tertiary treatment where chemicals will be added. Now this is the activated sludge. So this activated sludge is having the floc, so we will pass it to the anaerobic sludge digester. Why are we passing it to the anaerobic sludge digester, bache? Why are we passing it to the anaerobic sludge digester? Why are we passing it to the anaerobic sludge digester? Because here the oxygen is absent, O2 is not there. So obviously these flocs, they will die here. They will die here. They have the anaerobic bacteria. That bacteria will destroy that flocs. So obviously, so further it can be used for biogas production, the manure like this. So this is about the secondary treatment. Okay. So anaerobic sludge digester say we can have biogas and manure. So this is about the sewage treatment, and that is what you need to revise. Okay. This is about the sewage treatment, and this is what you need to revise. Done, bache? Done, bache? Done, bache? Sure? Sure. Are you sure? Right. So this is the sewage treatment. This is a sewage treatment. Baki biogas mein, you know that methanogens are there. The concrete tank is 10 to 15 meter deep, and here you will have methanogens, right? And that methanogens, they are basically anaerobic. That's all, right? So do revise the other compounds, right? The bioactive molecules and the biocontrol agents. Okay. So now let's focus on the बाकी ये देखो बच्चे, ड्रग्स में से यू शुड नो द पिक्चर हियर, जैसे ओपीएम और पॉपी है, ठीक है. सो व्हाट आर यू गोइंग टू गेट द इट इज पेपिबर सोमेनिफेरम. व्हाट आर यू गोइंग टू गेट द स्ट्रक्चर ऑफ मॉर्फिन, दे कैन गिव यू द डायग्राम. सो दिस इज समथिंग दैट यू नीड टू रिवाइज. ठीक है. वेयर आर देयर रिसेप्टर प्रेजेंट, जैसे ओपीएम के सीएनएस में भी है ना, सो यहाँ जीआई ट्रैक में. सो दैट इज हाउ यू हैव टू रिवाइज इट. ओके, दैट इज व्हाट यू नीड टू रिवाइज. Okay, so it is something that we have discussed I think multiple times. So immunity में भी the question can come from the barriers, जैसे physical barriers, skin and mucus coating. Physiological में acid in the stomach, saliva in the mouth which is having lysozyme, tears from the eyes, they are also having lysozyme. Then cellular barrier में you have the WBCs and especially your neutrophil. Neutrophil is having many lobes, so that's why it is polymorphonuclear leukocyte, and along with that you will have the monocytes here and natural killer cells here. ठीक है. Cytokine में the example of interferons. So interferons, they protect the non-infected cell. So virus infected cell, they will secrete the protein called interferon. ठीक है. They will secrete the protein called interferon. Done बच्चे. So acquired immunity में you know that, right, the primary and the secondary response is there. So primary response will be time taking. ठीक है. It will be time taking. Secondary is also known as anamnestic response. It will be very quick. Primary response में IgM will form first and then later on IgG. But in secondary response, because it depends upon memory, firstly your IgG will form. So whenever any pathogen will enter in our body, the first antibody that is going to cater it is IgM. ठीक है. So secondary response is also known as anamnestic response, which depends upon memory. So obviously acquired immunity में you will talk about AMIS, you will talk about CMIS. So AMIS is antibody mediated. It is also known as humoral immune system. B cells are involved there, so that plasma B cells will form your antibodies, right? B cells will divide, plasma B cell and memory cell will form, plasma B cell will form antibody. CMIS में you will have cell mediated immune system, T cell will be there. ठीक है. So here you will talk about the T helper cells, cytotoxic या killer T cells, T regulatory cells या suppressor cells, and memory cells. So T cells can even suppress the immune response. So during the organ transplantation that will be done. ठीक है बच्चे. During the organ transplantation that will be done. ठीक है. This immune system will be suppressed here. Okay. बाकी antibodies में you know that these are the variable regions of heavy and light chain. These three constant region in heavy chain, one constant region in light chain. So the part of antibody that will bind with antigen is paratop, and epitope is present on the antigen which will bind to the paratop of antibody. ठीक है बच्चे. Paratop of antibody. So two heavy, two light chains are there. ठीक है. So active immunity where body is itself involved. ठीक है, right? Body will itself form antibody. So obviously it is going to be slow, it will be time taking, right? But it will be long lasting. But passive में you will get ready made antibodies, right? Ready made antibodies या pre-formed antibodies will be there. जैसे देखो, you know that placenta will pass IgG, ठीक है, placenta is going to pass IgG to the fetus, placenta will pass IgG to the fetus. That is also the example of passive immunity, right? The colostrum, the mother's milk is also going to give the antibody IgA. That is also the example of passive immunity. That is also the example of passive immunity. If someone is having that snake bite, right, and we have to inject the pre-formed antibodies, that is also the example of passive immunity. So active immunity में, natural active immunity में, let's say a pathogen has entered in your body and we have made the antibodies against it. So artificial active immunity is there, which depends on, right? You remember ना artificial active immunity, जैसे vaccination और immunization में, vaccination में live or attenuated pathogen will be injected in the body, so that will not cause the disease, but that pathogen can be encountered by our immune system, and our immune system can form the memory against it. It can form the memory against it, right? Right बच्चे? So that's it. ठीक है, that's it. Next topic में we are having this diagram. So diagram में they can ask you the layers. Outer epidermis, endothelium, middle microscopic mother cell, and tapetum. So tapetum is nutritive and secretory. And one more thing that you need to remember here is, due to endomitosis, firstly there is endomitosis. जैसे let's say there is a nucleus, the chromosomes will not divide. Here the number of nucleus will increase, later on it will divide. So because of endomitosis and polyploidy will be there, and tapetum is basically multinucleated, right? More specifically you write it as binucleated. That is what you have to remember. Okay, that is what you have to remember. Plus tapetum is secretory. You know that it forms the Calais enzyme. It also secretes the sporopollen. Which forms an exine around the pollen grain. So this is for your quick revision. ठीक है बच्चे? So layers are important. बाकी in the embryo sac, you know it very well, 7-celled, 8 nucleated, and after there is the double fertilization. One male gamete will fuse here with the egg, zygote will form, one male gamete will fuse with the secondary nucleus, you will have primary endosperm nucleus, and this is your primary endosperm cell. So here what's going to happen? Firstly, right, the endosperm development is there. First of all, what is going to happen? The endosperm development is there. Clear बच्चे? What will be there? The endosperm development is there. Right बच्चे, yes or no? Right? So first of all, endosperm will develop. Why endosperm will develop? Because it has to provide the nourishment to the developing zygote. So this zygote, firstly transverse division. So you have apical cell and basal cell. Okay, what do you have? Apical cell and basal cell. So that is how it divides. So this cell will stay like that, right? This cell, first of all, see, there are this lower cell is going to form your zygote. So here you have trick, that is PGHM, right? Postgraduate Diploma in Hospital Management, whatever you want to say this. PGHM, Postgraduate Diploma in Hospital Management. That is what you can remember. So embryo stage, globular stage. Firstly, zygote will form, then pro-embryo stage, globular stage, heart-shaped, and mature embryo. So this is the sequence of layer, right? Right, Bache Surya? PGHM. So zygote, pro-embryo, globular stage, heart-shaped, and mature embryo. So this cell will divide. First of all, this upper cell, this cell will divide, right? It will form this haustoria and suspensor, and this lower cell will develop into the embryo. ठीक है बच्चे? So it will form globular embryo. It is going to form globular embryo. You can see that, right? So then heart shaped, and then this is the mature one. ठीक है बच्चे? This is the mature one. ठीक है? So now you guys can see the cotyledon here, right? Endosperm done है. So endosperm में you know that the examples are important, right? Examples are important. जैसे ये देखो, coconut water, coconut water from the tender coconut, right? Coconut water from the tender coconut, right? It is nothing but the free nuclear endosperm made up of thousands of nuclei, right? And it is surrounding with the white kernel is the cellular endosperm. ठीक है बच्चे. So coconut water from the tender coconut, you are familiar with, is nothing but the free nuclear endosperm, and the surrounding white kernel is the cellular endosperm, right? Surrounding white kernel is the cellular endosperm. That is what you have to remember, right? That is what you have to remember. Clear बच्चे? Clear बच्चे? Clear? So you remember that diagram na? So it is the cotyledon. So imagine these are two cotyledons. They are attached to coordinatory node. Above cotyledon, apicotyle, then plumule, which will form the future shoot. Below cotyledon, hypocotyle, then radicle, which will form the root. So this is the root cap here. This is the root cap here. Okay, so this is the dicot ka cotyledon. So when it is the monocots, it will be like this, right? So monocot mein single cotyledon is there, that is scutellum, which is shield shaped, and it is on the lateral side. Okay, it is shield shaped and it is on the lateral side. Okay, and here you will see epiblast. You will see epiblast, which is the reduced cotyledon, So bache, here the plumule is covered with colluteal and radicle is covered with coleorhiza. R for radicle, coleorhiza. R is the thing. Colluteal, P. Plumule is the thing. ठीक है बच्चे. So endosperm can either be completely consumed by the developing embryo, then it will be the non-endospermic seeds. Non-endospermic seeds माने your albuminous seeds, right? It is your albuminous seed. And where will you see this? You will see it in the case of dicots. There is an exception, but dicots में. ठीक है. बाकी monocots are having the seeds, right? The endospermic seeds. Monocots can have endospermic seeds because they have single cotyledon. So right? So what do you need to remember? That when you talk about the castor being a dicot, still it contains endospermic seed. It is an exception, but still it contains endospermic seed. And your orchid being a monocot, it is having the non-endospermic seed. Orchid being a monocot, it is having the non-endospermic seed. Are you getting my point? It is having the non-endospermic seed. Are you getting my point? Sure. Are you getting my point? Okay. And yes, perispermic seed where nucellus is persistent, right? Perispermic seed where your nucellus is persistent, it is beetroot, right? It is beet and black pepper. So what is the thing here? Here your nucellus, even nucellus is persistent. So yes, question can come from the examples here. Okay? Question can come from the examples here. Okay? Next part, apomixis and polyembryony. Okay? We have to discuss the apomixis and polyembryony here. Okay? Apomixis and polyembryony here. Guys, there is one more thing for all of you. Beet and black pepper is done. Ye dekho. In the video section na, though I will discuss it, if we will get time, I am going to discuss it. But theek hai, again, I will share the same video in the Telegram group, that is Unacademy NEET English. Okay? So there is the organism and population in 21 minutes. So the complete chapter is discussed here. Okay? The complete chapter is discussed here. Okay, in 21 minutes. The J-shaped growth curve, the population interaction, everything is covered here. Okay, everything is covered here. So you can revise that chapter because 4 questions you guys are going to expect from this particular chapter. Okay, you guys are going to expect 4 questions from this particular chapter. So do not miss it. Okay, do not miss it. Now see this, apomixis and polyembryony. Apomixis is a type of asexual reproduction. It's a type of asexual reproduction, and it is a type of asexual reproduction that mimics a sexual reproduction. It's a type of asexual reproduction that mimics a sexual reproduction. Okay? It is a type of asexual reproduction that mimics a sexual reproduction. Are you getting my point? Right? It's a type of asexual reproduction that mimics a sexual reproduction. ठीक है बच्चे? ठीक है? Is it clear? right? So here in apomixis, what you need to consider that there is no meiosis, there is no fertilization. There is no meiosis, there is no fertilization. Baki it is ditto like, the asexual sexual reproduction. So seeds will form. जैसे let's say here also again, जैसे you are having the ovule. Ovule में you know that ovule है, the nucellus is there. You know ना ovule में nucellus is there. Yes or no? Ovule में you have the nucellus. हाँ, ovule में you have the nucellus. So here again that nucellus will grow. Why am I saying that it is mimicking the sexual reproduction? Let me tell you. Why am I saying that it is mimicking the sexual reproduction? Let me tell you. जैसे you have the nucellus here. So nucellus में you know that one cell will grow. This is the megaspore mother cell. It will grow and it will divide. Here also the same thing is there, right? The megaspore mother cell that is diploid. Okay. So it will again, because here no meiosis, mitosis will occur. You will have two cells, right? So these cells will further grow. Are you getting my point? These cells will further grow. Okay. These cells will further grow and they will grow in such a way that they will also form the embryo sac. So here the embryo sac that you will see will be diploid here. The synergid and all will be diploid. Antipodal will be diploid. So here if you have two nuclei, that will be tetraploid, right? So that is why I am saying that it mimics the sexual reproduction. It mimics the sexual reproduction and seeds will be formed, right? Apomictic seeds will be formed. Is that clear? Apomictic seeds will be formed here. Okay, so seed is the product of fertilization, but here they will form without it. So let's focus on the points which are given in NCERT. Okay, so here you guys can see that although seeds, right, general are the products of fertilization, a few flowering plants, जैसे Asteraceae and grasses, they evolved a special mechanism, right? Asteraceae and grasses, they will form seeds without fertilization. This is apomixis. This is apomixis. So it's a form of asexual reproduction that mimics sexual reproduction. Okay. So in some species, diploid egg cell is formed. Diploid egg cell is formed without reduction and it will develop into embryo without fertilization. Right. So that's what you have to remember. Or citrus or mango. Citrus or mango mein polyembryony is there. Usually in one embryo sac, we see one embryo. Right, we see that this egg will fuse, this will form one embryo, but sometimes the cell of the surrounding nucellus, they also protrude here in this embryo sac and they also grow and they form that is why in one embryo sac you get so many embryos. So this is the polyembryony. Citrus and mango is the example. Citrus and mango is the example. So nucellar cells surrounding the embryo sac, they will start dividing, protrude into embryo sac, develop in the embryo. So in such species, each ovule contains many embryo, right? Each species, each ovule contain many embryo. This is the polyembryony. Okay, this is the polyembryony. Now I will pick up the quick revision. So quick revision में this RNA polymerase. So obviously it is in the eukaryotes. You know na, eukaryotes. So eukaryotes mein transcription will be there in the nucleus. So this is an obvious question, please revise it. This is an obvious question, kindly take the screenshot. This is an obvious question, kindly take the screenshot. Kindly take the screenshot. Kindly take the screenshot. This is an obvious question. Kindly take the screenshot, right? Kindly take the screenshot. Done? 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 So this is very important. This is very important. So you know that even in the eukaryotes, there will be the splicing, right? There will be the RNA processing. So RNA processing में removal of intron, RNA splicing में there will be the removal of intron. There will be the removal of intron, which is the non-coding sequence, and that will be done with the help of spliceosomes. So you will see it only in the case of eukaryotes. So here you have some snRNPs, small nuclear ribonucleoproteins. Small nuclear ribonucleoproteins, they will form, you know, kind of groups, right? Some other proteins are there and spliceosomes are formed. Plus capping and tailing will be done. So 5' end में 7-methyl guanosine triphosphate will be added. 7 methyl guanosine triphosphate will be added. 7 methyl guanosine triphosphate will be added. और tail में polyadenylation means many adenyl groups will be added. ठीक है, polyadenylation will be done, many adenyl group will be added, right? And it will be added in template independent manner. It will be added in template independent manner. How will it be added? It will be added in template independent manner. Clear बच्चे? Clear. देखो जेनेटिक कोड के लिए भी द ट्रिक इज देयर ऑन अनअकैडमी नीट इंग्लिश चैनल. You guys can check it, so you know how to make it. You can arrest gangster. You can arrest gangster. First codon, you can arrest gangster. Second codon, sorry, third base, right? Codon is the triplet basically. It is having 3 base. First base 5 dash and you can arrest gangster. Second base you can arrest gangster. Then this is how you have to write it. So you at first position, you at second position. Now last में it will be like this. You can arrest gangster, right? So you. Now first base is C, second base is U here. Now see here, first base is C, second base is A here. CA. So here also you can arrest gangster. So anyone interested in revising it again, please check the video on genetic code. In 10 minutes it is done. ठीक है, in 10 minutes it is done. Can you see that? In 10 minutes it is done. Okay, so one more important thing here is, this is what you have to remember. These are the 3 stop codons. This is ochre, this is amber, this is opal. Ochre, amber, opal. ठीक है जी. One more thing, methionine is coded by only 1 codon, tryptophan is coded by only 1 codon, and there are 3 stop codons. ठीक है, there are 3 stop codons, right? There are 3 stop codons. ठीक है, बाकी बच्चे, this is just my advice to all of you. Please don't this part. जैसे ये देखो, in the paper sometimes they give you the codon and they ask you that it is coding which amino acid. So at least see this. This is your tRNA. You know that in 2-dimensional structure it is clover leaf like. ठीक है, it is clover leaf like. And when you talk about its 3D structure, 3-dimensional structure, it is inverted L shaped. What's that? It is inverted L shaped. है ना, it is inverted L shaped. So when you look at this is for the serine. So serine के लिए code is on mRNA AGU and on tRNA UCA. Tyrosine के लिए UAC AUG. So this is my gut feeling that question like this can come in your paper. So please take the screenshot and revise it. Right? This is literally my gut feeling that question like this can come in your paper. Okay. Okay, so take the screenshot and everyone just type it in the chat section. Quick, just type it in the chat section. Quick. Quick. Guys, be quick. Done? ठीक है. So very good. This is what you have to remember. Okay, this is what you have to remember. Okay, now let's come to this part. After this, let's revise Human Genome Project and Principles of Inheritance and Variation. Okay. देखो, one student requested me to consider this topic. Operants. Operons, you will see this thing in the case of prokaryotes only. Where are you going to consider it? You are going to consider it in the prokaryotes only. Where are you going to consider it? You are going to consider it in the prokaryotes only. ठीक है, operon. Operon is basically the group of genes which includes the one regulator gene, structural gene, operator gene, promoter gene. You know it very well. ठीक है, you will see it in the prokaryotes only. So I hope you remember the name of the scientist. So Jacob and Monod. ठीक है, Jacob and Monod. ठीक है बच्चे, Jacob and Monod. Yes, Jacob and Monod, they basically, right, they basically elucidated it in the case of E. coli. Now, as I said, it is the segment of gene, DNA, having the group of genes which are having one regulator gene. When you talk about the regulator gene, you are going to denote it with I. Right, when you talk about the regulator gene, you are going to denote it with I. So if you remember in the paper, in the NCERT itself, we consider it like this: PIP, P-I-P, Pipo ZY, Pipo ZY, Pipo ZY. This is what we consider. Pipo ZY, Pipo ZY. This is what we consider. Yes or no? Pipo ZYA. This is what we consider. Pipo ZYA. This is what we consider. Hanji. This is what we consider. Yes or no? Yes or no? Pipo ZYA, this is what we have to consider. Pipo ZYA, it is the what you have to consider. So this I is the regulatory gene. This I is the regulatory gene. Okay, right? So what you have to remember here, as a देखो, I here it forms the mRNA. That mRNA will form the protein. Actually, the regulator gene here forms the repressor protein. What kind of protein it is going to make? It will form the repressor protein. What kind of protein it will make? Repressor protein. Actually, in your syllabus, what do you have, students? In your syllabus, what will you see? You will see the operon. You will see the operon which will show the negative regulation. You will see the negative regulation of the operon. What will you see? You will see the negative regulation of the operon. Are you getting my point? What will you see? You will see the negative regulation of the operon. ठीक है जी, negative regulation. And you see the inducible operon. What is the meaning of inducible operon? What is the meaning of inducible operon? जैसे let's say you are entering in a room, the light is off, you have to on it. So by default protein या enzyme synthesis is not there, but you have to switch it on. You have to switch it on. And in your syllabus there is the negative regulation. What is the meaning of negative regulation? Inducible operon, that is one that you have to switch on. जैसे we have the example of lac operon. So by default the genes to the enzymes to digest lactose, they are absent. So we have to switch it on. Right, we have to switch it on. That's the point. So here we are saying it is a negative regulation. What is it? It is the negative regulation of the inducible operon. We have to switch it on. Now what's the point? You have regulatory gene, it will form mRNA, it will form protein, and it is a repressor protein. What kind of protein it is? It is the repressor protein. Repressor. So if regulatory gene, it forms the protein that is a repressor, it will be the negative regulation. If your regulatory gene, it will form an activator. If your regulatory gene, if it will form activator, then it will be the positive regulation. So why do we say it is the negative regulation? Because here this is the part, because of this, because it is forming the repressor. So regulatory gene, if it forms the activator, it is the positive regulation. So is it possible that regulatory gene form the activator? Yes. In the higher studies we studied, but it is not the part of our syllabus. It is not the part of our syllabus. One direct MCQ. Next MCQ, the protein, the product of regulatory genes interact with operator. I told you it is Pipo ZY. It is Pipo ZY. Regulatory gene, then promoter, then operator. Then these are three structural genes. It is Pipo ZY. Regulatory gene, promoter, operator, then three structural genes. Promoter and operator, they are overlapping. If the product of regulatory gene, that is repressor, if it is attached to operator, your RNA polymerase cannot bind to the promoter. Your RNA polymerase cannot bind to the promoter. So the transcription and translation is not there. So by default this is the condition. By default this is the condition. ठीक है बच्चे? By default this is the condition. Can you see that? By default this is the condition. Repressor mRNA, repressor. So the product of regulatory gene is interacting with operator. That is something very important. It's a PYQ. It's a PYQ. ठीक है जी? It is a PYQ. So that is why there is no transcription and translation. Now I don't want this operator to bind with the promoter. Product of regulatory gene bind with the operator, and I don't want it. I don't want it. Okay. Now basically what is happening and where is it happening? It is happening in the case of E. coli. It is happening in the case of E. coli. So E. coli normally feeds on bacteria. Now in its culture medium, bacteria is not there, lactose is there. So it wants to digest the lactose. That's why it wants to switch on the enzymes. So in the E. coli, I told you there are 3 structural genes. So this Z will give you beta galactosidase. It will give you beta galactosidase. Y will give you permease. Okay. A will give you transacetylase. A will give you transacetylase. Are you getting my point? So beta galactosidase, permease and transacetylase. Beta galactosidase, permease and transacetylase. Beta galactosidase, permease and transacetylase. These are the 3 things that we have, right? These are the 3 things that we have. So beta galactosidase, it will act on lactose. It will act on lactose and it will break it into glucose and galactose. It will break it into glucose and galactose. Permease is the one that allow the entry of lactose in E. coli. In E. coli. Are you getting my point? Are you getting my point? Transacetylase will transfer the acetyl group. So it is mainly helping in the detoxification. Okay? It is mainly helping in the detoxification. Are you getting my point? It is mainly helping in the detoxification. Are you getting my point? Right? 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 So these are the 3 enzymes. So now in the lactose, some amount of lactose will enter in E. coli. Dekho, come to this point. Come to this side. Here, if I want to switch on my operon, I don't want this repressor to bind to the operator. Okay, so I need to distract, right? I need to distract. What I need to distract? I need to distract my repressor. I cannot allow it to bind to the operator. Okay, so basically we don't want their patch up. So basically we have to implant someone that will attract the repressor, and repressor will be like, "Okay, yaar, I'm leaving operator, I'm going with someone else." So that will be the inducer. So here inducer is nothing but the lactose itself. But the lactose itself, it is more specifically, it is the allolactose. These are the isomers. Now, some students, they ask me if inducer is the lactose, okay, this inducer will bind to the repressor. Repressor now will not bind to the operator. So RNA polymerase, P for polymerase, P for promoter. It will bind with promoter, transcription and translation will start. And you know that here it will be polycistronic from that single M, right? So this is polycistronic, right? This is polycistronic. Am I right? Am I right or wrong? Is it polycistronic or monocistronic? Is it polycistronic or monocistronic? Monocistronic, isn't it? In the prokaryotes, is it monocistronic or polycistronic? Monocistronic or polycistronic? Guys, please answer it. Mono ya poly? Mono ya poly? Thank God. It is polycistronic. It is polycistronic. Prokaryote, polycistronic. It is prokaryotes are polycistronic, but they are monoreplicant. They are polycistronic, right? What is the meaning of cistron? Is that part of DNA which is going to form the protein. So what is the meaning of polycistronic? Hanji, what is the meaning of being polycistronic? What is the meaning of polycistronic? हाँ जी, anyone? Polycistronic. देखो, these polycistronic mRNA, here you know that it is having one regulator gene. So basically on this polycistronic mRNA we can form different enzymes. We can form different enzymes. You have this one polycistronic mRNA which is the product of obviously these three genes, right? And it is having single regulator, and from this polycistronic mRNA you can get these enzymes. So blastocidase, beta galactosidase, permease and transacetylase. Beta galactosidase, permease and transacetylase. Beta galactosidase, permease and transacetylase, this will be formed. So now when this RNA polymerase will bind to the promoter, obviously the transcription translation will be there and you will get the enzymes and they will help in the digestion of the lactose. Beta galactosidase will break the lactose into glucose and galactose. So some students they ask me ki madam, right, tell us. Some students they ask me that ma'am please tell us, right, that ma'am please tell us that how is it possible, right, that you are saying that inducer, lactose is the inducer and permease will allow the entry of the lactose, and here you are activating the permease. Actually some expression of permease is always there, some amount of permease is always there in the E. coli that will allow the entry of lactose here, and then this is how the further activation will occur. ठीक है जी, ठीक है जी, चलो जी. बाकी ह्यूमन जीनोम प्रोजेक्ट इज मेमोरी बेस्ड. अगेन डू नॉट मिस दिस टॉपिक, राइट, इट इज कंप्लीटली memory based. You just need to read it, okay, you just need to read it, you just need to read the features, you are not allowed to miss it. ठीक है. नेक्स्ट टॉपिक दैट वी नीड टू स्टार्ट इज, राइट, योर देखो, principles of inheritance. Disorders are already discussed in the separate session, right? Disorders are already discussed in the separate session, and that separate session is all about the disorders. ठीक है, right? So principles of inheritance है, disorders are very important, linkage is very important, that we will discuss today. I'll give you the overview of that, and laws are important. बाकी ratios में से they can ask you the question. ठीक है, so we will do it now. It's 6:20, so there is a break time till 6:30. Okay, there is a break time till 6:30. So after that let's start this. Okay, so I will give you just 10 minutes ka break, washroom break, tea break, whatever you want to consider it. At 6:30 let's revise it. After this chapter let's move to the ecology, then to the biotech, and then to the human reproduction part. But how can I forget, I cannot exceed the lecture more than 12 hours, otherwise it will be deleted from YouTube. So I will just give you the overview of that topics. If you want you can revise it from my marathon session. This genetics wala part we will discuss in detail, and for remaining you can just check the marathon sessions. Okay, and I'll provide you the PDF right after the class in the group Unacademy NEET English. And do not forget that tomorrow, right, do not forget that tomorrow this is what we have, right. Tomorrow we are going to practice. First of all, after my class Wasim sir class is there, Wasim sir's class is there, ठीक है, right, that you know, darkness, no light is there, ठीक है. I don't know what he's doing with the light, with the electricity, I don't know. So see, so and tomorrow morning 100 question from the concepts that we have discussed today. And bhai, do not forget about this paper analysis. So right after your NEET examination we will start the paper solving here. Okay, so break time is till 6:30. Let's start it. Okay, let's start it. So guys, I cannot extend the session more than 12 hours, otherwise it will be deleted from YouTube, and I believe you need it for the revision, है ना? So what can we do? I will quickly wrap it up, ठीक है? And then if like all the important topics are already covered, right बच्चे? बाकी okay, so you can revise it further. Okay, you can use that marathon sessions for the revision. So see this contrasting traits studied by Mendel: stem height, flower color, flower position, pod shape, pod color, pod shape, pod color, seed shape, seed color. So you should know that which one is dominant, which one is recessive. Just when it comes to the stem height, tall is dominant. Flower color mein which flower color is dominant? Which flower color is dominant? Violet, right? Flower position, axial is dominant. ठीक है? Pod shape is inflated. Pod color is basically green. Seed shape is round, and seed color is, yes बच्चे, seed color is yellow, right? Yellow round. So this is what you need to remember. Secondly, बच्चे, test cross. Test cross is something very important. So when you talk about the test cross, it's a type of back cross. It's a type of back cross. And now what is going to happen in this test cross, right? Homozygous individual. What is going to happen here? Homozygous individual will be crossed with, homozygous individual will be crossed with sorry, arey yaar, 1 second. One of the F1 individual, 1 second, one of the F1 individual will be crossed with homozygous recessive parent, right? So this is a fixed condition in this case. This is a fixed condition in this case, ठीक है? And what is that fixed condition? That fixed condition is one of the F1 individual will be crossed with the homozygous recessive parent, ठीक है? So in the case of test cross, this one point clear? ठीक है, this one point clear. So in the case of test cross, right, we are doing it to detect the unknown genotype. Why? Because we want to check unknown genotype. We want to check unknown genotype. Then how can we check the unknown genotype? Obviously बच्चे, if you are looking at a flower color, you can tell which color is it, ठीक है? जैसे let's say you are looking at a plant, you are like कि plant is tall, right? Plant is tall, you can see its phenotype, but you don't know the genotype. So you can assume either it will be capital T, or it will be small t, capital T, right? These are the two things that we have. So test cross will help us to figure out this thing, ठीक है? Test cross will help us to figure out this thing. Test cross will tell us कि अच्छा ठीक है, right? Test cross will tell us कि okay fine, that's how it is present. Like let me tell you, okay, let me tell you. जैसे let's say if you will assume that capital T is the unknown genotype. So you know that one condition is same, that you have to hybridize it with homozygous recessive individual. Another thing is capital T, small t, capital T, small t, small t, small t. So you see, so if the unknown genotype, like if the test cross, if after the test cross all are dominant, if after conducting the test cross all are dominant, then you will say that unknown genotype is what? Unknown genotype is homozygous dominant. But if this is the scenario, okay, if this is the scenario, right? So 1:1 is the thing, right? जैसे 50% are tall, 50% are dwarf. So in that case, if it is 50% wala thing, then in that case unknown genotype is heterozygous dominant. That is how we have to remember, right? So this is the monohybrid cross. In the dihybrid cross, if this is the condition, you know na, dihybrid cross mein if one is heterozygous dominant and other is homozygous recessive, then what you have to consider, the ratio should be 1:1:1:1. ठीक है, 1:1:1:1, ठीक है? बाकी you know that law of dominance which says that characters, as per Mendel, characters are controlled by discrete units called factors. Characters are controlled by discrete unit called factors, isn't it? Discrete mane these are the separate unit, they will exist as a pair, right? And they are going to control the character. So factors, they are in pairs. So in a dissimilar pair, right? Jैसे one is dominant, another is recessive. You know that if they are dissimilar, so obviously one will be dominating, another will be recessive. ठीक है? This is the law of dominance, and on the basis of that, you know that 3:1 is the phenotypic ratio, 1:2:1 is the genotypic ratio. बाकी law of purity of gamete and law of segregation is same, right? Law of purity of gamete and law of segregation is same. So as per this law, at the time of gamete formation, you know that chromosomes are also paired, these genes are also paired. So you know it, at the time of gamete formation, each gamete will receive only one allele for a particular character, right? It is not at all possible that it is a gamete. It is not at all possible that it is a gamete and it will have RR like this. It is incorrect. So at the time of gamete formation, from this pair of allele, what is going to happen? From this pair of allele, what is going to happen, bache? These alleles, they will get separated and each gamete will receive only one allele of a particular character. Each gamete will receive only one allele of a particular character. ठीक है बच्चे? So this law is based on the fact, that alleles do not show any blending and both the characters are recovered as such in F2 generation. ठीक है? Alleles, they do not show any blending and both the characters, they are recovered as such in the F2 generation, though one of these is not seen at the F1 stage. One of these is not seen in the F1 stage. ठीक है बच्चे? That alleles, they do not show any blending and both the characters are recovered as such in the F2 generation, though one of that is not seen in F1 stage. Why do we consider the ratio of the F2 generation? Because we see in the F2 generation, if there is any recessive allele, that will also express. Okay? That is why we consider the ratios of F2 generation. 3:1 F2 generation, 1:2:1 of F2 generation. Okay? So this law is based on the fact that alleles, they do not show any blending and both the characters are recovered as such in the F2 generation, right bache? Though one of these is not seen at the F1 stage. So the parents contain two alleles during gamete formation. The factors or alleles of a pair, they segregate from each other such that gamete will receive only one of the two factors. Okay? Gamete will receive only one of the two factors. Right, that is what you have to remember. So a homozygous parent will form same type of gamete, heterozygous will form different type of gamete. ठीक है, will form different type of gamete. बाकी ये देखो बच्चे, law of independent assortment में you know that, right? Law of independent assortment में you know that what's the scenario, what's the story. Sorry, law of independent assortment, where you consider the dihybrid cross. What do you consider here? You consider the dihybrid cross. What do you consider? You consider the dihybrid cross. You will consider the inheritance of two genes. So when we consider the inheritance of two genes, we say, जैसे ये देखो, this is the F1 and when we cross F1, right, when we cross F1, so we are going to get 9:3:3:1. This is our phenotypic ratio. So here what do we say? We say that the inheritance, right, that we are saying that R is not affected. This pair of gene is not affecting the segregation of this pair of gene. They are independent of each other. Capital R is not saying that capital Y will stay with me, right? Capital R will not see, right? Yes, bache, capital R will not say that Y will not stay with, capital Y will stay with me only. Capital R is like, theek hai yaar, theek hai. If I will get capital Y, fine. If I will get small y, it is also fine. So basically the segregation, right, that one gene pair will not affect the segregation of another. This is the basic funda here. This is the F2 generation phenotypic ratio. Now, if you want to check the ratios, you know that your ma'am, she has told you already that there is something called product rule, right? That there is something called product rule. Okay? So when you talk about the product rule, just let's consider the monohybrid cross. So product rule mein you have to multiply it. It is the dihybrid cross. So multiply the genotypic ratios of the monohybrid cross. You will get your answer. Let me tell you. Okay? So 1 1s are 1, 2 1s are 1, 1 1s are 1, 2 1s are 2, 2 2s are 4, 2 1s are 2. Okay? 1 1s are 1, 2 1s are 2, 1. So this is the genotypic ratio of the F2 generation. So this is the product rule. So same rule you can also follow for calculating the monohybrid, for the phenotypic ratio. Let me show you. Ye dekho. Phenotypic ratio for that monohybrid cross is this 3:1. Now you are considering the dihybrid cross and conditions are same. So just multiply it. 3 3s are 9, 3 1s are 3, 3 1s are 3, 3 1. Dekha? So there is no need to cram the ratios. That is how you can get it. This is the product rule. That is how you can get it. This is the product rule. Same way में you can get trihybrid cross का ratio, right, and even the tetrahybrid cross का ratio. ठीक है, right. So now let's move to this part, meiosis and germ cell formation. You know ना, chromosomal theory, Sutton and Vovry has given. How do we compare it, right? जैसे ये देखो G1 में this is what you have, right? G1 में let's say this is a cell having 4 chromosomes. You know that in S phase there is the duplication of DNA, right? So during this time even your alleles will get duplicated. जैसे let's say this is the chromosome, here you have A, sorry, here you have A. So after S phase this will be the condition, this will be the condition. ठीक है, so you know that, right? So this is how the condition is, right? This is how the condition is in general. If I'm considering the meiosis, right? Meiosis maybe you know that pair of chromosome will be taken, one is paternal, another is maternal chromosome. Let's say here you have A, here you have small a. So after S phase this will be the scenario, after S phase this will be the scenario, duplication. So your allele A will also be duplicated, small a will also be duplicated. That's how the things are. That is how the things are. So you know that when it is the meiosis, when it is the metaphase, when it is the metaphase 1 of meiosis 1, so basically this will be the condition. This will be the condition. When it is the metaphase 1 of meiosis 1, this will be the condition. Your bivalent will be arranged here, right? Your bivalent will be arranged here. Are you getting my point? Your bivalent, right, will be arranged here. So anaphase में bivalent will get separated. Bivalent will get separated. जैसे let's say these two will get separated, these two, right? But when it is the anaphase 2, anaphase में जैसे anaphase 1 में bivalent separate, right? Bivalent separate. Or when it is the anaphase 2, there is the splitting of sister chromatid, right? There is splitting of sister chromatid. So if I have to explain it, right, basically we are comparing the genes ka behavior and the chromosomes ka behavior. Consider this case. After S phase, this is what you guys are going to have. Let's say here you have capital A, here you have small a. When there is the metaphase 1, right, when it is the metaphase 1, let's take only one example. Okay, let's say take only one example. When it is the metaphase 1, this will be the scenario. When it is the metaphase 1, this will be the scenario. So obviously in anaphase 1 it will separate. It will separate in anaphase 1. So one chromosome will have this, one cell will have this, another cell will have this. Two cells will form now. One cell will have this, another will have this. So this one is having capital A, this one is having small a. So dekha, both, right? So during gamete formation, these alleles, they, right, from a pair they will get separated. They will get separated. Now when it is the, right, now when it is the metaphase 2, now when it is the metaphase 2, you know that what's going to happen in metaphase 2? That is how the chromosomes will arrange itself on the equator. Okay, so there is the splitting, of, in the anaphase 2, there is the splitting of centromere, there is the separation of sister chromatid. So now here you will have two cells, here also you will have two cells. So here you will get this, here you will get this. Okay, so here you have capital A, small a, small a. So we consider the behavior of chromosome and the genes. That is how they will separate. That is how they will separate. Okay, so now after this diagram, if you will revise it from this particular diagram, I think it will be easy. जैसे ये देखो ना, yellow and red, right? This yellow and orange, they are making one pair, red and green, they are making one pair. So after the anaphase 1, right, what will happen? They will separate. In anaphase 1, they will separate. Okay, bache? Now in the anaphase 2, you know that splitting of sister chromatid will be there. So finally, these are the germ cells, right? So from this yellow and orange, it is separated. Red and green, it is also separated. Right, it is also separated. So this is the how they compare the behavior. This is how they have compared the behavior. Clear bache? Clear bache? So here as per it, okay, as per it, what will you say? Here they have compared the behavior. Okay, in this diagram they have compared the behavior. Wait. Right, so independent assortment is shown here, right, that one pair will not affect the segregation of another. And here what are they showing? That meiosis and germ cell formation in a cell, right, in 4 chromosome, right? So segregation is explained here, I already told you. So this is about the independent assortment, right? That yellow one can go with the green one also, with the red one also. Okay, it can go with this. Now this table is also very important, students. This table is also very important. So you can see this A and B is given. You have to tell the chromosome and gene. A occurs in pairs, segregate at the time of gamete formation, and only one of each pair is transmitted to a gamete. Okay, segregate at time of gamete formation and one of each pair is transmitted to a gamete. Independent pairs segregate independently. One pair segregates independent of another pair. So which one is gene, which one is chromosome? Tell me quickly. Which one is gene, which one is chromosome? Anyone? It's simple. Which one is gene, which one is chromosome? Which one is gene, which one is chromosome? Hanji, which one is gene, which one is chromosome? Very good, very good. A is gene. Just here it is given na independent pairs, they will segregate independently of each other. One gene is not affecting the segregation of another, and this B is nothing but the chromosome. This B is nothing but the chromosome. Now this thing is showing the linkage. Linkage may, you know that wherever there is linkage, independent assortment will not be there. When genes are present on same chromosome and they are present in linear order, they are the linked genes. So if they are too close to each other, they will not segregate during the gamete formation, they will stay together. But if they are very far from each other, crossing over can occur, they can separate. Now if genes are not linked, unlinked, means they are present on different chromosomes, then they will segregate independently. So wherever there is independent assortment, there is no linkage. Wherever there is independent assortment, there is no linkage. There is no linkage. Okay, bache? So now here they are showing the linkage. Dekho, two genes are there. They are very close to each other. They are very close to each other. So in the F1 generation also they will stay together, in the F2 also. So when you talk about the inheritance of two genes which are so close to each other, because complete linkage is very rare. In the male Drosophila you will see complete linkage, it is very rare. Complete linkage may as such parent-like combination will be there in the next generation, not possible. Linkage will be incomplete because always you will see that, you know, some, right, like little distance will be there. Rare linkage is very rare. So here you will see that two genes which are too close to each other, which are so close to each other that genes, right, see parental type is 98.7%, recombination is 1.3 because they are located very close to each other, right? So linkage is inversely proportional to distance. More distance, less linkage, less distance, more linkage will be there. Okay, so cross B may you can see these genes, they are having a good distance, so crossing over can occur. So that is why parental type is less here, right? It is somewhere in 52 something, or here it is 37.2, 62 something and 37.2, right? So cross A is having the genes which are too close to each other, that's why more parental type. Here the distance is more, that's why parental type is less. That's why parental type is less. Okay, Baki disorders of this part is already discussed. So Morgan was the first one who experimented the, right, who experimented the laws of Mendel on the animal, that is on Drosophila. But what he observed, bache, he got the different ratios because of linkage, right? So chromosomal theory of linkage was given by Morgan, but chromosomal theory of inheritance is given by Sutton and Vovry. It was given by Sutton and Vovry. Okay, ji? It was given by Sutton and Vovry. ठीक है बच्चे? Guys, obviously I cannot stretch session more than 12 hours, otherwise it will be deleted from YouTube. So I will suggest revise the organism and population from that short video. That will be helpful. Right after the class I will share that in the Telegram group. Okay, I will share it in the Telegram group. Okay, bache? Okay, bache? And now one more thing. So PCR dye, okay, it is very clearly, right, it is very, you know, very, if you will check the zoology ka marathon, you will get it there. ठीक है, if you will check that zoology marathon. बाकी from organism and population you can revise from that video. Productivity में GPP is just like your pocket money, right? Gross primary productivity, it is the rate of production of organic matter. The plant, after photosynthesis, what plant is going to form? So when it is productivity, when it is production, the unit is C, gram per meter square, kilocalorie per meter square. Productivity mein you are talking about the rate, you will mention that duration as well, right? जैसे let's say in 10 hours we have covered 80% of the biology, ठीक है, in 10 hours we have covered 80% of the biology, है ना, we have covered 80% of the biology. So this is what I am expecting from my students, that today right after the class everyone is going to put a comment. If you enjoyed this lecture, if you think that yes, this lecture is very helpful for me, I have revised approximately above somewhere in 80 to 90% of the biology, right, the most important topics of biology, then I want you people to put the comment in the comment section. ठीक है, I want you people to put the comment in the comment section. ठीक है जी. So now focus here. GPP of an ecosystem is the rate of production of organic matter during photosynthesis, and now obviously plant will use that biomass, right? Respiration will be there. Remaining is NPP. Don't miss this topic. Then बच्चे, this pyramids में you know that pyramid of energy is always upright. We have the pyramid of number, we have the pyramid of biomass, we have the pyramid of energy. So without any exception, pyramid of energy is always upright, because only 10% of the energy will pass from one trophic level to another. These are the ecological pyramids, and they are also known as Allentonian pyramids. ठीक है, these are the ecological pyramids and they are also known as Allentonian pyramids. What do we call it, students? We also call it as Allentonian pyramids. ठीक है जी. They are also known as Allentonian pyramids. So it is always upright. ठीक है जी. So pyramid of number, it's upright in the case of pyramid of number, means number of organism. It is always upright in the case of grass ecosystem, in the case of pond as well, but you will see that it is inverted or spindle shaped. It is inverted या spindle shaped. This is what you have to revise. Inverted या spindle shaped in tree dominating ecosystem, because you are talking about the number. So tree dominating ecosystem will have inverted or spindle shape. जैसे मान लो one tree, this tree is having many, it is having many let's say birds, that birds are further having the some organism that are feeding on it. So this is how you can revise it. ठीक है, so tree dominating में बाकी you can also consider, जैसे tree है, leaves पे ना some insects they will feed, या some birds are there, then birds will come, they will feed on that insect. That is how you can relate it. So it is basically inverted or spindle shape. ठीक है. Now when it comes to the biomass, in the case of grass ecosystem, obviously it is upright. The grasses are having more terrestrial ecosystem में more biomass is there, organic matter. But in the case of aquatic ecosystem, जैसे कि in the pond, it will be inverted. Because planktons are having, let me show you this, number of in grassland ecosystem it is upright. Biomass देखो, in grassland ecosystem it is also upright. ठीक है, biomass is more at producer level, then this. Now next is what? Next is the inverted pyramid of biomass, right, in the aquatic ecosystem, because small, this phytoplanktons, they are having the less biomass and they are supporting these organism having larger biomass. So it is inverted. ठीक है, it is inverted, don't miss it. One question will come from this part, it is inverted. So pyramid of energy is always upright and 10% of energy will pass to the next trophic level. ठीक है. बाकी बच्चे from the biodiversity also revise these graphs. Examples also, जैसे genetic diversity में Rauwolfia serpentina, species में western घाट, eastern घाट, community diversity में भी you can see that. बाकी बच्चे species area relationship is important. Okay, species area relationship is important. So Alexander Humboldt has given this, right? So S is equals to CAZ. Right, so Z is basically regression coefficient, C is basically the y-intercept, the slope of y-intercept, A is area, and S is basically what? S is the species richness. So do revise it. So I cannot increase the session duration, otherwise I would have, because only 3 to 4 topics are left. Okay, so I will share the PDF in the Telegram group. You guys can check that PDF. So I want everyone to put comments in the comment section, and see here also paper discussion. right? So paper discussion, so hit the like button here. So after the NEET paper, you can check your most accurate paper discussion here, right? And guys, cell cycle and cell division, genetic code, organism and population can be revised here. Plus tomorrow morning we will meet for one another session. So things to carry for examination hall, that this is informative. How to fill the OMR sheet, that is informative. Do check such videos. Take care, and see you all. And after my class you will have 2 hours ka break, then Wasim sir's class will be there, and right? And today, tomorrow morning I will be taking this NT authorized complete biology in 100 MCQs. Okay, so take care, bye bye guys, thank you so much everyone. So we'll wait for your comments, and I hope this session is useful for your revision. So I have covered most important topics, few are left, I think 3 or 4, that you can check my marathon sessions, you can revise it from there, right? So make sure you revise it. Keep yourself calm, have proper diet, and take care of your health. Right now, you cannot change anything. You can just revise and you can just give your best in the exam. So you have to keep yourself cool, right? You have to keep yourself calm. And trust me, if you will keep yourself calm, then you can do wonders. And in the paper, your productivity will be more, right, bache? And you will attempt the paper more efficiently. So take care, guys. Bye-bye. Thank you so much, everyone. Thank you.